So this project will be implementing with the help of whatever things we have learned so far, let's say LangChain, large language model, vector database. Okay, even we'll be also implementing one front-end application of this project. That means user will get one user interface, and their user will upload the data and they will get the results. Okay, so these kinds of things actually will be also implementing. That means I'm going to show you the complete project structure here. That means we'll be doing modular coding here. But before that, I'll show you the notebook experiment, like how we can implement this project through the Jupyter notebook. Then I'll try to convert this Jupyter notebook to the end-to-end manner. Okay, so I think you saw the name interview question creator. I think you are already getting what is the project about. Interview question creator means, let's say you are having one PDF documents, or let's say any kinds of documents, whether it's a docs documents, PDF documents, TXT documents, or whether it's a books. Okay, so what you have to do, you just need to upload that let's say PDF to this application, and this application will automatically generate the questions. Okay, question as well as the answer. Okay, of the topic actually will be giving. Let's say you have uploaded one Python PDF here. So this application will generate some Python questions, interview questions, as well as the answer. Okay, and that question and answer you can use, let's say for your candidate, or let's say you are a teacher and you want to generate interview questions, or let's say exam questions. What you can do, you can use this application to generate this kinds of question and answer. So it would be very easy for you to generate this kinds of question. Otherwise you have to manually find the questions, manually let's say prepare the answer, so it will take time. But if you are creating this kinds of application, it will help you a lot, okay, to automate your process. Again, it seems like a simple project, but whenever you will be implementing, you will get the complexity. And this is like very interesting project because this is the first project I should be implementing after learning LangChain. Going forward, we'll be also implementing some advanced projects, like we'll be implementing medical chatbot, source code analysis. Okay, so these are the things we'll be also implementing. So instead of talking too much, guys, let's start the implementation. But before that, I will show you the, let's say, the requirements actually I need to implement this project, and I will also show you the project architecture. So guys, to implement this project, I need some requirements. Okay, I need some requirements. So here we'll be using LangChain to implement the entire, let's say, project. And why LangChain, I think you know, because LangChain having all the functionality, right? Let's say you want to integrate vector database, you want to integrate large language model. Okay, everything is available here. So that's why we'll be using the complete LangChain here. And large language model wise, we'll be using OpenAI model. OpenAI will be using GPT 3.5. Okay, this model actually will be using. Going forward, we'll be also learning how we can use open source large language model. With the help of that, I will also show you how we can create the application. Now, third, I need vector database, vector DB. So here we'll be using FIAS. Okay, so FIAS is another actually vector database. I think I haven't covered in my vector database series. So that's why I thought let's also show you this FIAS in this video, so that you will be also learning about FIAS. So FIAS has implemented by Facebook AI, and this is one of the vector database. This is the local vector database actually, local vector database. So you have to set up everything in local machine. Going forward, we'll be also using Pinecone Web 8. Okay, no need to worry. Then to implement the entire, let's say, front-end part of our application, that means we'll be creating the user interface with the help of Fast API. Fast API. I think you know what is Fast API. Fast API is a Python framework. With the help of Fast API, we can create a user interface web application. Apart from Fast API, we're having, let's say, Streamlit, Flask, Django, okay, Falcon. So these are the things you can also use. We'll be exploring one by one all of them. I think we saw the Flask previously. I think remember Flask. I think I showed you. We created some of the application with the help of OpenAI. We'll be also using Streamlit. Streamlit is very easy. If you are using Streamlit, you don't need to write any kinds of HTML and CSS code. So guys, yes, as of now, these are the requirements are needed. If I need it later on, I'll tell you. Okay, now let me show you the project diagram. Okay, the project, let's say, structure. That means the high level architecture. So here, first of all, user will, let me just draw it here. First of all, user will upload one PDF documents. Okay, let's say this is the PDF documents. So what I have to do, I have to extract the data. Extract docs. So why I have written docs? Because I think you already know, if I am using LangChain and if I'm, let's say, extracting any kinds of data from any kinds of PDF or any kinds of, let's say, file format, it would be considered as a documents. I think I already covered multiple time, like Langchain data loader. Even I also showed you inside vector database session. So guys, vector database session is very much required here, because inside vector database session I have explained each and everything you need to know to implement any kinds of project. Okay, how to connect the LLM, what is documents, what is chunk overlap, everything I have discussed there. So please go ahead and try to watch that let's say session first of all, then you'll be able to understand, okay, what is happening here, because here I'm not going to explain in detail everything. We are implementing the project only, and we're using our previous concept. Okay, this is the idea. So make sure you complete that vector database series first of all. Fine. So we'll be extracting the documents from the PDF. Then we have to create a chunks. And what is chunks? I think I already told you why chunking is required, because LLM is having one kinds of input limit. Okay, but, so that's why actually we have to create a chunks. Okay, chunks. Then what we'll be doing, we'll be using one embedding model. What is embedding model? I think you already know. I already explained inside my vector database session. Embedding model will help you to generate the vector embedding. Okay, because I have to convert these chunks to the vector embedding. So this will give me something called vector embedding. Okay, vector embedding. Okay, embedding. And with this vector embedding, we'll be creating one semantic search. I already explained what is semantic search. Semantic search, because I think you know the power of VectorDB. It will give you one semantic search kinds of functionality. Now what I have to do, I have to store this vector to a vector database. Vector database, because if I want to perform the semantic search operation, I have to use the vector database. Okay, I think you already know. Now guys, you can see my knowledge base has been created. So this is called actually knowledge base right now. Okay, knowledge base, because it is having the entire information about my data. Now I'll be connecting my large language model here. So let's say this is my large language model. LLM, that means that GPT 3.5. Okay, so this large language model I'll be connecting here with my vector database. Okay, and here I'll set a prompt. I'll just set a prompt here. So inside this prompt, actually I'll be writing what kinds of, let's say, task it has to perform. So here I'll be writing, you are a expert interview question creator. So what you have to do, whatever, let's say, data user will give you, you have to create a interview questions. Okay, or let's say 10 questions, 20 questions, you have to create it. Okay, this is the idea. So this kinds of prompt actually I'll pass to the large language model. So I think you already know prompt is everything if I'm using any kinds of LLM, right? So with the help of prompt we can achieve our task. This is the main idea. So this LLM will go to the vector database that time, and because vector database is having all the information about the PDF, and it will create, okay, it will create what? It will create you interview questions. So it will return interview questions. Interview questions. Okay, fine. Now what I told you, I'm not going to take only the interview question. I will also going to take the interview question answer as well from the large language model. So again, what I will do, whatever questions actually I'm getting, again I'll pass. Okay, again I'll pass to my large language model. Again I'll pass to my large language model, and I will tell my large language model also provide the answer, the questions you have generated. So it will give me the answer at that time. So it will give me questions answer, okay, as well. So this is going to be my complete project architecture. Okay, so based on this architecture, we'll be developing the entire projects. Fine. So first of all, let's do everything in my Jupyter notebook. Then once Jupyter notebook is working fine, then I'll show you the let's say modular coding implementation as well. So for this, guys, what I will do, I will open up my local folder, and here I already created one folder here, empty folder. Inside that I'm going to open up my terminal. Okay, so in case if you're using Anaconda, Git Bash, whatever terminal you are using, you can open it up. Now here I'm also going to open up my Visual Code Studio. So let me open up my Visual Code Studio. Now here the first thing what I have to do, I have to create one virtual environment. I think I already told you, you just need to create a virtual environment every time whenever you are creating different projects. So to create the virtual environment, you have to execute some of the commands. So let me share the command with you as well. So here I'm going to create a file called readme.md. So this is the markdown file. Inside that I can mention all the command, and this file will help you to render actually these kinds of masses in the GitHub. So let's say whenever you will be uploading this code to the GitHub, that time you'll see that in the GitHub description, that means your project description, all the details has been written. Okay, let me show you one example. So guys, this is my GitHub profile. You can follow me here also, because here I have created lots of repository that might help you a lot. So let me show you my repository, guys. One of the project actually I implemented previously. So let's say this project, okay, MLOps production ready machine learning project. So this is the project actually I created. Now if you open this project and if you go to the readme section, you will see that the complete details about my project. Okay, see the complete details about my projects, like how we can set up, what is the workflow, what are the command you have to execute. Okay, everything I have set here. So how it is rendering? It is rendering because of this readme file. You can see a readme.md file. Okay, so that's why we are getting this readme file here, because whatever things you will be writing here, it will render in the GitHub later on. Fine, this is the idea. So here some of the common command you have to execute every time. Let me show you all the command. So see guys, these are the command you have to execute. First of all, you have to create the environment. After that, you have to activate it. After that, you have to install the requirements. To install the requirements, you have to execute this command. Okay, pip install -r requirement.txt. So let's create a file here. I'll name it as requirement.txt. I'll copy and let me create the file as well. Okay, now first of all, create the environment. So copy this command and open up your terminal and execute it here. Okay, execute it here. For me, I already created the environment. What I'll do, I'll just try to activate it, but for you, you just need to create the environment. So for me, let me activate. So this is the environment I created already. Interview, you can see. Fine. Now inside interview, I have to install some of the required package. The package actually I need, I think I showed you the LangChain, OpenAI, then vector database, fast API. Okay, everything I have to install here. So I already listed down all the required package you need. So these are the package, guys, you need. Okay, you need to install. So you can see LangChain community, LangChain code. So these are the actually dependency package. If you want to use LangChain, so you have to install it. And again, we are doing local setup, guys. That's why some additional package you can see. Otherwise, what will happen? Actually, you might get installation issue. That's why I've added everything. Now, OpenAI PyPDF because user will upload PDF documents here. As of now, we are considering PDF documents. Fine. And TikTok is the dependency of OpenAI. Then you can see AI files, fast API, UVCon. So these are the dependency of fast API. I'll tell you whenever we'll be using these at the package, that time I'll explain. Okay, as of now, just consider these are the packages actually I need to implement the entire projects. Okay, now you can see we'll be using FIAS, and to install the FIAS, you have to execute this command FIAS CPU, then python.env, because I have to manage my secret credential. Okay, now let me save everything and you have to install it. To install it, this is the command, guys, I already shared. So copy the command and let's execute it here. For me, I already installed all the package. That's why it's telling requirement is already satisfied. But for you, it will take some time. Okay, now let me clear. All right, now first thing, I'm going to create a folder here called research. Inside research, I'm going to create a notebook. I'm going to as experiment. I'm going to name it as experiment.ipynb, because this is the Jupyter notebook file I want to create. Okay, that's why it's ipynb file. Now let me select the kernel. So the environment I created, this in interview. Okay, I'll select it up. Now here, first of all, let's import some library. I need the operating system. Then I also need .env. So from .env import load env. Now let me execute. See, it's working fine. So I think remember I have to create a .env file here. Inside that I have to mention my OpenAI API key. So let me do it. So guys, as you can see, I have created this .env file. Inside that I mentioned my OpenAI API key. Okay, so for you, you have to do the same thing. Now let's load this OpenAI API key. So to load it, I'll call this load env. After that, simply I'll call the key OpenAI API key, and I'm going to use os.getEnv. Inside that, I'm going to pass my key. Okay, so this will give you OpenAI API key. Let me show you. See, okay, it is printing the OpenAI API keys. Now let me comment as of now. I don't need to print it. Fine. And now what I have to do, I have to set this OpenAI API key as an environment variable. So for this, you have to execute this line of code. So it will set this OpenAI API key as an environment variable so that OpenAI package will load, okay, from the environment itself. I think I already explained previously this part, okay, how to do it and all. Now the first thing what I have to do, guys, I have to load the data, but I don't have any data here. So let me show you some of the PDF actually I'm having. So guys, as you can see in the data folder, I'm having actually two PDF. One is like HGD PDF, one is like stats PDF. Let me show you. Let me open the PDF and let me show you. So if I go to the data folder, so this is the PDF, guys, I downloaded from the internet. So the PDF name is Sustainable Development Goals. Okay. So about this topic, actually, they have written this PDF. You can see what is sustainable, let's say, development and all. They have written this particular, let's say, PDF. So this is one PDF actually will be using to generate the interview questions. Let's say you want to generate interview question based on this topic. Okay, so you can use this PDF. Not only this PDF, guys, you can use any kinds of PDF, whether it's a Python book, any kinds of physics, chemistry, English, okay, anything you can use here. It's up to you. So this is the PDF, guys, actually I'm having. Now the next PDF, let me show you. So this is the statistics PDF. So this is the topic of importance and the use of correlation in statistics. And again, you can see correlation topic has been written. So we'll be also generating some interview questions based on the statistics. Okay, that means the correlation. So these two PDF actually I just downloaded from the internet. Okay, now let's load the data here. So I'm going to open up my notebook. So to load the data, you have to, I think remember, you have to import one, let's say, function from the Langchain. So let's import it from Langchain dot documents loader. Okay, documents loader, import import PyPDF PyPDF loader. I think, yeah, this one, PyPDF loader, because it's a PDF document, right? Now let me import it. Now one thing I want to show you, so let's say if I show you my project working directory right now, so let's say pwd, this is the command to check my project working directory. Now you can see that I'm inside my resource folder. Okay, you can see I'm inside my resource folder. So because this experiment.ipynb is available inside my resource folder, but where is my data located? Data located outside of the resource folder, yes or no? Because outside of the resource folder data is available. Okay, now if I want to go back, to my root project directory, that means Langchain project, what I have to do, I have to execute one command. This command is cd dot dot. Okay, cd dot dot is the command. So this will actually go back one folder back. Let me show you. So now see if I execute the command. Now if I again check the project working directory, now you can see that I'm inside my root directory, that means this directory. Okay, Langchain project. Now I can easily access my data right now. Okay, this is the idea. So make sure you always check the path, project working directory. Okay, if you're working with, let's say, Jupyter notebook in a specific folder. Okay, this is the requirement. Now let me define the file path. File underscore path is equal to, so my file is present inside my data folder. Okay, data. And let's say as of now I want to load this hgd.pdf. So it should be sdg. Okay, sustainable development goal. This PDF I want to load, PDF. Okay, and to load it I'll be using PyPDF loader. Inside that I'm going to pass my file path. Okay, and it will give you loader object. Now I'm going to load the data. So I'll just write data is equal to loader dot load. That's it. Now see if I execute, it should load the data. Now if I show you the data, see, so the complete documents, so guys, you can see it has extracted all the data from the PDF itself, and it is having around 24 pages. You can see it has started from 0 till 23. That means 24 pages actually it is having this PDF. If I open this PDF, you'll see that 24 pages it is having, and all the page content it has extracted. And some of the places you can see page content is equal to empty, because in this page actually there is no content, that's why it's empty. And whatever actually documents I'm having, it has extracted. Okay, one by one everything. Now if I want to show you the length, you can see 24 pages are available, okay, in the PDF. Now what I have to do, see, it's a separate page content now I'm having. Now I want to, let's say, store all the data in just one variable. So for this, what I will do, I'll just take a variable here. So let's say variable name is question underscore gen. You can give any variable name, it's up to you. It should be initially empty string. Now I'll just write a for loop. So for page in, let's say data, let's say the complete data I'm having. So it will give me all the page one by one, and I just need to extract the content. So questions in plus and equal. I'll be just adding, okay, in this variable. Okay, this is the idea. I'll just write page dot page underscore content. Okay, so it will give me all the content one by one, and it will save inside this questions in variable. Now let me show you. Now if I print my questions in, now see all the data I have extracted. Okay, see now it is in one place only. This is the idea. Now see, this part actually have completed. That means whatever PDF I uploaded, I extracted the entire documents. Okay, now what I have to do, I have to do the chunking operation. That means I have to create a chunks for my large language model, because if I want to, let's say, generate the embeddings, before that I have to do the chunking operation. I already explained this part, I think you remember. So to perform the chunking, we'll be using one package. So it is available inside Langchain. So for Langchain.TextSplitter, so we'll be using one text splitter here called token text splitter. Okay, so previously I think we used something called character text splitter, then recursive text splitter. I think you remember we use character, okay, character text splitter, okay, splitter. So with the help of that, we can perform the chunking operation, I think you remember. Then we also have something called recursive okay, text splitter. So again, this is another method to perform the chunking operation. And now we'll be using something called token text splitter. Token text splitter. Now what is the difference between token text splitter and character and recursive? See, let's say this is my entire documents. So I think you remember we used to perform something called chunk size. Okay, chunk size. Let's say 500. And there is another parameter called chunk underscore overlap. Let's say it's 100. Okay, now how it will create the chunks, I think remember, first of all it will start from the first and it will count 500 words. Let's say 500 words ends here. So this is our first chunks. Okay, and to start the second chunk, first of all it will apply the chunk overlap. Let's say 100 word back actually it will go. So it will count 100 word. Let's say this is the 100 word start from here. So it will start the second chunks from here, and again it will count till 500 word. Let's say 500 word ends here. Okay, so this is my second chunk. Okay, so that's actually it will perform the chunking operation. Now you can see there is a chunk overlap you got. So this is called actually overlap. Okay, this is called overlap, and with this overlap actually my model will understand after this first chunks, this chunks is coming, because you can see it is getting overlap now. This is the actually manual approach actually we can consider. This is the manual approach we can consider to get the context of my first chunks and second chunks. Okay, and so on, like whatever chunks actually we are defining here. But this is actually what we do in the character text splitter or recursive text splitter. But what about token text splitter? See, token text splitter, what it will do, instead of using actually this manual approach, it will use one large language model. In case actually we'll be using something called GPT 3.5. okay, so this GPT 3.5 will decide, okay, how to create the chunk, how to perform the overlapping, and it will automatically remember, let's say after this first chunks, this second chunks is coming, after second chunks this third chunks is coming, after third chunks this fourth chunks is coming. Okay, your large language model will try to remember this part. Okay, and this is like more powerful method than your previous one, whatever, let's say, method you used previously, because now LLM is like remembering everything, the context. Okay, that's the idea. So let's try to export this this token text splitter. So for this I'm going to open up my notebook. So I already imported. Now let me execute. Now see, this is the syntax to use the token text splitter. So I think you remember previously we didn't use any kinds of model name whenever we used to perform the, let's say, chunking operation. Now you can see I'm using the model name. I'm using GPT 3.5 Turbo. That means my model will try to decide, okay, how to remember the context. Now you can see this is the chunk size. Chunk size I'm expecting 10,000. Okay, 10,000 actually what would be considered as one chunks, and chunks overlap should be 200. Okay, as of now, let's say this is the things I'm just showing you, just to show you, okay, how it will work. It's just an experiment. Okay, I'm just showing you how it will try to create the chunk. Now let's define the splitter. Okay, this is my splitter. Now inside that I'm going to pass my entire documents. So you can see the entire questions and documents actually I'm passing to my splitter. Okay, splitter objects. You can see split text. Now it will give me chunk questions, and that means the chunking. Okay, it will give you the chunking result. Let me show you. So here is the chunk I got. See, this is the chunk I got. Now how many chunk it has written? For this you can use length function. You can check. See, it has only given me one chunk. Because why? The PDF, you can see this PDF is DG. So if you count all the words, it won't be actually 10,000 words. Okay, it won't be 10,000 words. It is less than 10,000 words. That's why here I've given chunk size is equal to 10,000. It is only considering one chunk the entire documents, because I told you if you count the all the, let's say, word, okay, in this let's say PDF, it won't be 10,000. Okay, because it's a like huge size I have given here, just to show you okay how chunking will happen. Now let's perform our actual chunking. For this, what I have to do, I have to first of all convert this actually data to the document format, because you can see now it's a list format. Okay, if I show you the type, okay, if I show you the type of this one chunk question, it's a list. Inside that, if I just extract the first element, it would be a string. See, it's a string, but I have to convert to the document representation. So for this, what I will do, I'll import one class from Langchain called docstore documents import documents. Okay, with the help of documents, we can easily convert any kinds of string to document representation. Okay, now let me show you. See, now whatever, let's say, data you got, that means your this one chunk question gen. So I'm applying on for loop. That means it will give me all the, let's say, data one by one, and I'm converting to the documents, you can see. Okay, and I'm storing in this particular variable. Now if I execute, now see, I got the documents and it is format of documents right now. Okay, now if I show you the type of document question gen, it should be a Langchain code document base document documents. Okay, it's a now document format, because if I want to apply the splitter, so first of all you have to convert everything to a document. This is the recommended way. Okay, if you're also giving the, let's say, string directly, it's completely fine, but this is the recommended way. First of all, convert everything to the document format, then try to use the splitter, that means the chunking operation. Now I'll do the chunking again. See, again token text splitter. Again, I'm using GPT 3.5 turbo model. Now I've given the chunk size is equal to 1000. That means 1000 word I want to consider as one chunks, and chunks overlap is equal to 100. Okay, now let me execute. Now let me give my documents. Now you can see document question gen. Okay, I'm passing it to my splitter. Okay, splitter object right now. Now it will give me the chunk. Now let me show you. Now see, I'll get multiple chunk here. So I got here 4 chunks. Okay, 4 chunks actually I got from the entire PDF. Now if I show you the length, see, 4 chunks I got. Fine, I think it is clear now. So guys, as you can see, we successfully created the chunks. Now the next thing what I have to do, first of all, I will generate the questions. Like whatever, let's say, chunk I have created, I will pass to my large language model and I will generate the questions. Okay, interview questions based on the prompt actually I'll be providing. I think you remember, we'll be passing one prompt to the large language model. Okay, so with the help of this prompt, actually, I'll tell my large language model, I need a interview questions. Okay, let's say the documents I have given, based on that, it should provide me some interview questions. That's what actually I need to perform. So for this, I don't need to convert these documents to the embedding representation, because as of now, we are only passing the, let's say, documents to my large language model. Large language model will give me the questions, but later on, whenever, let's say, I'll be doing the answer generation, okay, the complete answer generation, that time actually I need to pass the entire documents. Okay, and it will create the vector embeddings and it will store to the vector database. Okay, and vector database, I'll connect my large language model, and large language model will refer this entire information to give me the answer as well. Okay, this is the idea. So let's define my large language model right now. So here I already told you I'm going to use something called OpenAI large language model, that means GPT 3.5. okay, this model. And to use it, I can use this class actually chat OpenAI. You can also directly import OpenAI. It is completely fine. But we can also import like that. Okay, both way you can import. And if I am importing like that, so here I can also give my model name. That means which specific model I want to use. Whether I want to use, let's say, GPT-4 model, 3.5 model, you can use. So let me show you. So this is the code snippet. So chat OpenAI, inside that you can give the model name. Let's say I want to use GPT 3.5 turbo model, and this is the temperature parameter. You can also give max length parameter and so on. So temperature parameter is a creativity parameter. I already explained. Okay, what is the temperature parameter? Now let me define my LLM. Now here I already created one prompt, guys, prompt template. Let me show you. So this is the prompt I have created, guys. You can see you are an expert at creating question based on the coding material and documentation. See, whenever I designed this prompt, actually I was like generating coding related questions, and now I'm using any other documents. You can see that means the this one, sustainable development goal and statistics one. So if you're using statistics one, that time you need to give statistics material. If you're doing sustainable development goal, you have to give sustainable development goal here. That means whatever subject you are referring, you have to give the prompt with respect to that, because it's a changeable prompt. Is changeable. Okay, you have to change every time based on your requirement. Now your goal is to prepare a coder for a programmer for their exams and their coding test. You do this by asking the questions about the text below. That means whatever, let's say, data user will provide, that means these chunks. Okay, based on that, it will create interview questions that will prepare for the coder, a programmer for their exam test. Okay, make sure not lose any important information. Okay, this is the prompt actually I have created, and I already taught you like how we can design a efficient prompt. What is the art of, let's say, design a prompt? I already took on session on the prompt engineering. That session you can refer. Okay, so that's how always you have to prepare a good prompt. Whenever you are preparing good prompt, that means you will get a good response from the large language model. This is the idea. Now let me define the prompt. Now to use this prompt, I think I already taught you one concept called prompt template. You have to use something called prompt template from the Langchain. So let me show you. So this is the code snippet, prompt template. Okay, so here I'm passing the prompt template I've created, and this is the input variable is text. That means user will give this data. Okay, this is the input variable. I think it is clear. Now let me execute the prompt. Okay, now this is my template right now. We can do another actually very important, let's say, technique here. See, if you're not doing it, it's completely fine, it will work. But I was going through some of the research article, and I got to know people are using something called second layer verification. That means they are doing refined prompt template. So what is refined prompt template? Let me show you. I created one prompt template. See, this is the prompt template I again created. That means whatever questions actually your model will generate from the first prompt, you have to give those questions to the second prompt. That means it will refine that particular question. Let's say if there are some issue with the question, if let's say this question is irrelevant based on the topic you are asking, again this refined prompt template will try to refine, and again it will give you some new questions, okay, on top of it. So here you can see I've written the same prompt again, but one more additional information I have added. We have received some practical questions to certain context. That means it will give me some question. Okay, this question actually I have to give to my second prompt, and second prompt will try to check. We have the option to refine the existing questions or add new one only if necessary with some more context below. That means if some issue is there, if let's say it is irrelevant, that time what it will do, it will try to rectify that question. Okay, this is the idea. Give the new context, refine original questions in English. If context is not helpful, please provide the original questions. This is the idea. So this will actually refine prompt template. You are refining the questions here. That is the idea only. And this is like very powerful method, guys. If you are using, you will see that your result would be pretty good. If you're not using it, it's completely fine. No need to worry. But I'm showing you because see, we are creating it an advanced application, and in advanced application, we have to take care. These are the part. Okay, this is super important. Let's also define this refined prompt template. Again, I'm going to use prompt template. Inside that, I'm going to pass the input variable. Now input variable is two. One is this existing answer. The existing answer I will get, and the text. That means again you have to give the entire text. That means the chunks. Okay. So these two input now you have to give. You can see text and existing answer, and it will give me the refined prompt template. Fine. Now I'll generate the questions. For this, I need to integrate my large language model as well as the prompt template. For this, I'm going to use one function from Langchain called load summarize chain. Okay. Previously, I think I showed you we can use chain. Okay, only chain we can use. Now there is another chain actually called load summarize chain, because inside Langchain you are getting different chains. Okay, we are using this particular chain, actually load summarize chain. Now we'll be creating my entire chain. See, this is the entire chain. First of all, you have to give the large language model. Okay, the LLM we have defined GPT 3.5. Then chain type is equal to refine, because we have prepared one refined prompt template. Okay, that's why it's a refine. Verbose true, that means it will show you the execution, all the, let's say, logs. Then here I'm giving the question prompt. First of all, the prompt I have defined at the very first. Okay, this is the question prompt. Okay, because it's a chain, it will execute after one after another. Okay, first of all it will execute, and whatever question actually I'll be getting, I'll pass to the refine prompt template. Okay, you can see refine prompt template. Okay, now this is going to be my chain right now, and now simply I'm going to pass the document question. That means this one I have to pass, this one, that means the entire document. Okay, this document I have to pass right now to my large language model, and it will give me the questions. Okay, it will give me the questions, and these questions I'm printing. Let me show you. See, it is generating and it is giving all the information because you have defined barbas is equal to true. Now see, these are the questions I got. I got 10 questions. Now if you want to get 100 questions, you can define here. You can define inside the prompt. I need 100 questions. Okay, you have to generate 100 questions. It will generate 100 questions. By default, it's generating 10 questions. Now if I want to show you, I will open in a text editor, see all the 10 questions I got here. But apart from that, I'm getting some more additional information. I don't need them. I only need the questions. You can see 1 to 10 questions it is giving me. What is the main goal of the sustainable development goals method? What are the some key achievements in the, see, that means if you read these questions, it's pretty good. Now, as a human, if I tell you just prepare the question for me, I think you will be thinking in that way. Okay, this is the idea. That means my answer is pretty good, guys. And why I got the pretty good answer? Because I used the refined prompt template. Okay, so this is another powerful concept you can use. Okay, so now we'll be creating the next part. That means we'll be using the embedding model. We'll be generating the vector embedding and we'll be storing to the vector database. Okay, because I also need to generate the answer right now. Fine. So this is what I have to perform. So let's do it. So for this, first of all, I have to define one embedding model. So here I'll be using OpenAI embedding model. So for this, you can import from the Langchain embeddings OpenAI. I need OpenAI embedding model. Okay, so let me initialize. So here I'm going to use OpenAI embedding model. So if you go to the OpenAI website and if you go to the model section, you'll see that OpenAI also provides lots of embedding model. Okay, so you can use any of them. Now I also need to initialize my vector database. So here I'm going to use FIAS vector database. I already told you. So it is available inside Langchain vector store FIAS. You can also use ChromaDB, Pinecone, Web8. It's up to you. But I'm going to use the FIAS because I need to show you the FIAS as well. Okay, and FIAS is very like fast. I mean than your ChromaDB. Okay, you'll see that it's like very fast, quite fast. Now let's initialize my vector store. See, that's how you have to initialize the vector store. FIAS from documents, and you have to give the documents here, like which document you want to create the embedding. I think remember we created the chunks. These chunks, I think remember. Document answer gen. These chunks I have to pass, and I have to create the embedding. Okay, and I have to give the embedding model. This is the embedding model I'm passing. So this will give you the vector store, and it will save locally, guys. Okay, it will save locally. You won't be able to see that. Okay, it will save in memory actually. And if you want to see that, you can store in the cloud-based, I mean, you can use the cloud vector DB that time. In the cloud, you can save. I think I showed you the Pinecone. There you can see the visualization of your vector. Okay? It's possible. Now let me again initialize my large language model. You can see, again, I'm using GPT 3.5 Turbo large language model to generate my answer, because you can see, I told you, na, the question I'm getting, I'll again pass to my large language model. Large language model will give me the answer. Okay, that's why I'm initializing my LLM again. Now, previously, I got some questions, I think remember. So this is the questions I got. Okay, these are the questions I got. If I show you beautifully, so what I can do, I can split with the help of /n. So it will give me line by line everything. Now this is the question list. See, so this 10 question I got. Now I have to generate the answer of this 10 question. Okay, with the help of large language model. Now for this, let's create a retrieval QA. Okay, question answer, let's say chain, because inside chain we are having different chains. I think I told you. Now I'm using retrieval QA chain. This chain I already used in my vector DB. I think you remember. Let's create it. Now let's initialize my QA chain. So here you have to give the large language model first of all. Now you have to give the chain type is equal to stub because it's a QA chain. Okay. Now you have to give the retriever object. That means your vector store. That means you are connecting with your large language model right now. See, LLM, you are connecting with the vector store. Okay, for this you have to write this code, vector store as retriever. That's it. Now this is going to give you one chain. Now you can give the, let's say, question and you can get the answer. For this I written a for loop here. See what I'm doing, whatever question list actually I'm having, I'm looping through it. That means I'm taking all the question one by one. Okay, you can see, then I'm printing it. Then I'm generating the answer. You can see I'm calling this chain run question. That means I'm giving the question, it will give me the answer. This answer actually I'm also printing. After that, I'm opening a txt file. Inside that, I'm just saving it. Okay, inside that, I'm just saving it. That's it. As of now, inside a txt file, I'm saving it. Going forward, inside a CSV file, I have to save it. Okay, this is the idea. Now let me execute. See, first of all, this is the first question, it is generating the answer. See, this is the answer. Okay, second question, it is generating the answer. Third question, answer. Fourth question, answer. So that's how it will generate for all the questions. Let me show you. See, beautifully it is generating. So we have created one amazing application, guys. Now we have to convert it the modular coding. There's the idea. Now see all the answer I got. And if you read the answer, guys, if you open your text editor and if you read the answer, it's pretty good. It's pretty good. If you see that question and answer, it's pretty good. Now you can use as it is for any kinds of exam, any kinds of interview, you can prepare. It's amazing, right? Okay, so this is the entire, actually, let's say, notebook experiment of our project. Now let's try to convert everything in a modular coding. Modular coding is, I just need to write everything in a function. That is the idea only. Okay, I'll refer the same notebook only. I'll copy paste the same code, but I'll write everything in a function. Okay, there is nothing new I'll be doing. So let's start the modular coding. So guys, now let's start the modular coding. But before that, let me show you this answer.txt. Now see, inside answer.txt, it has saved everything, all the question and answer. But again, it's not readable. So next time what I will do, I'll save everything in a CSV file. In one column, I will add the question. In another column, I'll add the answer. Okay, that would be more readable. So what I'll do, guys, so now let me close everything. So left hand side, I'm going to create a folder and I'm going to name it src. Okay, src, because this is going to be my source folder. Inside that, I'm going to write some helper related function. That means if you open up any kinds of, let's say, real-time implementation of any kinds of package or any kinds of project inside Python, let's say if I open this one, Keras, GitHub, you will see that they have also created this kinds of folder structure. See, this is the Keras. Now Keras is also using this. See, it is having one root folder Keras. Inside that, they are also having the source src, and inside src they have created all the, let's say, utility related functionality. That means whatever functionality they need, let's say activation function, application, backend, callbacks, they're writing everything here and they're integrating in the endpoint. Okay, it is also having some endpoint. See, API gen, this is the endpoint, and they're importing it here. If you open it, any kinds of endpoint, they're importing it here. Okay, this is called actually modular approach. That means instead of writing everything in just one file, we have to create a separate file, separate function, and whenever I need it, I'll just call it, okay, from that particular, let's say, a helper function. This is the idea. So inside src, I'm going to create a file called __init __.py. Okay, this is the constructor file, because this folder would be considered as my local package right now. See, this is the modular concept, guys. This modular concept I already explained in my Python session. Okay, so I think you know. So guys, this is our YouTube channel. So here, if you go to the playlist section, I already created complete Python course. So here I already explained about modular coding, everything. What is this constructor file? What is modular coding? How we can write any function in any other file, how we can import it in the endpoint, everything I have explained. Just try to go ahead and watch that one, because modular concept is required here. Okay, I'm expecting you are already familiar with this kinds of Python concept. Fine. So you can also see the master OP actually playlist. So there also I have covered lots of advanced topic related Python. So that's why I'm creating this constructor file, because this folder would be considered as my local package right now. Okay, and inside that, I'm going to create a file called helper.py, and I'm going to create another file called prom.py. Okay, prom.py. So inside prom.py, I'm going to mention my prompt. So let me show you. So the prompt actually I showed you in my Jupyter notebook. So here I'm going to just define. See, this is my prompt template, first prompt template, and this is my define prompt template. Nothing new, guys. I'm just copy pasting from my notebook only. See, the same prompt I just copy pasted, because prompt is a changeable. Okay, it's a changeable, it's a static one, people can change anytime. So that's why I've written inside prompt let's say file. So user will open the prompt file and there actually they will change, so that they don't need to open the actual code implementation, and inside that they don't need to change. Okay, I don't need to hard code these are the value. That's why I kept this separate entity. I hope it is clear now. Now let me close it. Now inside helper.py, see, whatever code I have written so far, that means I loaded my documents, I performed the chunking operation, then I created the questions. Okay, these are the thing I'll be writing inside a function only. So inside helper, I created two function. First of all, you have to import all the required package you need. I think you remember these are the packages actually I need. I loaded in my notebook. Then I need to load my I need to load my OpenAI API key, and I have to set as environment variable. I think you know, got it right. Now the first function I have written called file processing. Same thing, guys. If I show you the same thing I'm performing here. First of all, I'm loading my documents. I'm adding all the, let's say, content inside one variable. I was performing this one. Chunking operation. First of all, I was doing with the help of 1000 token. Then next time I was doing with the help of, first of all, I was doing the 10,000. Okay, 10,000 chunk. That means one chunk I want to consider as 10,000. Then I was doing for the 1000. That means the same experiment I did here. Remember, same experiment. See, same experiment. I just written inside a function only. That's it. That is the difference only. This is called actually modular approach. You can also create a Python class, but as of now, it's a very, let's say, a small implementation. That's why Python class is not required. But if you see the actually very big implementation, any ML project or deep learning project, you will see that there I've written like lots of class. Let me show you. So inside US Visa, if I open the components, that let's say data ingestion, you can see I've written a class that time. Okay, so class is required because you can see lots of function I have to handle. And whenever you are having lots of function, lots of method, that time you can write a class. But here I don't have actually lots of method. I only have 1 to 2 method. Okay, that's why I've just written directly a function, not a class. Okay, this is the idea. So that's how you have to design your own project, whether your project size is very huge or not. If it is huge, try to maintain the class, otherwise try to maintain the function. This is the difference only. So if you see any kinds of GenAI project, so most of the time actually we create, let's say, inference on top of large language model, we create a RAG application on top of large language model. Okay, that's why the code implementation is not big that much of. But whenever actually I'm creating any ML project, DL project, there actually we are training our custom model. That time actually lots of method we have to handle, very big code base we have to handle. Okay, that's how we need class concept. This is the idea. Now you can see, guys, I will get my object. Okay, object related my chunking. You can see it will give me document question gen. That means after performing the chunking, and document answer gen. Okay, both actually it will provide. So question gen is nothing but you can see I'm converting to the documents this question, whatever questions actually I was getting. So this is the document question gens. That means after converting to the documents, whatever documents I'm getting, this is my document question gen. And after doing the chunking, this is my document answer gen. So this question generation and this document I need for the answer generation. Okay, the same thing I perform in my notebook. I think remember. See, first of all, I was using document question gen just to generate the question. Okay, then I was using document answer gen just to generate my answer. Okay, I hope it is clear. So this function I have created, guys. Now the next function I have created my LLM pipeline. That means I will be using my large language model. I'll be creating the vector embeddings. Okay, so everything will happen inside this function right now. LLM pipeline. First of all, I'm calling the file processing. That means this function inside that whatever file user is giving, this file would be processed and it will give me document question gen and document answer gen. I'm creating my large language model, creating the prompt, both prompt actually. That means my prompt question as well as the refined prompt. Okay, both I'm creating. Then I'm first of all creating load summarize chain. I think remember load summarize chain I was creating. Okay, this one. So it will give me the question. It will give you the question, and I was creating the vector embedding after that. Vector embedding. Then I was creating the vector index. You can see vector index. Then I was creating the retrieval keyword that time. Okay, it will generate you the answer. That means question answer. That means here you will get answer question generation chain and filtered question list. Okay, both actually will get. So these two function I prepared here. Now let me save. Now let me create the endpoint. So here what I will do, I'll create a file. I'll name it as app.py. Okay. Now this is going to be my endpoint. So inside that I'm going to call this function actually, this LLM pipeline. Because inside LLM pipeline, I'm calling my file preprocessing. That's why I don't need to call separately. So let me open it up. But before that, let me initialize my fast API related code. So if you go to the fast API documentation, guys, you will see this is the starter code. That means this is the demo code they will also give you. So these are the library you have to import one by one. Okay. Then you have to initialize the fast API. So how to initialize the fast API, guys? So that's how you can initialize the fast API. Okay. See, this is the code to initialize the fast API. Now here you have to create two folders, static and templates. Inside that you have to create the index.html file. So inside template folder, you have to create a index.html file because index.html file would be your home page. Okay, that means the user interface. So you need some HTML code. Let me show you. I already created. So guys, as you can see, I already created one template folder. Inside that I created a HTML file. Okay, now see inside that I have written already HTML code. Okay, that means my front end part of my application. And how I created, again, I referred that Bootstrap website. I think you remember. I also used the Bootstrap website. If you don't know about HTML code, it's completely fine. You can skip this part. You can use, let's say, any other framework, let's say Streamlit or on. And see, this HTML creation would be done by the front-end developer. As of now, just to beautify this project, I created the HTML, okay, from my end. That's the idea. And there is another folder I created called static. Inside in static, I created two folders called docs and output. See, whatever documents user will upload, that PDF, it will save inside documents folder, and whatever output you will get from the, let's say, application, that means the question and answer in a CSV format, because you can see I've imported the CSV, it will save inside output folder. And from output folder, actually, I will get that particular, let's say, CSV output, okay? And inside documents, it will store the PDF. That's the idea. Now, this is the first API code, guys. First API will handle each and everything. Now, I also need to import this one. That means my LLM pipeline. Let's import. So it is available inside, I'll call it from, let's say, src dot, let's say, helper import LLM pipeline. So it is inside helper. I need to import LLM pipeline because inside helper, I have this LLM pipeline. Okay. Now see, if I am importing like that, from src helper import LLM pipeline, that means src is now considering my local package. And if I want to use src as my local package, what I have to do, I have to create one file called setup.py. Okay, setup.py. So this is the modular coding concept, guys. Again, inside setup.py, you have to write some setup related code. Let me show you. So this is the code, guys. Setup tool. First of all, give the project name, version, author name, author email, package, and install requires. That means this find package will try to find, okay, wherever this constructor file is available, this folder would be considered as my local package. Now you can see constructor file is only present inside src. That means src would be considered as my local package. Now see, if I show you pip list inside my environment, see, src is not mentioned. Src is not a package. Okay, see, src is not a package. But whenever I will install it, whenever I will install this setup, you will see that this src would be considered as my local package. That means there would be a package name called Generative AI project. You can give any name. I've given Generative AI project. Now let me save. And to install it, in the requirements, you have to add one more line called -e space dot. Okay. So this -e space dot will look for the setup.py and it will install this package. Okay, let me show you. Now if I again run, let's say pip install -r requirement.txt. See, this would be installed as my local package right now. Done. Okay, now see, some egg info file would be created. Okay, whenever this egg info file is created, that means this setup is successful. Now if I again open up my environment, let's say pip list. Now see, there is a package it has created, Generative AI project. Okay, now see, it is my local package right now. That means this src would be considered as my local package. Now I won't be getting any kinds of error right now if I'm importing like that. Okay, so this is called actually modular approach. I think you got it. So here, first of all, user will upload one PDF. For this, I have written a function with the help of first API. So this is the function. So there is a route called upload. User will upload one, let's say, file, and this file would be saved inside my documents, inside statics documents. Okay, it will save. Now there is another function I will create called get CSV. That means the complete results. Okay, I want to save as a CSV file. So this function will help me to do that. That means the file actually I'll be receiving here. This file I'll give where in the LLM pipeline. And LLM pipeline, what it will do, it will pre-process. It will create the, let's say, prompt and everything. Then it will give me the that means chain, entire chain. Okay, and that chain actually I will utilize here. You can see. So you can see I'm getting the entire chain, and whatever question list actually I'm having. Okay, question list. I'll pass the question inside my chain, and it will give me all the answer. And this answer actually I'll save inside my CSV file. You can see right row. Okay, CSV writer right row, and with for this actually I'm using CSV package. You can see CSV package. Very simple code, guys. Only have written inside a function only. You just need to go through this code. You will able to understand. Okay. Then I need another function, guys, called chat. So this particular function, what it will do, it will load the output file. That means the CSV file. Okay, and it will show. It will return you. Okay, it will return you. That means you can also see the complete PDF. Okay, in the UI. Let me show you how this application will look like. So now let me execute my first API code. See, this is the first API code. If you can run app, this is the local host and this is the port number 8080. Okay, now let me save and now let me execute. So I'll open up my terminal. So python app.py. Now see, it is running. Let me give the allow permission. Now I'll go to my Google Chrome and here I'll search for localhost 8080. See, this is the user interface, guys. Okay, now here you can upload a file. First of all, let's say I'll upload this file inside data. Let's say I will upload this SDG. First of all, this sustainable goal development, And here I'll generate the question and answer. Let's see. It is generating. This is the user interface we created, basic user interface. Now see, it's loading. And how this loading is happening, animation is happening, because I written everything inside HTML code. So guys, you can see I got the output. Now left hand side you can see it has rendered my entire PDF. Okay, the PDF I uploaded, and right hand side it has given me the CSV download. And now see, if I click here, it will download the CSV file. See, QA CSV. Now let's open the CSV. How I can open? Let's open it here. So I'll open it. See, this is the CSV. I don't have Excel right now, guys, in my system. That's why I've opened in a VS Code. You can see this is the question, this side, and that side actually I have the answer. You can open in a Excel viewer. You will see that it's a beautiful format I have just stored. Okay, so that's how actually things are happening. Okay, now I think you got it. Why we have written these are the function. So this function will help you to render your PDF documents, as well as it will give you the download option. Okay, to download this particular PDF. Now let's upload another PDF. Let's say I will upload this statistics one right now. Now let's generate again. So guys, as you can see, I got the results, and this is my PDF I uploaded, and let's download the QSCSV as well. See, this is the correlation answer and question I got. Fine. So yes guys, this is the project actually. I hope you liked it, and this is like very interesting project, guys. If you develop it, you'll feel like it's like very interesting. Going forward, we'll be also implementing lots of projects, no need to worry. So in the next video, we'll be implementing another amazing project, very interesting project called Chatbot for any website. That means, let's say I think you saw website chatbot. If you go for any kinds of website nowadays, they're having their chatbot integration with that. Okay, so if you ask, let's say, some question related about the website, about their, let's say, product and service, it will able to give the answer. So that means they're replacing the human behind it. Previously they used to, let's say, use one human. They used to receive the chat, they used to give the reply, but nowadays they have added the chatbot there. Chatbot can handle all the answer. If you go to any of the website, you will see that. So we'll be implementing these kinds of application. That means the custom website chatbot, it will only work based on our website data, not any other, let's say, question and all. Fine. This is what actually we'll be implementing, and this is kinds of RAG based application we'll be creating. Okay, that means we are using our custom data. On top of that, we are adding our, let's say, like a large language model. Large language model will try to refer that data to provide you the answer. Fine. So in this implementation also, I'm going to use Langchain large language model. Even we'll be also using something called vector database. Okay, with the help of that, actually we'll be implementing this entire application. But see, this application would be a little bit advanced, because here we'll be creating something called RAG based system. Okay, like retrieval augmented generation. This is the basic RAG. So here we'll be using our custom data. So custom data wise, actually we're going to use our website data. That means we'll be giving some website, okay, website URL. So my Langchain will automatically fetch the information from the website itself, and this data actually I'll give to my large language model. That means my LLM would be connected with this data, and if you're asking something related about this website, okay, it will give you the answer related that. Okay, so this is the application we'll be implementing. So first of all, let me show you the architecture, like how we are going to develop this project. Then I think this part will be clear. So before showing you the architecture diagram, guys, let me show you one thing. So let's say if I want to open any kinds of website, let's say I will open this openai.com. Okay, this one, openai.com. So this is the openai.com website. Now see, if I want to see the, let's say, XML page of this website, so what I can do, I can give this particular, let's say, route here. So slash sitemap, sitemap.xml. So if you open any website and if you give slash sitemap.xml, it will show you the entire structure of the website. Let me show you. So guys, here you can see, this is the page actually I got. Now see, inside openai.com, okay, inside openai.com, whatever, let's say, content you are having, whatever content, whatever sub pages you are having, all the information is coming here. You can see, if you just see it carefully, so it is having different URL, okay, different URL for the different tab. Let's say research, for research actually it is having one URL. For GPT 4.0, it is having one URL. For safety, company, see, company I think I saw here. So see, this is the company one. Okay, this is the company one, you can see. Okay, company one. So I think I showed you the company. So see, this is the company URL. So that means it is having all the information, all the data, whatever content you can see in this website. Okay, everything is visible now in this XML page. Now what I have to do, I have to use this concept to extract the data. That means I'll be using LangChain data loader. So inside LangChain, actually, we are having website loader. With the help of that, we can easily load these at the content. So I'll tell you how we can extract the information. So this is the things actually we'll be doing. Now let me show you the architecture diagram, what we are gonna perform here. So let me open up my Blackboard. See here, first of all, I told you we'll be using website URL. Okay, website URL. So from website URL, what we'll do, we'll just get this sitemap, sitemap.xml. Okay, this page. And from this page, actually, we'll be getting different sub pages as well. Let's say page 1, then page 2, page 3, okay, and so on. That's a multiple page actually we'll get from here. Now what I have to do, from each and every page, I have to extract the documents, that means the data. So it should be docs1, let's say docs2. Then after getting all the documents, we'll be using one embedding model. I think you know why embedding model, because I have to convert all the documents to the embedding representation. Okay, so I'll pass all the data to the embedding model. Okay, and embedding model will try to return embedding, vector embedding. So you will get different vector embedding, let's say 0.2, 0.3, 0.5, and so on. Let's say these are the vector representation as of now, just try to consider. Then with all the embeddings, what I have to do, I have to create one semantic index. Okay, semantic index, I think you know, build semantic index. Okay, build semantic index. Then this semantic index, that means this embedding, I will store where? I will store to the vector database. Let's say this is my vector database. So in this case, actually, I'm going to use FIAS. You can use any other vector DB. Let's say this is vector database. Okay, I'll be using FIAS. You can use anything. You can use, let's say, ChromaDB. You can use Pinecone. I'll tell you how to use Pinecone ChromaDB. Later on, I will also tell you. Now, what will happen? So user will ask question. Okay, user will ask some question about the website. And this vector DB will return some ranked results. Okay, I think you know what is ranked results. Ranked results. Okay, rank results I'll get. But what I have to do, I have to initialize my large language model, because with the help of LLM only, I'll be able to get the correct response. So what I will do, I'll pass this rank results to my large language model as well as this query also. Okay, and this LLM will give you the actual response. Okay, actual response. So this is the complete idea. Okay, this is the complete architecture of our application. Okay, and this is called actually RAG. Okay, RAG. That means retrieval augmented generation, because here we are integrating our custom data. Okay, and we're integrating our large language model with that data. That means this is called actually knowledge base. Okay, knowledge base right now. Okay, entire knowledge base. So now let's open up our Collab notebook and try to install everything, and let's implement this project. So guys, as you can see, I open up my Collab notebook. So first thing, just try to change the runtime. So here runtime, just keep it as CPU only, because here we'll be using OpenAI model. But if you want to use, let's say, any other open source model, that time you can use GPU. Okay, that time. So as of now, let's keep it CPU only. So later on, I will also show you how we can use a new open source large language model. Okay, now let me connect this notebook. So here, first of all, you have to install some package. So you can see I'm installing LangChain, LangChain community, PyPDF, then a sentence transformer, okay, OpenAI, TikTok, and these are the things. So these are my dependency package actually I need. So let me install all of them. So some of the package actually you don't need. I just written additionally, because later on this project, I will show you how we can implement with the help of open source large language model. Okay, that time actually this sentence transformer is required, because if I want to use any, let's say, open source embedding model, that time this is required. So as of now, let's install everything. Then apart from that, I also need to install some more packages. So TikTok and Fire CPU and unstructured. Let's say if I want to load the website now, website data, that time I need this package unstructured, because it's unstructured data. And again, I'm going to use Fire's vector database. Okay, that's why Fire CPU I'm installing. So let me install all of them. Then I also need to install NumPy and NLTK. Okay, so let me install, because these are some dependency packages. If I want to extract the information from the website, so LangChain needs, these are the dependency. Okay, so that is why actually we are installing everything. Now see, after installing this NumPy and LTK, it will tell you restart the session. So let me restart the session. So it will restart the session. Then after that, we'll be importing all the necessary library we need. You can see I'm loading unstructured URL loader from Langchain. So with the help of unstructured URL loader, we'll be loading this data. Okay, here we'll be giving the URL, website URL. It will automatically extract all the information. And we'll be performing the chunking. For this, we are using character text splitter. OpenAI embedding will be using just to convert my data to the embedding representation. We'll be using OpenAI large language model, GPT 3.5 Turbo. That's why we are using OpenAI. Fires, this is the vector DB, retrieval QA with source chain. That means it will create the QA object. That means the chain object. Okay. And Huggingface embedding as of now, I don't need. I'll just try to remove it. Okay. Later on, I'll tell you how we can use the Huggingface as well. Now let me import all of the packages. So it's working fine. There is no error. Now let me download this two thing like PUNKT, and you have to download another thing, average perceptron tagger. Okay. So this one you have to download from the NLTK. So let me download. Then after that, I will set my OpenAI API key because here I'm going to use OpenAI large language model. Definitely you need the key. Now I'm going to pass different website URL. So now you can see I have just collected different website URL. Let me open all of them. Let me show you. So these are the website actually I'm going to refer. So this is one blog website, Medium website you can see, and the content about paper review, Llama 2, Open Foundation, fine-tune chat model. Okay. Now if you just read it, you will see lots of content related Llama 2. Okay. Now there is another website, Databricks I'm using, introducing MPT7B, a new standard for the open source community usable LLM. So this is another large language model. Now you can see the information is written about this large language model. That means we'll be extracting these are the data and we'll be creating one chatbot. It will provide, and that chatbot actually will be able to give the answer related. These are the topic. Okay, the topic actually you have created. Let's say Llama 2, then MPT7B, then stability.ai. Okay, so this is another website. Then you can see Vicuna. So this is another website. Okay, so these are the information actually I want to see. So I have given all the website link. So here you can pass any kinds of website link. You can pass any kinds of website link. Let's say you have one website, your own website. You can give the website link here. So this will automatically extract your website information and you can create your website chatbot. Okay, on top of it. This is amazing. Now let me initialize the URL. So it supports actually multiple website URL. It's not like that it only supports one URL. No, multiple URL you can give here. Now let me extract the documents with the help of unstructured URL loader. Inside that you have to pass all the URL and it will automatically extract all the information. Let me show you. Now if I print the data, all the information it has extracted from all the websites. See, okay, amazing. Now if I show you the length, you'll see that 4 documents it has written. Why 4 documents? Because I have given 4 website. 1, 2, 3, 4. That means 4 website information I'm having right now, and this is in the document format. Got it? Because I already told you if you're loading anything with the help of Langchain, that should be document format always. So now I think this part is clear. So we have extracted the content successfully. Now what I have to do, I have to create the chunks. Okay, I have to create the chunks, different chunks. You can see these are different chunks. So I think I forget to mention this chunking here. So it should create a chunk. Okay, chunk. Okay, all the chunks. That means it will create all the chunks. These chunks actually I'll give to the embedding model. Okay, now let me create the chunk here. So to create the chunks, actually I'll be using character text splitter. See, these are some repetitive code. Again I'm using. Previously I also already taught you what is character text splitter, what is chunk size, what is chunks overlap. Everything I taught you, even in the vector database session. So this is very much important session, guys. Just try to complete that session first. So you can see character text splitter, separator is equal to /n, because you can see /n is there. Okay, sometimes. So slash would be the separator. So here /n would be the separator. It will separate by /n. Now chunk size 1000, chunks overlap 200. Okay, now let me create my text splitter. Now inside that I'm going to provide my data. Now it will give you chunks. Now let me see how many chunks I got. So here I got 86 chunks. If you want to see them, simply just print like that. Let's say I want to see the first chunks. This is the first chunks. Let's say I want to see the second chunks as well. I can also see that. See, second chunks as well. And you can see it is also giving me the source URL, like from which URL it is giving you the data. Okay. Now we'll be initializing the embedding model, because you can see the architecture. Now I have to download the embedding model. Then I have to convert everything to the embedding representation. So let's use the OpenAI embedding. Now let's test whether it is able to convert to the embedding representation or not. So here I'm calling the embedding model and I'm passing one sentence, hello world. So it should give me the embedding results. Let me show you. And the vector dimension is 1536. Okay, this is the dimension. Now if I show you the numerical representation of this sentence, so this is the numerical representation. That means this is my vector embedding. Okay, so we'll be following the same concept. Now let me convert my text to the embeddings. But for this, actually, I'm going to use FIAS vector database, because whatever embeddings I'll be generating, I'll store in the FIAS. Okay, FIAS vector database, and FIAS is a local vector database, I think you know. So here I'm giving my text chunks and my embedding. Okay, embedding model. Now guys, see, this is my semantic index right now. Okay, this is my semantic index. That means my vector index right now. Okay, now what I have to do, I have to connect my large language model. So let's initialize my large language model. So here I'm going to use OpenAI large language model. By default, it will use GPT 3.5 Turbo. Now let's test our large language model, whether it is able to generate or not. So here I've given a prompt. Please provide a concise summary of Harry Potter book. Okay. Now if I execute, it should give me the summary of Harry Potter book. See, this is the summary of Harry Potter book. Okay. It has given me. Great. That means it is working fine. Now with the help of LLM as well as my vector database, I have to create my chain. So for this, I'll be using retrieval keyway with source chain. Okay. I think I already imported from the LangChain. And inside that, I'm passing my large language model as well as my vector database. Okay. And this will give me the chain. Now inside chain, actually, I can ask any kinds of question right now. See, question is equal to how good is Vicuna. So here I'm asking related Vicuna. Okay. This particular Vicuna. So Vicuna data I have already given to my large language model. I think remember, it is already available inside my knowledge base. Now it should give me the answer. Okay. Let's see. Okay, now if I want to see the answer, so I'll just call result. Inside that, I want to only extract the answer. Okay, now let me show you. See, Vicuna has shown competitive performance compared to the others model like Stanford Alpha. Okay, that means if you read it, okay, if you read this documentation, you will see that that is what actually they're telling. That means amazingly, it is able to give me the answer right now. Great. Now let's ask any other question. Let's say the next question I'll be asking about Llama 2. Llama 2, how does Llama 2 outperforms other model? Okay, let's ask this question, and whatever answer I will get, I'll also print it here. Now see, Llama 2 model outperform other models in various categories, including MPT models and similar size and so on. Okay, now see, it is referring the Llama 2 right now. Yeah, Llama 2. Great. Now let me ask another question. So I'll be asking about MPT, this one, MPT 7B model, and whatever results actually I will get, I'll just showcase it here. See, again, I got the amazing response. Okay. Now see, it is referring my website data. That means my custom data, not any other data. Okay. This is the main thing here we have developed. Now, if you're asking any other question, let's say, tell me about India, it won't be giving you the answer, because here we have created the custom chatbot. It will only refer my data, the custom data I have given. Now here I can create a while loop and I can continuously ask the question. Okay, so you can see I'm taking the prompt from the user, and if it is exit, I'll do the exit operation. Otherwise, I'll continue and I will keep on asking the question and it will generate the answer. Okay, let me show you. See, it is asking the question. So what I can give the same prompt again, copy, and here I can pass, and let me press enter. Now what you can do, guys, you can convert this project to the web interface. That means web application. I think I showed you how we can use different let's say Python package like Flask, then Fast API. So this should be your task, guys. Try to create one web application, at least basic web application. Their user will give the prompt and it will provide the answer. Okay, that's it. Now see, it has given me the answer. Okay, now again it is asking another question. Now let's say if I give exit, it will exit the application. Sorry, it should be exit only, but I have given exit parenthesis. Now see, if I'm giving this prompt, it is telling that text provided does not seems to be relevant to the questions. Now see, this question actually doesn't have any context, whatever knowledge base it is referring. That's why I told you it won't be able to give you any other information. Now if I give exit right now, it should exit the application. See, okay, so that's how we can create any kinds of custom website with the help of our custom data. Now what you can do, you can open up any kinds of website and you can implement this project, guys. Okay, and later on I will also tell you how we can use the open source large language model. Okay, and with that, how we can create this application. So with that, guys, thank you so much for watching this video, and try to complete that task. Try to convert this application to the web interface as well. So guys, as of now, we have worked with OpenAI based large language model, which is nothing but GPT. Okay, so we have seen like how to use GPT series to build this kinds of generative AI application. And one thing I think you have seen there, like GPT is not free, so you need to pay for it. So whenever you are using OpenAI API, you need to pay some money, okay, for that. But let's say if you don't want to spend this much of money here, so what you can do, you can use something called open source large language model. So in the market, actually, we have lots of open source large language models are available. So if you are using it, so you don't need to pay any money for this. So you can directly use them, and it is completely open source and for commercial use cases as well. You can either do research on top of it. You can either create a commercial application on top of it. It's completely free for you. Okay. So in this video, actually, I'll be discussing about like open source large language model, like what is open source large language model, okay, and what are the open source large language model we have, and from them actually I'll be discussing some of them, like most popular used open source large language model, and it is like very powerful, okay. And I will also show you how we can like build generative AI application with the help of these kinds of open source large language model, okay. So it would be completely amazing video, so make sure you are watching this video till the end. Don't skip any part of this video, otherwise you might get confused for sure, right? So yes guys, let's start with our video. So guys, here we'll be learning like most used and most popular very powerful large language model. Here you can see we have Meta Llama 2. So this is the model from Meta AI. I think you know, like we also call them Facebook. So they have introduced this model called Llama 2. It has another version called Llama 1, but Llama 1 is for like research purpose. They have given the permission, but you can't use Llama 1 for the commercial use cases. So for this, actually, they have open sourced this Llama 2 model. So you can either do research on top of it, either you can create commercial application. It's completely fine. Then from Google side, we have another large language model called Google Palm 2. So this is one of the very powerful large language model, okay, and it is completely open source and free. Then we have another like most used large language model called Falcon. So Falcon has lots of variant. I'll show you like whenever I'll be discussing like Falcon, I will tell you like what the variant it has actually. So it has different parameter variant, okay. Even Meta Llama 2 has different variant, okay. I will tell you whenever I will discussing about this Llama 2 and all, okay. So these are the most used and most popular large language model. I'll be discussing like how we can use it, okay, and how we can create generative AI application on top of it. I will be discussing each and everything. So apart from that, we have lots of large language model are available in the market, and it is completely open source. So guys, I found one GitHub repository. So there actually that guy collected lots of open source large language model list, and he has created one readme file there. So I'll show you that one, like what are the open source large language models are available in the market. So if you also want to explore that one, you can also go ahead and check it out, okay. So if you learn like how to use Meta, Llama 2, Google Palm 2, Falcon, okay, you will also able to do that, okay. So guys, as you can see, this is the repository, and the repository name is like Open LLMs. And here if you see, we have lots of open large language model are available. You can see T5, EUL2, then Pathia, Dolly, okay. Then here you will see like Bloom is there, then Fast Chat, then MPTP 7B. This is the 7 billion parameter. Then Falcon, I will be discussing about Falcon. So as you already saw, like in my topic, I will be discussing about this Falcon, okay. So even that, actually they have also shared this paper, blog and everything, okay. If you want to learn, you can open it, and all these steps actually will be getting. Then Llama 2 is also there, okay. Then Mistral 7B also there. Then Google Palm is also there, okay. So here actually we'll get all kinds of open source large language model, okay. And if you see here, it was committed 4 days ago, so it's like very update repository. So here you can check it out if any large language model is coming in the market. So here actually will get all the list and all. And apart from that, you can also search from your side. Let's say if you are exploring any other topic and all, so you can search and you can learn about, okay. So yes guys, this is all about our large language model, open source large language model. I think you got it, okay. So guys, we don't only have the option using like you can say OpenAI GPT model. Apart from that, we have these kinds of open source large language model we can utilize, okay. So I personally prefer this kinds of open source large language model because this is like very powerful. So it can also work like your GPT 3.5 turbo, okay. So it's like very powerful model. So using these are the model, actually you can solve a very complex problem statement. Even you can create a very beautiful generative AI application. So why you need to pay, right? But if you also want to pay, because see, GPT is like very good model, I know that, but again it's like completely hosted like API. So you can directly call the API, you can hit the model, you can get the response. So this is the beautification they have created in their website. But apart from that, let's say you don't have money and you don't want to spend money on top of these kinds of model, so you can use these kinds of LLM model and you can create your application on top of that. Even you can also fine tune them. Okay, so this is the beautification of these kinds of large language model. So in future I will also show you how we can fine tune these kinds of large language model on top of our custom data, on top of our custom use cases, and how we can use it. Okay, so fine tuning is not required unless and until your data is like very complex and it is like very private data. So that time you can fine tune them, but most of the use cases can be solved using these are the model. Okay, so yes guys, now let's go back and try to see like what are the things actually we'll be learning from this video. So guys, in this video actually I'll be discussing like the introduction to Llama 2, like what is Llama 2 and all, like who has published this Llama 2, like what are the variant actually Llama 2 has and all. Then I will show you like how we can run this Llama 2. Okay, I'll show you like some difficulty level, like how why we can't use the actual Llama 2 model, okay, hosted from Meta AI. So which model actually I'm going to use it, so how to execute this Llama 2, okay, I'll be discussing about on Google Colab, because you can also do it in your local machine as well, but I will do on Google Colab because Google Colab would be pretty much good environment for me, because there I will already have lots of predefined library setup, right? Then I will show you like how we can use this Llama 2 with Langchain, because nowadays actually people uses this Langchain's framework, okay, to create generative AI application. So I'll also show you how we can use the Langchain, okay, with this kinds of Llama 2 open source large language model. And at the end of the video, I will also show you how we can build generative AI projects using Llama 2. So there actually will be implementing one project, so very interesting projects, okay, with the help of this Llama 2. Even I will be using Langchain there also, okay. Then we'll see like how we can integrate open source model with this kinds of framework Langchain, then how we can create these kinds of generative AI projects. So it would be completely end-to-end video about this open source large language model. Okay, you'll be learning each and everything about open source large language model, like you will be knowing each and every part of this Llama 2 and all. So make sure you are watching this video till the end. So this should be my request guys, and also try to practice with me, okay, in live. Whatever things I'm writing, you just also try to write with me. Even all the code and everything will share in the resources section. From there actually you can get it. So first of all, let's discuss about Llama 2, and in the next video, I'll be discussing about Google PAM and Falcon. So guys, if you search on Google like Meta Llama 2, so you will able to see this website, the first website, okay. So this is the website of Llama 2. So here actually they have published this Llama 2 documentation and all, like how we can use it and all. And this documentation will give you the entire idea about Llama 2, like what is Llama 2 and how many variants actually it has, okay. Even the benchmark also you will able to see. So guys, here if you see Llama 2 is nothing but it's a next generation open source large language model, and Llama 2 is available for free research and commercial use cases, as I was discussing about. And if you want to access this Llama 2, so they have given the link here. So here actually you need to fill some information like your name, email address, then country and organization. So these are the basics form you need to fill and you need to submit. So after some time actually they will give you the permission, because see, you can't directly use this Llama 2 model. So for this you need to send some information of you. Then after some time actually they will give you the permission. Okay, I also applied this request form. So after let's say 30 minutes or let's say 1 hour, you will get the access for sure. Okay, so I will also show you one alternative. So if you want to do it right now, so one guy actually cloned this complete Llama 2 model, okay, in his you can say Huggingface repository, and it is completely public. Okay, so you can use that model if you're not getting permission. And once you got the permission, you can use official version of the Llama 2 model. Okay, so I'll show you like both option how we can do it. So for me, I already got the access from this Meta, so they have given me the access. I'll tell you like how to apply for the access and all. Okay, so as of now the experiment actually I'm going to do, like how we can execute this Llama 2 model. I'll be using something called quantized model, because the actual like Llama 2 model you can't execute on Google Colab, on free Google Colab. So for this actually you need good instance. Okay, like good instance means like you need powerful machine, you need more RAM, okay, you need more memory there. But if you are using free version of Google Colab and if you're using your local system, so there actually you can't load this model, so it would be very hard for you. So better we'll be using some quantized model. I think you know what is the quantized model. So quantized model is nothing but it's a quantized version of the actual model. So they have just compressed the model, okay, with the integer encoding, and they have proposed this model, and this model size is a little bit less, so we can load this model in our memory, okay, in very easily. I will tell you like how to use a quantized model and all. Okay, So guys, here if you see, Llama 2 was trained on 40% more data than Llama 1. Okay, because I told you there is another model called Llama 1 and Llama 2 trained here Llama 2 trained actually more than 40% data than Llama 1, and it has actually double context length. So, basically the context length is like double, okay, than your Llama 1. And see, these are the Llama 2 variant. Actually Llama 2 has 7 billion parameter, and another variant has like 13 billion parameter, and another variant has 70 billion parameter. And this is the pre-training token, you can say. So they have used true trillion token to train this model. And here if you see, this is the context length, so it's 4096, but whenever I was talking about Llama 1, so it has actually 2000 something context length, but it is like double, okay, double than your Llama 1. And this size is around 4096. And here if you see the training strategy, so they also use supervised fine-tuning technique on top of it. Then they also use something called human preferences. I think you know like how we can train these kinds of large language model. Okay, what is the idea and all about? Basically this is the strategy we follow in every large language model. Okay, then they have applied something called reinforcement learning to understand the human input, to understand the human you can say prompt. Okay, so they have used this strategy to train their entire model. And Llama 2 pre-trained models are trained on 2 trillion tokens. Here I already discussed, and have double context length than Llama 1. Its fine-tuned models have been trained over 1 million human annotation. Okay, so 1 million human annotation means they have applied this supervised fine-tuning technique. So they have created one chat use cases. So basically, see, whenever I'm giving any input, let's say just fix this code for me, or let's say generate you can say a Python code for me. So these are the chat actually I'm giving. So with respect to that, actually, what is human annotation? Human annotation means like see, whenever you are giving this kinds of prompt, so one human will be replying the actual thing here. Okay, that's how your model will be learning. Let's see, if you're giving any random message, let's say hi, how are you, fine, okay, and all. So one human will chat with you, like manually they will chat with you. So we call them human annotation. And with the help of this data, actually we train our actual model, and we create these kinds of very powerful large language model, right? And this is the benchmark, as you can see. So here we have lots of model. We have MPT 7B, then Falcon 7B, and we also have our Llama 2 7B 13B, and we also have 65B and 70B. Okay, so here we see these are some benchmark data, and this is the performance of the model. As you can see, MPT 7 billion, this was the accuracy, 26% accuracy. And here if you are using Falcon, so 26.2% accuracy. And if you're using Llama 2 7B here, so see, accuracy is like very much increased here. It's around 45.3% of accuracy. And if you're using 7B, that sorry, and here if you're using 13B, that means 13 billion parameter version of the model. So here this is the accuracy, 54.8% of the accuracy. And here if you're using MPT 30 billion, so this is the accuracy. Then I mean, it's like less than your Llama 2. And Falcon 40B actually will give you 55.4%. And if you're using Llama 65 billion, so 63.4%. And Llama 7B, like very good accuracy here, 67.9% of accuracy. Okay, so with respect to that, you can see this is again another data. So this is like MMLU data. So this is trivia QA data. This is natural questions data. So you have lots of benchmark data. With respect to that, these are the model has been trained, and this was calculated the accuracy. Okay, and this is the complete benchmark table. Here you will see all the performance of the model. Okay. And guys, if you want to test this Llama 2 model, so here there is a one UI has been published here. If you see on top of the Llama 2 model, so if you just write www.llama2.ai, so this is the chatbot actually you will able to see. So this is kinds of chat GPT kinds of interface they are providing, and in the backend actually they are using Llama 2 model here. If you see, so you can select Llama 2 model, different model. So by default it is selected Llama 2 7 billion. So let's select this one, Llama 2 7 billion parameter, this model. And you can also give the your system prompt here. So let's take this prompt only. And the temperature you can also select. Let's say if this temperature is close to 0, that means this model would be more strict to the output. So it won't give you any randomness. And if you set this temperature as close to 1, that means your model will be like more random. So it will give you like more random output. Okay, and if you want to make your model like more generalized to randomness, so you can increase this parameter to close to 1. and this is the max length, like how many output you want from your model and all. So you can set this parameter and all, and this is the top probability score and all. Okay, so here you can write your custom prompt as well. Let's say here in this case I'll be doing chat operation with this Llama 2. Here if you see chat with Llama 2, you can also set this prompt as summarization, let's say code generation, anything you can do. Okay, so you need to just change this prompt. I think you know what is prompt and all, so this thing is very common, okay, in LLM and all. So you can give the prompt here. So let's take this Llama 7B parameter, this model, and let's do some chat with this model. So here first of all, let's say I will just write hey, or let's say hi. So here if you see, this is giving me the response. Okay, now here I can ask like what is the library we can use to build Gen AI application. I'm just giving any random question. Let's see whether it is able to uh, answer or not. So here if you see, it's giving different answer, okay, with respect to the question I have asked. Now let's say here I can also give any error of my code, and if I tell it actually just try to solve this error. So let's say I was trying one OCR code here. So this is the error actually I got. So let me show you the error. So guys, this is the error actually I got here. So could not find the version satisfied the paddle. Okay, this is the error I got. So this error actually I will ask to this Llama 2, and let's see whether it is able to fix or not. Here I will just write fix it. Okay, if I just write fix it, now let's see what happens. So guys, see, it is giving me the response, and it's telling like install this version of this paddle. Okay, and you can also use some third-party GitHub to build this setup tool and all. So it's giving all kinds of possibilities, like you can try, you can get this suggestion and you can try and you can solve this error. Okay, so Llama 2 is telling actually this model is like more powerful than GPT 3.5 turbo model. Okay, because see, I already used this Llama 2 model, and what I feel like, yeah, this model is pretty good than your GPT 3.5 turbo. If you're using GPT 3.5 turbo, you saw like lots of task actually it won't be able to solve in a good way. But if you're using Llama in this case, Llama 2 in this case, actually it can solve like various kinds of tasks. Okay, so this is the playground you can play with this Llama 2 model. You can select different version of the model, and you can play with this model, all kinds of question you can ask, and you can realize like how powerful this model it is. Okay, so yes guys, this is all about our Llama you can say introduction and all. I think you got it, like what is Llama 2 and all. Okay, the basics overview, you got it. Now I will show you like how we can use this, how we can run this Llama 2 model on the Google Colab. So guys, for this actually I already prepared one Google Colab notebook for you. As you can see, this is the Google Colab notebook, and here we'll be learning like how we can execute this Llama 2 model on the Google Colab. So as I already told you, we can directly load this Llama 2 official Llama 2 model from the official Llama. You can see this Llama 2 is available on this Huggingface. So from Huggingface itself, actually you can see this Meta AI Llama. Okay, and this is the Llama 2 model. This is the original Llama 2 model, official Llama 2 model. It is hosted on Huggingface. From here actually you can load this model, but this model actually I can't load in my free Google Colab. For this actually you need good instance, good memory, good GPU and all, but here I'm using free Colab, that's why I can't load. And you can also load this thing in your local machine. Okay, so for this actually what you need to do, you need to use something of quantized version of the model. So again, Huggingface also provides like quantization model. So some of the actually organization have already applied this quantization technique, and they compress, these are the actual model, and they hosted on the Huggingface community. So here if you see, we have like various kinds of quantized model. Here if you see, so these are the quantized models. So this is the, so here guys, if you see, this is the ggml format of quantized version of the model, and if you see like lots of model are available. Okay, so from this model actually I'm going to use one particular model. So this is the model link I have given, just let me open it. So the model name is Llama 2 13 billion chat ggml. Okay, ggml is the format of quantization, and this is the organization. So this organization has quantized this model. Okay, and it is published here. Now this model is like more like a small model, okay, than your actual Llama 2 model, which is published on Huggingface. This model actually you can easily load in your free Google Colab. Okay, or if you're using your local system as well, you can also load there. Okay, and this model has lots of variant here. If you see, the bin means this is the model. Okay, this is the bin format of the model, that means binary model. So from these are the model, I'll be using one particular model because these are different quantization, you can say, format. So I'll be using one particular quantization here, and this is the size of the model. As you can see, this is the size of the model, and after applied quantization, this size has been reduced. Because what is quantization? Quantization means all the weights you have in the model, by default it would be floating number. Okay, but if you apply quantization on top of it, it would be converted to integer and your size would be reduced. Okay, your model size would be reduced automatically. So this is the idea of quantization model. So here your accuracy might decrease, but again, you are like getting the faster model here, you are getting the smaller model here. So this is the idea. Okay, and if you want to use actual this meta llama, or that means this llama 2 model, so here actually you need to get the permission. You can't directly access this model. So let's say if I open this link in a different, or let's say incognito window, so you will see it will ask for the permission actually, because I'm using my account there, so that's why you can't see the permission. Now see here, if you see access to access llama 2 on Hugging Face, so here first of all you need to log in with this website. Okay, if I click on this login, so it will ask for just logging with your Hugging Face. So here you need to first of all log in with your Hugging Face. Let's say I will log in with my Hugging Face here. Okay, now see here I have already logged in, that's why it's telling like permission granted. But for you actually it will show like you need to apply for the access. Okay, so whenever you will apply for the access, so it will give you that form. I think you remember, it will give you this kinds of form. So you need to fill this form. Okay, and you need to select all the information. So you can select like which model you want to use. So you can select both of them and you can just send the request. Okay, so after some times you will receive one mail like that. So after some times actually you will see one mail like that. Let's say I applied for this access. So this is the mail I got. So hi puppy, this is let you know that your request to the access model Meta Llama 2 on the Hugging Face has been accepted by the author. Okay, so once you got the access, then you will able to see this kinds of window here. This kinds of window here, gated model, you have the granted access to this model. Okay, but initially whenever you will be applying, so it will take some time, at least 1 to 2 hours, then it will give you the access. But if you want to try okay this model, so again I will tell you another option, because this model is available on the public repository as well. Okay, because see in Hugging Face we have two kinds of repository. One is like organization repository, that means private repository. If you want to use private repository, so you need to like take the permission from the author, and one like you have like public repository. So in public repository actually you will have the access to the model. You don't need to take any permission from the author, they will by default provide the access and all, so you can directly use that. So one guy actually cloned this entire model and he has published from his account here, and I will be using that model. Okay, same model only, but this is the unofficial and that is the official one. Okay, I'll tell you like whenever I'll show you like how we can use this Llama 2 model with the help of Langchain. At that time I will show you like how we can use it, but as of now let's try to run this quantized version of the model. As I already told you, I'll be running this quantized version of the model, which is nothing but this model. If I show you, this is the quantized of the model. Okay, and guys, Meta AI actually also provides like different version of the Llama 2 model, as you can see. So we have 7 billion, we have 13 billion, we have 70 billion. So in this case, actually, I'm running this 13 billion. So you can't execute this 13 billion in your free collab. That's why we are using quantized version of the model. But in our next experiment, so whenever I'll be using Langchain over there, so I'll be using this 7 billion parameter model, and this model actually you can easily load in the Google Colab or your local system as well. Okay, so for this model I'll take the permission, and see guys, these are the model are hosted. Now if you see, these are the model are hosted from the Llama 2. As you can see, chat model, HF model, I'll tell you like whenever I will be using these are the model, I'll tell you. So yes guys, this is all about. Now let me just quickly show you like how we can execute. So see, to execute like quantized model, you need one library called Llama CPP. Okay, so this is the library actually you need to use. Llama CPP is a library. Actually, this library helps you to make the quantized of the model. Okay, and if you're using quantized version of the model, you need to install this library. So first of all, I will connect this notebook. Now make sure you have selected runtime as GPU. So just click here and click on manage GPU. Sorry, not here. Just click on the runtime and select here you will get one option called change runtime type, and I have already selected GPU here. So now if you want to check whether you got GPU or not, so you can execute this command, and here you will see I got Tesla T4 GPU, and it has actually 15 GB of like VRAM. Now here, these are the requirements actually you need to install. So first of all, I'm installing this one, Llama CPP library. Okay, and this is the command to install everything. And here I'm also installing Huggingface Hub, because from the Huggingface itself, I want to access this model, because see, this model is hosted on Huggingface, and if you want to access any Huggingface model, so you need to install Huggingface Hub. And here I'm also installing llama 2 cpp python. Okay, so these two commands actually you need to execute to install llama cpp library. Then I also need numpy with this specific version. Now let me execute. So guys, as you can see, my installation is done. Now here you just need to give the name of the model, like which model you are using. So here, this is the model I'm using. Just copy this name here, and here you just need to paste it. Okay, so I've just given this name here. Now here you also need to specify the base model name, like which particular model you need to use. So here I'm using Q5.1.bin model. So if I go here, so it has lots of variant, I already told you. So here I'm using this Q5 this model actually, I think. Let me just see. Q5_1.bin, Q5_1.bin. Yeah, so this is the particular model actually I'm using. So you can use any model, no issue with that. So I'm using this model, and this is the size of the model. So I'll be executing. So you need to give the same name. Just copy paste from here and just give it here. Now once it is done, now so here first of all I'll be importing one class called hf hub download. That means Hugging Face model download. So this class will help you to download any particular model from the Hugging Face. First of all, let me import. Then I also need to import this llama from llama cpp library, because we have already installed this library. So let me import it. And if you're not using quantized version of the model, okay, you don't need to install this llama cpp. So we can directly download the model from Hugging Face. Okay, I'll tell you whenever I'll be using this model actually, because I already told you llama 2 provides lots of version of the model. Whenever I'll be using smallest version of the model, I'll be directly downloading the model from the Hugging Face. Okay, at that time I don't need this llama cpp library. Okay, but here I'm using quantized version of the model, that's why this needed. Now, first of all, you need to download the model. To download the model, first of all, you need to give the repo ID. Repo ID is nothing but your model name. So this is the URL I'm giving. Okay. And you also need to give the file name, like which particular file you need to download. So here you need to give this base name here. Now it will automatically go to the repository and it will automatically download for you. See guys, it's downloading, and this is around 9.76 GB. So let's wait. It will take some time. I'm able to load this model because here if you see my VRAM, GPU VRAM, I got 15 GB. That's why I can load this model very easily. That's why actually I'm using this quantized version of the model. But if you're using actual this model, if I show you actual 13 billion parameter llama 2 model, okay, without you can say quantized model. So it is more than your 9 GB and you can't load it. Okay, that is the issue actually. So I'm following this approach. See, this model has been downloaded. Now if you want to see the path of the model, like what it has downloaded, so it has downloaded in this folder actually in my machine. Now first of all, I need to load my model. To load the model actually, first of all, I'll be defining one class llama. Actually, you have seen like we have imported the llama. And here you just need to give the model path. So this is my model path here I have given, and these are the parameters you need to keep it. Okay, these are the default parameters you need to keep it. Now let me execute and load the model. So guys, as you can see, my model has been loaded. Now here you can also check like the number of GPU layer you have in your GPU. So we have 32 layers. And now first of all, I'll be creating one prompt template, because we don't directly give the prompt to our LLM. We also create a prompt template. Okay, so we won't be directly asking the question, because let's say what kinds of question actually you want to ask to your LLM, you need to specify using the prompt template. I think you are already familiar with what is prompt template and all. So here I have created one prompt template. So this is my prompt. This is the question of the user. Just write a MNIST image classification code in Keras. And here is the prompt template. So I'm telling my LLM. So here I'm telling to my LLM as a system. System means it will consider I'm telling to my LLM. And here I'm telling you are a helpful and respectful and honest assistant, always answer as helpfully. Okay, this is my prompt template. And here I'm giving one example. So user will ask these kinds of question and you need to give the answer as an assistant. Assistant should be the response from my LLM. Okay, so this is the prompt template I have created. Now let me execute. Now here I'm initializing my LLM. So here I'm giving first of all my prompt template. Then I'm also initializing the max tokens. Max token means like how many output you wants from your model. You can, if you're using GPU, so you can decrease this length. If you're using GPU, you can increase this length. Okay. Temperature, I think you already know. If it is close to 0, that means you are taking like more streak output from your model. And if you are increasing to 1, that means you are taking the randomness from your model. But here I have set 0.5, so it's middle position. And this is the top probability score, and these are some default parameter you need to give. Okay, now let me execute it. So it will take the prompt and it will understand the prompt template and it will give you the answer. So here I have written like write a MNIST classification code in Keras. So it will give you the code with respect to that. And this model is pretty huge. That's why the response time is a little bit high. So you need to wait for some time. So guys, execution done. Now let me print the response I got. So this is the response, but it's not readable. So from this response, I only need to see the text from my model. So let me execute. See guys. So here I got the answer. So here if you see, this is my system. That means this is my prompt I have given to my model. And this is the question user has asked, and this is the response I got from my assistant. So first of all, it's telling hello. I would be happy to help you your MNIST classification projects using Keras. Before we begin, may I ask what specific aspect of the projects you need to assistant with do? Do you any prior experience with the deep learning and Keras additional? So it's giving some output. So what you can do, you can again execute this code. I think it will give you that, because if you're using for the first time, I think it will give you that response. Now let me execute for the second time. So guys, now you can see it has given me the code for the MNIST image classification. Now let me give another prompt. So here I will just write a linear regression code. Write a linear regression code. Let's see like whether it is able to give or not. So I'll again execute. Now guys, I got the response, and guys, this is the code for linear regression. Okay, so it's amazing guys. So we are getting our output, and yeah, so that's how actually we can use our Llama 2 model. Okay, Llama 2 model we can run, and this is the quantized version of the model. Again, some accuracy might be less. Okay, you might get some wrong output because of the quantized version of the model. Okay, but again, it's a pretty good. You will get like all of the response. Okay, whatever question you are asking. Now, what I will do. This was like how we can execute like quantized version of the model, because I was using because here I was using Llama 2 13 billion parameter this model. But next actually I'll show you like how we can execute using a Langchain. Okay, how we can use using Langchain. So there actually I'm going to use this model called 7 billion. So 7 billion parameter this model actually I'm going to use. Okay, and this model has actually lots of variant. Okay, I'll tell you. So we'll be using some HF version of the model. Okay, then I'll show you like how we can load this model. So yes guys, this is all about this execution of this Llama 2 model on Google Colab. Now let's explore like how we can use this Llama 2 model with the help of Langchain. So guys, now let's see like how we can use Llama 2 model with the help of Langchain framework. And we have already seen like how we can execute this Llama 2 model on Google Colab. So there actually I used like one particular model, so 13 billion parameter model, but there actually I used something called quantized model, because I can't load this 30 billion model, okay, in my free Google Colab. I think I was already discussing about, okay. But in this example, I'll be using this 7 billion parameters. So this model would be a little bit small for me to load in my memory. So I can load this model, okay, in my free Google Colab. There is no issue with that. But again, to load this model, you need to take the permission from Meta AI. Okay, this model is available on the Hugging Face website. I will tell you like why you can get this model. So if you search on Google like Llama Facebook research, so you will get this GitHub repository, and there actually they have mentioned everything about Llama 2 and all. And they will also give you the download link and all. So if you click on this download link, so you will redirect to this page, and here you just need to fill out this information. Okay, so I think I already showed you this thing. And they have already written like how we can access this model from the Hugging Face also. See, this model is also available on the Hugging Face website, so you can visit Hugging Face and see it has this three variant like 7B, 13B and 70B. I think I was already discussing about. And again, if you see here, these are the model has lots of sub variant like Llama 2 7B chat model, Llama 2 13B HF model. Okay, so these are the like sub variant of the model. So this is nothing but like some of the model would be bigger, some of the model would be smaller. Okay, so that's how they have trained different model with respect to these are the variant of the model. Okay, now here if you see here in the GitHub, they have written one thing. This Llama 2 comes with two different model. One is like pre-trained model and another is like fine-tuned chat model. So what is pre-trained model and what is this fine-tuned chat model? So pre-trained model is nothing but these model are not fine-tuned for the chat or question answer. They should be prompted so that expected answer is the natural continuation of the prompt. So basically what they're telling, actually with this pre-trained model, you can't do actually chat operation or you can't do actually question answering operation, right? Like the way we usually perform with our LLM model, we ask any question, we do the chat operation with that. So with this pre-trained model, you can't do. Let's say if you want to generate text or if you want to, let's say, generate something, okay, from the model, you can use this kinds of pre-trained model. Okay, and what is this fine-tuned chat model? So this fine-tuned chat model were trained on dialogue applications, so to get the expected features from and performance for them with specific format defined chat completion. So basically what they're telling, so with this fine-tuned chat model, actually you can do the chat operation. Let's say if you want to do any question answering, if you want to perform a chat operation, you can use this fine-tuned chat model. So in this example, I will be using this fine-tuned chat model because I want to perform chat operation with the LLM. Okay, I want to ask some queries and all. So I'll be using this model. But let's say if you want to generate text and if you want to generate something, so you can use this pre-trained model. Okay, so now if you visit here in this Meta Llama 2 on Hugging Face, so they have different model, as I already told you. So it has chat model also, and it has without chat model also. So now you can choose any of them. Okay, so guys, from these are the model itself, I'll be using one particular model. So I'm going to use this particular model called Llama 2 7B chat HF model. So here is the model description and all about, you can read it out. Okay, so with this model, actually you can do chat operation and all. Okay, and this is 7 billion parameters, so I can easily load this model in my free Google Colab. Okay, so there is no issue with that. I don't need to use any you can say quantized model, okay, from them. So now what I will do, before before loading this model, you need to take the permission from the Meta AI. So what you need to do here, so you will see one option here, just apply for the permission. See, for me, I have already applied for a permission and they have already given me the access. That's why it's telling you have been granted to this model. Okay, so I already have the access to this model. But if you're doing it for the first time, make sure you have applied for the permission. Okay, so once you get the permission, so you will get this kinds of message here. If you see here, you will get this kinds of email like you have granted to this model and all. So they will mail you with respect to that. And once you click here, so you will redirect to this kinds of form. So here you just need to, these are the form and submit your information. So after some times, actually they will give you the permission. But if you're doing it right now and if you're waiting for the permission, so what you can do in between, I will show you another option. Okay, another alternative I will show you. So that alternative you can follow. And guys, one particular thing you will always need to remember. So whenever you are submitting the request, okay, whenever you are submitting the request for this model, make sure the email address you are using, the same email address you are used in your Hugging Face as well. Okay, so the same Hugging Face email address, okay, you have created your account, so same email address you need to submit here. Okay, as you can see, you need to submit your email address here. So make sure you have selected the correct email address with respect to your Hugging Face account so that you will get the quick access there. So guys, I already created one notebook for you. So here I will show you the demo how you can use this Llama 2 model with the help of Langchain. And I think you already know what is LangChain. LangChain is nothing but it's a framework for developing application powered by language model, or you can say we can also develop generative AI application with the help of LangChain. And this is the LangChain documentation and GitHub I have already given here. You can go and check. And if you don't know like LangChain, so we have a tutorial in our YouTube channel. Just go ahead and try to finish that lecture. Otherwise, it would be a little bit difficult for you to understand like what I'm trying to say, right? So guys, here I'm already expecting you are familiar with this LangChain framework, like what is chain, what is prompt template and all about, okay? So this should be the prerequisite for this video. Now guys, the first thing what I need to do, I need to connect my notebook and make sure you have selected runtime as GPU, because you need the GPU to run this model. So change runtime to GPU. So for me, I have already selected, and let me connect the notebook. So guys, notebook is connected. Now, first of all, let's see whether I got GPU or not. So this is the command to check the GPU. So here I got Tesla T4 and here I got 15 GB VRAM. Now what I need to do guys, I need to install some of the libraries. See guys, if you're using any open source large language model, okay, open source LLM model, which is available in Huggingface. So for this actually you need to install this transformer library. Okay, so using this transformer library, we can actually access our Huggingface model. Okay, so that's why this transformer library we need to install. Then I need to also install, these are the two libraries, Accelerate and ANOPS. Then I need also LangChain, because here I'm going to use LangChain. Okay, and this Bison's bytes. Okay, so these are the package actually I need to install. So these are the actually dependency. So LangChain I need because I will be running these are the LLM model, Huggingface LLM model, with the help of LangChain. And I also need transformer because I will be using my Llama 2 model from my Huggingface itself. Okay, that's why this transformer is required. Now let me install. So guys, as you can see, installation is done. Then first of all, what I need to do, I need to log in with the Huggingface account. Okay, so to log in with the Huggingface account, you need to use Huggingface CLI to log in. Okay, so here you just need to give the API key. Okay, Huggingface API key. So there is a secret key actually will get from your Huggingface account. So let me open with my Huggingface account. So guys, this is my Huggingface account. If you don't have any Huggingface account, just try to create one account. Okay, now if you click on the profile and go to the settings, and here you will get one option called access token. Okay, just click on the access token. So here previously I already created one access token here, so I'll be creating a new one. So you can also create a new access token. You can give any name. So let's say I will give as Llama, and you can get read and write permission. I will be giving read permission because I only want to read the model from here. Then I'll just generate a token. So this is my token guys. Now what I will do, I'll just copy this token. And guys, don't share this token with anyone. Okay, otherwise they will also able to access your account. So I'll remove this token after this recording. Okay, that's why I'm showing. Now let me execute this command, and it will ask for the token. So just click here and paste your token and just press enter. So if you do it, so now it will tell add token as get credential. So what I will do, I'll just give yes and press enter. Now guys, here if you see my logging is successful. Now what I will do, I will import, then I need to import this Huggingface pipeline from LangChain, langchain.llms, because with this Huggingface pipeline, so with the help of this Huggingface pipeline class, I will be loading my large language model, which is nothing but my Llama 2. Okay, so I need to import this library. Then I also need to import tokenizer. So what is tokenizer guys? Tokenizer is nothing but it is responsible for pre-processing the text into arrays of number as input to the model, because so whenever I will be giving any input to my model, it would be completely text input, right? But my model can't understand that text, raw text actually I will be giving. So for this actually what I need to do, I need to convert to numbers, right? Even I also need to perform some pre-processing. So everything can be performed using this tokenizer, okay, auto tokenizer class. So that's why I need to import it. Then I also importing transformers, then torch and these warnings. Okay, now let's load our Llama 2 model from this Huggingface. So as I already told you, so you will get these kinds of access once you got the access and all. Okay, so I have already added some screenshot here, and once it is done, it will tell you this message, right? Now here guys, you need to define the model actually you want to use. So in this case, actually I'm using this model. As I already told you, I've just copied this name and just paste it here. If you see, this is the complete name I have given, and this is the model from Meta, because this is the official model actually I'm going to use. And this model I need the permission. I think I already told you this model I need the permission. But let's say if it is taking for you to take the permission and all, so what you can do, you can use this model. You just comment this line and uncomment this line. So this is the same model, but this is present in the public repository, and this access is given to everyone. Okay, so you can easily use this model, and this is the same model, guys. Okay, this is the same version of the model. So what this guy has done actually, so he has cloned the official version of this Llama to 7B chat agent model, and he has published in his you can say repository here, and this is completely public access, so you don't need to take any access okay from this author, so you can easily use this model. So let's say if you have applied for the access and it is taking time and you want to do it right now with me, so what you can do, you can uncomment this line and you can load this model. Okay, but for me, I have already access to my official model, so I'll be using official model and I will comment it out. Okay, so it's up to you which model you're going to use. Now guys, first of all, what I need to do, I need to load my tokenizer. So to load the tokenizer, you need to give the same model name. Okay, so with respect to that, it will load the tokenizer. Now here, what you need to do, you need to create one pipeline objects, and here you need to call this transformer pipeline. Okay, and here you need to give the pipeline name. So here I have given text generation, because if I go to this model I'm using, so this is a text generation model. As you can see, this is a text generation model. So that is why I have given text generation here. Now I also need to give the model, like which model I'm going to use. So this is the model I have given here. Okay, then I'm also need to give the tokenizer. So this is the tokenizer I have given, and these are the parameters. Just keep it as default, and this is the maximum input length. So I've given 1000. You can also increase and decrease the size. Okay, it's up to you. Now guys, what I will do, I'll just quickly load my pipeline. So basically it will load the entire pipeline. It will load your model, it will load your tokenizer, everything it will load as a pipeline. So what is the use of this pipeline? Pipeline means, like, first of all, whenever you are giving any input to the model, first of all, it will apply the tokenizer and it will convert that text to numbers. Okay, it will pre-process the text, then it will apply this data to the model. Okay, so that's why this pipeline handles each and everything. You don't need to write any custom code for it. And now guys, here if you see, it is downloading the model. Okay, and I'm using free collab, and I got 15 GB VRAM there. So I think you can see RAM is not utilized till now because it is downloading the model. So once it will load the model, it will utilize my RAM. So guys, my model has loaded. Now what I need to do, I need to call this Huggingface pipeline. I think you remember we load this Huggingface pipeline from Langchain. Okay, here if you see from Langchain .llms, we load this Huggingface pipeline. Now I need to give this pipeline object to this Huggingface pipeline from my Langchain. So here you will get two parameters called pipeline. So here you just need to provide the pipeline. Okay, this pipeline we have created. And another keyword you need to give the temperature value. So what is temperature value? So see, I think you already know like what is temperature value. So here I've already written. So temperature value, like so if it is 0, that means the model is very safe and it is not taking any bets. And if you are giving this and if you're setting this value to close to 1, so it will be taking risk. Okay, and it might generate wrong output, but it is very creative. So this is the parameter actually you can change. Let's say if you want some stick output from your model, okay, you can set this parameter as close to 0. And if you want, let's say, very creative results and you are not worrying about the wrong output or let's say random output, so you can give this parameter as 1. Okay, so this is the parameter you need to give. So here I want streak output from my model, that's why I set this parameter as 0. Okay, so this is the parameter I have given. Now here I'm defining as LLM. So this is my large language model. Okay, but I think you remember initially I was using something called OpenAI large language model, which is nothing but GPT 3.5 turbo. You can use anything, GPT 3, GPT 4, anything you can use. But there actually I was using OpenAI API and it was taking charge for me, right? But this is completely free. Now see, with the help of these kinds of open source large language model, and it is also available inside Huggingface, we have easily loaded this model. Okay, and we have created our LLM object here. Now this is one prompt actually I have prepared. So what would be the good name for a company that makes colorful socks? So this, let's say this is my prompt. This is the user prompt. This is the user input, and it is giving this input to the LLM. And now let's see like what LLM will predict. Okay, so here I will give this prompt to my LLM and let me execute. You can also set your custom template, prompt template. I will tell you like how to set it. But first of all, let's give my prompt without any template. Because by default, your LLM will have some custom, like you can set default template. It will use that template. So guys, here is the response I got from my Llama 2. So I would suggest the following names for the company that makes colorful socks. So Sol Mats, Hue and Cry, Tall, Tally, Socks. Okay, it's great actually. Even it is giving also the description with respect to the name it is suggesting. Now you can give any kinds of prompt, you can check it out. So let's give another prompt. So here I've given, I want to open a restaurant for a Chinese food, suggest me a fence name for this. Okay, so you can also give, let's say, Indian food. Okay, I'll give Indian food. Now let's see whether it is giving me some name or not. So I'll execute my LLM. Now guys, as you can see, it has given me the name. So restaurant, I would suggest the following names for your Italian, for your Indian food restaurant. So Tandoor Nights, then Spice, Rahut, Mumbai, Bazaar, Curry Leaf. Okay, so great. I am getting very good name. Let's see if you want to open a restaurant. So you can refer, these are the name, and these are the name is like very unique. Okay, and this is the description. Now also you can create your custom prompt. Let's say see, this is the better practice to create our custom prompt always. Let's say whatever task you want to perform with the help of your LLM, so you can give the custom prompt, okay, instead of using the default prompt. So to give your custom prompt, you need to import prompt template from LangChain first of all. So let me import, and I also need to import something called LLM chain, okay, from LangChain. Now this is the first example I have given. So this is my prompt template one. So here I've given the same prompt as I think you remember, and I've just written I want to open a restaurant for here I've given cuisines. Cuisine should be the input. Okay, here I've given this should be the input variable. Food, suggest me a fancy name for this. Now I'll be using this prompt template and I will be giving to my LLM model. Okay, so it won't be using that default prompt template after giving it. Now let's say how it will work. So this is the technique it will work. So basically it will apply this format on top of it, and whenever it will get this cuisines, actually it will replace this input. Okay, the input I have given, let's say I've given Indian. Now if I print this input prompt, if you see I want to open a restaurant for the Indian food, search me a fancy for this. Okay, so this is the input I have prepared with the help of this code, right? Now let's take the second example. So this is the another prompt I have created, prompt 2, and here I'm using another prompt, provide me a concise summary for this book, and here I'm taking book name as input from the user. So how it will work, so whenever user will give any input, let's say I have given Alchemist book. Okay, so it will take as input and it will make the complete prompt. See, it will make the complete prompt. Okay, now let's use the first one first of all. So I'll be using this from template 1. So here just let me write. Now I'm going to use this prompt 1 at the very first. Let's use prompt 1, and here I have created LLM chain, and here I have given my LLM. Okay, so LLM model I have given, so which is nothing but the LLM we have created. I think you remember, this is my LLM, this is my LLM. Okay, and here I have given the LLM, and here I'm giving the prompt as my prompt template, and here I'm also giving verbose is equal to true. That means it will also print the log, like what it's doing actually. So if you're making it false, so you can't see the output log, and if you are making it true, so you can see the output log. Okay, now here you need to call chain.run, and here you just need to give the input. Okay, so here let's say I'm running this prompt 1, and this for the cuisine. So here what I will give, I'll give Indian cuisine. Okay, and this is the response I will get. Now let me execute and show you. See, first of all, it is entering to new LLM chain prompt after formatting. So this is the prompt it has prepared. So it has taken my input Indian, and this is the prompt actually it has created. Now it is applying LLM on top of it, and it will predict. Now let's see. Now guys, chain has been finished, and this is the response I got. A restaurant name is a crucial aspect of any business. Okay, and these are the name actually it is suggesting. Now what I will do, I'll give this prompt template 2, that means my book prompt, and here now I'll ask any book name. So let's say I'll give Harry Potter book. I want the summary of Harry Potter book. Let's see whether it is able to give or not. And this model is pretty good, guys. Just try to explore this model. I am loving this model a lot. Okay, as an open source model, I can say like this is one of the best model you can use from Meta AI. So see guys, this is giving me the summary. Again, if you mention the book with a specific name, let's say it is giving the summary of Philosopher's Stone. Okay, you can also give any specific book, it will give you the summary. In the summary it will give you. Okay, so great guys, we are able to use this Llama 2 model with the help of LangChain, and we have seen like how we can load this model with the help of LangChain and all, how we can create the template. Okay, how we can create the LLM chain and everything we have seen, right? Now guys, it's time to make one projects with the help of this Llama 2. Now what I will do, I will create one chatbot projects with the help of this Llama 2 and Langchain. So basically, we'll be creating one chatbot so that can chat with any kinds of website. So let's say if you have any website, okay, so you can integrate that website to your chatbot. So whatever question user will ask with respect to the website, it will give you each and every answer. Let's say this is one website, Llama Meta website, okay. So let's say I want to ask any questions, okay, from this website. Let's say I want to ask like what this website provides, okay, what are the services it provides, give me the contact information and all. So that chatbot will able to give me everything with respect to the website I have. So this kinds of chatbot actually will be implementing with the help of this Llama 2 and Langchain, okay. And I will also utilize like a vector database with that projects, okay, because I have already explained like vector database. So I already created one dedicated session on vector database. Just go ahead and check it out if you haven't checked it out, that session. So guys, we'll be using everything like vector database, this Llama 2 and Langchain. With the help of that, actually we'll be implementing this entire projects, okay. And this is going to be one very interesting projects, okay. You will be enjoying a lot. So now let's start with the projects and let's see like how we can develop these kinds of generative AI projects. So guys, now let's build one generative AI projects, generative AI application with the help of large language model. So here I'm going to use Llama 2. And here I'm also going to use some of the additional tool. Let's say I'll be using vector database, then I will be using Langchain framework, okay. Then we'll be implementing this amazing application. So the application actually I'm going to implement called website bot. So what is website bot? I think you have probably seen like if you visit any kinds of website, so some of them are already created some bots. So if you ask some question in the website, like what this website and all about, like what are the services it provides, so everything it will give you the answer, right? Whenever we visit any website, let's say I will visit openai.com. So if I visit this website, so if you want to see this website structure, like how many pages actually it has, and like what is the layout of this website, what are the URL of that page, actually everything you can see, okay. If you visit this link called sitemap.xml, okay. If you just write this one, sitemap.xml, and if you press enter, so it will give you all the detail about this website. Let's say this is the website, and it has actually different pages. If you see, if I go to OpenAI, so if I, let's say, click on research and click on, let's say, overview, so it will open a different tab for me. Like let's say this is the different page for this website. So that's how actually you have different website, and with respect to that, it has the different links as well. As you can see, different links actually it will also provide, okay. Let's say this is another page, okay. This is another page inside OpenAI. So let's say I'll copy this URL, and if I paste it here, so it will open that particular see it is opening that particular page, okay. So that's how actually you can export with any kinds of website. So I already collected some of the website URL. So what I will do, I will use that URL and I will build this application. So here, if you see, I've already prepared one notebook here, and here I already collected some of the website links. So if I open it, so see, this is one blog website link. So paper review, Llama 2 open foundation fine-tune chat model. So it has some content, okay. It has some content. So we'll be chatting through this content, like what are the things actually this content is providing, okay. Everything we can ask in our bot whenever we'll be completing this thing. Not only this thing, I have attached multiple URL. As you can see, this is another link, okay. This is another link, this is another website. So again, some content is inside that. Again, it has different pages. As you can see, it has different pages. Different pages. If you just visit that site map.xml, you will see different pages link, you will see that. Then I also have another one. So this is the website of stability.ai, and again actually it has some content. So you can give any kinds of website link here. So I have collected, these are the website link, so you can use any of them. So here is another website, okay. So we will be using this 4 website URL, and we'll be implementing one website bot on top of it. So let's say if you're asking anything, okay, if you're asking anything regarding these are the 4 website, like what are the content, everything, like what are the things actually it is providing, what is this, let's say if you want to ask something about Llama 2 open foundation fine-tune chat model, you can ask. So it will give you the answer with respect to the content actually it is giving. Let's say if you want to ask like PT7B, okay, this is another open source large language model. If you want to ask something, so here you can ask, so it will give you the answer with respect to this content. So any website you can refer. Let's say if you have created your custom website as well, so you want to create one bot on top of it. So let's say I'm the user, so I will come to your website. First of all, I will ask for your bot, like what are the services actually provide, what are the things actually provide. I can get all the information from your bot. Then I don't need to visit your website, okay, again and again. So I can ask everything from the bot itself. So guys, this is going to be one amazing projects, and what you feel like, just try to comment in the chat, okay? So whether it's helpful or not, and make sure you are just watching this video entirely, don't skip any part, otherwise you might get some issue. So guys, now what I will do, I will first of all give you the project's idea. I'll be just giving you the project's architecture. I'll be just writing the project architecture, like what are the steps actually we're gonna do throughout this entire projects, like what are the component we'll be implementing. Okay, so we'll be seeing the project architecture at the very first. Then once you understand this architecture, we'll be moving to the coding part. So let's go to our whiteboard and try to understand the project architecture. So guys, I'm inside my whiteboard. So now, first of all, I will just write the project's name. So it is website bot using Llama 2. Okay. So here, let me give you the project's architecture, like how we are going to do the project. So first of all, what I will do, I need to collect those website sitemap.xml. Basically, I need to collect all the content, okay, from the website actually I'm referring. So first of all, we'll be taking all the content with the help of this sitemap.xml, okay, xml. And you don't need to worry about manually, you don't need to write these are the thing. Actually, if you're using LangChain, so with the help of LangChain, actually you can easily extract the content from any unstructured website. Okay, I'll tell you like how to do it. So what it will return, uh, so it will return you page, okay, page, let's say 1, page 2, and page 3. So after getting the page, actually I need to get the documents, okay, present in the page. So it will return me the documents. Let's say docs, okay, docs 1, docs 2, docs 3, okay, docs 4, and so on. So docs 4, okay. Now it will return me that documentation, like all the page content. So once I get all the content, okay, basically here let me write out here, we are just extracting text, okay, extracting text. And after getting all the text, what I will do, I will use my embedding API, that means embedding model. So in this case, I'm going to use Huggingface embedding model. I think you already know what is embedding model and all. I already discussed this thing in my vector database session. So if you haven't watched that session, you can go ahead and watch it. So everything would be clear there. So I'll be using embedding model. So with the help of embedding model, actually, I'll try to convert this text to vector, okay, vector representation. Now this will return me the vectors. So here I will get lots of vectors. Then once I get the vector, I will build semantic index. Okay, I think you know what is semantic index. Semantic index means you will be combining all the vector together. Okay, then we will be building the semantic index, and you will be storing this semantic index to the knowledge base. Okay, so what is knowledge base? Knowledge base is nothing but your vector database. So let's say this is my knowledge base. Okay, this is my uh, knowledge base, or let's say vector db. So these are the vector will come here. These are vector will come here, and it will store inside my vector db. Okay, so once I'm able to store, these are the vectors, okay, in my vector db. Now what will happen, let's say this is the user. Let's say this is the user. So user will hit some queries. So let's say this is the question from the user. So the first thing what I need to do, I need to convert these questions to the vectors, because again it's going to be the raw text. Okay, so again I will be applying something called embedding model. Okay, then I'll convert this text to vector. So here I will get something called query embedding or query vector. So this query vector, I will apply something called semantic search. I think you already know what is semantic search. Okay, so semantic search on top of my vector db. Okay, so I'll do the semantic search. So once you do the semantic search, it will return you some ranked result. Okay, rank results. Now I will have my rank results. Now I will take the help from my LLM. I'll be using large language model, which is nothing but my Llama 2. Okay, here I'm going to use Llama 2. So with the help of this large language model, I will get my actual response. Okay, the query user has asked, so it will give me the actual response. Okay, so this is the complete idea, and this is nothing but this is my user. Okay, so this is the complete you can say diagram of our projects. As you can see, first of all, we'll be using, these are the website. With the help of sitemap.xml, we'll be extracting all the pages available in the website. Then we'll be extracting the documents, that means extracting the text. After that, we are just converting, let me write here, converting text to vectors. Okay, here we'll be converting text to vectors. Then we'll get our vector embedding. That vector embedding will be building one semantic index and we'll be storing into the vector db. So in this case, actually I'm going to use something called Pinecone vector db. Okay, you can use any vector db, Web8, you can use ChromaDB, you can also use Face, okay, from Facebook, anything you can use, but I will be using Pinecone. Then what will happen, user will ask some query, I will be applying again embedding model and I'll be getting query embeddings, and with the help of this query embeddings, I'll be do semantic search on top of my vector db. It will give me rank results, and with the help of LLM, I'll extract my correct output I was expecting. Okay, and it will give me the correct response to the user. So this is the complete idea of these projects. Now what I will do, and here I already prepared one notebook for this project. So I'll just explain like whatever things I have done. So first of all, I need to connect my notebook. Make sure you have selected runtime as GPU. So here just click change runtime type and select GPU. So for me, I have already selected. Now here I need to install some of the package. So here I'll be installing Langchain, then bytes accelerate transformers. Why we need it, I think you remember. I think previous experiment I was showing how to use Llama with the help of Langchain. Okay, and I was reading that Llama model from my Huggingface, and for Huggingface actually I need to install these are the libraries. Then these are the actually dependency you can install. Okay, then PyPDF should be another dependency, and also you need to install sentence transformer. Now let me install them. So installation is done. So here I'm not going to use OpenAI. So let me just delete this thing. Then I also need to install this library unstructured, because the website will be loading. So it has lots of unstructured format. So to overcome this thing, actually you need this package called unstructured. So let me install it. I'm not using Face. Face is again another vector database. So you can remove this thing. I'll be using something called Pinecone. So this is done. Then I also need to install tokenizers, then Xformers as well. Now I will be also installing Pinecone client, because here I'm going to use Pinecone vector database. And guys, if you haven't checked my vector database session, you can check it out. Okay, it is available. Otherwise, you might get some confusion. So it's better to try to understand this vector DB. Okay, then you will get the entire idea. Now all the things I have installed. Now I'll be installing all the requirements libraries actually I'm going to use, and whatever libraries actually I'm going to use, I will tell you, okay, which library actually I'm using for which purpose actually I will tell you at that time. So here you can see some additional library also I'm importing, but again I will discuss like what are the things actually I need here. Now I also need to install punctuation NLTK. So the first thing I need to collect some of the website URL. The website URL actually I want to use for my bot. So here I already showed you I am using this 4 website. Okay, I'm using this 4 website. You can use any of the website and you can use it. So these are the 4 website link I have provided inside one variable called URLs. Okay, now let me execute. Yeah. Now I think you already saw we have imported one class called unstructured URL loader from Langchain. Here if you see unstructured URL loader. So this class will help you to extract all the data from this or the URL. Okay, I think I was explaining this project architecture, like it will be using something called sitemap.xml. Then it will extract the pages. Okay, from the pages it will extract the documentation. So everything can be done with the help of this function actually we have imported here. Okay, unstructured data loader, and here you just need to give the URL, and it is not only working with the single URL, it will also work with the multiple URL as well. Okay, so now if I execute and show you, so it will easily extract the data, and it will go through all the pages actually this website has, and it will extract all the data for me. See, it has extracted. Now if I print my data, see guys, all the data you can see here, it is amazing, right? So that is the power of Langchain. So that's why we use this Langchain framework to build this kinds of generative AI application. Okay, now if I show you my data length, so it should be 4 because I'm using 4 website, so it will give you 4 website data. Okay, here now this data should be in a document format. I think if you see the format of this data, it should be a document format. Okay, and now I need to apply something called text split on top of the entire corpus I have, because I need to convert my data to chunks. Okay, why I need to convert my data to chunks? Because see, I think I already discussed this thing in my vector database session. Why this chunks is important? Because whenever you open any kinds of model, okay, let's say if I open let's say OpenAI model here, OpenAI model, OpenAI, or let's say if I open my Llama 2 model. So here if you see, it has context length as 4096. Okay, like it can take like 4096 tokens, okay, at a time. But if it is more than that, actually at the time your model can't take this and it will give you error. Okay, but the data actually we have extracted, it has like more than 4096 you can say tokens. Okay, so that's why I can't directly pass this data. I can directly pass this corpus to my model. So that's why I need to convert to chunks. Chunks means I will be converting different chunks. Okay, different chunks means different paragraph. Okay, and that paragraph I will be converting to like embedding vector. Okay, then I will be giving that data to my model. Okay, I already discussed this thing in my vector database session. Just try to go ahead and check it out. This should be very much clear. Now here I'll be converting my entire corpus to the chunks. So this is the character splitter function I have imported from Langchain. Here if you see, character splitter from Langchain I am importing. Now with the help of this one, I will be creating the entire chunks. Now here you need to provide two things, the chunk size and the chunks overlap. Chunk size means like how many tokens you need in a chunks, and chunks overlap like how many tokens actually you want to consider from your previous chunks. Okay, so these two parameters you need to give here. Now let me execute. Now my chunks object is created. Now I'll give my data. I'll give my entire data I got from my URL, and it will convert it to chunks. Okay. Now if you want to see the chunk size, so it has created 90 chunks. So if I print my text chunks, okay. So now let me show you. See, this is another chunks. Then again, this is another chunks. Okay, then again this is another chunks. That's how it has created 90 chunks. Okay, and if you want to see individually, you can also see this is the chunks 0, chunks 1, and if you just read it carefully, you will see some of the tokens are coming, okay, from your previous chunks as well. Okay, so this is the chunks overlap. So basically it helps us to understand the context of the sentence actually you have. Okay, now we have successfully converted our entire corpus to chunks. Now I'll be downloading the Huggingface embedding, because here I was discussing I got my all the documents, okay, and I have converted to chunks. Okay, if you see, we have converted to chunks, docs1, docs2, docs3, and docs so on. Now I need to use Huggingface model, Huggingface embedding model, to convert these chunks into embedding, okay, vector embedding. So that's why I will be downloading first of all Huggingface embedding. So to download the Huggingface embedding, I think I already imported this library here. Hugging Face embedding, I think somewhere, yeah. So from Langchain embeddings, Hugging Face embedding, so it is available inside Langchain. Now here I'm importing. Okay, now if I execute, it will automatically download the default model. So Hugging Face has lots of you can say embedding model. So this is the one of them. Okay, so this is the name I have already given. You can open it up. So this is the model for embedding. Okay, so you can read about this model. I have already downloaded this model, and now let me see the model, which model I got here. So here if you see, I got something called sentence transformer all MPNet base v2. This is the model I got. Okay, this is the embedding model. Now if I, let's say if I want to convert any text to embeddings, okay, and I want to see like what kinds of vector and what is the length of the vector, so I can test it. So let's say I have given hello world, and from the embedding I'm just doing query embedding. Now see guys, the length should be 768. Now this is the vector representation of this sentence. Okay, this is the vector representation of the sentence. So you can give any here. So let's say I'll give hello, or let's say how are you? How are you? And I have explained this thing detailedly in my vector database session. So that's why I'm again and again telling you, just go ahead and try to check it out, that video. This should be very much clear. See, again, I'm getting the same length, like 768. And this is the how are you vector representation. Okay. Now what I will do, I will initialize my Pinecone vector DB. So for this, actually, I need to collect two things. One is like Pinecone API key, and it is like Pinecone API environment. So for this, I need to visit first of all Pinecone. So just write pinecone.io, and here make sure you have the account. So I have already account, so I'll just log in with my account. So guys, if you log in with your accounts, you will able to see this kinds of interface. So first of all, you need to get the API key. Just click on the API key, and here is my API key I have already created. So what you can do, see, this is my previous API key. I will just copy this API key, and if you don't have API key, just create it here. Okay, just click on create API key, give the name, and create the API key. Will get your API key. Then I'll just paste this API key here. So this is my API key, and don't share this API key, guys. I'll remove this after this recording. That's why I'm showing. And I also need like a Pinecone API environment. So for this, actually, you need to create one index. Just click on the indexes and create an index. And you need to give the name of the index. So let's give Llama projects. Or you need, let's give Llama, only give Llama. Okay. And here you need to give the dimension of the vector. So this is the dimension actually. So here I'm using Huggingface embedding. So Huggingface embedding, this is the dimension 768. So this dimension I have to give it 768. And I will take this cosine metric. Okay, so you have any other metric as well, so I'll use this cosine metric, and because here I'm using free plan, then I will create the index. So it will take some time to ready your indexes, so let's wait. See, once it is done, it will give you this green icon. Now here you will get this environment name called GCP starter. Okay, I will copy this name, and here I need to give it. Okay, done. Now let me execute. So I have set my environment, so API key and API environment. Now I'll initialize my Pinecone. So here, instead of giving inside your ways, you can give it directly. It is also fine. So let me just give it directly. So that's how I can provide. Now let me execute. And now I'll give this credential, and I will just initialize my Pinecone. And here you need to give the index name you have created. So this is my index name, which is nothing but Llama. I'll copy, and here I'll just give the name. Okay, and this particular line will convert your entire like chunks to the embedding, vector embedding, and it will store inside the Pinecone. See, this is the code. Basically, I have my text chunks, and one by one, I am just reading the content, and I am using my embedding, okay, and I'm converting to vectors, and index I'm giving also, like this is the index, like this is the index I have created. So in this index, actually, your vector will store. Now let me execute and show you. Done. Now if I go to my Pinecone and refresh the page, you will see like all the vectors actually. Okay, see, this is my text with respect to that. This is my vectors. Okay, this is the vector representation, and this is the index. Okay, and now see, we have successfully stored our data. We have successfully stored our vectors to the vector database. Okay, and you can see all the vectors here. Okay, you can also query out everything you can do, and this thing you can learn from my VectorDB tutorial. So there actually I have showed you like how to use this VectorDB and all. So here I'm not going to explain in depth, okay, because they are already explained this thing. Now see guys, I already stored my vectors inside my VectorDB. Now what I will do, I will first of all logging with my uh, uh, this one, my Huggingface, because I want to use that Llama 2 model from Huggingface. For this actually I need to log in. So let me log in. So if you want to log in, you need this access token. I think you remember I was collecting the access token. So this is my access token. I'll just copy. You can create your access token. Okay, I think I already showed you how to create it. Now here I just need to give the token and login. See, login successful. Now here you need to specify the model name, which model you want to use. I already told you I'll be using this Llama 2 7B chat HF model. So this is the model name I've given here. And you can use that alternative also. Like let's say if you don't have the permission, you can use that model, that open source model. I think previous experiment I was showing, okay? Because I already have the access, so I'll be using this model. Now, first of all, I'll load my tokenizer and model. I already discussed like what is tokenizer and model. Okay, why I'm loading? Because I want to create the pipeline. Now let me load it. See, it is downloading the model. So it will take some time. Let's wait. So guys, we have already downloaded the model. Now we need to create the pipeline. I think I already showed you like what is pipeline and all. Okay, why we need it. So now let me initialize the pipeline. Okay, so here if I show you my diagram, so we have completed till this point. Actually, we have stored the data. Now we are initializing our LLM. Okay, then we'll be handling the user. Now pipeline has been initialized. Now I'll be calling this Huggingface pipeline, and inside that I will give my pipeline objects, and I will also give this argument called temperature. I already told you what is temperature. Now let me initialize my large language model. Okay, now let's first of all test it whether it is initialized successfully or not. So here I'm giving one prompt. Please provide a concise summary of the book of Harry Potter. So it should give me the summary. So guys, as you can see, we are getting the output. That means my LLM has been initialized and it is working fine. Now let's do some question answer with my LLM. The data we have given, like the website we have given. Okay, so from the website we can ask any kinds of question. Now first of all, I need to import this retrieval QA. Okay, this function. Now here, this is my query. Like I'm just asking how good this Vicuna. Okay, so there is another website actually. I think you remember. This is all about Vicuna. So I want to ask something about Vicuna. Okay, from this website. So it will give me the response, okay, with respect to that. Now this is my question. Now this is my query. If I perform something called similarity search on top of my VectorDB, so it will give you 3 different results. As you can see, I think I already discussed this thing like similarity search, how to perform. And now let's say if you want to get the actual results, okay, actual results with respect to your questions, so you can take the help from the LLM. So that's why you need to call this retrieval QA, and here you need to initialize the LLM chain type and retrieval. You need to give your vector store object here, okay, and as retriever, so it will, so basically it will refer your vector database, and it will also take the query, and it will understand the query with respect to that. It will also understand the question you have asked, okay, the documents response you got, then it will give you the authentic results. Okay, now let me initialize this one. Okay, yeah, now I will ask the same query like how good this Vicuna. Now if I ask this query to my LLM, see, it will give you the answer. So guys, as you can see, it has given me the answer. Vicuna is a chat bot that uses stable diffusion 2.1 generate the response while its quality is high. Okay, it is giving this response. Now I'll ask another question like how does Llama 2 outperforms than other model. Let's see, because if you see here, I have another website of Llama 2. So this is the Llama 2. Okay, so I'm asking uh, the question with respect to that. Okay, so this is the power of this LLM, and we can create these kinds of generative AI application with the help of this Llama 2, Pinecone, and Langchain. See guys, Llama 2 outperforms model benchmark. Okay, so it is giving like GPT-4 PAM2. Okay, basically, yeah, this is the response it is giving. Now let's ask another query, like what is stable LM. Okay, I think again, if you see, like I am also passing one question with respect to other website. See here, you can also add your custom website. You can ask any kinds of question with respect to that. See, this is the response I got. Now we can create one while loop, like ask the question repetitively one by one. So now it will ask for the user input. Now here I will ask one query, like what is MPT7B. So I think you remember we have one website of MPT7B. Okay, now let's ask one query on top of it. So yes guys, as you can see, I got the answer. MPT7B is a 7 billion parameter language model developed by LLM Foundry. Okay, it is giving all the answer. Now you can ask any kinds of question. You can give, see again, it is asking for the prompt. So I won't be asking, I'll just write exit. So it will exit my code. See, here I've written the logic. So yes guys, I hope you got it, like how we can implement these kinds of beautiful generative AI application with the help of Llama 2, Pinecone, and Langchain. Okay, so this project actually you can also convert to Streamlit app. In future, I will also show you how we can convert it to Streamlit app. Okay, and whenever I will show you like end-to-end project implementation, I will show you that part. So yes guys, I think you have liked this particular session, and you have learned everything about Llama 2, like open source large language model, how to run it, and how we can also implement this kinds of generative AI application. So if you have liked this particular video, just try to share with your friends and family, and if you need anything from my side, you can let me know in the comment. Okay, so guys, as of now we have seen like various kinds of open source large language model. We have seen like how to use Llama 2, how to use Google PAM 2. So in this video, I'm going to discuss another open source, very powerful large language model, which is nothing but Falcon. So guys, this is another open source large language models. Even Falcon has lots of variant like, so recently Falcon has published this 180 billion parameter, this model, but it has some other variant as well. Here if you see, Falcon has actually 1.3 billion, 7.5 billion, 40 billion, and this is the recent one, which is nothing but 180 billion parameter. So actually I can't load this 180 billion parameter with this Google Colab and all. So if you have good instance, so you can load it, process would be same, but I will take this model guys, 7.5 billion, this model, 7 billion model, and I will show you one demo like how we can use this Falcon open source large language model to build our generative AI application. So first of all, I will show you like how we can integrate this Falcon 7B model with our LangChain. So we'll be seeing like how we can perform inferencing on top of the model. Then I will also show you how we can create generative AI application on top of that. So guys, here if you see, Falcon is nothing but it's a open source large language generative AI model. And if you see here, Falcon helps us to create a very advanced application, and it has actually lots of version like 180 billion, 40 billion, and 7 billion, and 1.3 billion parameter. And it is trained with high quality like data set, so that actually it can perform all kinds of job. Okay, whatever you will be giving as a prompt. So we'll see like how we can do it. And it has actually, these are the variant, as I already told you, 14B, and even they have already given you the download guideline and all. So to download this model, actually I'll be using Huggingface, because Huggingface has already this kinds of model hosted. Here if you see, this is the Falcon 7B instruct model. So this is the 7 billion parameter model, so I'm going to use this model. So you can use any other model as well. Let's say if you want to use this 14 billion model, okay, just try to search here, you will get the model. So in this example, I will show this model. Okay, I will use this model and I will show you the demo. So for this, actually I have already prepared one notebook. As you can see, now this is the notebook I prepared. So first of all, let's see like how we can perform the inference on top of this Falcon 7B model, okay, with the help of LangChain. So for this, first of all, make sure you have connected your notebook and you have selected GPU as a runtime. So I've already selected. So as of now, whatever things we have learned like Llama, then Google Palm, all the steps are same only, okay, but only you just need to change the model there. So this is the idea here. So if you're using any kinds of large language model, not only Llama, Google Palm, or let's say Falcon, if you're using any kinds of large language model, I already showed you, right?
like I already showed you, like we have different large language models, so all the process will remain same. You need to call the same method and all. Okay, if you are using langchain and all. And the way I imported my model here, you can easily load it. Okay, and you can refer some documentation, because whenever, let's say, you are referring any kinds of large language model, they will have their documentation. You can go through the documentation, you will get the idea. And guys, throughout this entire session, actually I showed you three large language model, like Llama to Google Palm and this Falcon one. And rest of the large language model you can explore, all the process will remain same. Okay, only you just need to do some exploration on top of it. So guys, here if you see, I already connected my notebook. Now if you want to check the GPU, whether you got GPU or not, this is the command to execute, then you will see the GPU. Then first of all, I need to import some of the libraries, because here I'm using like a Huggingface model. So for this, actually I need to install transformers, and these are the libraries. Okay, then I will be also using Langchain, so I also need to install Langchain on top of it. Okay, so let me install them. So guys, as you can see, installation is done. Now I will be loading the model. So guys, to load the model, if you're using Huggingface model, so first of all, you need to call this Huggingface pipeline from Langchain, as well as you also need to call the tokenizer, okay, and the pipeline objects. Now here is the name you need to define. So this is the name I've just copied from here and I pasted here. Okay, this is the name. And if you're using some other model, you can change the name here, so it will automatically download the model. First of all, you need to define the tokenizer. Tokenizer will help you to convert your text to numbers. Okay, and it will also do the pre-processing steps before feeding the data to the model. Then I will initialize in the pipeline. So it's a text generation model, that's why I have given the text generation. It will take the model, it will also take the tokenizer, and these are the parameters. You need to keep it as default. Okay, now if you execute this particular code, so you will be able to see, like, it will first of all download the model. So guys, this is the model size, around 9.95 GB. So let's wait, it will take some time. So guys, as you can see, my model has downloaded. Now I need to load this model. So I need to load this pipeline object actually. So to load this pipeline object, first of all, I need to initialize this Huggingface pipeline. I think I already imported, you saw that, Huggingface pipeline from Langchain. Then here I need to give my pipeline, and here one parameter I need to set called temperature. So temperature, I think you already know what is temperature. Temperature means, like, if you're setting it to 0, that means your model would be like very strict, and it won't be taking any risk whenever it will give you the response. But if you're setting it to 1, so it will take risk and it will give you some random output. That's why you need to think about, like, whether you need very creative results or random results from your model or not. Okay, if not, then try to keep this value close to 0. Otherwise you can keep this value close to 1. So here I've given 0 because I want strict output from my model. So let me initialize my LLM. Okay, now here first of all I need to initialize one prompt template. Okay, then I'm also initializing LLM chain. Okay, so let me import them. Then this is my template, custom template I have defined. So you are an intelligent chatbot, help the following questions with the brilliant answer. So here you will get this kinds of question, you need to return this kinds of answer. Okay, so this is the custom prompt I have created. Now this prompt I will initialize with the help of prompt template. It will take the template and it will also take the input variables. In this case, input variable is my question. Now let me initialize my template. Now first of all, I will initialize my LLM chain. To initialize the LLM chain, first of all you need to give the prompt and as well as your LLM. Okay, then it will give you the LLM chain. Now this is my LLM chain. So here is a question I'm giving. Explain what is artificial intelligence as nursery rhymes. So it should give me that explanation. Okay, so here I'm just writing LLM chain.run, and here I'm giving my question. Now let me execute and show you. And if you see here, guys, my memory is getting full because I loaded this 7 billion parameter model. So that is why I was telling, like, you can't load this 180 billion model because it's like very huge model. For this you need good system, you should have good GPU and good memory there. But all the process would be remaining same. Okay, only just need to change the model name there and everything will remain same. So guys, here is the answer I got. A child may be small, but with a AI can do all. Computers and machine learn faster and faster, allowing the child to great heights. So this is the response I got from my model, and with respect to this nursery rhymes. And you can ask any kinds of question, like let's ask another question. So I'll copy this one, and here I can ask, give me a code for adding two numbers. So here if you see it, it can also generate code. So any kinds of prompt you can give, any kinds of task you can do with this LLM. Let's say you want to do summarization, generate text, generate poem, generate code, anything you can perform with this model. Okay, and it's like very powerful model, guys. Even you'll be loving a lot after learning this one. Okay, I think you got the idea. Now, guys, in future I will also show you how we can fine tune this LLM. Okay, like we have learned Llama, then Google Palm, then Falcon. We can also fine tune them with respect to our custom task. Let's say you have some complex data and this task your model can't perform. So at that time you can also fine tune them. So in future I will also show you like how we can fine tune them on top of our custom task. Okay. But guys, all kinds of tasks actually these are the model can perform, so you don't need to even fine tune them because fine tune is not easy, so it like more costly. So I'll always suggest just try to use this at the model. Okay, these are the trained model, so and you can perform your job here. And you can also give the custom data, like I already showed you like how to put the custom data on top of that, like how to perform these kinds of operation, how we can do the information retrieval operation, how we can perform the summarization, everything I have showed. Even in future I will also create some of the videos, like we'll be implementing some projects. So and we'll see there like how we can create end-to-end generative AI application with the help of these are the LLM model. Now guys, this is the inference on top of this Falcon 7B. Now let's create one project with the help of LangChain. So here I'll be using ChromaDB and we'll be creating one multi-doc retrieval system. So basically here we'll be giving some documentation. In the documentation we'll be doing the information retrieval operation. I think we already saw in our Google Palm one. Okay, there actually I was using PDF, but here we'll be using the textual data. So for this actually, first of all, I need to install, these are the libraries. So let me install them. So I need to first of all terminate my previous instance. Done. Now let me install them. So here I'm using ChromaDB. So you can use any kinds of vector database. You can use Pinecone, Wave8, anything you can use. And I'm also using LangChain. So we are installing LangChain transformers. We are also installing because we are using Huggingface, and we also need sentence transformers. Okay, so everything we need to install here. So if you have already watched that Google Palm video, so this notebook will be mostly familiar with you because I'm referring the same code only, but only here I'm using Falcon model and I'm also changing the database here. Okay, only this part I'm changing. So installation is done. Now I'll be importing these are the libraries. So I'm importing ChromaDB, then recursive character splitter, then retrieval questionnaire, text loader, and directory loader. So first of all, I need to download the data. So this data is available in this URL. So I'm first of all downloading this zip file. Then I'm performing unzipping operation on top of it. See, if I show you the data, so guys, this is the stock market data. So it has lots of stock detail like Nvidia stock, then Tesla stock. So these are the txt file data, as you can see. These are the stock data. So on top of that, we'll be performing this information retrieval operation with the help of this LLM. Now first of all, I need to load this data. Then I'll be extracting the text. So this is the code for it. Then if you want to see the documents, like the final data you got, so these are the data I got. Now what I need to do, I need to perform this text splitter on top of it. Basically I want to convert my entire corpus to chunks. Okay, because I already told you what is chunks and all. So my model has like one particular input size. If you see the documentation, so if you're using this one Falcon 7 bin start, so it has some particular you can say input size, input token size, so you need to give that particular size. So it's better to convert to chunks, so that this kinds of problem you won't be facing, okay, whenever we'll be feeding the data. So let's convert to chunks. So that many of chunks I got 49. Now if you want to see some chunks, so this is the code for it. Okay, so see guys, all codes are same as I already used in my previous experiment as well. Okay, that's why I'm just going a little bit fast because I think you got the idea like how we are performing these are the operation, right? Now here first of all I will initialize my Falcon 7 instruct model the same way I'll be using. I showed you in that previous notebook, right? Yeah. So it will first of all download the model from the Huggingface. So it will take some time. Let's wait. So my model has downloaded. Now let's import my Huggingface pipeline and Huggingface embedding. Because see guys, this Falcon model doesn't have any embedding model. That's why I need to use Huggingface embedding, and this is the model I'll be using for my embedding. Basically, I need to convert my text chunks to vector embedding. So that's why I need this one. Now I'm initializing my LLM, and I'm also initializing my embedding model. So see guys, it is first of all downloading the embedding model. Done. Now I will initialize my ChromaDB database, and I already showed you like how to initialize ChromaDB database in my vector database session. Just go ahead and check it out. So here is the DB name I'm giving, and I'm also passing my text entire corpus. Okay, and I'm also giving my embedding. This is the embedding model, as you can see. So it should be embedding model. So this is the name. And I'm also giving my directory, like this is my DB directory. Now let me store the data in my ChromaDB. So it will convert all the text to vector embeddings and it will store inside your ChromaDB. Now it has done. Now first of all I will load this. So using this code actually will load this vector embeddings. Okay, so this code will load the vector embeddings. Let me load. So it should be HF. HF is my embedding. Then here I'm initializing this retriever as my vector DB. Then I'm creating one QHN, retrieval QHN. And here I'm giving my LLM. Now this is the process function I have just written. So whatever response I will get from my LLM, so it will process the output and it will give me that one. Now let me initialize the QHN. Now if you give any kinds of query and execute this code, you will able to see the response. Okay, as you can see, you will able to see the response. I think I already showed you like how to do it. Okay, so that's how we can use this Falcon 7B model, okay, with our custom task as well. Like we can create this kinds of generative AI application. Now guys, I want to give one particular task to everyone. Basically see, you have learned lots of concept right now in the field of generative AI, like how to use this kinds of open source LLM model. Now I have already shown you like three very powerful open source large language model. Now one thing actually you can explore from your side, there is another large language model called Mistral 7B. So this is another very good model, and this is the website of Mistral 7B, and this model is also available inside Huggingface. So Mistral 7B Huggingface. So this is the model guys, Mistral 7B version 001. So this model you can load inside your free Google Colab. There is no issue with that. So you can follow the same technique to load the model and you can perform these kinds of job here. And also try to share this notebook in the comment section. I will happy to see that, like whatever you have done from your side. So it would be pretty much good learning for you, right? So yes guys, this is all about our open source large language model. We have seen like how we can use them and how we can create generative AI application on top of it. Now in the next video, what I will show you, I will create one end-to-end generative AI projects, okay, with the help of this LangChain, then vector database and this kinds of LLM. I will be also using Streamlit package to create the web app and all. So guys, this is going to be very much interesting project. Just try to watch that particular video, then everything would be cleared. Like as of now, we have done the projects in the Google Colab, but now we'll be converting that Google Colab to like end-to-end projects. We'll be creating app and all.
I think you have heard of RAG inside generative AI, right? Because this is the most used actually topic inside generative AI. So the full form of RAG is like retrieval augmented generation. So in this video, we'll try to understand what is RAG exactly and how RAG works and why RAG is so important. Okay, let's say whenever we'll be working with generative AI, whenever we'll be implementing any kinds of, let's say, application. So why we have to follow this RAG concept there. Fine. So guys, I think you already know inside generative AI, we use something called large language model. That means LLMs. So LLMs actually have some limitation. You can see the first limitation it is having. So the first limitation you can see, LLM can't answer correctly to the private data. Let's see if we're having any kinds of private data. So that large language model won't be able to give you the answer related that. So if I give you one example, let's say you are having one personal website. Let's say I have one website called Code Commander. Okay, so Code Commander is my website. Now, if you open up your ChatGPT and if you ask related Code Commander, your ChatGPT won't be able to give the answer because ChatGPT trained with older data. That means I think ChatGPT trained around 2021 to 2022 data. Okay, around this year actually they trained this model. After that, actually I created this channel. Okay, so this data is not available inside my ChatGPT knowledge base. That means that time actually this data was not available in the internet. Okay, so you can consider it's a private data. or you can consider any kinds of private data, your private, let's say website data, private, let's say your company data, anything. So if you ask any question related to the private data, your model won't be giving you any kinds of response to that, right? Then you can see the second limitation, LLM can't provide the most current information. Let's say if you're asking any question which is like more current, okay, more current, let's say information, your model won't be giving you the answer. Let's say if you ask the question related this Olympic, okay, the current Olympic, it won't be able to give the answer because it hasn't trained with the current information. Okay, so these are the actually limitation we are having with the LLMs. But I want to create an application. That application will be also able to give the answer related to the private data as well as the current information. So how it can be performed? Okay, we can do it with the help of RAG concept, that means retrieval augmented generation. Now let's see how RAG works. So guys, here you can see RAG allows LLMs to use external sources for the better response. That means let's say if you're having any private data, let's say any external documents. So what you can do, you can give that documents to the large language model. How? For this, you just need to use one embedding model. You just need to use one embedding model. With the help of this embedding model, you'll just try to generate the vector embedding of the data. The data actually will be giving. And this vector embedding you will be storing to the knowledge base. That means to the vector database. Okay. I think we have already learned this thing previously. Previously, we already implemented this kinds of application, but I think you didn't know. Okay, this is a RAG application. I just given some high level overview, like how we can, let's say, use our external documents. I think we already created some of the project, right? So yes, this is called actually RAG. That means we are using our external documents. We are creating our knowledge base, and to the knowledge base, actually, we are integrating our large language model. Okay. Now, whenever user is asking any kinds of question, okay, whenever user is asking any kind of question to the private data, what it will do, it will go to the knowledge base. Okay, it will go to the knowledge base. Knowledge base will give the response. Okay, the question you are asking, the relevant question you are asking, and your LLM will process that answer as well as the query, and it will give you the correct response. Okay, so this is the complete architecture of RAG. That means retrieval augmented generation. Okay, so with the help of this concept, actually, we can easily use our private data sources or let's say external documents to get the information. Okay, I hope it is clear. That means if you are using RAG concept, it would be more accurate answer on the private data. Stay updated with the new information. Let's say if you're having new information, new data, what you can do, again, you can give that data to the knowledge base. That means you can use embedding model. You can convert those data to the embedding representation. You can store to the knowledge base and you can connect your large language model there. And if you're asking any question related that information, it will give you the answer. Okay, your model will give you the answer. So this is the concept of retrieval augmented generation or RAG. So guys, now let's try to see how RAG works. So as I already told you, whenever you are using RAG, that means you are connecting your external data. That means your private data. Let's say you have connected your private data. Let's say you have connected your website. Okay, you have connected your website. That means from the website itself, it will extract all the information. Let's say you are running one e-commerce site. So user has asked one question, what are your business hours? Okay, now how it will give the response by using your information. So first of all, what it will do, it will try to use something called retriever. So with the help of retriever, it will try to fetch all the information from your website. Okay, all the information it will fetch from the website itself. Then it will perform something called augmentation. So what augmentation will do, it will just try to augment the query. That means whatever question user has asked, okay, and the data actually you are getting after retriever, so it would be actually augmented. That means it will add them together. Okay, let's say the query as well as the data. Then it will pass to the generation. That means to the large language model. Large language model will try to understand the entire data as well as the query user has asked. Okay, and based on that, actually it will provide the answer. So the answer is Monday to Friday from 9:30 a.m. to 6:30 p.m. Okay, so that's how actually RAG works. That means it will use actually three components. One is like retrieval, another is like augmentation, another is like generation. Okay, that is why it is called retrieval augmented generation. Okay, I hope it is clear now. So guys, this was the introduction of the RAG, and I think you got it, how RAG works and all, and why RAG is important. Now let's try to see one practical example of RAG. So guys, here you can see I already prepared one code example of the RAG demo. So first of all, we'll try to understand this Jupyter notebook file. Then I will also show you how we can create a user application. That means app, let's say Streamlit app, how we can create it. Okay, so for this, what you have to do, guys, first of all, you have to install. These are the requirements, and this code would be shared, guys, in the resources section. From there you can download. And I already told you how to create a virtual environment. So to create the virtual environment, you have to execute this command. So conda create -n. You have to give the name. Let's say here I have given OpenAI demo. You can give any kinds of name. Let's say I will give test, then Python is equal to 3.10. Okay, 3.10, then -y. So this is the command you have to execute, and make sure you are using Python 3.10. Okay. So for me, I already created. I'm not going to create again. Then after that, you have to activate it. That means conda activate your environment name. Okay. Then you have to install this requirements. Just write pip install. Okay. -r requirement.txt. Fine. Now if I see press enter, it will install all the requirements I'm having in the requirements file. You can see inside requirements file, I'm installing LangChain, LangChain community, LangChain OpenAI, Python.env, Streamlit. Okay. So these are the actually dependency package you have to install one by one. So for me, I already installed each and everything you can see. Then after that, just open this notebook, rag demo notebook, and try to select the environment. So let's say I have created this environment, OpenAI demo, I'll select it. Now see, now if I execute the first line, see it is working fine. There is no error. Okay, that means it is working fine. So guys, in this experiment, I'm going to use one website. Okay, that means as a private data, as a let's say external data, we'll be using website. So from the website itself, we'll be collecting the data. On top of that, actually, we'll be implementing this rag application. So you can see this is the website URL. Now let me open this URL. So this is the URL of the website. So this is the entire website, guys. You can see. So they have given different information. So now I just collected some of the more page. Let me show you. So this is another page. This is the index page, and this is the contact page. Okay. Now let me open them. See, this is the index page. This is the contact page. So you can see, guys, this is the index one, and this is the contact one. Okay. So that's how actually you can use any kinds of website. I'm using this website. For you, you can use your, let's say, personal website. You can use your, let's say, private website, your official website, anything you can use. Even I will also show you how we can use any other format. Let's say how we can use PDF documents. Okay, these are the things I will also tell you. So this is the website data actually I'll be using. Now to load this website, I'll be using something called unstructured URL loader, and this is available inside LangChain. Okay, you can see I'm importing this unstructured URL loader. Now this is the URL list. So if you're having multiple URL, you can create a list, and this list you can pass to this function, and this function will give you one loader object. Now you can call loader.load, and it will extract the data. Let me show you. So if I execute this line, now see it is extracting all the information from the website itself. So extraction is done. Now if I show you the data, now you can see it has extracted all the information. Now why 3 documents is coming? Because here I was using 3 URL. Okay, 3 different I actually pages. Okay, that's why it is coming 3 documents. Okay, now what I have to do, guys, I think you remember we have to perform something called chunking operation. So for this we can use recursive character text splitter. Either we can use character text splitter, either you can also use token text splitter. Okay, so here I'm using recursive character text splitter. So here chunk size is equal to, I have given 1000. That means 1000 word would be considered as my 1 chunks. So let me create the chunks, and let me show you the chunk size. Okay, you can see 11 chunks it has created. Okay, now if you want to see the first one, so you can see this is the first chunks, and this is the URL it is referring. Now I think you remember, after extracting your data, that means documents, you have to use one embedding model, and you have to generate vector embedding, and that vector embedding will be stored into the vector database. Okay, any kinds of vector database you can use. So I have already showed you like multiple vector database. Like we can use ChromaDB, Pinecone, Web8, okay, Files. You can use any of the vector database. So here I'm going to use something called ChromaDB vector database. Okay, ChromaDB is a local vector database. Fine. So guys, you can see I'm importing Chroma from the LangChain itself, because inside LangChain this ChromaDB is available. Then I'm importing one embedding model. So here I'm using OpenAI embedding model. Okay, OpenAI embedding model. You can also use any open source embedding model. I'll also tell you, okay, how we can do it. Then I'm also importing OpenAI. That means I'm going to use OpenAI large language model. So let me import all of the package. And now if I want to use OpenAI, what I have to do, I have to set my environment. Okay, environment variable. So OpenAI API key, you have to pass your API key. So just try to create one API key and try to pass here. Then let's load this API key with the help of load env package. Then after that, I'm going to initialize my ChromaDB vector database. Okay, so you can see I'm going to pass my documents here, the documents I'm getting. Even I'm also passing my embedding model. So it will give me the vector store, entire vector store. That means this is going to be my knowledge base. Okay, see, this is my knowledge base right now. Now here you can perform something called semantic search operation. Okay, similarity search operation. So let me show you one example. So vector store as retriever. I want to perform similarity search operation. Search keywords, that means how many, let's say, result it will return. So here I've given 3. That means after searching, it will give me 3 relevant answer. Okay, let me show you. So let me create the retriever object. Now here I'm asking one question, what kinds of service they provide. Okay, this website, let's say I'm asking one question. Now if I perform the invoke operation, see, it will give you 3 results. Okay, 3 results actually it will give you. So let me show you. See, it has given you 3 relevant information. And from where it is referring, it has also given the URL, and you can see the 3 relevant information. But what I need the actual response. Okay, this question I have asked what kinds of service they provide. I need the actual response. I don't need this kinds of response. Okay, for this, what I have to do, I have to connect my large language model. I think you remember. So here I have to connect my large language model. Okay, then user will ask the query. So it will process the query as well as the relevant, let's say, answer will be getting from the vector database. Then your LLM will give the actual response. Okay, so now let's try to see how we can perform it. Now, if you want to see the page content, okay, the let's say result you are getting, if you want to see the contents, what you can do, you can call this one page content. Okay, I want to see the first, let's say, answer page content. So this is the entire page content. You can see. Fine. Now here I'm initializing my large language model. I think you know what is temperature parameter, what is max token parameter. Now here you can see I have created one chain. Okay, create retrieval chain. So this will give me the chain object. That means I can connect my large language model as well as the vector database. Okay, then I'm also going to pass one prompt. Okay, system prompt, and for this I'm going to use prompt template. Okay, I think you remember we can also create the prompt template. So this is the prompt I have created, guys. You can see you are an assistant for the question answering task. Use the following piece of retrieved context to answer the question. If you don't know the answer, say that you don't know, use 3 sentence maximum to keep the answer concise. You can also change the prompt, it's up to you, but I will use this prompt. Okay, it will take the context and it will give you the answer. Now for this I'm going to create a prompt template first of all. So here I've created the prompt template. This is going to be my system prompt, and user will give the input. Okay, whatever input actually user will ask, let's say this is the input user will ask. Okay, this input actually it will come here. Okay, and it will create the complete prompt that time. Now let me initialize the prompt. Now here I'm going to create a chain. So I'm using create stop document chain. So this is the function actually I'm using, because I already told you inside LangChain actually we are having different chains, right? Now here I'm passing my LLM as well as the prompt. Then again, what you have to do, you have to call another function create retrieval chain. Okay, so inside that you have to give your vector database. Okay, the vector database you have created, that means your knowledge base, and you have to give this object, your question answer chain. Okay, this object actually you have to give. Now it will give you the entire RAG chain. Now here you can ask any kinds of questions. So here I am calling this RAG chain invoke, and this is the input, what kinds of service they provide, and I'm only extracting the answer. Now see, if I show you the answer right now, see, this should be the concise answer. That means the accurate answer actually it will try to provide. Now see, Victoria on Move provides efficient and careful relocation services for the apartment, village, householders. Okay, see, blah blah blah. That means it is giving me the correct information right now. Okay, so this is called actually RAG system. Now it is referring my private data, my external data. On top of that, actually it is giving me the answer. And if you ask this question to the ChatGPT won't be able to give the answer because ChatGPT hasn't trained with this data. Okay, I think you are getting my point. Now let's try to see how we can create a user app. Okay, so what I've done, I've created another file called app.py, and whatever code I have written, okay, cell by cell, I just copy pasted and I just created like that. In this particular dot file, you can see I've imported all the library. I'm loading my, let's say, secret keys, that means OpenAI API keys. Then I'm giving the URL, I'm extracting the data, I'm creating that means chunks. Okay, then I'm creating the vector store. I'm initializing my large language model. Then I'm using Streamlit. You can see ST. Then I'm initializing my prompt. So you can see this is the prompt. And now if user is asking any query, this query actually I'm passing here and it is giving me the response. That response actually I'm showing on the Streamlit application. Okay, now let me execute and let me show you how this app will look like. So for this, you can execute one command called Streamlit run app.py. Okay, now see, if I execute the command, so it will open up my application. Now see, this is the title. I think you saw that st.title we have written here. See, RAG demo, and this title will show in the search bar. You can see this is the search bar because here I'm taking chat input now. So you can see this is the chat input. Here it will show the message. Now you can change the message as per your requirement. Now let me ask one query. So I'll ask the same query. So I'll copy this query, and here I can ask. You can go to the website and you can ask any kinds of query. It's up to you. So guys, as you can see, it has given me the response. Victoria on Move provides range of services including apartment moving, villa moving, okay, and so on. That means it is working fine right now. You can ask any kinds of question, guys. Any kinds of question you can ask, whatever actually information you are having in this website. Fine. So yes, guys, this is the RAG demo, and that's how we can create a RAG. Going forward, we'll be also learning some advanced RAG. We'll be, let's say, creating hybrid RAG and all. Okay, going forward, we'll be learning. These are some advanced RAG application you can also create. So in the next video, what we'll do, we'll just try to create another RAG application, okay, with the help of a Google Gemini Pro model. Okay, this is the open source model we'll be using. With the help of that, we can also create a RAG application. In this video, we'll try to understand what is the difference between RAG versus fine tuning, because many people has this question, when we have to perform the RAG, when we have to perform the fine tuning operation, and what is the difference between them. So see, both technique actually we use to extend the abilities of the large language model. Okay, see, when you have to use the fine tune approach, when you have to use the RAG approach, let's say you are working in a very specific domain with some specific data, okay, and with some specific task, that time actually you can use something called fine tune approach, because whatever pre-trained large language model you will be using, it won't be having like these are the information. Let's say you are working in the field of medical, okay, medical domain, and there actually you are creating one bot, okay, you are creating one medical, let's say, information bot. So this will give you, let's say, medical related information, and here you are using very specific data. Okay, so this data actually was not used during training of this large language model. So that time what you can do, at the very first time you can do the fine tune operation. That means you can fine tune one pre-trained model and you can create this application. So let's say this is the application we created. Now user has given one question: what are the latest treatment for the type 2 diabetics? So whenever you train this model, so you provided actually these are the information. So the latest treatment for the type 2 diabetics include meditation like metformin, then lifestyle changes such as diet, exercise, and in some cases actually insulin therapy. So these are the information actually you have given during fine tune. These are the model. Now let's say there is a new treatment came. Now if you are asking the same question again to your, let's say, system, it will give you the same answer again and again, because it is already trained with your older data. Yes or no? So that new information actually it doesn't have, so it won't be able to give the new actually, let's say, technique for the, let's say, treatment of diabetics too. Now in case what you can do, you can use this new information and you can create a RAG based application. So what you have to do, you have to use the same LLM model only, but you will be creating one additional knowledge base. I think I showed you how to create the RAG. So with the help of this data, you will be creating one additional knowledge base, and with that knowledge base you will be connecting your medical bot. Then your medical bot will be able to give the response, okay, from the latest, let's say, technique, from the latest information. Yes or no? Okay, now I think you got it. When we have to use the RAG technique, when we have to use the fine tuning technique. Now see, here we are using RAG technique. Now if you are asking the same question, now here you will see that it will give you the recent treatment, okay, for the type 2 diabetics. Okay, the recent treatment, whatever actually it's came in the market. Okay, now I think this is clear when we have to use the fine tuning technique, when we have to use the RAG based technique. And again, fine tuning is like more costly. So for this you need huge amount of data. You need a good computational machine. That means you should have GPU, good configuration GPU, good configuration RAM. Okay, if you're not having this kinds of GPU, so you can't do the fine tuning operation. That means in fine tuning you are retraining that model, you are updating the weights, right, which is not involved inside RAG. So inside RAG actually we are not training any kinds of model. Instead of that we are creating an additional knowledge base, and with the knowledge base actually we are connecting our large language model. Okay, this is the difference only. Fine. Now I think guys you got the clear cut idea what is the difference between RAG versus fine tuning and when we have to use it. So even I will also show you how we can perform the fine tuning operation. Okay, let's say if I want to create any specific task, how we can perform the fine tuning operation on top of our custom data. So guys, as of now we have seen the RAG demo. Like I already showed you what is RAG and what is the use of RAG and why we have to use the RAG. Okay, even I also showed you what is the difference between RAG and fine tuning. So in this video we'll be implementing one RAG based project. So the project name is QA system. Okay, we'll be using here Gemini Pro model and Langchain. So if you don't know, Gemini is a large language model developed by Google. Okay, so we'll be using this model. And this model is actually free, so we can use actually Google API to use this model. Okay, I'll tell you how we can collect the API key, and with the help of that, how we can use this large language model. Now see, this is the entire diagram of our project. That means here we'll be creating this RAG application. So we are having some external documents. So in this case, actually, I'm going to use PDF documents. I'm having some PDF documents. Okay, we'll be using this data. So we'll be first of all extracting the documents. Then after that, we'll be performing the chunking operation. Then we'll be building one semantic index. Okay, that means we'll be creating one knowledge base. That means whatever, let's say, data we'll be getting, we'll be trying to using embedding model to generate the vector embedding. Then we'll be storing this vector embedding to the vector database. Then user will ask some query. This query will go to the knowledge base. Knowledge base will return some of the relevant answer. And with the help of large language model, we'll just try to process the answer as well as the question, and it will give you the correct answer. Okay, so this is what actually we'll be implementing here. So let me show you how we can develop this particular application. So I already prepared one example. So let's open up. So guys, as you can see, this is the demo. So for this, what you have to do, again, you have to create one virtual environment. I already showed you how to create the virtual environment. For this, you can use this command conda create -n, give the environment name, then specify the Python version, let's say 3.10, then -y. Okay, this is the command to create the virtual environment. After that, just try to activate with the help of conda activate command, then install the requirement. So pip install -r requirement.txt. So for me, it is already installed. See, that's why it is telling requirement is already satisfied. So let me show you the requirements. So these are the requirement you have to install, guys. So same requirements only as per our previous project. The only thing I have added this Langchain Google Gen AI. So with the help of this package, actually we'll be accessing the Gemini model. Okay. So here vector database wise, I'm going to use ChromaDB again. You can also use Fias, Pinecone, okay, Webit, any kinds of vector DB you can use here. So let me open this first of all notebook and let me explain, okay, what are the things we'll be doing here. So guys, you can see I'm having one PDF document. Let me show you this PDF. So this is the PDF, guys. So this is my research paper actually. So I published this research paper. So you can see I'm the author here. So I'm the author here. And the research paper is about development of multiple combined regression method for rainfall measurement. Okay, now you can read the paper. Like what are the things actually we have proposed here. So we'll be asking some question, okay, from this paper itself. That means this is my private data, this is my external data. On top of this data, actually I'll be performing the chat operation. So here I'll be asking some questions related this particular data. Okay, now let me show you how we can do it. For this, first of all, we have to load the PDF. For this we can use PyPDF loader from the Langchain. Now let me load the data. So it will, you have to give the path of your, let's say, data. So here is my path, my pdf.pdf. Now see, it will give you enter extracted documents. That means you can see it is having around 15 pages. Okay, 15 pages in the research paper if you open it up. Then what you have to do, you have to perform the chunking, guys. I think you know what is chunking. So here chunk size is equal to, I have given 1000. That means 1000 what would be considered as my 1 chunks. Now see, if I execute here, I will get around 44 chunks. Okay, now if I want to show you, so this is my first document chunks. Now I have to get the Google API key. So for this, you can open this link. So this is available inside Google AI Studio. So just click here, Google AI Studio. Now from here, you have to collect one API key. Now see, it will give you this kinds of interface. Now you can create an API key. For me, I already created. I won't be creating again, but for you, you can create here. See, just select the project. If you don't have project, just try to create a project and try to create the API keys. Now see, if I click here, create API key in existing project, it will create the API key. Okay. Now after creating the API key, you will get this kinds of API key. Okay, this is your Google API key. Now just try to give the key Google_API key is equal to paste your key here. Make sure you are writing like that, otherwise it won't be working. Fine. Now let me save. Now if I open up my notebook. Now guys, what I have to do, I think remember we have to use one embedding model. Okay, embedding model just to convert my data to the vector embedding. Now for this, we'll be using one open source embedding model from the Google. So you can see this is the embedding model, embedding 001. And this is available inside this Google Generative AI embedding. Okay. Now apart from that, you are having so many embedding model. Let me show you. Let me open this link. So you can see you are having AI2, AI Labs, then LF Alpha. Okay, so these are the actually provided. So it is also having different embedding model. You can use them as well. So let me load this embedding. For this, I'm going to import this library. I'm going to load the API key. Then after that, I'm loading this embedding model. You can see. Then after loading the embedding, I'm just doing one test operation. I'm just writing hello world. So it should give me the vector representation. Let me show you. So this hello world is represented with this vector, and I'm only printing 5 actually vector. You can also print the complete vector. Okay. Now let me create the knowledge base. For this, I'm going to use ChromaDB. I already told you. Inside that, I'm going to pass my documents as well as the embedding model. You can see embedding model. Now it will give me the knowledge base. Then again, I can perform similarity search operation. That means semantic search operation. For this, you can execute this line of code. So it will give me actually 10 relevant answer. And this is the question I'm asking. What is the new in development of multiple combined regression methods in rainfall measurement paper? So this is my question. Now see, if I execute, it will give me 10 different response. Now if I want to show you, so 10 different relevant response actually it will give me. Now if you want to see the page content, you can also see that. See, this is the page content. Okay, now I will be integrating my large language model. So for this, let's initialize my Gemini model. You can see, so here you can see I'm initializing my Gemini model. For this, I'm using chat Google Generative AI. Inside that, you have to give the model name Gemini 1.5 Pro. This is the model. So Gemini having different model. You can search Gemini model list, you will get different model list. So from there, actually, I'm using 1.5 Pro model. And temperature max token parameter, I think you already know. Okay, I already explained this part. Now again, I have to create the chain. I think you remember the same chain actually we are creating. The same we have created our previous project as well. After that, we are preparing the prompt. Okay, this is the same prompt I'm using. This is my prompt template right now. So let me execute. Then here I'm creating the complete chain. I'm giving my LLM object as well as the prompt. And this one I'm passing to my create retrieval chain. Okay, you can see I'm giving my vector database as well as my this object. Now this will give me the complete chain. Now here I'm asking the question again, The same question, what is the new development of multiple combined regression methods for the rainfall measurement paper? Now see, if I ask the question, it should give me the answer from the paper. So guys, here you can see I got the response. The paper of development multiple combined regression methods for rainfall measurement introduced a novel approach to predicting rainfall quantity. The author utilized 10 supervised regression machine learning models to predict the rainfall based on the historical weather data. Their goal is to identify the most accurate regression techniques for the rainfall prediction. See, it is giving me the correct response. Now if you see the paper, if you read the paper, you will see that we have proposed the same thing here. That means it is working fine. Okay, that's how also you can use different data sources. That means if you're having any private data, okay, if you're having any custom data, you can create the RAG based application like that. So guys, this was the notebook experiment. Now let me show you how we can create a user app. So for this, I'm going to again use Streamlit, and whatever code I have written here, I just copy pasted inside this app.py. You can see all the import operation. I'm loading then my secret key. That means my Google API key. Okay, here I'm loading it. Then I'm loading my documents, performing the chunking operation, creating the vector store, initializing the large language model. This is my prompt, and this is the chat input I'm taking. That means I'm creating one chat input box with the help of Streamlit. So this is my prompt. Then after that, if user has given any query, so it will do the generation, and it will show the on top of my Streamlit application. Now let me show you how it will work. So for this, you can run this command, Streamlit run app.py. So guys, you can see this is the title, RAG application using Gemini Pro. You can also change it here. Okay, anything you can give here. Now here I got the input box. Now I can ask any question. Let's say I will ask the same question. You can ask any question from my paper. Just go to the paper and ask any kinds of question. So here we're using Gemini model through the API request, and it is like free API. Okay, you don't need to pay for anything. Now see guys, this is the answer I got. Now if you see the answer, it's pretty good. Okay, that means the correct information it has given me. So yes guys, this is the project, actually the QA project we have developed with the help of Gemini Pro, Langchain, and vector database. So far we have learned about like RAG, retrieval augmented generation, and there I showed you what is the use of RAG and how we can create a RAG. Okay, even I already I think discussed what is the difference between RAG versus fine tuning. That means if you want to work in a domain which is like completely new domain and you are working with very specific task, that time what you can do, instead of implementing the RAG, you can fine tune one LLM. Okay, and to fine tune the LLM, what you have to do guys, you have to use one pre-trained model. On top of pre-trained model, you have to train your custom data. So let me open up my Blackboard and let me discuss there what is fine tuning exactly. So guys, inside fine tuning, you will be using one pre-trained model. Okay, pre-trained large language model. Okay, I think I already showed you there are so many large language models are available as open source. For this, you can go to the Huggingface. So here you can see there are thousands of large language models are available. Now you can choose any kinds of model as per your requirement. Let's say you want to use something called Llama, Meta Llama. You can simply search Llama here. So you will get all the Llama model. Okay, Llama 2, Llama 3, all kinds of model actually will see that. See, okay, and this is from Meta AI. Now what you can do, you can download this model. On top of that, you can fine tune your custom data. But before fine tuning, what you can do, see, first of all, let's say whatever, let's say project you want to implement. Let's say you want to implement one chatbot. Let's say you want to implement one medical chatbot. Okay, medical chatbot. First of all, use one pre-trained large language model and try to perform the inference operation. Okay, try to perform the inference operation, inference on top of the model. If this model is able to give the correct answer, okay, if it is able to give the correct answer, try to select this model. Okay, otherwise what you can do, just try to build one RAG, retrieval augmented generation. Okay, that means create a external knowledge base, then try to connect your one pre-trained large language model and try to again perform the inference operation. Okay, and try to see the accuracy of the model. Try to see like whether your model is giving able to give the correct response or not. If it is giving, try to select this model. Okay, otherwise if this both approach is not working, that time what you can do, you can perform the fine tuning operation. Okay, fine tuning operation. So there what you can do, you can take one pre-trained large language model from Hugging Face, from any kinds of, let's say, platform, and on top of that you can train your custom data. The data set you are using, let's say you are using one very specific medical data, that time you can use this data and you can train one custom model on top of it. Okay, this is called actually fine tuning, and that should be my suggestion, guys. I mean, directly don't do the fine tuning. Before that, try to check whether pre-trained model is working or not. If pre-trained is not working, try to build the RAG based system. If it is not working, then try to do the fine tuning. Okay, because fine tuning is a more costly task at the end, because here you need like huge amount of data, even you need lots of computational power. You need actually higher configuration machine. Okay, you should have good GPU instance in your system, otherwise you can't do the fine tuning operation. But if you want to do the fine tuning operation, there is some way actually we can do it, because all kinds of large language model you can see, it is having actually huge parameter size. You can see Llama 2 7B, that means it is having 7 billion parameter. It is having 8 billion parameter. That's how it is having 70 billion parameter. Just try to consider. Okay, it's a huge size model. So we can't use any kinds of low configuration machine here to fine tune these are the model. So for this, what we can do, we can use something called PFT technique. We can use something called PEFT. Okay, what is the full form of PFT? Parameter efficient fine tuning. Okay, this is the full form of PFT. So inside this PFT, we are having some method we can use. So the first one, you can use something called LoRA, or you can use something called QLoRA. Okay, so this LoRA and QLoRA will help you to do to perform this parameter efficient fine tuning. That means it applies something called quantization technique. Okay, that means it will load your model in a lower memory instance. That means it will load your model in a 4-bit precision, 8-bit precision. Okay, that's how actually it will perform the parameter efficient fine tuning process. Now you can ask me, what is quantization then? Okay, let me show you what is quantization. See, quantization is nothing but it's just a way of converting from higher memory format to a lower memory format. So this is called actually quantization. Now I think you already know about neural network, right? Let's say this is one neural network I'm having. So inside neural network, what do we have? We have lots of weights, yes or no, right? We have W1, W2, okay, and W3 and so on. So this is what actually we are having. That means we are having lots of weight and biases. Let's say B1, B2, and so on, right? Now you can represent these are the weight as a matrix, because if you know about artificial neural networks, so there I think you know how we can represent these are the weights. Okay, how we can represent our input data and all. Okay, let's say this is the one 3x3 matrix I'm having, and inside that we're having lots of weights. Let's say W1, W2, W3, and so on. Okay, this is the weights, and this weight is nothing but it's a floating number. Okay, it's a floating number, it's a floating value. If you see any kinds of weight, it would be like that. Let's say 7.23000 like that. Okay, so this is called actually floating value. These are the floating value, and if you see, this floating value stores in a FP32 bit. Okay, FP32 bits. Now what is the full form of FP? FP means full precision. Okay, full precision. Okay, full precision. You can also call it as single precision. Okay, single precision. Got it? So whenever we are doing the quantization, that means what we are doing, we're just trying to convert this higher memory representation to lower memory representation. That means it is now saving these are the weights in the FP32 bits. Now what we will be doing after doing the quantization, we'll be converting these 32 bits to, let's say, 8 bits. Okay, 8 bits, or let's say 4 bits. 4 bits. That means what will happen? Let's say you are having one floating number like that. Let's say 1.70890. Now, if you want to convert it to 8 bits, what you will be doing? You will just remove, these are the numbers actually. These are the numbers actually you will remove. And you will take this number only. So that's how actually you can reduce the memory size. That means you can convert any kinds of higher memory actually format to lower memory format. So this is called actually quantization. Okay, I hope it is clear. And the technique actually we usually use, let's say LoRA and QLoRA. Okay, QLoRA. So these techniques help us to perform this quantization. That means it will load the original model as a quantized model. That means in a lower precision. Okay, let's say I want to load this model in a 4-bit precision. 4-bit precision. Okay, so let's say previously this model was in 32 bits precision, but I want to load in 4-bit precision. So how it will happen? With the help of QLoRA or LoRA, you can do it. Sorry, with the help of LoRA and QLoRA, you can perform it. We are having already some Python libraries. Okay, so we are having one library called PEFT. Okay, this is called parameter efficient fine tuning. So with the help of that, you can perform LoRA and QLoRA technique. So with the help of that, you can load any kinds of actual model. So these are the model. Okay, in a 4-bit precision, in a 8-bit precision. Okay, that means you can load as a quantized model so that you can perform the fine tuning operation. Because as I already told you, this actual model you can't load because it is having huge amount of size, huge amount of, let's say, weight size. Okay, and it is storing those are the weights in a 32-bit precision. And to load these at the model, we need a good configuration machine, good configuration GPU, memory, and so on. But we don't have that much of resources. We are having, let's say, Google Colab, free Google Colab, or let's say you are having a 3060 GPU. That time, what you can do? That time you have to load these at the model. With the help of this, these are the technique actually. The technique actually I showed you. This one, quantization. That means you will be using LoRA and QLoRA. With the help of that, you will be loading the model and will perform the fine tuning operation. Now you can ask me, sir, if I'm doing that one, so definitely I will lose some information. Definitely will lose some information because you are loading the model in a 8-bit and 4-bit precision from the 32 bits. That means here you are getting rid of some of the numbers. So definitely you are losing some information. But again, LoRA and QLoRA takes care of this part actually. So they try to optimize your, let's say, model weights as much they can. Okay, so you don't need to worry about if you're using these at the library, everything would be happen in an optimized way. So we'll be learning as a practical also how we can fine tune one large language model. So in the next video, we'll be learning how we can fine tune one model called Llama 2, Meta Llama 2. Okay, we'll be fine tuning this model on top of our custom data. And here we'll be using this PFT technique, parameter efficient fine tuning technique. Got it? Because I'll be using free Colab here. If you want to do in your local machine, if you are having, let's say, any basic GPU, you can also do it. But I'll try to train on Google Colab if you're not having any kinds of GPU, okay, and not having any kinds of good configuration machine, you can perform on Google Colab. Fine. So yes, guys, this is the introduction of fine tuning, and I think you got to know how we can perform the fine tuning operation and what is this PFT, okay, PFT technique exactly, and what is LoRA and QLoRA, because I know that many people will have this question: what is QLoRA, LoRA, and what is PFT and all. Okay, so I think now everything is clear. Okay, how things are working here. Fine. So in the next video, we'll see the practical demo of the fine tuning. So we'll be fine tuning one model, large language model called Meta Llama 2. So here we'll be fine tuning one large language model called Meta Llama 2. I think you know Llama 2, right? Llama 2 is a large language model. So if you go to the Huggingface and if you search for Meta, Meta is having different large language model. If I show you, let's say if I go to the Meta LLM, see, it is having different large language model like Meta Llama 3.1, Llama 2 is also there. If I expand all the things, see, this is the Llama 3 family, this is the Llama 2 family. So the way actually I'm doing the, let's say, fine tuning of Llama 2 family, you can also perform Llama 3 as well. Why I'm taking Llama 2? Because it would be a little bit, small size model. That's why I'm taking Llama 2. You can also take Llama 3 as well. Okay, the process will remain same. And how to get the permission from the Llama, I think I already showed you in my open source large language model session. So you have to apply for the permission first of all, and they will give the permission. Then after that, you can load it. And if you're not getting the permission as of now, what you can do, I can also show you one alternative approach. You can also follow this one. Fine. I think I already showed you one alternative approach. Like you can use any other repository to load the model. It is also fine. Then what you can do after fine tuning this model, you can also push this model to the Hugging Face hub. Let's say if I show you my hub now. So if I go to my profile, see, I already published one model, this fine tune Llama model. After fine tuning it, I publish this model in my Hugging Face hub. Now people can use my model. So they will be just copying this name and they can use my model. You can see it is already downloaded 65 times. Okay, 65 times this model got downloaded by the audience, right? So that's how actually you can also publish your model. If you want, you can also publish your model to the Hugging Face hub. Got it? So that people can also use your model. Got it? So now let me show you how we can perform the fine tuning. For this, I have prepared one beautiful notebook. So in this notebook, actually, I have written each and every step you need to follow. So first of all, make sure you selected runtime as GPU because you are doing the fine tuning operation and definitely you need a GPU. So I'll be selecting T4 GPU because here I'm using free Google Colab. You can also take the premium subscription of the Google Colab. If you're taking the premium one, so you'll see that your training would be a little bit faster than this free one. Fine. Now let me connect this notebook. So guys, as you can see, my notebook is connected. Now the first thing what you have to do, you have to install some of the required packages. So here I have listed down all the packages actually you need, like let's say Accelerate, then PFT. PFT is the parameter efficient fine tuning that package. Accelerate you need if you're using transformer library, and if you want to, let's say, use the GPU, that time actually you need to install this Accelerate as well. Fine. Then you can see bits and bytes is also requirement of the transformer. And if you want to set up everything in your local machine, that means if you're having local GPU, but if you don't know how to set up the GPU, no need to worry. I have created one dedicated video. Let me show you. So if you search my YouTube channel, DSwithBappy, so here you will see that I have created one video in the video section, set up NVIDIA GPU for the deep learning. So here I showed you how we can install the CUDA and CUDA toolkit. So definitely, first of all, you have to set up your GPU in a proper way. Then you will be able to set up everything. That means you will be able to utilize your GPU. So make sure if you are doing local setup, you can try to watch this video. Okay. Otherwise, if you are doing on Google Colab, try to do the same thing the way actually I'm doing here. So let me install all the packages. So guys, as you can see, installation is completed. Now, the second thing, you have to import all the necessary library. So you can see I have imported all the necessary library like auto model for casual LLM, auto tokenizer. Okay, I think you already know these are the thing. The Huggingface actually library. Okay, why we need it. Then you can see I'm importing something called PFT. That means parameter efficient fine tuning. So from PFT, I'm importing something called LoRA. You can also use QLoRA, but here I'm using LoRA. Okay, so both technique we can use. It's up to you. So let me import as of now. So whenever I will be using it, I'll tell you, okay, what are the packages actually you are using and for which task. So see guys, execution is completed. That means everything is working fine. Now, let me show you the data set first of all. See, this is the original data. So let me open the data. See, this is the original data. So the data set name is Open Assistant. So the data set name is Open Assistant Guanaso. I think this is the data set name. And you can see this is the data. That means it is having some conversation between human and assistant. You can see. So conversation between human and assistant. You can see human and assistant. So this is the human, let's say conversation. And this is the assistant conversation. Okay. So that's actually they have collected this data. And it is having actually, you can see how many example. In the training, you are having 9.85k rows. Fine. Almost 10k example you are having. Now see, it is also using different languages. See, different language actually, they have collected the data. Not only English, it is also, they are using Chinese language also. They're using different languages. That means it is a multi-language data and it is a conversation data. So we'll be training one chat model. That means Llama to chat model. Okay. I think I already showed you what is the difference between Llama to chat model and fine-tuned model. Let's say if you want to only perform the text generation, that time you can use pre-trained model. Okay. And if you want to perform, let's say, chat operation, and let's say all kinds of tasks, the way actually you perform with the chat GPT, that time you can use chat model. Now, if you open the Huggingface and if you go to the actually Llama model, you will see that it is having different model. Let me show you. So if I search for Llama, see if I go to the Llama 2 series actually, Llama 2 family, you can see it is having Llama 2 7B model, HF model, and it is also having something called chat model. You can see, chat model. Chat model means you can perform the conversation, chat operation, the way actually you perform with the chat GPT, right? So we'll be fine tuning one chat model. So that is why I'm using this chat dataset, conversation dataset. Okay, instruction. So these are the instruction. I think this one, see, this is the instruction human is giving, assistant is replying. So these kinds of dataset actually will be using. Now you can use any kinds of data. You just try to prepare your data, okay, in that format. You can also create a CSV file. So inside CSV file, in first column, you can write the human, let's say conversation. In second column, you can write the assistant conversation. That's how also you can collect the data. Okay. It can be any kinds of format. So as of now, we are using the data from the Huggingface. You can also use your custom data. And how to upload your custom data to the Huggingface? For this, you can see Huggingface documentation. They will also give you the, let's say, entire process, like how I can, let's say, publish my data to the Huggingface hub. And from there, I can load my data. It is also possible. But most of the data actually will see from the Huggingface itself. You can use it from there. So see, this is the Llama 2 supported data. That means whenever you will perform the fine tuning, so you have to convert this data in that format. See, this is the format. So first of all, you have to give the S token. You can see S token. Inside that, you have to give the instruction. And what is the instruction? Instruction is nothing but it's a human conversation. Whatever conversation human is doing, now this is called instruction. See, if I open this example, see, this is the human. See, this is the human conversation. Okay, see, till this token actually, that means /inst, that means instruction. This is the human conversation. After that, whatever text you can see, this is the assistant conversation. Okay, this is the assistant conversation. Got it? So that's how actually you have to prepare your data, and at the last your S token will end again. Okay, that means this is the complete system token right now, the complete prompt. That means you are creating the prompt here, because my large language model supports prompting, right? So that means we are creating the prompt here, so that my model can understand whenever we are doing the inference, whenever we are, let's say, sending any kinds of prompt to the large language model, it can automatically understand we are sending the prompt. Okay, so that's why I'm first of all teaching my model. This is instruction, and after instruction, whatever actually message you can see, this is the your output. That means your response, assistant response. Okay, this is the format. Now, if you open any kinds of data, you'll see that it is using the same format only. Okay, same format only. So we have to convert our data, this format to this format. Okay, now you can ask me how to convert this format to this format. For this, we can use one notebook. See, this is the notebook, guys. Even I already attached this notebook link inside this original notebook. Let me show you. See, this is the notebook. Okay, so in this notebook, actually, I already written one function, transform conversion. So this one actually will take the human conversation as well as the assistant conversation, and will add these at the token. Okay, like that, the way actually I showed you here. Okay, I think it is clear. Now you can use this function as it is, and you can convert any kinds of, let's say, these kinds of conversation data to your like LLM format. That means your Llama 2 format. Now there are so many large language model. It takes actually different kinds of format. If you go to the documentation of the Huggingface, you will see that what kinds of format they supports. Based on that, actually you can actually write the converter. Also, you can get this converter from the Huggingface itself. Huggingface also provide these kinds of converter. You can use this converter to convert your data to a specific format. Okay, so most of the large language model will follow this format only. Okay, we'll see that most of the large language model will follow the same format, the format actually I'm using here. Fine. So that's why you can use this converter as it is. Now see, here I'm loading the data. That means my entire data. That means this data, this open assistant data. You can see I'm giving the name of the open assistant. Then see, instead of taking all the data, all the, let's say, 10k example, I'm only taking 1000. Okay, 1k actually example, because here I'm using free collab and fine tuning will take time. That's why I'm only taking 1000 example to perform the fine tuning operation, and I'm doing the, let's say, conversion operation. Then after that, I'm just pushing this let's say data here. So this is the data. Now see, the same data, but here actually this guy is taking actually 1k example, and he has already converted this data to the required format. Okay, so this is so this data is already available. You can see this guy has already converted this data to this format, so directly you can use this data. But if you want to do it, so this is the notebook you can use. Okay, the same notebook you can use. Got it? And if you want to use the entire data, guys, what you can do, so here I've already given the complete reform dataset link. You can open it up. So see, it is having actually 10k example only. See, around 9.85k rows. Now see, it is already formatted. Okay, it is already formatted. So you can also use this data. If you're using good configuration PC, you can use this data, okay, for the fine tuning operation. But I'm going to use this data actually, 1k example data. Okay, only 1k example I'll be taking here. So guys, I think now you got to know how we can reformat our data for the Llama 2 model. And see, here we are using free collab, and free collab actually offers 15 GB of graphics card. If you see here, it will give you 15 GB of graphics card. See, okay, and here you will get disk around 112 GB, and RAM actually will get 12 GB. Okay, so this is the configuration of our free collab. Now here you can see it is having actually limit resources, barely enough to store Llama 2 7B words. That means we can only use 7 billion Llama 2 model. Okay, 7 billion Llama 2 model. If you're using 70 bay, 30 bay, 13 billion, that time actually will get difficulties. Okay, because it is a free Google Colab. But if you're using a premium Google Colab, that time actually you can also use this model. Okay, it's completely fine. Now here you can see full fine tuning is not possible. Here we need to perform the parameter efficient fine tuning technique, like we'll be using LoRA and QLoRA. Because the full model we can't load here, we have to use a quantization technique. That means we'll be using LoRA and QLoRA to perform the parameter efficient fine tuning. Got it? And to drastically reduce the VRAM, we must fine tune the model in 4-bit precision, which is why we'll be using we'll be using LoRA here, not QLoRA. We'll be using LoRA here. Fine. That means we'll be loading our model in a 4-bit precision. I think I already explained here what is 4-bit precision, right? So initially your weight would be in the full precision. Okay, 32-bit precision. This is called full precision, and we'll be loading the model in the 4-bit precision with the help of LoRA technique. Fine. I think it is clear now. Now let's load the model, guys. Now you can load the official Llama 2 model. You can see you can also load the official Llama 2 model. So Llama 2 is having also official model. So this one. So see, this is the official Llama 2 model. You can load, you can copy, and you can just paste it here. But if you didn't get the permission, what you can do, you can also load the model from any other repository. So see, this repository has it having this model also, this Llama 2 7B chat HF model. So this repository has already published, and here you don't need to take the permission. You can directly download the model. So if you haven't get the permission, you can use this model. Either you can use the official model. Okay, official model. Let me also copy here and let me mention it here. Let's say I can comment here just for your reference. You can copy the name and you can paste it here. Okay, later on. Now this is the dataset, guys, I'll be using. I think you remember. So this 1K example we'll be using. So copy the name and try to mention it here. Okay. And after fine tuning, what is the name you want to assign? I want to assign this name Llama 2 7B chat fine tune. And these are the LoRA parameter, you can see. And LoRA parameter wise, everything just keep it default, because you can see I'm loading everything in a 4-bit precision. Okay, 4-bit precision. So no need to change anything. Keep it everything as default. See, I won't be changing anything. Only the change you have to do, the epoch size, number of epoch you want to train. So I think epoch I have mentioned here somewhere. See, number of epoch, training epoch. So as of now, I'm showing you one let's say epoch training, because one epoch training will take time if you're using free collab. And if you're doing the actual training, that time just try to increase the epoch size. Now everything keep it default, no need to change anything. Now let me initialize all the parameter. So this is my LoRA parameter, guys, for the parameter efficient fine tuning. Fine. Now we'll be loading the dataset. I want to use the training dataset because I want to do the fine tuning. And here I'm loading everything in a 4-bit precision, you can see. Okay, with the bits and bytes actually configuration, we are loading everything in a 4-bit precision. So this is the way actually we can define our LoRA. And how I got this code, if you go to the Huggingface documentation, you will see that, okay, they have already given this kinds of code snippet. So you just copy paste and try to use it as it is. No need to change anything. Fine. Now see, here I'm loading the model in a 4-bit precision. So here you can see I'm loading the base model as well as the tokenizer. Okay, tokenizer I'm also loading. So guys, here you can see I'm setting all the LoRA configuration. After that, here is the training arguments. I think you know what is training arguments. In the Huggingface, you have to set your directory, the number of epoch, your optimizer, everything you can set here. Then with the help of SFT trainer, I'm initializing the training process. You can see model.train. Now see, if I execute this code, it will start the training. But see, training will take time actually, around 30 minutes actually it will take. I was training previously. I know that it will take around 30 minutes. Okay, 30 minutes you have to wait because here we are using free Google Colab. So as you can see, it is downloading the model. After that, you will see that it will start the training. See, it's downloading the model. So see, I won't be waiting 30 minutes. What I'll show you, the next process actually you can follow. Like after training, what you can do. Because see, I have written all the code. Only you just need to execute if you're doing it. Because here I'm recording currently. So I can't wait actually 30 minutes to train the model. Let me show you what you can perform here. See, after training the model, you have to save the model. You can see you have to save the model, trainer, model, save, pretend. Then you have to give the new model name. I think new model name, I think you remember, we have given a new model name here. Whenever we define all the configuration, this is the new model. Okay, so it will save with the help of this model. Fine. So it will save the model in the here in this disk actually. You'll see that it will create an output folder. Inside that it will save the model. Then after that, you can also visualize the TensorBoard logs. See, this TensorBoard will show you the losses, then the accuracy, okay, of your model, everything it will show you. That means the complete metrics it will show you, the training losses, validation losses, everything it will show here. Then after that, what I was doing, I was loading the original model. You can see I'm loading the original model, not the trained model I've trained. I'm loading the original of the Llama model. And then I'm testing with a prompt. What is large language model? I just wanted to see what would be the output from my original large language model, because that means I want to compare this result with my trained model, the model I have trained right now. Okay, that's why I'm loading the base model. That means my original model, and I'm only want to see the output. Okay, so here I've given a prompt. What is the large language model? And this is the actually output I got. Okay, from my model. Then after that, what I did actually, I deleted all the model pipeline and everything just to empty my VRAM, because in RAM actually it will occupy lots of space. So you have to execute this code after executing this line actually. So no need to execute this line of code. Just try to skip as of now. First of all, is execute this line of code. This line of code, what it will do, it will try to load your base model as well as your trained model. Okay, that means new model. Then it will merge. That means if you want to save the model right now, if you're using parameter efficient fine tuning, first of all, you have to load your base model as well as your new model. Okay, both you have to load. Then after that, you have to merge. After merging, what you can do, you can also load your tokenizer. Then you can push this model to the Hugging Face hub. For this, just execute this line of code and you have to perform the Hugging Face CLI login. Okay, Hugging Face CLI login, and it will ask for one authentication token. See, this is the token it will ask. Now what you have to do, go to the Hugging Face, go to the settings. I think you know how to generate the tokens. Go to the access tokens. Now create a new tokens. Let's say I'll give the token name is equal to test. And now you have to give the right access because you want to write something. You want to push something to the Hugging Face app. That's why you have to give the right access. Now create the token. Let's create the token. Now copy the token and pass the token inside that. Inside that you have to pass the token. Then give Y. Then press enter. After that it will automatically authenticate with your Hugging Face. Then it will be pushing your model to the Hugging Face itself. Now here you have to give your username. See, this is my username, ENTBappy. So make sure you are giving your username here. Okay, not my username. Otherwise it won't be working. Okay, so if you execute this line of code, it will push your model as well as the tokenizer as well. Now after executing this line of code, go to the Hugging Face, click on the profile, go to the, let's say, your profile. Now you'll see that in the model section, this model would be published. Okay, and this is the model and this is your tokenizer. That means the same model you have to use for the tokenization as well. I think I already showed, right? Now, after that, let's test this model, okay, whether it is working or not. So for this, I created another notebook. Let me show you. So this is the notebook I created, guys, fine-tune model test. Now, again, just try to install Transformer Accelerate. That means all the required package. Then after that, just try to load your model right now. The model actually you have trained. See, this model, just try to copy the name and just try to paste it here. Okay. Then again, I'm giving the same prompt. What is the large language model? I'm loading the tokenizer first of all. So inside this pipeline, I'm giving my model. Then after that, you can see I'm creating the complete pipeline. Then it is predicting and it is giving me the results. Now see, this is the results actually I'm getting. See, although I've trained only one epoch, but if you see the results, it's not actually bad. Somehow actually it has given me the good output. Then again, I have given another actually prompt. Now see, this is the results. I'm executing my model and this is the result actually I'm getting. So the prompt is actually explain to me in a simple to understand way what is the equation of finding the nth triangle number is and how it can be provided by using the high school level math. Please give each step of a proof of using latex. See, this is the latex actually output I'm getting. That means all the, let's say, mathematical equation and everything it has given me as a latex. Now I can convert this latex to the mathematical format and you can see that particular output. Okay, so that's how actually we can also test our model. And this is the entire process of fine-tuning, guys. Entire process of fine-tuning. And see, still training is going on. You can see still training is going on and it has created the result folder. And inside result, inside branch, it will save the weights. Okay, it will save the weights. That means the artifacts. Fine. So yes, guys, that's how actually you can perform the fine-tuning operation with the help of parameter efficient fine-tuning. You can use either LoRA, either you can use QLoRA. Fine. So now what you have to do, guys, just try to perform this fine-tuning. And if you are having any error, if you are having any issue, you can let me know in the comment. I'll try to help you with that, okay, to fix that particular error. Now, apart from that, just go to the Hugging Face, try to pick any other model, guys. Go to the Hugging Face and pick any other model, not this Llama 2 model. You can also take Llama 3 model. You can also take, let's say, Mistral model, Falcon model, any kinds of model you can take. Just go to the model section, just find a model and try to perform the fine-tuning process. Okay, you can use the same technique to perform the fine-tuning process. Fine. So in future, I'll create some more video there. Actually, I'll show you how we can fine-tune any other model as well. Let's see if we want to fine-tune the Gemini model, how we can do it and all. Okay, we'll be creating some more video. But before that, first of all, try to explore by yourself. The way actually I showed you, the entire notebook I shared with you. Try to pick up any kinds of model and try to follow the same technique to perform the fine-tuning operation.
So LlamaIndex is nothing but it's an alternative framework of LangChain. So LlamaIndex gives you the ability to build a very powerful generative AI application with the help of large language model. So whatever things actually we have learned with the LangChain, like we saw like how we can use LangChain framework to build generative AI application. The same things can be performed with the help of LlamaIndex as well. So this LlamaIndex and LangChain is like very popular in the market nowadays. So people are using LlamaIndex and LangChain very broadly in their generative AI application. Now it's up to you like which framework actually you will be choosing whenever you are developing any kinds of generative AI application, right? So we have learned like LangChain, like how we can develop generative AI application with the help of LangChain. Now it's time to also explore like this LlamaIndex one. So in this video, actually, I will give you like how we can build generative AI application with the help of LlamaIndex. So this is going to be one amazing video altogether. Just try to watch this video till the end. And don't skip any part of this video, otherwise you might get some issue. And if you have some query, you can let me know in the comment. I will happy to help you. So guys, let's start with our video. So first of all, I will take you through the LlamaIndex documentation, then I will start with our project implementation. So guys, this is the LlamaIndex documentation, and LlamaIndex is nothing but it's a simple flexible data framework for connecting custom data sources to the large language model. So basically LlamaIndex is nothing but it helps you to build this kinds of generative AI application with your custom data, as well as it will also give you the ability to connect with these kinds of large language model we have seen, right? So it is the similar kinds of framework of your LangChain. So whatever functionality LangChain provides, your LlamaIndex will also provide that one, but some of the syntax would be a little bit different. Okay, so I will discuss this thing whenever I will take you through the project demo. Okay, whenever I will be building projects with the help of LlamaIndex, at that time I will show you like where what is the syntax change actually you need to consider. Now guys, you can go through the documentation. They have written everything. Okay, so here it is telling we can easily build like lots of generative AI application with the help of this LlamaIndex. Even you can connect with these kinds of unstructured data, structured data, and semi-structured data. So unstructured data means text data, PDF data, video data, and it can be also image data. Structured data means you can also connect with Excel data, SQL data, and so on. And semi-structured data means like you can also connect with the API. Then you can also with this Slack, then Salesforce, Notion. So these kinds of platform you can also integrate to collect the data with the help of this LlamaIndex. Okay, so this is one of the very popular framework in the market, and it is like very powerful. So you can use this one also to build your generative AI application. So it's fine you if you know like both framework like LangChain and LlamaIndex, so it will help you to build like very powerful generative AI application, right? So I personally like this LlamaIndex a lot. Okay, I usually use LangChain to build my generative AI application, but I also like this LlamaIndex. Sometimes I also use LlamaIndex to create my generative AI application. And guys, this is the documentation of this LlamaIndex. So there actually they have given how to set up this LlamaIndex and what are the things actually it provides. See, it has also this agents, then chatbot, structured data extraction, then indexing, everything like whatever you have seen inside your LangChain, everything it has. If you see here, all the things actually they are providing. So you can go with the documentation. So they have given each and everything. Now I'll quickly show you like how we can set up this LlamaIndex on our Google Colab, and how we can build like one basic generative AI projects with the help of this LlamaIndex. Okay, then it would be very much clear for you. So first of all, what I will do, I will open my Google Colab. So let me open my Google Colab. So here I will create a new notebook. Here you can give the name. So I'll just give LlamaIndex demo. And here make sure you have selected runtime as GPU. So let me select runtime as GPU. And let me connect the notebook. So in between what I can give you, I will give you the project architecture, like actually what I'm going to do exactly with the help of this LlamaIndex. So for this actually I'll open my Blackboard, and here I already kept this project architecture, as you can see. So basically here we'll be building one projects. Basically here we'll have lots of like documents. So basically we'll be chatting with the documents. Okay, so chat with multiple documents. Okay, so this is the project name. So it can be any kinds of documents. So it can be PDF, it can be, let's say, doc, it can be txt. Okay, it can be image, anything you can give. So we'll be extracting the data all together. Okay, then we'll be chatting with these kinds of documents. So this is nothing but our custom source. Okay, so this is nothing but our custom data. Okay, or custom data source you can talk about. Okay, and here first of all what I need to do, so user will give me these kinds of like data, custom data. So I need to extract the data, and after extracting I also need to convert them to chunks, because I already told you what is this chunks and why we need it. Because here I'm going to use large language model. Okay, LLM, I'm going to use large language model. So LLM wise I'll be using something called Google PAM, Google PAM 2. I already discussed like Google PAM 2. And if you already know, Google PAM 2 has one specific input size, which is nothing but 8096 tokens. Okay, So if you're extracting the data altogether, so it might be more than 8096 token. So that is why it's better to create a chunks. So instead of giving all the corpus together, I will provide as a chunks to chunks so that my input size it can handle very easily, right? So that is why chunks is important. So after creating the chunks from my entire corpus, I also need to convert this text to vector. Okay, I'll be converting text to vector. So for this actually I'll be using some embedding model. So in this case actually I'm going to use Huggingface embedding model, Huggingface Huggingface embedding model. You can also use PAM2 embedding model. It's completely fine. I already showed you how to use PAM2 embedding model. You can also use Huggingface embedding model. Then after creating this vector store, I also need to store these are the vector, okay, in a knowledge base. So by default actually this LlamaIndex has one functionality, so it will create a knowledge base in your local. I will show you like how to create it. Then after that we'll be handling the user. So user will raise some query, so we'll first of all convert that query to query embedding. Then we'll be performing something called semantic search, so it will give me some rank results, and we'll be applying generative model, that means large language model, to get our actual response. Okay, so this is the complete idea of our project architecture, right? So now let's implement with the help of this LlamaIndex. As of now, we have seen like how to implement with the LangChain. We have seen like how we can develop end-to-end generative AI projects with the help of LangChain and vector database and so on, right? So same thing you can do with the help of LlamaIndex. You can also add your vector DB here. You can use Pinecone. You can use Web8, you can also use ChromaDB, anything you can use, but here I'm not going to use any kinds of vector DB. I'm going to use default knowledge base providing your LlamaIndex. Okay, so it will store your vector in a local. I'll show you like how to do it. Okay, you can also connect with the vector DB, so that can be also done. I already taken lots of session on it, so you can go ahead and watch it. So guys, now let's see like how we can set up this one. So to set up LlamaIndex, there is a Python package actually we'll get called LlamaIndex. Okay, so just write pip install -q LlamaIndex. Okay, Llama hyphen index. So this is the package name you need to install. If you visit their documentation, and if you visit their installation guideline, okay, if you visit their installation guideline, see this is the LlamaIndex package they are using. Okay, now I also need to install something called PyPDF, because here I'm going to use PDF data. So let me install PyPDF, PyPDF. Then I'm also going to install something called doc to text, because I'm going to use also doc type data. So I'll just write pip install docs to text txt. Okay, this package I need. Then I already told you I will be using Google PAM2 as my large language model. So for this actually I need to install something called Google Generative AI. So pip install Google Generative AI package. Okay, now I will be using something called Huggingface embedding. So for this I need transformer. So I'll install transformer. So pip install transformers. Okay, now let me install them together. So guys, installation is done. Now I'll import some of the libraries. So let me import. So first of all, I will import something called simple directory reader and my vector store from my LlamaIndex. I'll tell you like whenever I'll be using it. So these two function I need. So these two function actually I need, called simple directory reader and my vector store index. I'll tell you like whenever I'll be using. So what is the use of it? Then I also need something called PUM model. So it is already available inside LlamaIndex. So as you can see, LlamaIndex .llms PUM, and I'm importing this PUM. And this is the similar things actually with the LangChain as well. So I think you remember we are also importing PAM2 model from LangChain. So from LangChain.LLMs, then I was also importing this PAM model, right? So if you have already used LangChain, so using this LlamaIndex would be very much easy for you, because lots of functionality will remain same, will look like similar to you. So some of the functionality and syntax might different, but rest of the things are I think similar. Okay, what I feel like. Then I also need something called service context from LlamaIndex. I'll tell you like what is service context. Then I also need something called storage context and this mm, load index from storage. Okay, these are the thing. Then I also need something called operating system package. Now let me import them. Okay, done. Now I will load my data. So here let me comment out load data. So to load the data, first of all, here what I will do, I will create one directory. So here I'll just write one command mkdir, and I will name this directory as data. Now if I refresh, I think directory has created. Now here I will upload some of the data, that means documents. So I can upload, see here I have PDF as well and this docs data as well. So let's upload these docs first of all. So this is the like LlamaIndex documentation, as you can see. So it is present inside my docs file. Now here I will also upload this one YOLO. Okay, YOLO PDF. So with the help of this simple directory reader, we can load everything, any kinds of file format you can load. Okay, so that is the power of this LlamaIndex. But if you used, I think LangChain, you remember, we used to use something called PDF loader, then TXT loader, separate file. But if you're using LlamaIndex, so you can directly load them together. Okay, so these kinds of some functionality will might vary and will look new to you. So it's completely fine, but functionality are same. So guys, let me show you like my data once, like what are the things I have. So in this LlamaIndex docs, I have some content related LlamaIndex, like what is LlamaIndex and all. Okay, so here is the content I prepared and it is present inside these documents. Then in the PDF, actually, we can see this is a YOLO related PDF. So what is YOLO and YOLO architecture? So these are the content are available. So you can ask any kinds of query, any kinds of question from these documents. Okay, you have submitted. So we'll be doing that with the help of this large language model and with the help of this LlamaIndex. Okay. So guys, as you can see, my data has been uploaded. Now what I can do, I'll first of all load the data. So I'll extract the content from these documents and PDF. So for this, I'll be using something called this simple directory reader. So I'll call it, and inside that you just need to provide the directory. So this is the data directory. Inside that I have this data, and here is one function called load underscore data. You need to call, and I will store it inside a variable called documents. Okay, now let me load them. Yeah, now if you want to see the data, so this is the data it has extracted. Okay, and this is in a document format, as you can see. Okay, and it will also give you the reference ID and if you're using any embedding or not. So it's none by default because we haven't used any embedding, and this is the content it has extracted. Okay, now what I need to do, guys, we have successfully extracted the data. Now I need to perform something called chunking operation on top of it, because this is my entire corpus and I also need to convert them to chunks. So for this, let me just first of all comment. So we'll be performing split text into small chunks. So before that, first of all, I need to set my Google API key. Okay, Google API key I need to set. So the using this Google API key, we'll be able to access our PAM model. Okay, from this uh, Google PAM API. So if you open this Google PAM website, so here they are telling just try to create one API. I already showed you how to create the API. Just click on this PAM API, and here you just need to get your API key. And here you can generate a new key. Okay, so for me, I already created one key. So this is my key I already created. So if you don't have any key, you can create from here. So guys, I already created the key, so this is my key, and don't share this key with anyone. I will remove it after the recording, so that's why I'm showing. Now let me set this key as my environment variable. Done. Then I need to initialize my LLM. So LLM wise, I am using something called this palm model. So it will automatically authenticate using this API key. Okay, so palm is not initialized. Please install Google Generative AI. I think we have already installed this package. Why it is giving? Okay, let me install it. Okay, I need to restart the runtime, so that is why I think it was not working. So guys, we have restarted the runtime. Now let me import them again. Now I think my documents is already there. Okay, so I need to again load the documents. Now this is my data. Now I'll set this API key. Now I load my palm model. Okay, it's loaded. Now, see guys, initially whenever I was using LangChain, so we used to create these chunks in a different way. We used to use something called text character splitter function to create these chunks. But here, this things is a little bit different. So here you need to use something called this service context. Okay, so here is a service context function. You need to use this function. So here you just need to initialize it. So it has one method called from documents. So from no sorry from default. So from defaults, and here you just need to pass the LLM at the very first. So LLM wise, so palm is my LLM. Then I also need to give the chunk underscore size. I think you already know what is chunk size, so it will like split your data with respect to that. And I also need to define something called chunk overlap. Okay, so overlap, so let's give 20. So chunks overlap helps us to understand the context of my entire corpus, because it will convert to chunks, and to get your previous context I need the chunks overlap. I already explained this thing in my vector database session. Now here you can also give like embedding, which embedding you want to use, and if you're not giving anything, so by default it will use that Hugging Face embedding. I'll show you. So service context, this is my service context I got. Now if I execute this code, you will see it will first of all okay, it's giving one error. No API key found for OpenAI. uh okay, it's giving the error because I need to again install this transformer, I think. So let me install the transformers. So guys, as you can see, it's giving one error. It's telling no API key found for OpenAI. So here, by default, if you are not giving any embedding model, so it will try to take the OpenAI embedding model. But here, in this case, we haven't provided any OpenAI API key, so that's why it's throwing error. So if you visit this URL, so they're telling if you want to use some other embedding, so you need to first of all import it. So let me import this Hugging Face embedding. So I told you I'll be using Hugging Face embedding. So first of all, let me import this Hugging Face embedding here. You can also use Google PAM embedding the way I showed you in my previous project. You can do it, but let's use this Hugging Face embedding. Now I need to create one object called embed model. So here I can create. Now here I'll be using this model. This is the model available in the Hugging Face. This is the embedding model. So I need to install something called sentence transformer for this. So this is the command. Let me install it here. Done. Now let me import it. Now guys, see, first of all, it will download that embedding model from Hugging Face. Then it will load that. So done. Now I need to give one parameter here called embed model is equal to embed model. Now let me execute it. So my service context is prepared right now. Now what I will do, now what I need to do, I need to convert my documents to chunks, and that chunks I need to convert to something called vector embedding. Okay, so for this, you need to use something called uh, vector store. Okay, so vector store, I think we have already imported this thing above. So this is the vector store index. So this class will help me to do that. So let me import it here, and it has one function called from documents. Okay, so here you just need to give your document. So in this case, I have my documents here. I think you remember. So this is my documents. This is my entire corpus. Then I also need to give my service context. So service context equal to my service context. This is the service context. So it will take the model and everything from here, and all the configure I have set here, chunk size, chunks overlap, everything I have given here. Now I will get my something called index here. So in LlamaIndex, the vector you get, we call them index. Okay, so this is my index. Now let me convert them. So it is taking some time because it is taking all the documents and converting to chunks and converting to vectors. Okay, now we have successfully converted them. Now I need to store them in my local. So let me comment it here. So to store it, first of all, call this object called index, and there is a method called storage, 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 storage context dot persist. Persist. Okay, now if I execute this one, you will see it will save everything as your local. Okay, so there is a folder it will create called storage. Inside that, see all the vector it has saved. Okay, now you can open it, anything, you can see that. Okay, see, this is the uh, data it has saved. So it follows one particular format to save your documents. So it might not understandable to you, but this is my, see, this is my vector. Okay, this is my final vector of my entire data. Now guys, we have successfully stored our indexes. Now let's see if you have some existing storage or existing index already. So instead of creating them, you can directly load it. So this is the code. So this is the code, load the index. So here you need to call storage context. I think you remember we imported this thing, storage context. So using storage context, there is a method called from default, and here you just need to give the persist directory, which is nothing but storage, and it will load that. And to load it, you need to use load index from storage. Okay, we imported, I think above, you remember, load index from storage. Then it will load that index for you. Okay, it will load that index for you. So you can execute this code. Okay, I already created my index object, that's why I will comment it out. Okay, I'll comment it out. You can if you have already, so you can load it out. And here you can also use like vector db to store these other data to your vector db as well. Okay, this is also possible, but LlamaIndex provide this functionality, so that's why I am showing this functionality to you. Okay, how to store them in a local machine. Now we can perform our QA operation. So let's do Q&A operation. So here, first of all, you need to define one query engine. So this is my index. So it has one parameter as query, as underscore query engine, and this is my query engine. Hmm. Now I'll call my query engine, and here I will ask the query. So this is my query. So here, first of all, I will ask like what is LlamaIndex, because I have one LlamaIndex related documentation here, right? So that is why I'll ask what is LlamaIndex, and it will give you the response, and this response I will print it here. So guys, this is my response. Again, it's not understandable. So if you want to extract the actual response, if you want to see the actual text, so for this, you can use this package, because we are using Google Colab. So there is a package called IPython display, markdown and display. So these two packages I'll be importing. Then I'll be using something called display.markdown. And here I will give my response. Okay, the response I'm getting. Now if I execute it, so it should give me the response. See, LlamaIndex is a data framework for building an LLM application. It provides a comprehensive toolkit for integration management and query of your external data so that you can use with your LLM app. Great. Now you can ask any other query. So let's say I have one YOLO documentation. So I can ask anything about YOLO. So what is YOLO? Now if I execute again, see, YOLO is a regression algorithm. It takes image input and output, building bounding boxes and level images. Okay, great. Now let's see if I'm asking anything out of this context, out of this data. So let's see what happens. So I'll ask uh, who is Bappy. Let's say I will ask this question. See, it's telling Bappy is a random name, and it's not mentioned in the context. So basically, we have created these projects, and basically it is only relying upon our custom data we have given. Okay, apart from that, if you're asking anything, so it won't be giving the answer. So you can ask anything like related to your documents. So in this case, you can use this question, anything you can ask, like whatever question actually you have. So it will give you the answer with respect to that. Yeah. And this project actually you can convert to Streamlit app. I already showed you how to convert them to Streamlit app and all. So you can try this thing from your site. Okay, I think you can do it. So yes guys, this was all about LlamaIndex. I hope you get it, like how we can use this LlamaIndex as our alternative framework of our LangChain. And this is one of like good framework, I can say. So you can visit the documentation and you can learn so many things about LlamaIndex. Okay, now try to explore from your side, so you'll be getting each and everything.
I think you already know about LlamaIndex. I already explained what is the LlamaIndex. LlamaIndex is nothing but it's a alternative framework of LangChain. That means whatever, let's say, things you can perform with the LangChain, the same thing you can also perform with the LlamaIndex. So both are actually generative AI framework. With the help of that, you can create generative AI based application. So in our previous video, we saw like the entire introduction of the LlamaIndex. So there actually we already performed one practical example. So in this video, I'll show you how we can use open source large language model with the help of LlamaIndex. So as an open source model wise, I'll be using something called Mistral. Okay, so if you don't know, Mistral is an open source actually large language model, and it is available inside Huggingface. Now, if you search here, let's say Mistral, if I search here, see Mistral is having actually different model. Let me show you. So let me go to the Mistral AI. See, it is having actually 17 different model. So expand all the 17 different models. See, Mistral is having 7B model. That means this is the 7 billion model, 22 billion model. Okay, that's actually it is having different model. So from this model, guys, I'm going to use one model called Mistral 7B Instruct V01. So this model actually will be using with the LlamaIndex. So this model will be downloading from the Hugging Face hub and will be using with the help of LlamaIndex. Okay, so here I'm going to create a simple system. So let me show you the diagram, what I'm going to perform here. See here, I will upload one actually PDF document. Then I will extract the data, extract the documents, extract docs. After that, I'll perform chunking operation. I think you know what is chunking, okay, and why it is required. Then I'll be using one embedding model. Here I'll be using one open source embedding model. Fine. Embedding model to generate the vector embedding. So it will give me something called vector embedding. And this vector embedding I'll be saving to a knowledge base. That means vector database. And if you're using LlamaIndex, guys, I think you already know LlamaIndex has one vector database service. So we can call it as vector store. Okay, vector store. So inside vector store, we can save our embeddings. Okay, whatever embeddings actually will be generating, and we'll be using LlamaIndex. Okay, LlamaIndex vector store. Okay, LlamaIndex vector store, and this is going to be my knowledge base. Then after that, user will ask one query. Let's say this is the user. User will send one query to the knowledge base, and knowledge base will return some relevant answer. Okay, it will give you some rank results. Then what I have to do, I have to use one large language model, LLM. So here we'll be using something called Mistral. Okay, Mistral. So we'll pass this rank results to this large language model as well as this query as well. So this query and this rank results will process your large language model, and it will give you the actual response. Okay, it will give you the response. So this is the system actually we'll be implementing. Fine, with the help of LlamaIndex as well as the open source large language model, because this system we already saw how we can implement with the help of Langchain. Now let's try to see how we can use the LlamaIndex as well. So let's get back. So here I already created one notebook, guys. You can see Mistral with LlamaIndex. So first of all, let's connect this notebook. So resources would be shared in the description section. So from there you can download and you can execute all the code. So it is connected. Now let me check the GPU, which GPU actually I got here. So I'm using Colab Pro, guys. So that's why I'm using A100 GPU. So if I go to the runtime, change runtime type C, I'm having A100 GPU. So if you're using Colab Pro, so you can access this GPU. Otherwise, you can select T4 GPU. Okay, it's completely fine. Now let's install the PyPDF, because I already told you I'm going to use PDF data here, and I have to upload one PDF documents here. Okay, but before that, let me complete the installation. Then I'm going to install the transformer. Then I am also going to install some required package for the transformer. Okay, so let me install everything. Why transformer? Because I want to access this Mistral model, and this model is available in the Huggingface app. And then I need to install something called sentence transformer. Why? Because I already told you we'll be using open source embedding model, and for this I need this sentence transformer. So let me install this as well. Now I'm going to install the LlamaIndex. So I'm installing one specific version. Why specific version? Because I already told you if you're installing any specific version, that will help you a lot in future. Because let's say today you have created one project with the latest LlamaIndex. What will happen after some days? Actually, they will upgrade their package, and again you will get issue, right? So that's why it's always better practice to use one specific version. Fine. Now let me import all the required libraries. So you can see I'm importing from LlamaIndex vector store index, simple directory reader, service context. Okay, then Huggingface LLM, then simple input from. So this is the vector store, guys. That means this is the vector database service LlamaIndex provides. So here actually we can create a knowledge base and we can store our embedding, and this is the local DB. Okay, it will save everything in local. Then simple directory reader will help you to read your content. That means whatever data actually will be reading, right? Then Huggingface LLM will help you to load that Mistral model. Then with the help of simple prompt, you can create a prompt template. Fine. So now let me import all of them. Later on, I'll tell you whenever I'll be using them. Now here I'm going to create a directory called data. Okay, because inside data directory, I'm going to upload my data. Now see if I refresh here, data is created. Now let me upload one PDF here. So guys, I'm having one statistics PDF. So I'm going to upload it here. So let me show you the PDF. So this is the PDF document, guys. Importance and use of correlation in statistics. So this PDF actually I'm going to upload in my Google Colab, and on top of that actually will be performing this operation. Now here you can use any kinds of PDF, any kinds of documents. Okay, whatever you have. Now see, it is uploaded. Now let me read the content. So inside simple directory reader, you have to give the data location. So you can see I've given the data folder. It will automatically load the PDF and it will extract the information. Let me show you. See, if I show you the documents right now, see all the document is has extracted. Fine. Now here, first of all, let's create a prompt. So here you can see I have created a system prompt. You are an QA assistant. Your goal is to answer the question accurately as possible based on the instruction and the context provided. Now this system prompt actually I want to use as a default prompt inside my large language model. For this, you have to create one query wrapper prompt. For this, you can use simple input prompt. Okay, and inside that you can pass these are the keyword. Fine. Now let me execute. Now you have to do the Huggingface CLI login, because this model is available inside Huggingface, and to authenticate with Huggingface, you have to give the token. Now here you have to pass the token, and how to get the token, guys? I think you remember. Go to the Huggingface, click on the profile, go to the settings, and left hand side you will see access token. You can create a new token here. So let me give the token name, let's say test. I want to give the read permission as of now. Let's create the token. I'll copy and let's mention it here. If I paste it and hit enter, it will automatically authenticate. Now here it is asking token as greet credential. I'll give yes. Now see, login successful. Okay. Now you can see this is the model link I have already given. So this model actually will be using. Now let's load the model. And to load the model, I'm going to use Huggingface LLM. Inside that, you can pass context with the max token. I think you already know what is max token. So what is context window? Context window means this is the input size of this LLM. That means it can take 4096 token actually as input. Okay, as the input. That means this is the input size of your large language model. Mistral can take 4096 token. Okay. Now you can give this temperature parameter and all. And inside that, just pass your system prompt, whatever prompt actually you have defined here. I think remember. And you have to also pass the query wrapper prompt. That means the default prompt you want to set. And here you have to give the model name, like which tokenizer you want to use. I want to use the same tokenizer as per my model. See, this is the model. Okay, I'm giving the model ID here. Now you need to also give the model name. That means the same name. Then after that, auto map is equal to true. That means I want to use my GPU here. I want to load this model in my GPU because it's a large language model. It is having actually lots of parameter, right? So we can't let's say run this model on our CPU machine. It's not possible. If you're running, actually it will take lots of time. Even your memory will also get crash. So that's why we have to load everything in the GPU based machine. Now let's load this model. See, first of all, it will download the model from the internet and it will create one LLM wrapper. See, it's around 9.994 GB. Just try to consider, guys, how much big this model is. So that's why actually whenever you are using any kinds of open source large language model to create any kinds of LLM powered application, so this is the issue actually you'll be getting. That means you should have good configuration machine, otherwise you won't be able to use that model. So we'll be learning something called LLMOps. So inside LLMOps, actually I will show you how we can create an efficient LLM powered application, how we can deploy it also on the cloud platform. We'll be discussing each and everything. Because of that only LLMOps came in the market. There are so many platform actually we can use, like cloud generative AI we can use. Let's say Bedrock is there, VertexAI is there, Azure OpenAI is there. We can use these are the service, okay, to overcome this issue. So this model has downloaded successfully. Now what I have to do, I have to download the embedding model as well. So to download this embedding model, I'm importing Huggingface embedding from Langchain. So because Langchain is having one embedding functionality, so from there we can easily download the embedding model. So let's try to download this embedding model. So we have to install Langchain community for this. So let me install Langchain community. Now let me execute this code. So see, it has downloaded successfully. Now let's create the service context. That means my vector store. That means I will be creating the knowledge base. For this, we'll be using service context from default. Inside that, you have to provide the chunk size. That means first of all, it will perform the chunking. Then it will create the, let's say, vector embedding, and it will store that vector embedding to the knowledge base. Okay. Now inside that, you have to pass the LLM as well as the embedding model. Now let's create the service context. So here actually some of the syntax are different. Okay, with respect to this Langchain. If you use the Langchain, I think Langchain syntax is a little bit different. LlamaIndex syntax should be a little bit different. But I mean, framework wise, both are same. Okay, both can perform the same thing. Now let me create the knowledge base. So here you are. So here I'm using vector store index from documents. Here I'm giving the documents as well as the service context, whatever service context we have provided. Okay, now it will create the entire knowledge base. Now I can perform the query operation. Okay, that means this operation. Okay, this operation. So it will go to the vector store, that means knowledge base, and it will return the rank results, and your LLM will process and it will give you the correct response. Okay, so here I'm given one question, what is the correlation? Now let's see what is the response I get here. So inside LlamaIndex, you need to write less line of code. But whenever you saw the Langchain, actually we have to write actually our vector store actually manually. That means we have to write some more additional code, right? But here everything is automated, everything it will handle. That means we don't need to perform the chunking separately. Chunking will automatically perform here. Okay, with the help of the service context. See, although I'm using GPU based machine, but still the inference timing is high here. Now see, it's done. Now if I show you the response, now see, this is the response I got. Correlation is a statistical measures that express the extent to which the two variables are linearly related. That means it has given me the correct response. Okay, so yes, that's how actually we can use any kinds of open source large language model with the help of LlamaIndex. Now you can go to the Hugging Face and you can use any of the, let's say, large language model, and you can use it with the help of LlamaIndex. Fine.
So I'm not going to implement these projects from scratch because I have already discussed the like process how we develop like one end-to-end projects. Okay, so that is why I already implemented one particular projects, as you can see here. So this is like a financial stock analysis project I have developed with the help of this LlamaIndex. So first of all, I will show you the demo of these projects. Okay, like what is the projects and all about. So those who are interested in the field of financial, or let's say in the domain of financial, so they will be loving this project because here you can do like stock analysis. Okay, so we have some stock data, we have some articles actually, as you can see. So these are the articles I have downloaded from the internet, and this is in the HTML format. So we'll be processing, these are the data, we'll be collecting the content. Okay, if you see, this is the completely HTML data. So here we have lots of like financial stock data, like we have Google data, then we have Nvidia, we have Meta. Okay, then we have ms here if you see MSFT. Okay, as you can see, so we have different like you can say companies stock data here. So I already given the link of the data in my GitHub, so you can download from here. I will show you like how to download the data. So that is script I have already written. So first of all, let me execute the project. So I will first of all execute this projects and show you like how it will work. So see guys, this is the Streamlit app I have developed, and here you can do two kinds of analysis. One is like you can do a single stock analysis, another is a competitive analysis. Okay, like competitor analysis. I'll show you both of you. Okay, so here first of all, let's do the single stock analysis. So I'll just ask what is the stock of, here if you see, so they have given the short name for each and every company. If you come here, so I've already listed down. So let's ask for the Nvidia. So I'll copy the Nvidia, and here I will ask. So guys, as you can see, I have asked like what is the stock of Nvidia, so it is giving me the answer. Okay, you can see it is giving like 2023 to 2027. Okay, it's giving the stock, as you can see. Now, and you can ask for any kinds of stock. Let's ask for the Google. So I'll copy Google, and here if I paste and enter, so now it will give me the stock of the Google. So that's how actually you can ask different stock related question. Okay, if you're interested in these kinds of stock and all, so you can ask lots of question and you can get the response with respect to that. Okay, as you can see, this is the Google stock answer it is giving. Now you can also perform like competitive stock analysis. So just select the competitive one. Now it will give you the interface of the competitive analysis. So guys, as you can see, this is the competitive analysis one. So now here you need to provide stock one symbol and stock two symbol. So let's do like MSFT, and I will also do for my Nvidia. Let's see the competitive analysis between them. So see guys, this is the competitive analysis between them. As you can see, you can read it out. Okay, so not only that, you can see like competitive analysis between all the company. Here is the listed. Okay, and this is the symbol of the stock. Like you can't directly pass the company name, so you need to give the symbol. Okay, because this is your custom data you have given like that. So yes guys, this is the projects actually I have developed with the help of this LlamaIndex, and this is very much interesting projects like in the field of financial domain. And you can see implement lots of thing with the help of this LlamaIndex. I think I already showed you like lots of like functionality and all, and I already showed you lots of things. Okay, with the help of open source model and all, you can implement anything. Okay, whatever you can think in your mind, you can implement anything. Just you need to try from your side. Okay, now guys, let me show you like how I have developed these projects. Okay, so this is the projects guys I have already developed, and let me show you This is the code for the projects. Okay, so I'll explain each and everything, like whatever things actually I'm doing. And I've already given the idea about LlamaIndex and this Streamlit and all. So I think you are already familiar with these are the thing. Okay, I'm expecting. So that's why I'll be explaining the projects. Okay, instead of writing all the line from scratch. So first of all, let me stop the execution. Then I will remove this article folder because this is my generated folder. Then I will also remove this stories. Okay, stories, I think you remember stories is nothing but it's a vector store we created with the help of LlamaIndex, right? So both I have deleted. Now here is the readme file I have already shared, like what are the steps you need to perform. So here first of all you need to clone the repository. So this repository will find from the description section. So from there actually you can download the projects. Then you need to create one environment, okay, Python environment using Python 3.8. Then you need to activate the environment. Then you need to install the requirements. So requirement wise, I mean using these are the requirements as you can see. So you are using LlamaIndex, then Streamlit, Python.env. Okay, and apart from that, I'm also using OpenAI and some you can say dependency package I'm also installing here. So this thing you need to install. I already showed you how to install them and all, how to create the environment in my previous project implementation. Then after that you need to execute this app.py. Okay, but before running the app.py you should have your data and you should have your vector store presence. Okay, otherwise it won't be working. So for this actually in the src folder I have written some of the script. As you can see, first of all we need to fetch the data. So this is the link guys. So in this link actually this articles is available. I have already given this link and this is hosted on my GitHub. So from here you can download those data set. Okay, download those articles. And after that, see I have written one function. With the help of this function I am downloading. So basically it will take this URL, data URL, and it will download that zip file, okay, from my GitHub, and it will unzip it. Okay, it will unzip it here, and that zip file it will remove. Okay, so this is the code I have written. Now let me show you how it is working. So I already created the environment. So now I'll execute this particular file. So I'll just write Python inside src. Inside src I have one file called 01 fetch data. Okay, I will execute this file. Now see guys, it will download that data from my URL. So see guys, it has downloaded all the HTML file, and now see if I open my articles, all the data are present. Now what I need to do, I need to create one vector state. I think you already know like what is vector state. I already explained these are the thing in my notebook experiment. Okay, what are the steps I perform, same thing I'm doing here also. Okay, so to create the vector store, I created another file called indexnews.py. So here I'm using this GPT vector store to create my vector embedding. So here you can also use Google PAM embedding. You can also use Huggingface embedding. Anything you can use. Just try to use open source embedding because if you don't want to use like OpenAI, so if you don't want to spend money, so you can go with like open source model. Otherwise, if you have like OpenAI account, you can also use OpenAI API key. So here if you see, I have already set my OpenAI API key. So by default, if you're not giving any embedding models, it will take that OpenAI embedding model. Okay. So this GPT vector store index already has like GPT based embedding model. It will take that model and it will convert your data to vector embedding. Okay. So guys, this should be your task. Just try to replace this code with your open source model. I think I showed you how we can use Hugging Face embedding model in this notebook. See guys, here Hugging Face embedding model I was using. See, you also need to use Hugging Face embedding model here. Okay. In this case, I'm using OpenAI. So you need to replace with the Hugging Face embedding model. Okay. I think I already showed each and everything, so you can do it. Now let me first of all generate these are the embeddings. So I'll clear. Then I will run this second file. So it's 02. So it will take time because it will take all the articles. It will convert to chunks. Then it will like convert them to vector embedding. Okay. Then it will create the stories here. So here you can also integrate like vector database. So you can use Pinecone, Wave8, and you can also use ChromaDB. But I'm using this default like vector store index. So LlamaIndex provide this thing. So it will store your embedding local. Okay, it will create one storage folder and it will store here. So you can also use a vector database and you can store them in the cloud as well. Okay, I already showed you. Just try to integrate here. So guys, as you can see, my storage has been created. Now this is my vector. So see, these are my embedding. So these are my vector. Okay, so now we are successfully able to store our vector embedding. Now see, now this is the third script I have written. So if you want to test on top of your like storage, so I'm loading the storage, and I'm just asking one query like what is tell me about Google's new supercomputer. Okay, so this is the query I'm asking, so it will give you the response. So you can try out. Okay, so let me execute and show you how it is working. So I'll just write Python. Then inside src, I have this 03. Yeah. So see guys, this is the response I got. Okay. So yeah, that means my storage has been created successfully, and we are also able to ask the query on top of it. Now we'll be converting. These are the thing, okay, as our app. So basically, I will give some of the input. Okay, user will ask the query, and they will also select like they want to perform like say single stock analysis, or let's say multiple stock analysis. So this kind of functionality I'll also add. So for this, I have already created one app.py. As you can see, this is the app.py. Here if you see, my index is already created, so that's why I'm importing the storage context and load index from the storage because I want to load it. Then I'm also importing like LLM wise OpenAI because I told you I'll be using OpenAI like model here instead of using open source. So here you just need to replace this OpenAI model with your open source model. You can also use Palm 2, then you can also use Llama 2, anything you can use. I already showed you this thing in my this notebook experiment. Okay, in my LlamaIndex session, just try to replace that. These are the model here. Then model wise, see, I've initialized GPT 3.5 turbo. Then here I'm just defining my LLM predictor. And I think you remember we had created one service context. Okay, so in LlamaIndex we create something called service context, and this will take your LLM. So what is done, I'm also loading my storage. That means this vector embedding. Okay, as you can see, I'm loading, I'm giving the path. Once it is done, I'm creating this query engine. Okay, so once query engine is ready, now we'll be creating the front end part. So here basically, if you see here, we are creating this title and all. Like this is the title, financial stock analysis. So let me execute and show you how this thing will look like. So see guys, this is the title and this is the report subtitle. So these two I've created. Now here I'm creating one select box. So what type of like report you want to you want. So this is the select box, guys. Let me show you. This is the select box. So if you want to create any kinds of select box, you need to select select box from Streamlit. And here is the message I've given. So what type of report you want to do, and a single and competitive. So here if you see these two things I'm giving here. So single and competitive. Then if user is selecting single one, okay, so first of all we'll be handling the single. So here is the prompt I have written. Let me show you. So I'm just using my engine query engine. So as you can see, query engine we have already created, and this is the like prompt I'm just giving. So write a report on like on the outlook for symbols. Okay, symbol, user will give me that. Okay, user will give me that symbol, because as you can see we are receiving the symbol. So as a text, input text, basically here is the symbol as input text we are receiving, and that thing we are passing here, okay, as a string. Then once it is done, this is my prompt. Stock from, I'm just mentioning the year. I need this stock from this year, and I'm also telling like be sure include the potential risk and the headwinds. Okay, so this is my prompt I have given to my LLM. So my LLM will give me some response, and that response actually I need to showcase. Okay, so I'm just using st.write, and I'm just passing my like this response, and it will show here. So once it is done, so I'm also handling the competitive analysis. So if user is selecting competitive analysis, so first of all I'm taking like two competitive. As you can see, if I select the competitive one, so here if you see, I'm receiving the stock 1 and stock 2, and this thing actually I'm storing symbol 1, symbol 2, and this is the my second prompt. Okay, so I'm just write a report on the competitive between my symbol 1 and symbol 2 stock. Okay, then it will give me the response, and that's the response I'm showing in my front end. So this is the simple logic actually I have written behind these projects. Okay, and this is like very easy. Now you just need to like convert them to open source model, and if you have any idea on top of it, you can also create it. Okay, I think you got the overall idea, and all the resources actually will get from the description section.
So I think you already know what is medical chatbot. Let's say if you have any medical related query, let's say you got one disease, so you are asking for the diagnosis, you are asking for the medicine. So this bot will able to give the response with respect to that. That means it will give you the suggestion, it will give you the medicine suggestion, it will give you the diagnosis suggestion. So these kinds of information this bot will provide. So we'll be creating the complete system here. That means here first of all we'll be using our custom data. The entire, let's say, medical information custom data we'll be using. First of all, we'll be teaching our model, we'll be creating the entire knowledge base. Then I'm going to connect my large language model there. So that means whatever information you'll be asking related the medical, let's say any kinds of disease, any kinds of medicine, any kinds of, let's say, diagnosis. So everything your chatbot will be able to give you the response. Okay, so this is the system we'll be implementing. And this is not going to be, guys, like notebook implementation. So here we'll be creating the complete pipeline. That means we'll be creating the front end part of our application. That means we'll be creating the beautiful user interface so that user can put the query and they can get the response from the chatbot. Fine. And here we'll be using something called modular coding in Python. So it's not a like scripting programming we'll be writing. We'll be using modular concept here to implement the entire project. Fine. And also we'll be using the Git and GitHub to, let's say, do the version controlling. So that means we'll be following the entire development pipeline here. What are the things you need? Even I will also show you how we can deploy this project, okay, in a cloud platform. So everything, guys, will be implementing in this project. So make sure you're watching this video till the end. And if you have any question, you can feel free to ask me, okay, in the comment section. So first of all, what I will show you guys, I'll show you the entire project architecture, like what are the things we are going to develop. Then I will also show you the tools and technology we'll be using here. Then we'll start the implementation. Fine. So let's open up our Blackboard and try to understand the project architecture. So guys, as I already told you, we'll be using our custom data here. Okay, we'll be using custom data, custom medical data. I can write medical data. So let me show you, I'm having one entire actually medical book. So guys, you can see this is the book. The book name is the Gale Encyclopedia of Medicine. Okay, second edition. So this is the book. You can also search on Google, you will get this book. And it is having around 637 pages. It's like very big book, and it is having all kinds of information regarding the medical. So see, if you open this book, actually, you will see all kinds of content. Let's say all kinds of disease, even with respect to that disease, what kinds of medicine actually you need, what kinds of diagnosis technique you need, everything this book has covered. Okay, so it is having different treatment, different actually medicine, different disease. Even the disease image is also visible here. All kinds of disease actually it is having. All kinds of disease actually it is having. Even with respect to that, they have also given a diagnosis, or even the treatment. Okay, how, let's say, you can do the diagnosis, how you can do the treatment, what kinds of medicine you have to, let's say, take. Everything this book has given the information. So here we'll be using this book, actually, the entire medical information, and we'll be creating the knowledge base. That means here we'll be using Pinecone vector database. Okay, I think you know Pinecone is a cloud-based vector database. That means there we can store the embedding, vector embedding. That means first of all, we will be extracting all the information from this book. Then we'll be creating the chunks, and that chunks actually with the help of embedding model will be creating the vector embedding, and that vector embedding will be storing to the Pinecone vector DB. And that Pinecone vector DB is going to be my knowledge base. That means the entire knowledge base. Why I'm not using the local vector database here? Because my data size is huge. If you see 637 pages of information I'm having. So if you just create the chunks, just try to consider how many chunks you will get. And if you're storing in the local DB, it won't be efficient. So that's why we'll be using cloud-based vector DB here. Fine. And I'll show you how we can use the Pinecone properly. It's one of the amazing vector DB when I personally prefer. So there actually you can also see your vector visualization. Okay, everything you can see. See, this is another actually disease. See, this is the disease actually. Even with respect to that, they have also given the diagnosis as well as the medicine. Now I'll share this PDF with you guys. You can see the complete book if you want to see different medicine and different let's say diagnosis. Okay, you can check it out. So here what we'll be doing, guys, we'll be using this medical book. So let's say this is one PDF documents actually I'm having, or here I can write medical. Okay, medical book. So from the medical book, what we'll do, we'll just extract all the information. Extract all docs. Okay, then after that we'll be creating different chunks, and I think you know what is chunking is required, right? Because here we'll be using large language model, and large language model is having input actually size, one specific input size, and we have to follow that input size. I think previously we learned about Llama. Llama is having 4096. Okay, this is the input length. That means this is the maximum input length it can take the data. If you're using OpenAI model also, let's say GPT. Okay, GPT is also having one specific input length. If you want to see that, just open the openai.com and go to the model section. You will see that GPT input length. So whatever actually large language model you are using, first of all, try to see the input length, okay, of that model. Like what would be the maximum token size. Based on that, try to perform the chunking operation. Okay, that should be my suggestion. Now it will give me different chunks. So let's say I will get chunk 1. Okay, chunk 1 will be getting chunk 2, will be getting chunk 3, and so on. Then after getting the chunks, what I have to do, guys, I'll be using one embedding model. Embedding model. Okay, with this embedding model, we'll generate the vector embedding. Okay, it will give me different vector embedding. So you'll be getting vector embedding. I can copy and I can paste it here. So we'll be getting different vector embedding. And with this vector embedding, guys, what we'll do, we'll just try to build one semantic index. That means the knowledge base, right? Build semantic index. So this is going to be my knowledge base. That means we'll be storing this vector to the vector database. So I can write knowledge base. Okay, knowledge base. And here we'll be using something called Pinecone vector store. Okay, so let me just write vector db. Okay, db vector db. And guys, this is going to be my complete backend component. Okay, so here I can write this is going to be my backend component. Okay, component. Now I have to work on the front end component. That means user will give some query, and with respect to the query, actually I have to give the proper response. Okay, let's say this is the user. This is the user. So user will send one query. Let's say this is the query user has asked. So first of all, it will convert to the query embedding. Okay, query embedding. That means this is going to be an English text, right? And that should also convert it to the vector embedding. This vector embedding will go to the knowledge base. Okay, it will go to the knowledge base, and knowledge base will return some rank results. Okay, rank result or similarity. Let's say result it will return. Okay, rank results. So then I'll be using one large language model. So here we'll be using one large language model, LLM. So here I'm going to use OpenAI large language model. You can use any kinds of large language model. You can use open source large language model. Okay, you can also use the Gemini. You can also use let's say Mistral. Anything you can use here. So here I'm going to use OpenAI large language model, because here I'm going to create a production ready application. So this application will be also deploying in the cloud platform. Okay, that's why I'll be using OpenAI model. Okay, why OpenAI model? Because OpenAI model is already hosted in the OpenAI server. We can access this model through API request. But if I'm using any open source large language model, we have to download this model in our local machine. And local machine doesn't have like good configuration, let's say instance. Let's say you don't have good configuration GPU, you don't have good configuration actually RAM, CPU. That time actually you can't execute this model in your system. Okay, it will be very much difficult for you. And you will see that inference time would be also very high. That means this model will keep processing the input. It will take lots of time to give you the response. So that's why we'll be using OpenAI model. And going forward, I'll be discussing about LLMOps, and there I will tell you how we can also use like different open source large language model. Let's say if I want to use Llama, okay, Llama. If I want to, let's say, use Mistral, Falcon, okay, Cloudy, any kinds of model. If I want to use, how I can use it, even how we can use it as an efficient way, even how we can deploy these are the model in the cloud platform. So for this, we'll be using something called LLMOps. Okay, LLMOps will be using. That means we'll be using different platform. We'll be running about Bedrock. Okay, AWS Bedrock. We'll be learning about, let's say, GCP Vertex AI. So these are the LLMOps platform. Okay, so we'll be using this LLMOps platform to access these are the model, and on top of that, we'll be creating the application. Fine. So this is what actually we'll be explaining later on, guys. So first of all, try to see how we can implement this production ready project with the help of OpenAI model. And that is another reason actually we are using OpenAI model, because if I let's say if I'm using open source large language model, you will see that open source large language model size would be very huge. Let's say around 10 GB, 20 GB, and this model you can't execute in your local machine. That means your low configuration machine. And if you're deploying this project to the cloud platform, there you have to take good instance. That means you have to take GPU based instance with higher RAM, higher CPU, higher GPU, and just try to consider about the cost, like how much cost actually it will take that cloud platform. You can go to any kinds of cloud platform, you can see their instance actually type. If you're taking GPU based instance type with higher RAM, higher let's say CPU, you'll see that per hour it will cost you like more amount of money. Okay, so again you are increasing the cost here whenever you are using open source large language model. Okay, without any kinds of LLMOps tool, LLMOps platform, you will get the difficulty for sure, right? So that's why we'll be using here OpenAI model. Although it will charge you, but it will charge you less than the open source model actually will be hosting in future. Okay, this is the idea here. So now what will happen? This rank results will go to the LLM. Even this query also will go to the LLM, and LLM will process. LLM will try to understand the query as well as the rank results, whatever results actually your knowledge base is returning. Based on that, it will give you the correct response. Okay, correct response. Or you can talk about answer. Correct answer. Let's say you are asking one question. Let's say I got fever. What can I do? So it will first of all refer the knowledge base. It will try to find out the, let's say, fever diagnosis, fever medicine. Then with respect to that, it will give you the response. Got it? So this is the entire system actually will be implementing, and this is what actually our front end. So this is what actually our front end. Many people also ask me like, sir, just try to create some application with the help of good front-end development as well. So that's why I also kept this front-end development here. We'll be creating one beautiful user interface so that user can give the query here. I think you use the ChatGPT. ChatGPT is having one beautiful user interface. Okay, so we'll be also creating this kinds of chatbot kinds of interface so that user can give any kinds of query and they can get the response. Fine. So this is the entire architecture of our project, guys. Okay, I hope it is clear now. Now, technology-wise, I already told you. Here we'll be using a large language model, OpenAI. Okay, OpenAI. LLM will be using. Then here we'll be using Langchain as a generative AI framework to develop the entire project. Then here we'll be using vector database, wise Pinecone. Okay, Pinecone is a cloud-based vector database. Okay, so there actually you can create a instance and you can store your vector. And here to create the user interface, we'll be using something called Flask. Okay, Flask is a Python framework. You can create web application. Okay, with that. Got it? Yeah, so I hope these are the actually technology we'll be using as of now. And if I need it, anything, I'll tell you, okay, later on. Now, guys, what I have to do, guys, first of all, let's create one. Yeah, so let me also write, we'll be also using GitHub. Okay, GitHub to do the version controlling of our entire application. Fine. And later on, we'll be also deploying this project to the AWS cloud. Okay, AWS cloud. So we'll be learning about the simple deployment as well as the CICD deployment. Okay, both will be learning. So guys, this is the entire agenda. So now let's open up our GitHub and try to create one GitHub repository first of all with our project. Then we'll be starting with the implementation. Fine. So I'll go to my GitHub, guys. So this is my GitHub. You can also follow me here. I have created lots of repository that might help you a lot. So just go to the repository and here create one new repository and give the name. Let's say I want to create a medical. I'll just write end-to-end. Okay, medical chatbot generative AI. So this is my repo name. You can give any repo name as per your requirement. Now I'll be keeping it as a public repository because I want to share this code with you so everyone can see that. I will add the readme file as well as I will add the .gitignore file. So here I'll be using Python programming. I'll be selecting the Python. Let's take the license. You can take any license. I'll be taking AMIT license. Now everything is fine. Now let's create the repository. Okay, now let's clone the repository. I'll copy the link address. Make sure you selected HTTP1. Now open up your local folder. So let me open up my local folder and here I'll open up my terminal. You can open up your, let's say git bash. You can open up your anaconda, anything, and just write the command git clone and press the link here. So it will clone that repository in your local machine. Now see, it has cloned. Now let me go inside this folder. You can see currently I'm inside Langchain project. Okay, now I want to go inside this folder. So I'll just write cd. cd means change directory. I want to go inside end-to-end medical chatbot generative AI, this folder. Okay, now if I hit enter, you will see that I'm inside this particular folder right now. Now I'm inside this folder. Now inside this folder, I'm going to open up my VS Code. So let's open up my VS Code. So this is my VS Code, guys. Okay. Now let me zoom. Now the first thing, guys, what I have to do, I have to create one virtual environment here, because I already told you if you are creating any kinds of end-to-end project, first of all, create a virtual environment. Then you have to set up all the requirements you need here. So here, let me add all the steps you need to perform. So here I have added all the steps in the README file. First of all, you have to clone the repository. If you're using my repository, first of all, clone it, then try to create the environment with this command. So make sure you're using Python 3.10. Okay, so I'll copy the command. You can give any name. I have given LLM app. You can give any name here. Fine. So what I can do, I think use Medibot. Okay, I can use Medibot. You can use any name. Now let's create the environment. So guys, as you can see, my environment is created. Now let's activate. For this, you have to execute this command. All the command I have shared in the README file, just try to copy paste. And I will also push this code in my GitHub so that you can see the changes. Now see, medical bot has been activated. Fine. Now the next thing, we'll be creating one file called requirement.txt file. And inside that, I'll be mentioning all the requirements I need. And we'll be installing all the requirements here. So guys, here are the requirement list. So these are the requirements actually I need to implement this project. We'll be using sentence transformer, because here we'll be using open source embedding model to generate the vector embedding. So that's why we'll be using sentence transformer, and sentence transformer uses actually transformer library. That means it will use Huggingface platform, Huggingface hub to download that model, open source model. And with the help of that model, actually we can generate the vector embedding. And here I'm installing one specific version. You can also install the latest version, but this is the stable version I'm installing so far. Then Langchain, I think you know Langchain. Then Flask we need for the user interface. Then PyPDF, here we'll be using PDF document, that's why. Then Python.env, why? Because here we'll be managing one .env file. Okay, .env file. So inside .env file, we'll be mentioning our OpenAI credential, as well as we'll be also mentioning our Pinecone credential, because Pinecone, you also need to use one API key to authenticate with your account. Fine. Then you can see I'm installing Pinecone, and if you want to install Pinecone, you need to install this tool library, Pinecone grpc. Okay. Then you need to also install Langchain _ Pinecone. Then Langchain community, Langchain OpenAI, and Langchain experimental. Okay, so these are the dependency package you also need to install. So let me install all of them. I'll just try to save. I'll open up my README file. I'll copy the command, and here I can execute. Now see, it will install all the packages one by one. So it may take some time, guys. Let's wait. Once installation is completed, I will come back. So guys, as you can see, my installation is completed. There is no error. That means congratulations, you have installed successfully everything. Now let me minimize the screen. And now let me save everything. Yeah. Now see, whenever you are implementing any kinds of end-to-end projects, the first thing you have to create the project. Okay, project folder structure. Structure. Okay, this is very much important, guys. That means you have to create the entire project folder structure, like in which folder, in which file you have to write which function. Okay, that's how you have to create the entire project folder structure. And again, this is your actually, let's say, design pipeline. Okay, it's not like that you have to follow my pipeline always. You have to follow my project folder structure always. If you feel like, okay, this folder structure is good for you, you can use it. Just try to design with respect to your project requirement, with respect to your, let's say, choice. Okay, no need to follow my one. But if you want to follow my one, you can also follow. I usually prefer one project folder structure. Okay, so I'll be showing you how we can implement this particular project folder structure. That means automatically we'll be creating the project folder structure here. So here we'll be creating one file. So the file name is template.py. Okay, this is going to be a Python file. So this will create the entire project template for me. So here only I need to give my one-time effort. That means I'll be writing the entire logic to create the structure. Going forward, whenever you want to create any kinds of project folder structure, you can execute this file. It will automatically create. Otherwise, what will happen? You have to manually create it. Let's say you want to create a folder. You will be clicking here. You will give the folder name. Let's say test. Okay, then I want to create another file inside folder. Again, you will be opening this folder. Inside that, you'll be creating another file. Let's say test.py. Okay. So this is like very time-taking task. Let's say you want to create 100 of folders, 100 of files. Just try to consider how much time it will take. Even you have to manually check everything, whether this file is present inside this folder or not. So it's not a efficient way to create the folder structure. Okay, you can create it, but I won't be suggesting you because it will take lots of time. So what you can do, you can create one template file. And inside template file, you can write one very Python basic code, and this code will automatically create the project folder structure for me. Let me show you how we can create it. So for this, I'm going to use some package. I'll be using operating system package. Then I also need something called path lib. Okay, so let me import. So from it is available path lib import. Okay, path. I need the path. Why I need the path, I'll tell you later on. As of now, let me import all of them. Then I also need something called login. Okay, so login is an inbuilt package inside Python. So here I will also log the information in my terminal. Fine. So first of all, you have to create a logging string. Okay. So basic logging configuration you have to create. So that's how you can create a basic logging configuration. See, okay, this is the basic login configuration. So here you have to write logging.basic config. Inside that you have to mention the log label first of all. So here I am to create an information label log, and this is the format of my log. That means first of all it will save the ASCII time. That means the current timestamp. Like let's say whenever you are executing your code, it will save that timestamp. That means the time, date. So it will save everything. Then after that it will also save the log message, like which message you want to show. Okay, it will also save that. So whenever I'll execute the code, you will get it. Okay, what I have written here. As of now, just try to consider. You have to mention this logging string here. Fine. Okay. Now you have to give a list of the file you want to create. So let's say left hand side, I want to create some list of the folders and file. So for this, I have created a Python list. You can see. So the name of the list is list of the files. Inside that, I've mentioned I want to create a folder. You can see folder name is src. Okay. So it will create a folder here called src. Inside src, I want to create a file called init.py. That means __init__.py. And this is nothing but my constructor file. If you already familiar with OOP concept, I think you know what is constructor. So constructor is nothing but it's a special method. It's a, let's say, the magic function. It can execute automatically inside OOP. But you can also create, this is actually constructor as a Python file. Okay. So if you open up any kinds of end-to-end project, now let me show you. So if you go to any kinds of end-to-end repository, let's say if I open TensorFlow GitHub, it's an open source project, so I can also see their code implementation. See, they have also follow the modular approach. See, if I open any kinds of folder, let's say if I open Java folder or let's say Python folder. Now, if you just go below, you'll see this constructor file is present here. Okay, why? Because they have created so many folders. You can see so many folders, and inside that they have created different Python file. So this folder would be considered as their local package. That means they can also import some functionality from this folder. Let's say I want to import, let's say this particular function. Let's say this function, import a graph depth. What I need to do, I need to write. So what I have to write, from TensorFlow.python, okay, then this file and import. I want to import this function. Okay, that's how I need to import this file. That means instead of writing like all the function in just one file, what I'm doing, I'm creating a different folder. Okay, different let's say component. Inside that I'm keeping those functionality. Okay, and whenever I need it, I'll be using it later on inside my endpoint. Okay, this is called actually modular approach. And to whenever you are like following this modular approach, whenever you are creating this kinds of folder to keep your function in a file, make sure you are creating this constructor file, because this folder would be considered as your local package. Okay, because later on you have to import it. Let's say from TensorFlow.python import this function. So whenever you will be importing, make sure your Python interpreter will consider this is my local environment. Okay, that means I can import something from that folder. This is the idea. Okay, so that's why we are creating this constructor file, because src is my folder. Inside that I'll be creating one file called helper.py. Okay, and helper.py, inside helper.py I'll be writing all the functionality. Let's say I want to ingest the data, I want to, let's say, extract the information, I want to download the Huggingface model. All the functionality I'll be writing inside helper.py. Okay, this is the idea. Now apart from helper.py, I need another file. So inside src I'll be creating another file called prompt. Okay, prompt.py. Inside that I'm going to write the prompt. Okay, prompt, whatever prompt actually I need. The prompt, let's say whatever system prompt I'll be using, inside that I can write it here. Now I want to create a env file. Then I want to create a requirement.txt file. Oh, sorry, requirement is already created. I can remove it. As of now, I don't need it. I want to create a setup.py file. Why setup.py file? Because I want to install these are the folder as my local package. For this, I need setup.py. Okay. Previously, I think I already explained this part. Then app.py. Then I want to create a folder called research. Inside that, I want to create a Jupyter notebook file. That means trials.ipynb. So inside that, first of all, we'll be doing the Jupyter notebook experiment. That means the entire project will be implementing through Jupyter notebook. Then we'll try to convert everything as our modular coding. Okay, this is the idea. So this is my list of the files and folder I need. Now I have written a simple Python logic. Let me show you guys. It's not a very fancy code. It's a simple Python code I have written. So this code, it will loop through this list one by one. That means it will loop through this list one by one. See, I'm looping through the list. It will give you the file path, the entire file path. Then you are giving this path to the path function. Why you are giving to the path function? Because see, here we're using Windows machine, and Windows by default use backward slash. I think you know. See, if I click here, see, Windows by default use backward slash. But which slash actually we're using here? We are using forward slash. Okay. But in Linux, Mac actually, they will be using this forward slash, but in Windows you have to use backward slash. So that's why to I overcome this issue, we're using path, actually path library from pathlib. See how it will work. So let me show you one example. So first of all, I will open up my Python. Okay, now here let me first of all import. So from pathlib, okay, import path. Okay, then let's define a path here. So I'll just write p is equal to test, let's say slash t.py. Okay, let's say this is my folder. Inside that I'm having one file. Now what I will do, okay, it has given me one error. Let me see the error. Okay, so test is not defined. That means I need to give inside a double quotation because it's a path, not. So it should be a string type data. Now fine. Okay, now if I give this p to my path function, now see what will happen. It will automatically detect my operating system. Based on that, it will convert that part. See, it has given me Windows path. It has automatically detected my operating system. Based on that, it will convert this path to the Windows path. Let's say you are using Linux, you are using Mac. Automatically this path would be converted to that operating system. Okay, so that's why instead of manually giving that path as a backward slash, what I can do, I can give to the path function. Path will automatically take care. That means we can execute this project in any kinds of operating system. Okay, otherwise in some of the operating system you might get some issue. Okay, that's why we have to always handle this kinds of scenario. Got it? So whenever you are designing your software, make sure you are handling this kinds of scenario and you are making your application more robust. That means in production it won't be failing. Whenever it is failing in the production, this is not a robust application. Always you need to take care. Then after that, what I'm doing, I'm just splitting my folder name as well as the file name with the help of this actually function. So inside operating system dot path dot split. So what path dot split will do, it will split your folder name and your file name. That means inside this file directory it will give the folder name, inside the file name it will give the file name only. Okay, so you can also execute and test. So let me show you. So let's say this is my path now. So this is my folder and this is my file. Now if I use, first of all, let me import operating system. So if I give os dot path dot split, okay, inside that I'll give the p. Now see, if I hit enter, it will give me one tuple. See, so in the first item it should be my folder and the second item it should be my file. Okay, and this is what actually I'm storing inside two variable. Okay, two variable. I'm doing the tuple unpacking here. Okay, I hope it is clear. Then first of all, I have to create the folder. Okay, I have to create the folder, and to create the folder I'm using was.make directories. So first of all, I'm checking whether this file directory it is empty or not. If it is not empty, that means definitely I have some file folder name here. So I'm creating the folder, you can see. Then I'm performing the login operation. I'm just doing the login in my terminal. I'm telling creating a directory, file directory for the file of file name. Okay, this is the log message actually I'm printing in my terminal. Then after that, I'm also creating the file. That means folder creation is done. Then inside the folder, I also need to create the file. For this, I have written this code actually. First of all, I have to check whether this file path is exist or not. If it is not exist, that means if it is not created, I have to create it. Otherwise, it is already created. Now I don't need to create it. And I also check the size of the file path. That means the file, it is 0 or not. Let's see if it is not 0. That means inside that file, I have written some code. So I don't need to delete that file again. Let's say you want to create again. It won't be replacing that file. Instead of that, it will skip that file. So that's why I'm also checking the size. If size is empty, I'm creating this file, you can see, and I'm doing the login information. Otherwise, I'm telling this file is already exist. Okay, so this is the simple Python code I have written. Now see the power of this script. Okay, see the magic. Now left hand side, see there is nothing. There is no folder structure, no file. Now if I execute this script, now see what will happen. I'll clear and I'll simply execute this template.py file. See template.py. See, automatically it will create the folder structure for me. Got it? So it's just a one-time effort, guys. You have to like write this code only one time, and later on you can use it every time. Let's say you want to create another project, copy this file, try to execute, it will automatically create a folder structure for you. Let's say in future I need some more actually, let's say folder, or let's say file. Let's say I need another file called test.py. I'll just add it here. Make sure you are giving inside a string, okay? And you are giving a comma here because it's a list. Okay, now see, I'll execute it again. It will automatically create that for me. See, test.py is also created. That's how you can add as much as file and folder you need. Okay, it will automatically create. You don't need to manually create it here. Okay, this is the advanced ways to use this template.py file, guys. Okay, I hope it is clear. Now you can check it out. See, inside resource, this trial.ipynb file is created. Now inside src, init created, helper created, prompt created. Okay, you can see init created, helper created, prompt created, .env also created, app created, setup.py is created. Okay, everything has created. So now let's set up our project as my local package. Okay, so for this I'll be writing the setup.py code, and this is a simple code, guys. I think previously I also shared. So this is the setup.py code. First of all, give the project name. That means the package name you want to give. Let's say Generative AI project, because if I show you currently in my terminal, inside my environment, this package is not present. So I'll just write pip list. See, Generative AI project is not there. Okay, so I have to install as a Generative AI project. Okay, for this we'll be using the setup.py. Now give the version, author name, email. Okay, and find package will try to find this underscore init.py, and whenever this init.py is present, it will consider this folder as my local package. Okay, let me show you. Now to install this one, you need to give one command inside requirement.file called -e space dot. Okay, -e space dot. This is the command. Now let me save. Now let me again install the requirements. Now see, automatically it will install as my local package. Now see, one egg info file would be created here, and whenever this egg info file is created, that means this project has been set up as my local package. Let me show you. Now if I again do the pip list operation, now see, Generative AI should be there. See, Generative AI project is there. Now it is my local package. Okay, that means now I can import anything from this SRC itself. Got it? So this is the entire idea. Now let's commit the code in my GitHub, guys. So for this, I'm going to open up my git bash, and here I'm going to write one command called git add, then git commit -m. Now let's give one commit message. Let's say folder structure added. Then let's do the push operation. So git push origin main. Okay, now it has pushed. Now if I want to check, let's go back our GitHub. Now let's refresh. Now see, it is pushed in my GitHub, and readme is also updated. Now you can copy all the command and you can execute in your system. Okay, I hope it is clear. Great. Now the first thing, we'll be doing the notebook experiment. Okay, first of all, we'll be implementing the entire project in our Jupyter notebook. Then we'll be converting as our modular coding. And after implementing Jupyter notebook, only you just need to copy paste operation. Okay, that's it. Now, first of all, let me select the kernel. So I already created one environment called medibot. Okay, so let's select it. Now let's test whether this is working or not. So I'll give one print statement. Let's say print okay. So this notebook should work. Now it is telling just try to install some IP1B kernel package. So let me install, because I'm using Jupyter notebook inside my VS Code. For this, you need some additional package, and it will automatically install for you. So it will take some time. After that, you will see that execution would be completed. So let's wait. Okay, guys. So as you can see, execution is completed and it is giving me okay message. Okay, it's fine. Now, one thing I just wanted to show you. Let's say if I show you my project working directory right now, let's say pwd. So I'm inside this resource folder. Okay, inside resource folder. But I want to load my data, and that my data would be present inside my data folder. Let's say I'll create a folder for data. Okay, inside that I'm going to move the PDF I'm having. Let me move quickly. So guys, as you can see, inside data folder, I'm having the PDF. Okay, PDF document. Now see, whenever you are implementing any project, make sure you are working in the project directory. Okay, that means your root project directory. So this is my root project directory, but currently I'm inside this resource folder. But if I want to get back, okay, inside my project working directory, so what I have to do, I have to execute one more command. So let me import operating system package. Inside operating system, you are having something called change directory. Okay, let me show you. So os.chdr, that means change directory to hire one folder back. So for this, you can write .. slash. Okay, .. slash means, so .. slash means it will get back one folder back. Okay, let me show you. Now if I execute, now if I again show you the pwd project working directory, now see I'm inside my root project folder itself. Okay, so that's how actually you can check the folder location first of all. Okay, otherwise what will happen, you will get like path issue. Sometimes you'll get, let's say, data not found and so on. Okay, so that to prevent this issue, actually make sure you are working in the project folder directory always. Okay, this is the suggestion I want to give you. So first of all, let's import some of the library here. So here I'm importing Langchain. From Langchain, actually I'm importing PyPDF loader and directory loader, because I have told you I will be using PDF documents, and to load the PDF documents I need this PyPDF loader. It is present inside a directory. Okay, that's why I've given directory loader. Then I also need to perform chunking operation, and to perform the chunking operation I can use recursive character text splitter. Okay, I think you're already familiar with these other things. Now let me import all of them. Now here to load the PDF, here I have written a function. Let me show you. So this is the function I have written, guys. Okay, extract the data from the PDF itself. So the function name is load PDF. It will take the actually data directory. Okay, data directory, and it will only load the PDF documents. Okay, it will only load the PDF document. Let's say you want to load the docs document, txt document. At that time, you can give the extension here. Fine. So with the PyPDF loader, it will extract the information from the PDF itself. Okay, and whatever let's say information it will extract, it will give me as a documents. Okay, you can see. Now let me show you. Let me execute. So it will return me extracted data. So here I've given the path. Okay, so it should be data. Okay, data directory. Now let me show you. So if I execute, now see it is extracting all the information from the PDF itself, and it is having almost 700 actually pages. So it will take some time. So let's wait. So guys, as you can see, my extraction is done. Now if I show you the extracted data, see this is the entire extracted data actually we got. Okay, from all the pages, it will show you the data. Now let me comment it as of now. Now what I have to do, I have to perform the chunking operation, because you remember, see the architecture, I have extracted the documents. Now I have to perform the chunking operation. Okay, and to perform the chunking operation, I will be using recursive text splitter. So with that, I have created another function here. So split the data into text chunks. So it will take the extracted data, it will perform the chunking operation, you can see. So here is the code. So chunk size is 500 and chunk overlay is 20 I have given, and it will perform the chunking operation and it will give you the chunk results. Okay, now let me show you. So now if I execute the function and if I show you the length of the text chunks, now see, you got 7020 chunks here, guys. 7020 chunks you got. Just try to see how much data actually you have in the PDF. Okay, and this is enough information to create one medical chatbot. I believe that. Fine. That's why I have taken this big data, guys. Now see, this is the entire chunks actually I got. Now what I have to do, I have to use one embedding model to like perform the vector embedding, and this embedding I'll be storing to the knowledge base, that means inside my Pinecone vector database. Okay, so now let's download one embedding model from the Huggingface. Okay, so here is the function I have written, guys. Download Huggingface embedding model. Now for this, I need to import this package. First of all, let me import. So this is the package, guys, Huggingface embedding. I'm importing from the Langchain embedding. Okay, now let me execute. Now this function will automatically download one embedding model. See, this is the embedding model I want to use. Let me show you this embedding model. So this is present inside Huggingface. So the name of the model is All Mini LM L6V2. So this is one actually embedding model, and it will give you vector dimensional 384 dimensional vector actually it will return you. And this dimension you need because whenever you are using Pinecone vector database, you need to also mention the dimension of the vector, like what is your vector dimension. Whenever you are creating the cluster, now whenever you are creating the index, that time you have to mention this dimension. So that's why always try to remember, whenever you are using Pinecone vector database, try to see what kinds of, let's say, embedding model you are using, and that embedding model returns what kinds of dimensional vector. Just try to see the documentation, you will also already get it. Fine. Now let me download the embedding model. So let me execute this function. I'll download the embedding model. See, it is downloading from the Huggingface hub, so it will take some time. Let's wait. So guys, you can see my model has downloaded. Okay, now let's test the model, whether it is able to convert my sentence to vector embedding or not. So for this, I've given one sentence here, hello world, and there is a function called embed query. So it will automatically give you the vector embedding. And I'm also checking the length, whether it is giving me 384 dimensional vector or not. Now see, if I execute the program, now see, length is 384. And if you want to see the vector, see, this is the complete vector actually you got. Okay, I hope it is clear. Now let me comment this line as of now. Got it. Now what I have to do, guys, I have to initialize my Pinecone. Inside Pinecone, actually I have to store, these are the vector. Okay, the complete vector actually I'll be generating from my text chunks. So for this, let's open up my Pinecone. So if you want to open up the Pinecone, just write pinecone.io. So this is the website, and make sure you created one account, guys. Just do the sign up operation with your email address. You can create an account. So for me, I already have one account. Let me log in. So guys, as you can see, this is my Pinecone website. Okay, this is the interface of the Pinecone, and this is one of the amazing vector database provider, guys. You will be loving a lot. Even I personally like it. So here, what I have to do, guys, I have to create a index. That means I have to create a cluster. In that cluster, actually, I'll be saving all of my vector. They have also given the quick start, like how we can set up the Pinecone, how we can, let's say, store the data. See, all the code example they have also given. Okay, so we'll be following the same approach to store our embeddings to the Pinecone. But before that, you have to collect one API key. So how to collect the API key? Left hand side you can see one API key option is there. Just try to click here. For me, I already created one API key. If you don't have, just try to create an API key. Just give the name. Let's say I'll give test, or you can give any name. Let's create the API key. Okay, so this is the API key. Now just try to copy the API key, guys, and try to mention inside this .env file. So I'll open the .env file. So let me paste it here, and make sure you are giving one key name here. That means this is your Pinecone API key. Okay, that's it. And make sure you are writing this thing in a string. Got it? Now let me open up my trials.ipynb. Now what I will do, I'll just create a cluster here. So let me go back to the database, and don't share this key with anyone, guys. Otherwise they will be also able to access your account. Okay, I'll be removing it after this recording. So for you, no need to share with anyone. Now inside Pinecone, either you can manually create the index. Let's say you can click here, create index. Let's create one index. Let's say I want to create, let's say anything. You can give test. Now dimension, let's say 384. The same dimension I will give here. The dimension actually I'm getting. Cosine matrix, just keep it. You can also select different metrics, like what kinds of, let's say, similarity metrics it will apply whenever it will do the semantic search operation. I want to use cosine score. Now just keep it everything as default. You don't need to change the provider. See, AWS is the free one. If you're, let's say, sign up for the first time, you can create 1 to 2 cluster here with the help of AWS cloud provider. But if you want to take their premium subscription, that means you want to create a multiple cluster. If you want to take some more space, you can see, if you're using free plan, you will get 2 GB storage here. But if you have more than 2 GB data, that time you have to take the premium subscription. Okay, that time actually what you have to do, you have to take their plan, subscription plan. Let's say if I take this one, Google Cloud. Now see the price plan. See, this is the price plan actually they have. So with respect to that, you can also purchase their let's say machine. Okay, but as of now I'll be using the free services only. I don't need the, let's say, premium subscription of the Pinecone. But if you are creating the actual project, if you need more spaces, that time you can do it. So I'll be selecting the AWS cloud provider, and region, just keep it everything as default. Only just need to give the name. Okay, name and the dimension. That's it. 384. Okay, now let's create the index. So this is the manual approach to create the index, guys. Okay, this is the manual approach. See, this index is getting created. It is getting initialized, and once it is initialized, see, it would be connected. Okay, see, it is now connected. Okay, now if you want to connect it, you can execute this Python code and you can insert your data. All the config code they have already given. Okay, but I don't want to create this index manually. I want to create through the Python code. So let me delete it. So if you want to delete it, just click here and try to delete the index. So you have to give the name. Okay, I'll be deleting because I will be creating through the Python code. And how to create through the Python code, guys? I think they have already given one starter code. Remember? So here you can give the index name, like which index you want to create, and create index. Dimension you can give here, metrics, serverless, AWS, region. Okay, everything you can pass here. So now let's use this approach to create the index. So what I'll do, I'll go back to my VS Code, and I already prepared this code for you. So let me show you. So this is the code. Only you just need to change the API key. So let me change the API key. The API key I have collected here. Let me copy and let me change it here. Or I think I can read it from the environment only. So what I can do, I can import the environment. Just a minute. So let's import. So from .env, import load env. Okay. Then I will load the env. Now simply I'll get this Pinecone API key from my environment, and here it will save inside this variable. Now this variable actually I'll pass here. Okay, so nobody won't be able to see my API key that time. So this is the best approach, guys. You can also follow. Now you can give the index name. Let's say I will give medical bot. Medical bot. Let's say this is my index name. And here you have to give the dimension. So make sure which embedding model you are using and what is the dimension size. 384. That means it's fine. 384. Keep everything as default. Cosine, serverless, AWS, US East 1. Okay, no need to change anything because we are using free cluster here. Fine. Now, once you will execute this code. Okay, once you will execute this code, you will see that your index would be automatically created in the Pinecone. Let me show you. So if I execute this code now, see what will happen. So guys, execution is done. Now if I get back to my Pinecone and if I refresh it here, see, medical chatbot should be created here. Let me show you. See, medical chatbot is created. Automatically it has created. And now it is active and running. Okay. Now what I can do, I can convert our, let's say, chunks to the vector embedding, and I can store inside the Pinecone vector database. So for this, what I can do, So for this, first of all, set this Pinecone API key as your environment variable, because whenever we'll be storing the, let's say, data to the Pinecone, so Pinecone internally looks for this API key inside the environment variable. Okay, so for this we are using operating system environ. Okay, environ, and this is the key name, guys, I've giving, and I'm setting my Pinecone API key. Okay, whatever API key I'm loading from my .env file, so it will set inside my environment variable right now. Okay, so whenever I'll execute my Pinecone code, I don't need to like again and again pass it. Okay, again and again I don't need to pass it here. This is the advantage. Now see, to store the vector embedding, this is the code snippet you have to execute, guys. So you can see this is the code snippet. Let me comment here. Now I'm importing Langchain Pinecone import Pinecone vector store. Okay, now inside Pinecone vector store you have one function called from documents. So first of all you have to give the documents, that means my text chunks, the text chunks I have created, remember. So this is the text chunks I have created. Okay, so this text chunks you have to give. Then you have to give the index name. So what is the index name I have given, guys? I think remember this is the index name. That means this index name it is already created. That means inside this index it will store the data. Got it? So make sure you check this at the variable. Now I need to give the embedding model. So I think remember we downloaded one embedding model, okay, from the Huggingface app. Got it? So these three parameters you have to pass here. Now see, if I execute this line, it will convert all of my data to the vector embedding and will store to the Pinecone vector database. And how many chunks I got, guys? I think remember I got 7020 chunks. That means 7020 chunks vector would be stored inside my Pinecone. So it will take some time, guys. Let's wait. After executing this code, I'll pause the video, and once this vector will get stored in my Pinecone, I will come back again. See, let me show you. If I go to my Pinecone right now, and if you refresh the page here, see, all of the vector would be stored here. Even you can also see the count. Let me show you. See, as of now, 864, let's say, chunks has been added. Now see, 1000. Now see, you can also see the visualization of the vector. It's amazing, right? So whenever you used to use local vector DB, it was not possible to visualize our vector, but here it is possible. You can see. You can also see the score. That means semantic score. Like what is the score between this vector, and this vector? Got it? This is one amazing visualization, guys, you will get in the Pinecone. And see, this is the entire vector representation of this entire sentence. Okay, entire text. Okay, and even it is also showing the page number, in which page it is extracting the data, and what is the PDF name as well. Okay, every information you can see here. Even you can also perform the query operation. That means the way you perform the SQL query, you can also perform the query operation here manually. Everything is possible, but everything will be doing through the Python code. I'm not going to use the manual approach here. Now see the vector count, guys. So 4120 vector has been stored. Now let's wait. Once it has saved all of my vector, I'll come back and I'll show you. So guys, as you can see, my execution is completed. Now if I get back to my Pinecone and if I refresh, see, all of the vector it has stored here, like more than 7000 vector it has stored inside my Pinecone index. Okay, now what I can do, I can use this index as my knowledge base. That means we'll be connecting my large language model with this knowledge base, and we'll be asking the query, and it will do the semantic search operation here. Okay, this is the idea. Now let's get back to my code editor. Now see, I already created the index and I already stored my vector there. Now I want to load my existing index. If you want to load the existing index, what you can do, you can use this code snippet. Okay, see, again I'm importing Pinecone vector store from Langchain Pinecone, and there is another function called from existing index. Okay, from existing index, you have to give the index name. So the index name, I've given the same index name, and you have to pass the embedding model. The embedding model you have downloaded. Now see, if you execute this line of code, it will load the index. That means whatever index you have created and all the vector, actually it will load, and it will give you the doc source object. Okay, this is an object, doc source object. Now you can also perform the retrieve operation here. That means you can perform the similarity search operation here. Let me show you one example. There's a doc source as retriever, search type similarity, search keyword 3. That means it will give you 3 relevant answer. Let me show you. So if I initialize my retriever object, and now I will ask one question here. So this is my medical data. I will ask, let's say, what is acne? Okay, acne. So I think you know inside this PDF, I'm having acne related disease also. Let me show you. So if I press Ctrl F, acne. So guys, as you can see, this is the acne disease. What is acne and all? So you can see acne and acne related actually treatment, okay, medicine. They have suggested each and everything. So I'll asking one question here. So what is acne? So it should give me the relevant answer, okay, for the acne from my knowledge base. Now let me execute and let me show you. Now see, if I show you this retrieved docs, it will give you three results actually. Three results. Even it is also showing the source, okay, from where it has referred. Now see, different actually acne related response it has given me. Okay, because I have set search keyword is equal to 3, it will only give me 3 response. Okay, but I don't need this kinds of output. I need a complete, let's say, definition. Okay, what is acne? Got it? So for this, what I have to do, guys, I think you remember I have to integrate my large language model. That means here we'll be working on. User will give the answer, query. This query will go to knowledge base. Knowledge base will give the rank results. I'll be using the large language model. So LLM will process this rank results as well as the query, and it will give me the correct response. Okay. So for this, let's initialize my model. So I already told you we'll be using OpenAI model. So OpenAI. So let's initialize my OpenAI model. And I think you already know what is temperature and max token. So it is giving me one error. Okay, it is giving me error because I haven't set my OpenAI API key. So let's set the OpenAI API key. I'll open up my environment. So here is my API key, guys. So make sure you create one API key and just try to paste here. And similar wise, I also need to set this API key as in my environment variable. Okay. So let me execute this code. So here what I can do, I can duplicate this line and here I can write OpenAI API key. So it will also give me my OpenAI API key. Then here, whenever I'm setting as an environment, here I can also change OpenAI API key, OpenAI API key. Okay. Now let's set this one. Okay, string expected none time. Okay, so I think I have to load it again, then I have to execute. Now it should work. Now it is working fine. Now if I get back here, now if I initialize it, it should work. See, successfully I have initialized my large language model. Now I have to create the complete chain. For this, let's import some library. Previously I showed you now how to create the RAG application. There I think you remember we were importing this library, create retrieval chain, create stub document chain, okay, create prompt, chat prompt template, okay, everything I already showed you there. So we are importing the same code here. Now this is going to be my system prompt. So here I want to give this prompt in my language model, okay, large language model. Now I'm going to create the complete prompt template. You can see this is the system prompt, and whatever input user will give, that means the input actually I have given, it will come here and it will give you the complete output. Now let me initialize. Now let's create my chain. So create a stub chain. Inside that you have to give the LLM as well as the prompt, and whatever object you will get inside create retrieval chain, you have to pass it as well as the retriever. That means your vector store. The vector store you created, okay, retriever object. Now let's initialize my chain. Now let's ask the question. So here I will give what is acne. Okay, what is acne? Sorry, acne. Now see the response, guys. See, acne is a common skin disease characterized by pimples on the face, chest, and back. It is caused by clogged pores and become inflamed due to the oil, dead skin cells, okay, and bacteria treatment, and so on. See, that means it has given me the correct response. If you open the PDF now, this book right now, and if you read it here, you'll see that it has given me the correct response. Now see, if I giving any other question which is not relevant about the PDF, what will happen? See, now see, if I give any other, let's say, question, let's say I have given what is stats, that means what is statistics, it is telling me I don't know, because here I have given the prompt now. So if you're not getting the context, that means here this question I'm asking, this is out of context. That means the data I have given to my model, okay, the knowledge base I have given to my model, so this information is not available here. So that's why it is telling I don't know. Okay, so this is the complete custom system we have created, like custom chatbot we have created, which is only referring our custom data. Okay, I hope it is clear. So guys, this is the actually entire demo. Like that's how actually we'll be implementing the entire application. Now you can ask any kinds of question. Let me show you. So you can take any other disease. Let me show you. Or let's take any other disease. Okay, let's take this disease actually. This one. I'll copy. and I'll come back here, then I'll ask here. Now let's see. See, it is giving you the response. Growth hormones resulting the abnormal growth. Okay. See, that means this is the correct response actually I'm getting. Now, if you see the image, so the same thing. Okay. So you can see this disease is a abnormal releases particular chemical from the so blah blah blah. Okay, so you can read it. So that means we are getting the correct response. Fine. Now let's try to convert this project as our end-to-end implementation right now. That means we'll be also implementing the UI. But before that, I have to first of all create the modular coding. Okay. So what I'll do, guys, I will first of all open up my helper.py. Inside helper.py, whatever, let's say, utility related code I have written, let's say loading the data, then creating the chunks, then loading the embedding model, all the function I will move inside this helper.py. So let me open. So inside that, I'm going to import all of the library. See, I just copy pasted the code from my notebook only. If you open the notebook, the same code actually I'm copy pasting. And why it is giving the error? Because below you can see I have to select my environment, the correct environment. Let's say medical bot. Now this error will be disappeared. Now see all the function I'll just copy paste here. All the three function I have written now. My load PDF, then this one text split, and this one my load embedding model. So here I kept all the function, you can see, because I want to import from here. So these are the function I don't want to create inside my endpoint. Otherwise my code base would be like messy, right? That's why I am creating inside this particular file. Now let me save, and inside prompt actually what I will do, I'll give the system prompt, whatever prompt actually I've written. So here is the prompt, guys. I think you remember. I'll copy the prompt, and inside prompt.py I'm going to mention it here. Okay, so from here I'm going to open the prompt. Let's say in future you want to change the prompt, you want to give any other prompt, you can open this prompt.py, you can change here, it will reflect in your code. Okay, no need to open your actual code implementation that time. Fine. So let me close this at the tab. As of now it's not required. Now yeah, so helper is fine. Now what I will do, I will create another file here, and I will name it as store underscore index .py. Okay, .py. Why? Because let's say you want to update this book, let's say you want to add some more information. That time again you have to store all the embeddings to the knowledge base. That means inside your Pinecone, yes or no, right? And to store it, I again need to execute one like endpoint, that means store underscore index.py. Whenever you will execute it, it will load the new information and it will store to the vector database again. Fine. So for this, what I will do, I'll prepare this one. So see, whatever code I have written now here, that means I extracted my let's say documents, I created the chunks, downloaded the embedding model. After that, I pushed everything to my vector database. Okay, see all the let's say vector database code I have written, everything I need to write inside that one. So let me import all of the library. So you can see I'm importing from src helper, that means from src helper. So inside helper I'm having three functions: load PDF, then text split, and download face embeddings. Okay, see I'm importing all of them. Huggingface embedding. Okay, then I'm also importing Pinecone, then Pinecone vector store, then load env and operating system. First of all, I have to set my environment variable, that means my credential. Okay, OpenAI, sorry, Pinecone API credential. Then I will be loading my data, extracting the data, creating the chunks, then I'll be loading the embedding model. See, load file, that means I'm loading the data, so I have to give the data location. So this is my data location. Then text splitter will run, then download the embedding model. Okay, then after that I will initialize my Pinecone code base. The same code, guys. If you open the Jupyter notebook file, the same code. See, Pinecone initialization, it will create the medical chatbot. Okay, medical bot, that means this bot it will create. Okay, then it will actually create the index, then it will store the embeddings. Okay, so at the very first time you have to execute this line, guys. Okay, very first time you have to execute this file. Then whatever actually, let's say data you are having, it will do the vector conversion, that means embedding conversion, then it will store to the vector database. Okay, now what I'll do, I'll just delete my previous embeddings, whatever I created. This cluster I want to delete it, because now I'm doing the modular coding now. So I'll be executing everything from my modular coding itself. Now let me remove it. Now see, it will delete it. After some time you will see that it won't be visible here. Now see, make sure, guys, before launching your application, first of all, you need to execute this store index.py. Make sure this index should be created. Otherwise, you won't be able to do the query operation, right? So at the very first time, you have to execute this store index.py. Okay, then you will be launching your application. That means app.py. And this one you have to only execute one time, not multiple time. Multiple time when you will be executing, whenever you will update the data. Let's say you want to add any other data, one more PDF. That time you will be executing this file. Okay. Otherwise, just keep it as default. That's it. Now let me save. Now I think this is deleted. Now see, there is nothing. Now what I will do, let me show you how it will create everything. So I'll open up my terminal. Let me clear. Now let's execute this store index.py. Python store index.py. Now let's execute. See, again, it will perform all the operation, whatever things we have done in the Jupyter notebook. So let's wait. After some times, you will see that your index would be created, and inside index, all the vector would be stored. So guys, as you can see, my index is created. Now if I open it up, inside that, now it will store the embeddings. One by one, all the embeddings it will save. So guys, as you can see, my execution is completed, and it has stored all of my vector. Now that means my this store index is working fine. I'm successfully able to store my vector. Now let's create the endpoint. Okay, that means my main application. So user will start this application right now. So here I already told you we will be using Flask. Okay, so here I already told you we'll be using Flask here. And if I'm using Flask, I need a HTML and CSS code to create the one beautiful user interface. So I already created one HTML and CSS code for you guys. If you don't, it's completely fine. Again, I'm telling you, there are so many templates you will get over the internet. There is a website called Bootstrap. Previously, I also told you, I think Bootstrap. Okay, Bootstrap website. So from here, you will get different example. Even you can also see different template it is having. Even if you search like Chatbot, HTML, CSS, free template. You will get different actually template. See, different template. You can also download the source code. You can see code is also visible. You can also download. Even you will get some website. See, different chat template. Okay, different chat template. You can use it. Okay, it's up to you. Now, what I will do, I'll quickly just show you the HTML CSS code I have prepared. For this, I think you know, if you are using Flask, you need to create one folder here called template. Okay, templates. So inside that, you have to create a file called index.html. Okay, now let me show you my HTML code I have prepared. Or it's a chatbot. What I can do, I can name it as chat.html. Okay, chat.html. Now this is the entire HTML code, guys, I have prepared. Okay, save it. Now I need to create another folder for the CSS called static. So these are the requirement folder for the Flask. If you're using Flask inside Python, you need to create these are the folder. Inside static, I'll be creating a file called style.css. Okay. Now let me also paste the CSS code I copied from the internet. Okay. So this is one basic template I created. Now, whenever I will show you my application, you will see the user interface, whatever the user interface I created. Now let me create my endpoint app.py. Now inside app.py, I'll be integrating all of the functionality I have prepared so far. So first of all, let me all the required package actually one by one. So here I'm using Flask. So I have imported Flask. From the Flask, I have imported all the required functionality you can see. Then imported download Huggingface embedding model. Okay, because I need the embedding object to load my vector store. I think you know that I need to load this, note this actually Pinecone index. So where is the Pinecone index? So here is the Pinecone index. So I need to load this index, and to load this index, what I need the, let's say this one embedding object. I think remember at the last I showed you loading existing index. Okay, I think you need it. Okay, I think remember. Fine. So that is why I have to import it. Then I'm importing, you can see Pinecone store, OpenAI, retrieval, QA. That means whatever, let's say I was loading here. These are the thing I'm loading everything. Fine. Then I also need to load my prompt. So prompt is available inside my prompt.py here. So I can import it. So simply I can import, just write prompt src dot prompt import start. That means I want to start everything inside that file. Okay, that's it. Then I also need something called operating system. So import OS. That's it. Now let me initialize my Flask To initialize the Flask, you have to use this code. Go to the Flask documentation, you will get it. Now let's set all of my OpenAI and Pinecone environment. Okay. For this, I need to use the load in environment package. That's it. Then I will be downloading the embedding model. Then I will first of all initialize my embedding object. Then I will load my existing index from my Pinecone. So let me show you. See, the same code from the notebook I copied. See, so I'm loading the existing index, medical bot. Make sure name is correct. Medical bot, yeah, it's correct. Then it will give me the retriever object. Then I'm loading the OpenAI model. Then creating the prompt template. Then after that, I'm creating the chain. Okay. Now I have to create two routes exactly. First route would be my default route. That means user will get the interface of my application. Chat.html would be rendered. Got it? Now second route I'll be doing for the chat operation. That means user is giving any query to the chatbot. So that message actually I'll be accepting. And this message I will give to my LLM. Okay. That means you can see I'm doing the invoke operation. Okay. So same invoke operation I'm performing. Let me show you. So here is the invoke operation. Remember, okay, invoke. And whatever response I'm getting, I'm printing it as well as I'm showing in my that user interface. Okay, that's it. Now let me execute my application. So I'm running on my local host, port number 8080, debug is equal to true. That means if you change anything, it will automatically update everything. So now let me show you my application. So let's open up my terminal. So I'll just execute Python app.py. Sorry, it should be Python. Spelling is not correct. Python. Okay, now it should be running. Now see, just give the allow permission. Now see, your application is running. Now let's open up our Google Chrome. Search for localhost port number 8080. See guys, this is the interface we have created. And this is one amazing interface, guys. You can see amazing chat template we have created. Because many people have requested me just try to create one front-end part of our application as well, beautiful front-end part, and that's how we can create a beautiful front-end part. Now here you can ask any kinds of question. Let's say I will ask the same question. I'll ask what is acne. The acne is a common skin disease by characteristic by pimples on the face. Fine. Then I will ask another question. Let's say I got fever. What should I do? See, now this is the response. If you are experiencing high fever, it is important to seek the medical attention. Okay, so tell me some medicine. Now see, it is also suggesting some medicine, okay, related fever. Now you can ask any kinds of question from the, let's say, PDF itself. Any kinds of disease you can ask. Let's say this is the disease I want to ask. I'll just copy, and here I'll just write what is this disease and all about. See, it has given me the response. Okay, now you can read this PDF, and you can see that you can ask the medicine, you can ask for the treatment, anything you can ask. So this is our chatbot, guys. This is our medical chatbot we have created, and see, it is also giving you the one beautiful user interface. Okay, it is also returning. Now what we'll do, we'll just try to also deploy this application, guys. But before that, we'll be implementing some more end-to-end projects. Then after that, I'll keep one dedicated end-to-end, let's say, deployment session. There I'll show you how we can deploy this at the project on the cloud platform. Okay. So yes, guys, I hope you liked it. But before that, what I will do, guys, I will commit this at the code in my GitHub. So you can also commit from the VS Code. Let's commit from here. I'll write updated. Let's commit. And .env file would be automatically ignored by the git ignore, okay? Because inside git ignore, you have already mentioned it. .git ignore would be ignored. See, .env would be ignored, okay? So it won't be published inside my GitHub. Now if I open up my GitHub, now if I refresh, see, all the code has been updated. Now I can write the further code, let's see, step as well in the readme file. Okay, so I have added all the step. Like after that, what you have to do, after that, you can set your environment key, then run store index, then app.py, then you just need to open up your localhost. Okay, now let me commit the changes as well. So readme updated. And make sure guys you start this repository, all of you start this repository. You can also fork it so that you will have the reference. Okay, now if I refresh, now see readme is updated and you can see all the step I have also added. That's how you can also prepare your readme file so that if other people is referring your, let's say, GitHub, they will be also able to set up this code, okay, in their system as well. Fine. So yes guys, this is the complete implementation. I hope you liked it. So that's how we can create any kinds of end-to-end generative AI based project. Fine. And no need to worry, I'll also show you the deployment. Even we will be also discussing about LLMOps. With the help of LLMOps also will be learning how we can access any kinds of open source large language model. Okay, as a hosted open source large language model, we can use it. So yes guys, this is all about from this video. If you liked it, so please try to subscribe to the channel, try to like it and try to share it. Video will be implementing another end-to-end project called source code analysis. So here we'll be using LangChain vector database large language model. Even I will also show you how we can create a front-end application of the entire projects. So this is going to be completely end-to-end implementation, guys. So I think in our previous video, I already showed you one end-to-end implementation. We implemented one medical chatbot. So here we'll be following the same actually the process to implement this project as well. Fine. And what is source code analysis? I'll tell you. I'll show you the entire architecture diagram of this project. Then I will start the implementation. So first of all, what I will show you guys, I will show you the GitHub repository creation. After creating the GitHub repository, we'll be making all the setups. Then we'll start the implementation. So let's open up our GitHub and let's create one GitHub repository for this. So guys, as you can see, I'm inside my GitHub. So here I'm going to create a new repository and I'm going to name it as end-to-end source code analysis generative AI. Fine. So let's keep it as public repository. I'll select the readme file and I will also take the git ignore wise python. Then let's take the license. I'll take MIT license. Now let's create the repository. So after that, I have to clone it. So I'll copy the link address. I will open up my local folder and here I'm going to open up my git bash. Now let's write the command git clone and paste the link. That's it. See, it has cloned the repository. Okay, now I want to go inside this repository. I'll just write cd, that means change directory, to my end-to-end, okay, source code analysis. Now I'm inside this folder. Now inside this folder, let's open up our VS Code. So let me open up my VS Code. So here is my VS Code. So guys, I think you remember the first thing, we create a virtual environment, okay, for a new project. So let's create a virtual environment. For this, you need to follow some of the commands. So let me mention in the readme file. So you can see these are the steps we have to follow. So first of all, if you're using my repository, first of all, clone it, then try to create an environment with the help of Python 3.10. So the environment name is LLM app. So for me, what I've done, guys, I already created the environment in my system. So I'll just activate the environment. But for you, if you don't have the environment, just try to create it. So let me show you my environment. I'll just write conda activate LLM app. See, it is already there for me. Okay. Now the next thing what I have to do, I have to set up the requirements of the projects. Okay. So for this, I'm going to create a file called requirement.txt. Inside that, I'm going to mention all the requirements actually I need. So you can see, guys, these are the requirement I need. I need OpenAI, TikTok, and ChromaDB. So vector DB wise, I'll be using ChromaDB. Previously, I used Pinecone. You can use any of the vector DB. It's up to you. Then LangChain, Flask. So the front end implementation wise, I'll be using Flask framework. Then Git Python. Why Git Python? I'll tell you. Whenever I'll show you the architecture diagram, this part would be clear. Then python.env just to manage my credential. Okay. And I'll be using OpenAI large language model. You can also use Gemini. You can also use open source large language model. But I told you, if you're using open source large language model, you should have good configuration machine. Okay, otherwise you won't be able to execute. And that part we'll be learning in the LLMOps, right? Now let me save everything and let me install all the requirements. So for this, you can execute this command. So let's copy the command and here I'm going to execute. See, for me, I already installed all the package. That's why it's telling requirement satisfied. But for you, it will take some time. Now, the next thing, what I do, guys, usually I create a template file. I think you remember, project template file. So templates.py. Okay. And previously I shared one template code with you. I think you remember. So I'll just copy paste the same code. So if you missed out my previous implementation, guys, please try to check the end-to-end medical chatbot implementation. So there I already explained this code. Okay, this code, how we have written and all, everything I explain in detail. Okay, see, I'm using the same code, same actually template code. Now what will happen, this code will automatically create the template for me. So I already created requirement file. I don't need it. I'll remove it as of now. Okay, now everything is fine. So now if I execute this template.py file, see, it will create my folder structure. So let's see. See, it has created the folder structure. And whatever log actually you have written, it is showing in the terminal, you can see. Okay. So my folder structure is created. Now what I will do, I think you remember, first of all, we perform the notebook experiment. That means we'll be implementing the entire projects in our Jupyter notebook. Then we'll try to convert as our modular coding. Okay. So for this, I'm going to open the resource folder. Inside that, so inside resource folder, I'm having one Jupyter notebook file called trials.ipynb. So here, first of all, let's select my kernel. So this is my environment. Okay. Now let's test whether it's working or not. So okay message here. Yeah, so everything is working fine. Now, first of all, let me show you the project architecture diagram, like what we are gonna perform here. So guys, as you can see, this is the entire project architecture. So here we'll be basically performing question answer over the code base to understand how it works. See what happens actually whenever, let's say, we implement any kinds of project. Okay, let's say previously, I think you remember, we implemented one project called end-to-end medical chatbot. And this is the code base we have created, right? This is the entire repository of our project. Now, let's say if anyone new to this field, if actually he's not able to understand this project like how I have written, let's say this person will open this project. Let's say he will open this helper.py. And now he's not able to understand what is this function actually, download Huggingface embedding. Or let's say, what is this function, load PDF file and all. Okay, let's say anything actually he's not able to understand about the project we have implemented. He's not able to understand the code we have created, right? So what actually this application can do, so if you give this GitHub repository link to our software, my software, what it will do, it will try to first of all extract all the code from the repository. Then it will create a knowledge base. Okay. And with the help of large language model, it will try to understand what you have written. Let's see, now if you're asking any kinds of question, let's say what is SRC? Inside SRC, let's say you are having helper.py. Now, let's say you are asking, let's say what is text split function, what it does. So this model will try to read this code and it will able to give the like answer. This function does this thing. And that is how actually it is working. Okay. That means it will give you the entire explanation of the code you have created. Okay. So this is called actually source code analysis. Okay. Now I think you got it. What is the project actually we are implementing? So project name is source code analysis. So basically here we'll be performing question answer operation over the code base. Okay, to understand how this code works. Okay, and this is the entire diagram you can see, guys. Let's say you are having a source code. That means a complete GitHub repository. Okay, that means the complete, let's say, end-to-end implementation. So first of all, what you have to do, you have to first of all, let's say, extract all of the source code. Okay, then you will be creating actually chunk. Okay, different chunks. For this actually we'll be using something called context aware splitting. Okay, now I think you can see here we'll be using something called context aware splitting. So here is the context aware splitting, and how context aware splitting works. So let's say this is your entire source code, and I think you know inside Python programming we use functional programming, OP programming concept, right? So let's say you have created different function. I think I told you I had created different function. Let's say this one function. Let's say this one example. Def4, let's say this is the function. Inside that you are having some code. Now after doing this context aware splitting, what it will do, it will first of all extract all of the source code, then it will create different chunks. Let's say inside this function you are having let's say 200 line of code. Okay, 200 line of code. Now let's see if your chunk size, okay, chunk size, let's say you have given or let's say I can write 20,000 lines of code. Okay, now let's see your chunk size you have defined 500. Okay, 500. That means what it will happen? 500. Okay, 500. Let's say what? That means 500. These kinds of actually tokens would be considered as your one chunks. Now just try to consider how many chunks it will create. It will create different chunks. Obviously, let's say this is the first chunks. This is the second chunks. This is the third chunks. Let's say it has created 3 chunks. Okay, 3 chunks it has created. Now how your model will try to understand whether these chunks, the entire chunks, so it is related to this particular function. Let's say there would be so many functions. There would be let's say thousands of function, but how your model will understand these 3 chunks I got, this chunks is related this function, def2 function. So what context aware splitting will do, it will automatically tag. So see, it is automatically tagging. So this is the chunks of def2 function. Okay, let's say you are having another function, let's say def test. Okay, this is the function. Inside that you have subcode. First of all, it will perform this splitting, that means chunking operation. You will get different chunk. Okay, then it will also perform the tagging operation. Let's say this is the tag of test function. That means your model will try to automatically understand now Now your model will try to understand, okay, this chunks actually I'm getting, this is related to this particular function. Okay, so that's how actually it will understand the context, it will remember the context. Okay, this is called actually context aware splitting, and this context aware splitting we only perform whenever we are working with let's say code. Okay, code data, because previously we work with text data. Okay, text data is a different thing and code data is a different thing. That's why you have to follow this thing. Okay, now let me clear my screen. Now see what will happen. You have to create a vector store, yes or no. You can see after actually getting all the text, okay, all the chunks, you'll be using embedding model. With the embedding model, you'll be creating vector store, and here we'll be using something called ChromaDB. Okay, ChromaDB will be using. Okay, then this would be your knowledge base. Okay, and you'll be connecting your large language model. After that, whatever question actually user will ask, okay, let's say this is the user, whatever question user will ask, it will take this actually relevant answer as well as the question. It will try to understand. Based on that, actually it will give you the actual response. Okay, so this is the entire application we'll be creating. And again, you can see here we are implementing something called one RAG application, retrieval augmented generation. Okay, because here we are feeding our custom data wise we are using code data. Okay, our let's say source code we are using here. So I hope now it is clear. Now let's start the implementation, guys. So first of all, let's implement everything in our Jupyter notebook, then we'll try to convert everything as our modular coding. Now let me clear my screen. Okay, so first of all, let's import all of the library I need. So here you can see I have imported all of the library actually I need in this implementation. Now the first library I'm importing called from git import repo. So I think you remember we installed one package called git python. Okay, so what is git python? Git python is nothing but this is the package like git github. Okay, this is the github actually package inside python. That means with the help of this package you can clone any kinds of repository from the github. Let's say the way actually cloned, I think you remember we open up our terminal, we just written one command git clone, then we pasted that link, right? We pasted our repository link, I think you remember. Okay, and it was able to clone this repository in my system. So now if I want to do with the help of Python programming, how we can do it? For this we'll be using this package actually git python. Okay, so with the help of that we'll be easily cloning any kinds of repository from our github, because I told you now user will upload one URL. Okay, that means github URL, project URL, and from the URL actually it will automatically, let's say, clone the repository, then it will extract the information, that means your code base, then it will perform the chunking operation, embedding model, store the embedding in the knowledge base, then it will connect the LLM. Okay, that's how we'll be performing the entire operation. Got it? And here I'm also importing another package called language, because here we'll be using programming language. So I'm going to use Python programming. So with the help of language, actually I'll try to use Python programming language here. Then generic loader, language parser, recursive character text splitter. Okay, so these are the actually additional package I'm also importing, and I'll tell you whenever I will be using them, I'll tell you each and everything. Okay, why I'm using it and what is the use of it. Now you can see I'm importing OpenAI embedding, because I'm going to use OpenAI embedding model. Then ChromaDB vector database, I already told you. Then we'll be creating our chain. Okay, the complete chain, and here we'll be using actually memory, conversation summary memory, because I think you remember in our Langchain series actually we learned how to create the memory. Okay, like it will remember your previous context. So with the help of this conversation summary memory, we can also create a memory buffer. Okay, so this thing actually we have imported so far. Now let me execute. Now see, it should work fine because we have installed everything. Now the next thing what I will do, guys, I'll just create a folder here. So mkdir. So this is the command to create a folder. I'll name it as test repo. Okay, test repo. Now see, if I show you my project working directory right now, so pwd project working directory, I'm inside resource folder. So inside resource folder it will create a folder called, okay, mkdir is not recognized. Okay, so it should be mk. Okay, not mac. Now it should work. See, now in the test folder it has created one folder called test repo. Inside test repo I'm going to clone the repository, and to clone the repository, guys, you can use this code snippet. So here I'm using this one actually, I think remember a repo. So the repo actually I have imported from git. So inside that you have one function called clone from. Now you have to mention the URL, like which repository you want to clone. Let's say I want to clone this medical chatbot repository. I've given the entire link. So this is the link I have given. Just copy the link and try to mention. Here you can give any kinds of URL, any kinds of GitHub URL you can mention here. That repository would be cloned. Then after that you have to define the path. In which path you want to clone? I want to clone inside this particular path. Okay, this folder. Now see, if I execute, it will automatically clone this repository inside the test repo folder. Let me show you. Execution done. Now inside resource test repo, see, it has cloned all the source code. See, all the source code you can see it has already cloned. Okay, amazing. Now the next thing will be loading all the codes. Okay, all the, let's say, codes, all the data from this repository itself. Okay, all the Python file will be loading. That means we'll be extracting all the source code. For this I'm going to use this code snippet. So here is the code snippet, guys. So here I'm using generic loader from file system. So I think remember we imported this generic loader from Langchain. Okay, generic. Now here I'm giving the repo path, that means where my repo is present. Then I'm giving the globe, that means it will open, that means it will extract all the Python file, okay, .py file. Then parser, you have to mention the language. So here it is the Python language, okay, that's why you have to give the Python language. And parser threshold, you just keep it this particular number 500, okay, this is the default number, you can keep it. Now it will give me the loader object, okay. Now from the loader object I will load the documents. Now see, it will give me the entire documents right now. If I show you, see, all the content is has extracted, okay. Now if you want to see them, now how many documents you got, you can check the length of documents. You'll see that 7 documents actually I got. Now if you want to see any kinds of specific, let's say, documents, you can print it. Now you can see this is the entire source code. You can see it has extracted, okay, from my repository itself. Now the next thing, guys, will be performing this context aware splitting. Okay, context aware splitting, I already told you, we'll be creating the chunks, and this particular chunks will tag with the function name. For this we'll be using this this particular code snippet. Let me show you. This is the code snippet, guys. Recursive character test splitter you can use, and inside that you only need to mention one parameter called language is equal to language.python. So it will automatically perform the context aware splitting. That means it will tag the chunks with respect to the function. Got it? And chunk size and chunks overlap I have given. Now let me execute. Now I'll apply on top of my entire documents. Okay, document splitter, split documents. I'm passing my documents. Now it will give you the entire chunks. So let me show you. So this is the chunks I got. If you want to see the length, you can also see the length. Okay, see, this is the length of my chunks. Got it? Then next thing what I have to do, guys, I have to actually use the embedding model. Okay, to convert all my source code to the embedding representation, and I will be storing to my knowledge base, that means ChromaDB. For this I will be using OpenAI embedding model, I think, remember. So let's set our OpenAI environment API key here. So this is my OpenAI API key. So I already created and I already set here. Now let me save. I'll go back to my notebook. Now first of all, let's load this API key with the help of .env package. So here you can see I'm loading it. Then I will set this API key as an environment variable. Then I'm going to initialize my embedding model. Okay, OpenAI embedding model. That's it. Now let's initialize my ChromaDB. So I think you remember we imported already Chroma from Langchain here. So Chroma we already imported. You can see vector store Chroma we imported. Now inside ChromaDB, we are passing our text. That means the chunks actually I created, and the embedding model as well as the parses directory. That means it will create a directory. That means database. Okay, so instead of data you can give database. Okay, DB. Okay, DB. So it will create a database, like local database. Inside that it will save all of your embeddings. And ChromaDB session I have already taken in the YouTube channel. You can check it out how ChromaDB works. Okay, now let me create the vector store. Now see, DB has created, okay, inside resource, and it is converting all the code to the embedding representation, and it is saving inside DB. Now see, it has created the local database. Okay, see. Okay, now what I'll do, I'll just make it as, now to activate this vector DB you have to execute this line, vector db.persist. Okay, now I'll be initializing my large language model. So here you can use any kinds of large language model. You can also use GPT-4. I'll be using the default model like GPT 3.5 Turbo. So let's initialize my LLM. Then I'll be creating the memory. That means that history memory, conversation summary memory. You can see I'm importing this library, and inside that I'm passing my large language model. Then memory key is equal to chat history. That means it will remember my previous context. Okay, then return message is equal to true. So this is going to be my memory object right now. Then I'll be creating my final chain. So for this you'll be using a conversation retrieval chain. Okay, now inside that give the LLM retriever vector database. Okay, and as retriever, so search type I'm giving MMR. Keyword, it will give me 8 relevant answer, and here I've given the memory. Okay, now this is going to be my key object right now. Now let's ask one question. So I'll prepare one question here. Question is equal to, let's say, I'll go to the test repo. Inside that I'm having src folder. Inside helper I'm having one function, let's say download Huggingface embedding. I'll copy this function name, and here I will ask what is download Huggingface embedding function. Okay, let's see whether my model is able to explain or not. So this is my question. So this question I'm going to pass inside my keyword, that means my chain. Okay, and it will give me and it will give me results, and I'm going to only extract the answer, okay, from the result itself. Now let's see. So guys, you can see I got the answer. The download Hugging Face embedding function downloads the embedding from the Hugging Face model. So this is the model actually. Okay, now see if I open it up. See, it is correctly identified this model actually we are trying to download, and which returns embedding of 304 dimensions. These embeddings are used for the processing and analyze text data into context of the application. That means correct information. Okay, amazingly, it has explained this function. Now you can give any other question. So what I will do, I'll copy this question and let's ask about this function right now. Let's say I'll ask about load PDF file. Okay, this function right now. Let's see what it will give me. So I'll copy the same code. And here I can mention, I think. Now let's see. So ignore this line. Okay, this line is not required. So this is your actual response. The load PDF function loads the PDF file from a specified directory using directory loader class, which is a filter of PDF files. And then it extracts the documents and return the items. Amazing, guys. So that's how you can perform the QA operation with your code base right now. If you don't understand any kinds of code, if you don't understand any kinds of function, just try to, give it here and try to ask it. So it will give you the entire explanation of your code base. Okay, this is called actually source code analysis. And this is one of the amazing project, guys. Amazing project. Got it? Now, this is the actually notebook experiment. Now let's try to convert this project as our end-to-end implementation. Okay, so I'll just do the copy paste operation from my notebook only, because I think I showed you in my previous implementation, I did the same thing. So now what I will do, guys, I'll open up my SRC folder inside helper. So whatever, let's say, code I have written, okay, then let's say individually, I was loading the, I was cloning the GitHub, I was extracting the data, I was performing the embedding model operation. Okay, so everything I'll just write as a function inside helper.py. Okay, so now let's do it. This is how actually I implemented, guys. So I'm importing all of the necessary library. Then first of all, I created one function called repo ingestion. It will take the repo URL and it will do the ingestion operation. That means clone operation. The same thing we are doing in our notebook only. Got it? Then second function I have written called load repo. The same code, guys. That loader, generic loader I'm using here. See, it will take the repo path and it will load the, let's say, code, and it will give you the documents after extracting. Then the third function I've written called text splitter. That means it will perform the context aware splitting. Okay, the same thing. Then it will give you the embedding model. Okay, it will first of all get the embedding model from the OpenAI. It will return you. So instead of actually writing the scripting, I've just written as a function. That's it. Now the next thing what I will do, I'll add everything inside my endpoint, which is nothing but my app.py, because app.py user will execute and they will get one user interface, and from there actually they will upload, let's say they will give the URL, they will do the QA operation. Okay, so for this actually I already told you we'll be using Flask, and for the Flask actually you need one template and a static file, I think you remember. So let me show you. I already prepared one HTML and CSS code for you. So guys, as you can see, this is the template file, and inside that I'm having my index.html, and this is the HTML code. And again, I refer the internet bootstrap website to implement this actually HTML and CSS code. If you're not aware about, it's completely fine. You can use my template as it is. Okay. Now inside the static folder, I'm having the CSS. That means CSS code. Okay. That means style of our web interface and all. And to execute this style.css, I am using some JavaScript actually code. You can see this is the JavaScript code. Again, I got it from the bootstrap website. Now see how your application will look like. I'll tell you. Before that, let me write this app.py code. So inside app.py, I'm going to import all of the library I need. So you can see I'm imported all of the library like ChromaDB, load embeddings, okay, from the SRC helper, because I need the embedding model, right? Then repo ingestion, I'm also importing from the SRC. Then my chat OpenAI, okay, function, then conversation summary, okay, conversation retrieval chain. So everything you can see in the notebook, I'm importing all of them here. Now, first of all, what I have to do, I have to initialize my Flask, and I will set the OpenAI environment key as my environment variable here. That's it. Okay, see. Now, first of all, I will load my embeddings, okay, from my vector database. You can see I'm loading the embedding from my vector database. So for this, before that, what I have to do, I have to first of all generate the vector embedding. Let's say if user has given the URL, so it will generate the embedding, right? It will create the embeddings and it will say inside my vector database, yes or no. So for this, I'm going to create another file called store_index.py. So previously in the medical chatbot implementation, I written the same file, I think, remember. Inside that, I was doing the actually embedding storing operation. See. So you can see repo ingestion, load URL. So I'm importing everything. I'm setting my open API key. Then load repo. That means see, user will give the URL. So this URL actually repo ingestion will load, and it will load the, let's say, documents. It will perform the text splitter embedding. Then this embedding will store inside my like ChromaDB. ChromaDB will create an like local database. Inside that it will save everything. Okay, I think you remember. Now here I've commented this 2 line because I will be doing this thing with the help of user interface. That means UI. Okay, not manually actually. So that means from the app.py user will give the URL. Okay, from the user interface web application user will give the URL. This URL I will receive here. Okay, I'll receive here, then I will execute this line of code. Okay, so that's why I've commented this line. But if you want to test what you can do, you can uncomment it and you can execute this line. You will see that it will work fine. Okay, so as of now I've just commented out. Now let me save it. Now I'll go back to my app.py. Now let's create the LLM chain. So this is the chain. The same code I've copy pasted from my notebook, guys. I'm creating the LLM, creating the memory. After that I'm creating the QA chain. That's it. Then I'll be creating 2 route. Then I'm going to create a route actually from my Flask. So this is the default route. First of all, it will render the index.html whenever the user will open the application. Okay. Then the second route I'll be creating for the repo ingestion. So whenever user will pass the URL of the GitHub and they will submit. So what will happen? It will execute this store index.py. You can see I'm executing this command, python store index.py. And if you want to execute any Python file, that means if you want to execute any command, you have to use system, voice.system. You can see I've imported operating system. So voice.system, and inside that just give the command, it will execute this file. That means what will happen? Whatever URL user will give. Okay. So first of all, it will perform the repo ingestion. I think you remember we created the repo ingestion function. Repo would be ingested in the repo folder. And if I go it back, now see, now it will execute this store index.py file. That means this file. Now this code will be executed. That means it will load the repo, extract the documents, create the chunks, load the embedding model, then store all the embeddings to the knowledge base. That means inside my ChromaDB vector database. Okay. Now I think you got it. Now see, this is my second route. Now I'll be creating another last route. This is for the chat operation. That means after ingesting the data, creating the knowledge base, it will perform the chat operation. User will give the message. Okay. And if message is equal to clear, it will remove your let's say entire repository. That let's say you want to clone another repository, so your previous repository should be deleted. Okay, otherwise what will happen? It will take all I mean space. Okay, in my system. That's why I'm removing it. I'm doing the you can say rm.rf operation. That means it will remove it. So this is a Linux command. That's why I'm executing inside voice.system. Okay, then after that, whatever input user is giving, I'm getting the results. I'm rendering the answer. Okay, that's it. Now let's open up my application and let me show you. Now I think this part would be clear. So I'll open up my terminal. Now let's execute my app.py. So app.py will open. It's running now. Let's go back. Now just search for localhost port number 8080. Now see, this is the interface of your application. Okay. Now here you have to give the URL. So let's say I will give this URL. I'll just give it here. Now see, I'll just send it. Now see, in the backend, what will happen? It will ingest. That means it will clone this repository first of all. After that, it will create the embeddings and it will save this embedding in the vector database. Now see, internally everything is executing. If you go here, now see, repo, it is cloning as well as DB would be also created. Now let's wait and let's try to see. So guys, as you can see, my execution is done. So if execution is done, you will see this message actually, response. Okay, response. So now if I open it up, now see, my repo has ingested and also my DB object is created. That means my embeddings has already stored here. Now I can perform the QA operation. For this, I'll be using this template right now. And this is the same actually chatbot template I'm using from my medical chatbot. Okay. Now here you can give any kinds of question. Let's say I'll give what is. I'll ask the same question again. So I'll open the repo src helper. Let's say we'll ask this one, download Huggingface. Like what is this function and all about? Function. Let's see. See, this is the answer I got. The download Huggingface embedding function responsible for downloading the embedding model from the Huggingface called sentence this model and specify return the 384 dimensional vector. Great. Now I'll ask another question. What is this function? Let's say text split. See, text split function See, text split function purpose is to split the extracted data into smaller text chunks. These text chunks are useful for the processing and analyzing the text in a smaller, more manageable section. Great. That means it is giving you the correct response. Now you can ask any kinds of question regarding your source code. Okay. So this is the entire implementation, guys, of our project. Yeah. So I think you liked it, guys. And in the next video, we'll see the deployment, like how we can deploy these kinds of projects, okay, to the like cloud platform. So for this section, we'll be using AWS. So in AWS, I'll show you the deployment part. So before ending the session, first of all, let me commit the changes in my GitHub. So I don't want to push the repo. Let's say this repo I don't want to push. So what I can do, see, let me show you another thing. Let's say if I give clear message here, it will remove the repo folder automatically. See, repo folder would be deleted because you have written the code here. I think, remember, inside helper, not helper, I think inside app.py. See here, if you give the clear, it will remove the repo folder. Okay. Now if I click here, now see, then I also don't want to push this DB objects. What I can do in the git ignore, I can mention this DB. Let's say DB would be ignored. Inside everything, just try to ignore. Now let's try to see. DB is also. Okay, another actually repo I'm having inside resource. So let me also mention resource also. Inside resource, I'm having test repo. So everything I want to ignore, as well as I want to ignore the DB as well. Now I think, okay, research spelling is not correct, so it should be like that. Okay, research. Now let me save. Now see, it is ignoring everything. Okay, now let me push the changes. So I'll just write updated, commit, and seeing the changes. Now if I get back and refresh here, see, all the source code has been updated. Now let me write the further step you can perform. So here I have added the next step, like you have to create the environment file. Inside that, just set your OpenAI API key and just run app.py, and you can execute your project. Okay, that's it. Now let me also update this readme file. Readme updated. Now let's refresh here. Now see, everything is mentioned. Okay, all of the command I have shared with you.
So before starting with our chainlit discussion, first of all, I just wanted to tell you something like why we should use this chainlit. And as a data scientist, actually, what are the difficulties actually we face whenever we try to develop any kinds of application, right? So I think you have used something called Streamlit to create your this kinds of web application. Even I have already showed you how we can create end-to-end like these kinds of generative AI projects with the help of Streamlit and all. See, whenever we are using Streamlit, it's a initial interface, right? Initial demo of your application. But nowadays actually this LLM comes and people are creating lots of application on top of these kinds of LLMs. And also, like, there are lots of application, there are lots of product in the market right now, like ChatGPT is there, Google Bard is there, right? Then Microsoft Bing Chat is also there. So if you have seen these kinds of product, these kinds of application, so you will see like this application has like very beautiful user interface, right? So whenever, let's say, I'm creating any kinds of conversational agents, okay, let's say I'm creating any kind of chatbot, so we should have one like very beautiful user interface. Otherwise user might not get interest, okay, with your application. So that is the main thing actually. And Chainlit provides actually this kinds of beautiful user interface whenever you are trying to create any kinds of conversational agents and all. So we can use this Chainlit to build this kinds of LLM app super fast. Okay, I will tell you like why it is super fast, because you will see using very short line of code will be creating these kinds of application very easily, right? But if you're using Streamlit, I think you saw we need to write some more code there. Okay, but if you're using Chainlit, so like more code doesn't required here. So only using some line of code actually will be able to complete our entire projects. Okay, so this is a like very amazing package I was exploring, and I thought let's also show you this one. So that actually whenever you are learning these kinds of large language model, generative AI, so at the end you need to build some application, right? So you can use this kinds of Chainlit package with your application. And there is another reason actually you should use this chainlit. You should explore this chainlit. Let's say you are building some projects for your client, so you need to submit that projects to your client. So you need to submit some good you can say output from your side, otherwise your client might not get interest. So at that time, if you're using this kinds of chainlit interface, okay, chainlit package to create your apps and all, so it would be very much realistic, and it would be very much amazing to your client whenever they will look into your application. So that is why actually whenever you are trying to build something, you have implemented any kinds of POC and all, so at that time just try to use this kinds of chainlit package to create your apps, so that actually you can submit some good application to your client, okay, and they will be very much happy with you, right, with your work. So guys, this is the video agenda. So first of all, I will take you through the chainlit documentation. Then I will show you like how we can use this chainlit, and we'll be building one basic chatbot here. So I'm going to implement one food delivery chatbot. So basically it will ask for the order, okay, it will suggest you the food, then it will ask for the location, and it will take your order and all. So these kinds of chatbot actually will be implementing. I think you have seen like Zomato, right? So we'll be building some something like Zomato. You can build anything, but this is the project actually I prepared for you, so that actually you can learn something, right? So I just wanted to make you this thing as realistic, so that whenever you are building your own projects, okay, you will get interest. So yes guys, this is all about. Now let's start with our chainlit discussion. So guys, as you can see, this is the chainlit documentation, and chainlit is nothing but chainlit is an open source Python package that makes incredibly fast to build ChatGPT like application with your own business logic and data. As you can see, if I open ChatGPT, so here you will see it has one beautiful user interface. Okay, that's why user are more interested to use these kinds of ChatGPT kinds of application. Now let's see, if you give any kinds of message, so it will take your message, even it will reply like that. Okay, so we'll be building something like that, so it would be like ChatGPT like interface, right? Then if you see here, it has also official tutorial, so you can also visit the tutorial they have given. So from there actually you can also learn, but I will make this video very simple, so that actually you can understand each and everything. You don't need to go through even the documentation. I will discuss everything, whatever things actually you need to explore, okay? And apart from that, anything is left and anything you want to explore from your side, you can visit the documentation and learn, okay? Yes guys, this is the documentation, as you can see, and it has also integration with these kinds of LangChain, then AutoGen, LlamaIndex, okay? You can either use OpenAI, either use LangChain, either use LlamaIndex, anything you can use, okay? All the things has been integrated with that. So in this video, actually, I'm going to use OpenAI API. That means I'm going to use GPT 3.5 Turbo model to create this application, because I just want to show you quickly. That's why I will be using this OpenAI model, because there actually I will get one API key and everything would be done for me, right? But you can also use open source large language model. I think I already taken some of the session, like how we can use Google Palm to Llama, then we have Llama 2, then we have Falcon, we have Mistral 7B, anything you can use here. You can also integrate a LangChain with that. I have already showed you like lots of things with the help of LangChain and all, so you can explore this thing, right? So yes guys, this is the documentation. Now here they have already given some starter code, like how we can start with this chainlit and all. So I'll show you like how we can launch this chainlit app and all, okay? But before that, what I need to do, I'll be creating one GitHub repository. So here's my GitHub. So let me create one GitHub repository. I'll name it as LLM app with chainlit. You can give any kinds of name. So let's keep it as public. I'll add readme file. Then git ignore wise, I'll be using Python, and license, you can take any kinds of license. So let's take MIT license. Then I will be creating my repository. Now let's clone this repository in my local machine. So I'll copy this link address, and I will open my local machine, and here I'll open my terminal and just write git clone and paste this link and clone it. Okay, now I'll redirect to this folder, LLM apps with chainlit. Now I am inside this folder. Now here I will launch my VS Code, so you can use any kinds of code editor, it's completely fine. So I already opened my VS Code. Now here I'll be creating some of the like folders and file. Then we'll be doing the environment setup because I need to install some of the libraries, like let's say Chainlit I need to install, then I need to also install OpenAI and all. Okay, so let's do it and see like how we can use this kind of Chainlit. So here I'm going to create one folder called src, and then inside src I'm going to create one file called underscore underscore init underscore underscore dot py. I think you already know why this constructor is needed, because I'm going to consider this src as my local package, because here I'm going to writing some of the Python file, and from that file I'll be importing some of the function and all. Okay, that's why I need to create it. I think I showed you in my end-to-end process, okay, what is the use of this. Then inside that actually I'm going to create two more file. One file I will keep my LLM model, and another file I will keep my system related configuration, or you can also talk about this prompt. Okay, you can also tell it as prompt. So prompt dot py. Yeah, now outside I will create another file called app.py. App.py. Then I also need something called requirement.txt. So requirements.txt. Then I also need something called setup.py because of this local package installation. Yeah, so this thing is required. Now let me just write down all the requirements actually I'm going to use. So the first requirement actually I need something called Chainlit. So Chainlit. So this is the package you need to install. Then I need something called OpenAI. Then I need something called python.env. I think you know why we need this .env, because I'll be keeping my like OpenAI credential inside this .env file, and using this python.env I will read that. Yeah, then I also need something called -e space dot because of this setup.py. Now let me create that file also .env. So here I'm going to paste my OpenAI API key. So I already created this API key. So you can also create your own API key. Okay, don't use my one. I will just remove it after this recording. Then I need to install, these are the requirements. So for this I need to create one virtual environment. So I'll open my terminal, and here I'll just write conda create -n. Let's name it as chain, or I can give yeah, chainlit demo. This is the environment name, and Python version wise I'll be using Python 3.9 and -y. Now let's activate my environment. Now I'll be installing the requirements. So just write pip install -r requirement.txt. Okay, it's giving error because we haven't added like setup.py code here. That is why it's throwing error. So I think you remember. So this code actually we usually add inside our setup.py. So this code is responsible to find this constructor file, and it will set up that folder as my local package. Okay, and here you can check the project name, version, author name, email address, and anything. Right, now let me install them. So now I'll again execute my requirement.txt. So it may take some time. Let's wait. I'll come back when it is done. So guys, as you can see, my installation is done now. Yeah, so everything is done. Now let me select the environment I created here. So it was Chainlit demo. Yeah, that's it. Now first of all, let's test it whether everything is fine or not. So I'll close these are the file first of all. Yeah, so I'll visit this documentation again, this Chainlit documentation, and if you click on in pure Python, so they have given one like code here. So let me just copy. So this code actually, this is the echo bot. Like if you send anything, so it will respond the same message, okay, as echo. So it's just for the testing purpose, like whether we are able to launch our Chainlit app or not, and it is working fine or not. Okay, so first of all, let me check it, everything is fine or not. Then I'll add my logic. I'll add my chatbot logic here. And here if you see, this code will remain same, and here you just need to write your logic. Okay, here we'll be writing our custom logic, and this code will remain same. Okay, and this is the EcoBot currently. Now here what I need to do, I'll open my terminal, and if you visit the documentation, so they're telling, first of all, you need to write one command called chainlit init. Okay, first of all, you need to initialize the chainlit here. So it will create one folder here called .chainlit, and inside that it will contain all the configuration. See, it has created this chainlit. Inside that it has created another toml file. This is the configuration file, and it has all the configuration. Okay, so here is the configuration. So you can change this GitHub URL and all. Okay, you can also change the project name here. So here is the project name, you can also change it. So this kinds of configuration you can change. So I'll just keep it as default, no issue with that. Then I'll again open my terminal. Again I will run one command called chainlit run app.py. Okay, now if I execute this command, so you will see it will launch one server for me, and this, it is running on localhost port number 8000. So I'll give allow access, and this is the default user interface. Okay, so why this message is coming here, welcome to chainlit and all. So if you see here, it has created one md file here. Automatically it has created one .md file, like markdown file, and these are the content actually it has automatically generated. Okay, now let's see if I change anything here. So let's say I will change welcome to my bot. Okay, if I change anything here, now if I go to my app and refresh, see, it has changed. That means if you want to, let's say, print any kinds of messages, okay, whenever user will launch your application, okay, so you can customize here. So I already created this md file. I already made some customization there, because I told you I'm going to implement something called this one Zomato bot. Okay, so for this actually I created some of the content related Zomato, and again I generated these are the content with the help of ChatGPT. Okay, so let me show you like what are things I have done. So here I'll just copy paste. See, this is the content I prepared. Hello, welcome to Zomato bot, and here I'm just showing some of the item like we have pizzas, then pasta, noodles, then Asian cuisines. Okay, so these are the thing actually I have generated with the help of ChatGPT. So here you can give anything, any message, whatever you feel good, you can give it here, and whatever application you are building with respect to that, just add the content here. Now if I go back to my application and refresh it, see guys, now it has changed to this content. Okay, now let's see if I give any kinds of message here, hi, so it will give me the same response like hi. Okay, now if I open my ChatGPT, and if you just compare with the ChatGPT, okay, now see, it's looking like ChatGPT only, right? So that's why they're telling Chainlit is nothing but it's a like a open source Python package, and with the help of that you can create ChatGPT like interface. Okay, ChatGPT like application. So I love this Chainlit a lot, because see, only using this line of code, okay, only using this line of code, like this only using just one function, we are able to launch this kinds of user interface. Now let's see if you're building any kinds of product for your client, so if you submit like that, so they will be pretty much impressed by your work. Okay, so that is why actually we should always use some good user interface whenever we are delivering our application, right? Now here you can give any message like I am Bappy, so it will give you the same response. Okay, because we have created the EcoBot. How it is working, so let me show you. So they have created one function, and this is the decorator they are using, this chainlit decorator. So this decorator is handling everything, and again they are using async and await, because async and await is helping us to read this message, okay, real time. So it is always sensing our input, and whenever we are giving something, it is receiving, and it is also sending the message to the front end, right? So this is the like code, simple code. Now here we'll be writing our custom logic. So basically we'll be building one Zomato bot with the help of this large language model. I'll be using like OpenAI GPT 3.5 Turbo, and here we'll be chatting with our bot, okay, with the help of this Chainlit. And here if you see, your app name is Chatbot currently, so you can also change this name. So I told you there is a configuration it has generated. Now if you go below, so here is the option to change the name. So by default it is Chatbot, so you can also give something called Chatbot for Zomato. Zomato. Okay, now if I refresh and again refresh here, uh, I need to, I think, stop the execution. So I'll open my code. Now guys, see, this name has been changed, chatbot for Zomato. Okay, now I can close the previous one, and again it's the ecobot. Now guys, let's add our custom logic. So for this, first of all, I will prepare my LLM, that means large language model. So this is the file. So here, first of all, I'm going to import OpenAI. So I think you know OpenAI has been updated. Now it is like latest version. So they have upgraded lots of thing. And if you visit that documentation currently, so if I go to this OpenAI, openai.com, and if I log in, so this is the documentation. Now let's go to any kinds of task and let's see how we need to import. See, this is the import and we need to like initialize this client object. Okay, but initially we just need to install import OpenAI. Okay, that's how we can do it. But now actually you need to import like that from OpenAI, import OpenAI. Okay, so this is the updated version of OpenAI, and if you see here, we need to upgrade it also. Okay, if you are using previous one, so you need to upgrade also. Okay, so this is the requirement you know always need to follow. You always need to upgrade with the documentation, otherwise you might get some issue. Okay, so let's import OpenAI. So from OpenAI, import OpenAI. Okay, so I need to make one client object here, client OpenAI. Then here I will be initializing one function. I'll create one function, so I'll name this function as ask order. Okay, ask order. So this function will this is going to be like main function. So basically this function will give me the response whatever question actually user will ask. So it will take the message. First of all, it will take the message. Then it will also take the model. So model wise I'll be using something called GPT 3.5 turbo, 3.5 3.5 turbo. So this is the model I'm going to use. You can use any kinds of model. You can use GPT-4, anything you can use here. I'll be using this model because this model charge would be a little bit less for me, so that's why. Then I will also take this temperature value. What is temperature? I think you know in LLM. Temperature is like how much randomness you want from your model. Okay, if you're giving it to 0, so that means it won't be giving any randomness. It won't be like more creative. It will give you auto, like always stick output. But if your setting is too close to 1, that means you are telling your model to take risk, and it will also generate some random output. Okay, so that's why this temperature parameter is important also. Now this is my function. Now here they have already given like how to initialize this one. If you see here, so we need to use something called client.chat completion.create. So let me copy this line. I'll copy this line. Then I will open my code, and here I will add it. Now inside that, I think you saw, first of all, it will take the model. Model is equal to model. Then it will also take something called masses. Okay, masses. So what is masses here? So let me show you. See, masses is nothing but it's kinds of prompt actually you are giving. Basically you are giving some like zero shot or few shot prompt here, like you are telling this is the role. Okay, role means system means like you are the role. Okay, like you as a chatbot, this is your role system, and this is the content. So you are a helpful assistant. Okay, basically it is I'm telling to my bot you are a helpful assistant. And whenever user is giving some content, okay, let's say this is the content user has given, so you also need to reply as an assistant. Okay, as you can see, this should be your answer. So that means we are giving some prompt here. Okay, we are just giving some zero shot or few shot prompt here to my LLM, so that my LLM can understand what kinds of job actually I want to perform. Okay, so I think you already learned this prompt engineering and all. Okay, so this is very much important here. So let's also define this one. So I already prepared one prompt here, so let me show you. So you can also create your custom prompt. There is no issue with that. So in this prompt.py, I'll paste it out. So this is going to be like very creative. The more good prompt you actually will give to your LLM, the more good results actually you will get. Okay, so this is the prompt actually I've developed. So system instruction, as you can see, you are a Zomato bot, an automated service to collect other orders from online restaurant. Okay, if you see here, so many like content I have written here. Like, so here I'm just trying to making my bot understand like what it is going to do exactly. And these are the actually item I also like pasted here. So if anyone is asking like for the menu, so it should return something, right? So these are the actually prompt I have developed from my side. Okay, so this prompt actually I'm going to use. Now I think you remember you need to create one format, as you can see, role as system assistant. So that's kinds of format actually you need. So for this actually I already prepared. So this is going to be the format, as you can see, message, role, system, content, and system instruction I need to import from my prompt. So here I'll just write from src dot I have LLMs. Oh no, sorry, src dot prompt. Then I need to import something called system instruction. Okay, so here is my system instruction. I'm importing this one. Now here I'm just telling role, system, and content. Okay, so here I'm giving the prompt to my LLM, as you can see. Now this message actually I will give it here. Okay, yes. Now I also need to set the temperature. So temperature is equal to temperature. Okay, now this will also return something, as you can see if you go below. So this is the response format. It will give you this kinds of format as a response. It's a JSON format response. So from here actually I will need to collect this content. Okay, if you see here, I need to collect this content. Okay, content is the response, okay, actual response, and these are some parameter it will also give you. So if you want to like extract the content, so you can copy this, either you can also copy this one, you can also copy this one. Okay, this one also you can copy. So let me copy this one and I'll open my bot again, and here I'll just write return response.choice message.content. I only need the content. Okay, so this is my function I have developed. So it should be messages instead of messages. Yeah, now it's fine. So now I will write my final logic. So I'll open my app.py. So here first of all I need to import my this function ask order. So let me import. So from src dot llm import ask order. Then I also need to import something called messages. Okay, because here if you see we have also created this messages. I also need this one here. Let me save it. Then if I show you now here, if you see here, whenever I was discussing this thing, so you need to prepare this message. Okay, we have created for the system. Okay, system, that means we have given the prompt. Now I also need to create for the user. Okay, like whatever input user will give. Okay, so for this, in this list actually, if I show you, we have a message. Okay, this is the list actually, and inside that we have a dictionary. So I need to add some more, like you can say I mean messages, as you can see, one by one. So this is for the system. Then I also need to add for the user as well. Okay, so I need to just append it. So for this what I need to do, so I'll open my app.py, and here you can append like that. So I'll just write message.append, and here I'm just initializing my user right now, role, this is user, and this is the content. What is the content user will give? The message. Okay, the message actually will send. Okay, the message actually will send from here. So this is going to be the content. So it will store here. Okay, it will store it here. That means in this list, because we are doing the append operation, right? So once it is done, I also need to give this message. Okay, I also need to give this message to my bot. So I'll just write ask order. Inside that it will take the messages. Okay, then it will also give me something called response. It will give it will give me something called response. Okay, now if you see here, I also need to provide the response here. If I show you, I also need to give the assistant response as well. Okay, as you can see, assistant response as well. So again I will append. So I, whenever I will receive the response, okay, I will extract the content. So as an assistant, actually, it will give me some response. So this response actually I am appending, because if I show you here, this response should be my content. Okay, as you can see, it is returning the content, and that content actually I am storing. Now once it is done, now I also need to send the response to my this Chainlit user interface, right? So to do it, actually, if you see by default, it is sending the like echo command only. The message user is giving the same message actually it is sending. So instead of that, actually, I just need to send my response. Okay, this is the response actually. I need to send to my uh, front end. Done. Yes, so this is the logic only. So this is a like very easy code we have written. Now here you can also integrate your open source LLM. You can use PAM2, you can use Llama. Okay, you can also use Falcon, anything you can use. I think I already showed you how to use them. And you can also integrate Langchain with that. Okay, so if you are using open source LLM, so you can also use Langchain. Okay, with the help of Langchain, you can also do it. And the same thing you can do the return here. Okay, as a response. Now let's test it whether it's working or not. So I'll go back to my Chainlit, then I will refresh. Yeah, now let's say if I give any message, let's say hi. So it is received hi, because I need to, I think, restart it. So I'll uh, open my terminal, and I will close the execution. If you press Ctrl C, it will close. Now let's restart again. So I have restarted. Now here is my new one. Now let's see if I give any message hi. See, it's giving hello, welcome to Zomato, how I can assist you. So here I can give my name is Bappy, uh, and I am looking for I'm looking for something. I'm looking something for dinner. I'm looking something for dinner. Okay, now it is telling, hi Bappy, I'm here to help you find something delicious for dinner. What type of cuisines you are in mood for? We have options like pizza, pasta, then Asian cuisines, then beverages and Indian cuisines. Let me know your preferred. So I will go for Indian food. Okay, now see, it is giving great choice, Bappy. Indian cuisine is always a treat, and here is some option for the Indian menu. Now it is telling butter chicken we have with naan, and even it is also giving the cost, because we have added the prompt here. I think you remember. Then tikka masala rice, then palak paneer, then chana masala, vegetable biryani, samosa, lachi. So I need this one, chicken tikka masala with rice. Okay, so I'll just write add chicken tikka masala rice in the cart. Yeah. So I have added chicken tikka masala in the cart. Is there anything else would you like to order, or this is all for you? Uh, no, it's fine. Okay, all right. Here is the summary of your order. So chicken tikka masala. Now, if you see, this is the price. Now it is telling, is that correct? And would you like to pick up your order or have it delivered? So I'll tell have it delivered. Delivered. Great. We have will deliver your order to you. Could you please provide me your delivery address? So I'll give some address here. So I'll tell my address. My address is this is my address. Let's give this address. Okay. So thanks for providing your address, Bappy. Your order will be delivered to 17th floor, Brigade Signature Tower. The total amount for your order $10.99. How would you like to make the payment? We accept cash on delivery or online payment. I'll go for cash on delivery. Cash on cash on delivery. Perfect. You can pay in cash when the delivery. Thank for the placing your order. Bappy, your chicken tikka masala with rice will be delivered shortly. If you have any other questions or need further assistance, feel free to ask. Enjoy your meal. Uh, Great. Thank you. Okay. See guys, we have implemented one amazing food delivery bot with the help of this Chainlit, and now see the interface, guys. It's like very professional, very amazing, right? Very amazing. Now, if you deliver this project to someone else, they will be going mad, right? Like whatever things actually you have developed, right? Now, what I will do quickly, what I will do, I will just quickly commit the changes to my GitHub so that else you can get the code. So I'll just write completed commit. Done. Now if I go back to my GitHub and refresh, yeah, so you have committed. So yes guys, this was the demo of the Chainlit. I think you enjoyed this package a lot, and even I'm also enjoying this package a lot. Okay, I'm just trying to use this Chainlit package to build my LLM apps and all. And see guys, like by using some like very less line of code, actually we are able to build these kinds of awesome application, and it's like very fast, right? Now we'll try to see the deployment part, like how we can deploy these kinds of projects on the cloud platform. So I think you already know we implemented so many end-to-end projects, right? So implemented medical chatbot, then source code analysis. Then we also implemented something called Zomato chatbot, right? So different application we implemented so far. Now in this video, I'll show you how we can deploy these kinds of application on the cloud platform. That means here we'll be deploying our application on the AWS cloud. If you want to learn any other cloud deployment, it is also fine. See, the process will remain same, only the cloud functionality would be different. So I'll try to create some more video on the deployment. Like I'll also show you how we can deploy these kinds of project on the GCP cloud, on the, let's say, the Azure cloud. But first of all, let's try to see how we can deploy this project on the AWS cloud. And see, this is not going to be a simple deployment. So here we'll be doing continuous integration and continuous delivery or deployment. That means CICD. So I think you have heard of this particular term called CICD, right? So we'll be learning how we can deploy this project as a CICD. I think you already know how to deploy any machine learning project, deep learning project as CICD, but we haven't seen how we can deploy any kinds of generative AI based project as a CICD, right? So that's why make sure you are watching this video till the end. So here I'm going to show you each and every step you have to follow. And trust me, if you follow this step, guys, you can use this step to deploy any kinds of, let's say, generative AI based project. Okay, and this is going to be production grade deployment. Okay, so here I'm going to use different kinds of service from the AWS. Even I'll be also using Docker. That means first of all we'll be dockerizing the entire source code, then we'll be deploying this application on the cloud platform. Okay, so make sure you are watching this video till the end. So before starting the deployment, guys, first of all, let me show you what exactly we're gonna perform here. What is CI/CD exactly? Then I will also discuss, let's say, what are the tools and technology we'll be using here, what are the services we'll be using here. Then I will start with the deployment, and make sure you have the AWS account. If you don't have the AWS account, guys, so you won't be able to deploy this project. So first of all, try to create one account. If you're creating for the first time, you will get $300 free credit. Okay, and this is enough for you. So try to create an account, guys. Then you can start with the deployment with me. So let's open up our Blackboard and try to see the architecture overview. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. That's a local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say
somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud manually. You just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again, you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time, then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application, then you will be uploading your updated code. Then this code will reflect to the endpoint, then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application. Yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CICD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called actually CICD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CICD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing. Now whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually 3 famous tools actually we are having in the market right now. So people are using more this GitHub Action, because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay, so here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can let's say use Jenkins, Circle CI. These are the services as well. Fine. So yes guys, this is the complete high level architecture of our deployment. Now let's discuss what are the services actually we'll be using for the deployment. See, here the first services actually I'm going to use called Docker. So I think you already know Docker. So Docker is a containerization service. So with the help of that, you can containerize your code. That means, let's say you are having a source code, you can perform the containerization. That means it will create a Docker image for you. Okay. So this image you can, let's say, keep anywhere. Let's say you can keep in the Docker Hub. You can keep, let's say, in the ECR, that means Elastic Container Registry. From there, you can pull the image and you can execute this image. Okay. So if you are using Docker, so you won't be getting any kinds of setup issue. This is the main advantage here. Then we'll be using something called ECR here. ECR means Elastic Container Registry. So this is the service from the AWS. Okay, AWS giving the service. So here you can store any kinds of Docker image. It is the same like your Docker Hub. Okay, but it is the service from the AWS. You can store the private image there, but in Docker Hub actually all the image would be public. This is the difference only. Now we'll be using another service called EC2. Okay, EC2 is a virtual machine service from the AWS. Again, it is from the AWS. Okay, so this will give you virtual machine. There you can buy, let's say, CPU based machine, GPU based machine. Okay, so all kinds of configuration would be there. So here we are using our local computer. So there we'll be getting a cloud computer. Okay, this is the difference only. Then as a CICD tool, I'll be using something called GitHub Action, as I already told you. Okay, we'll be using GitHub Action for the CICD management. Fine. So yes, guys, these are the services as of now I'm going to use. So let me show you the deployment step we'll be following. For this, what I have done, guys, I think you remember we implemented one medical chatbot. This is the code, and this code would be also available in your resources section. Even you will also get this code in my GitHub. So guys, this is my GitHub profile. Just search ENTBappy in the Google, you will see my GitHub, and here I have created one repository called end-to-end medical chatbot. So I'm going to commit this code here, so you will get all the source code from this repository itself. Okay, and even I will also add the deployment step in the README file. So that is what actually I have written. You can see the entire deployment step I have written here. Now this is the CI/CD deployment we'll be following. So first of all, what I have to do, we have to let's say create a IAM user. Then we'll be creating the EC2 machine easier. Okay, then we'll be, see, this is the deployment step as of now. Just try to follow the step I'm going to show you. First of all, we'll be building our so here, first of all, we'll be building the Docker image of our source code. That means Docker image we'll be implementing. Then we'll be pushing this Docker image to the ECR. That means Elastic Container Registry to store my Docker image. Then we'll be pulling this image from ECR in the EC2. That means we'll be pulling that image in the EC2 machine in our virtual computer. Then we'll be launching this Docker image in my EC2 machine, and from there we'll be creating an endpoint, and that endpoint user will be able to access. Okay, and these are the policy I have to give whenever I will be creating the IAM user. Fine. So this is the entire step, guys, I have written. Even I have also given all the command you need to execute here. Now let's start the deployment, guys. But before that, you just need to prepare some of the files. The first file you have to prepare the Docker file. So this file will help you to containerize entire your application. That means it will perform the Dockerization. And these are the Docker command you have to write. So I think you remember we are using Python 3.10. Okay, this Python version. That's why I have taken Python 3.10 Slim Bastard image. Then working directory, it will create a working directory called app. Inside that, it will copy all the source code. Then it will install the requirements. Okay, whatever requirements actually we are having here. Got it? Then it will execute this Python 3 app.py command. So that means my endpoint would be executed. Okay, my application would be running. And make sure before actually deployment, you just store your index. Okay, in the Pinecone. So this is the Pinecone, guys. It is running, and all the vector is already stored here. You can see 7020 actually record is already stored here. So I already executed this file. I think you remember store index. So it will create all the, let's say, vector embedding, and it will store in the Pinecone. Okay, Pinecone vector database. So in this project, I was using Pinecone. I think you remember. Okay, so this should be available here. Got it? So once it is available, now what I have to do, guys, then you can create another file called Docker ignore. Inside Docker ignore, you can mention like some of the file which is not required. Let's say here this file is not required. Let's say I think this file is not required. Generative AI project.egg.info. Okay, so whenever it will perform the, let's say, containerization, that means Dockerization. So I don't need this folder. That time what you can do, you can mention this folder name in the Docker ignore file. It is the same thing as your git ignore. So it is already mentioned inside my git ignore. That's why I haven't mentioned inside my Docker ignore. Docker ignore is completely empty. As of now, I need all the file. That's why I haven't keep anything here. Now let's say if you want to ignore any kinds of file which is not required, that time you can store these other file inside Docker ignore. Okay, that's the thing. Now the next things you have to create. You have to create one folder called .github. Okay, inside that you have to create one folder called workflows. Inside that you have to create one YAML file. You can give any name. Here I have given CICD.YAML. Okay, now see, this is the complete YAML file. So this YAML file will help me to do the CICD deployment. Okay, that means here it will be using something called GitHub action. Okay, and GitHub action need this YAML file. So here all the command is already written. So first of all, you will see that it will perform continuous integration. Inside continuous integration, it will authenticate with my AWS account. Okay, then it will log in with my ECR. Then whatever, let's say, Docker image actually will be building, you will push that image to the ECR. Okay, that means Elastic Container Registry. Then your continuous deployment will start. Again, it will authenticate with your AWS account. Then it will pull that, let's say, image from your ECR to EC2 machine. Then it will execute it here. And here all the environment variable I have set. You can see -e means this is the environment variable. See, AWS access key, AWS secret key. I'll tell you how to generate these are the key. then a Pinecone API key, OpenAI API key, everything I have set here. Okay, so these are the thing we'll be reading from the secret. Okay, GitHub secret. I'll tell you how to create the GitHub secret as well. So as of now, just try to remember this is the YAML file you have to use for the CICD, and this YAML file you can use as it is. No need to change anything in your other project as well. Okay, that's the thing. Now let's open up our AWS account. So guys, this is my AWS account. I already logged in with my AWS account. So here, so first of all, what you have to do, you have to create a IAM user. So let's create a IAM user. So IAM. So the first thing we'll be creating one user here. So let's create one user. I'll create a user. So let's say username is, I'll give medical bot. You can give any name, it's up to you. So let's click on next. Now you have to give policies. Okay, like what are the policy you want to give in this user? I don't want to give my entire policy. That means all the services I don't want to give the access. So I'll be giving some specific access. So access wise, I already written in the readme file. Let me show you. So these are the access I'll be providing: my EC2 container registry full access and EC2 full access. Okay, these are the thing we'll be giving. So here just search it. So this is the ECR. Okay, ECR, Elastic Container Registry full service, here I'm giving. So let's select, and after that again I can delete it. Then I'll try to copy the next service. This is the service. Okay, this is the EC2 machine service. So again search here and select the EC2 machine and click on the next. Now see that I have given this two service. Okay, next thing, just create the user. So right hand side you can see one button is there, create user. Just click on create user. So guys, as you can see, my user has created. Now I'll click on the user. Then here you will get one option, security credential. Just click here. Then you have to create a access key. So click on create access key, select command line interface, and I understand this above recommendation, and click on the next. So there is a next button, just click on the next. Now create the access key here. Now see guys, this is your access key and secret access key. Try to download as a CSV file. So let's download. So and just keep it with you. Okay, this thing I need later on. Okay, and no need to share this key with anyone, otherwise they will also access your AWS account. Okay, so here I'm showing because after the recording I'll delete everything. Got it? So my IAM creation is done. Now I'll go back to the home page. Now the next thing what I have to do, guys, I have to create a ECR repository to store my Docker image. So let's search for ECR. So just search for ECR, that means Elastic Container Registry. Just open it up and make sure you check your region, in which region you are working. See, I'm working in Mumbai, AP South 1. If you're in other region, just try to note it down. Okay, you have to note it down, this syntax actually, AP South 1, then CS Central 1. If you're, let's say, in North Virginia, you have to give US East 1. So just try to remember these are the tag. Okay, so I'm inside Mumbai, that means AP South 1. Now I'll be creating a Elastic Container Registry. So let's create, so let's click there. Now you have to give the name. Let's say I'll give medical chatbot. You can give any name, it's up to you. Everything keep it as default. Now click on next. Now see, my repo is created. Now what you have to do, just copy the URI and just try to paste it as of now here, because this thing I need later on. Just for reference, I'm saving it here. Okay. That's it. Now what I will do, I will go back again. Now the next thing I have to do, I have to create my EC2 machine. Then I have to set up, these are the requirements. Okay, that means I have to set up the Docker there. Then I will be also updating that machine. So let's create my EC2 machine right now. So search for EC2 here, EC2 instance. So this is the EC2 service. Now launch the instance. Now select the Ubuntu machine. And what you have to do, give the name of the machine. Let's say medical bot machine. You can give anything. Then see, instance type, you have to take at least 8 GB RAM. 8 GB RAM, just take 8 GB RAM. I'll be taking T2 large. Okay, this machine. And then select the key value pair. If you don't have the key value pair, you can also create it. So let's say I'll give medical. So it will create one RSA file. So guys, you can see after creating and download, it will give you one PEM file. So this PEM file you can use. Let's say if you're using any third-party tool to connect with your EC2 machine, let's say Putty or Mobile Extreme, that time you can use this PEM file. But I'm going to launch my, let's say, machine in my second tab with the help of AWS only. I don't need this PEM file. Okay. So now I'll select these two options, HTTPS and HTTP. Keep it everything as default. Configuration storage at least take, let's say, 30 GB. And launch the instance right now. So here you can see, click on view all instance. Then see, my machine is running. So if status is running, now click on the machine ID. Now here you have to connect this machine. So click on the connect button. Now I'll be selecting the EC2 connector and let's connect the machine. So it will create a new tab for me. So here I will get one terminal, block terminal. So we have to use this terminal to set up everything here. And this is the production server, guys. Okay, that's how your production server looks like. See, this is the production server. Let me zoom. Now let me clear. See, here you won't be getting any kinds of UI interface. Okay, that means the way we are using our computer, it is having UI. But in the production server, you won't be getting any kinds of UI. You have to work with the terminal always. And this is the Linux terminal I got. This is the Linux machine, guys. So that's why if you know any kinds of Linux command, it will help you a lot. Got it? So here, first of all, I have to update this machine. For this, you have to execute these at the command one by one. So let's copy all the command one by one. Okay, so this is done. Now I'll copy the next command and just try to paste here. Now give yes permission and press enter. Okay, so execution is completed. Now I have to set up the Docker in the EC2 machine. So this is the command you have to run. Copy the next one and execute. Then I will execute this one, then the last command. So we have to add the Docker in the sudo group. Okay. Now, if it is running or not, so what you can do, you can execute one command, docker ---- version. So if it is showing the version, that means Docker is installed successfully. Now, we have to set up our self-hosted runner. EC2 as our self-hosted runner. That means we have to connect our GitHub. Okay, you can see this is the GitHub. Now, this is our project GitHub. So this GitHub I have to connect with my AWS. That means whenever user will, whenever let's say developer will push the code in the GitHub, it will automatically get updated to the AWS. Okay, AWS cloud. So for this, what I have to do, I have to go to my project. Make sure you you committed your repository in your GitHub and go to the settings. Okay, go to the settings. Now here, left hand side, you will see one option called action. Just click on the action, click on the runners. Now create a new self-hosted runner. Now select the Linux machine and you have to execute. These are the commands. So let's copy this command one by one and let me execute here. So it will automatically make the connection with your GitHub. Let me show you. Then the third command. Then fourth command. Now you have to go to the configuration section and copy this command and execute it here. Now see GitHub action, it will automatically connect. Now it will see it has connected to the GitHub. Now it is asking for enter the name of the runner group. I don't want to give anything, press enter. Now it is asking enter the name of the runner. So here you have to give self-hosted. Okay, self-hosted. This is the thing you have to give. If you're giving another thing, it won't be working. Okay, make sure you're giving self-hosted. Now let's press enter. Now keep it everything default, just press enter again. Then again press enter. Now see, it is done. Now the last command we have to execute, this one. And you can ignore this one, it is not required. Now see, it would be connected with my GitHub. See, connected to the GitHub, listening for the jobs. Okay. Now if I show you, if I come back and now if I go to the runners, let's say, I'll go to the runners. Now see, status should be idle. You can see it is connected. Okay. Now the next thing what I have to do, I have to set up all the GitHub secrets. Okay. Now let's go back to the secret. So secret variable, click on the action. Now new repository secret. Now give the secret ID. Okay. So for the first ID I have to give AWS access key ID. Just copy and give the key name here. And where you will get the value, I think remember we downloaded one CSV file. So let me open this CSV file. I will open in a Notepad++, and this is my AWS access key ID. I'll copy, and here let me paste it. Then the next one I have to give secret access key ID, copy, and create another new repository secret and give it here. And in the CSV file, you will get the next one. See, it is comma separated. So before the comma, this is the AWS key ID, access key ID, and after the comma, this is the secret access key ID. So let me copy the secret access key ID and I will paste it here. Okay, now the next thing you have to give AWS default region. So region, I already told you I'm inside Mumbai. That means AP South 1. So I think remember, I'm inside AP South 1. See, AP South 1, you have to write it. So let's write AP hyphen South. Okay, hyphen 1, AP South 1. Let's try to check AP South 1. AP South 1. Okay, fine. Now let me add it. Now the next thing, I have to add my ECR repo. So ECR repo wise, I think you remember we copied one URL. So just try to get this name only. Okay, after .com, just try to get the name and try to mention here. Then the next thing, I have to set my Pinecone API key. So let's copy and add it here. And I think you remember in my .env file, I had my Pinecone API key. Let's copy. And this is not available inside my GitHub. That's why I'm reading from the GitHub secret. Okay, this is the idea. Now I also need to add my OpenAI secret. Okay, that means OpenAI API key. The last one, you can see OpenAI API key. Let's add it. So let's copy the OpenAI API. Here I'm going to paste it. Now let's add the secret. Okay, now see, everything is added. Now let me see anything is left. No, everything I have added. Now what I have to do, I have to push the changes. Okay, but before that, let me get back to my project. Now I'll push the changes. So just try to commit. To commit, just open up your git bash and try to write this command, git add space dot, then git commit hyphen m, let's say CICD edit, then git push origin main. Now if I go back to my GitHub, now see, if I refresh here, so it will start running my action. Now just go to the action. Now see, my action is running. See, first of all, it is running the continuous integration. So inside continuous integration, first of all, it will authenticate with my AWS ECR, build the Docker image, push it to the ECR. Okay, everything will happen. See, automatically. It's just a one-time setup, guys. Next time, you don't need to set up it. You just need to write the code and push it to the GitHub. Automatically, it will push to the, let's say, AWS server. Okay, now see. So let's wait. Once this execution is completed, I will come back. So guys, as you can see, my continuous integration is completed. Now it is running the continuous deployment. Now what it will do, it will again authenticate with my AWS cloud, and it will pull that image from the ECR to EC2 machine. And if you go to the Elastic Container Registry right now, and if you refresh here, you will see the image. Okay, see, Docker image is been uploaded here. Now see, it is running the deployment. Now see, it is pulling the image. So once it is pulled, then we'll doing the port mapping. We'll create the endpoint, and we can access our application. Let me show you. So guys, as you can see, my execution is completed. That means both integration and deployment is executed. If you're not getting error, that means congratulations, it's done. Now I will go back to my EC2 machine. Okay. Now here in the EC2 machine, you will get one public IP address. Just let me show you. So this is the public IP address. Just try to copy and just try to open it. Okay. Now see, if I open it up, so it won't be opening because see, my application is running on port number 8080. I think you remember. Okay. So by default, port number 8080 is not set. So I have to do the port mapping. So what I have to do, I'll go back, go to the instance. This is my instance. Then I'll go to the security. Okay. Now here you will see one option called security group. Just click here. Now on top you will see edit inbound rules. Okay, just try to click here. Now I'll just add the rules. Custom TCP port number, just give 8080. Just select 000. Okay, and here you will see save rules. Okay, just click on the save rules. That's it. Okay, so rules has been added. Now I'll go to the instance again. I'll open it up. Now I'll copy the public IP address again, and here let me paste. Now you have to give clone port number 8080. Now see, if I hit enter, my application should be running. See guys, this is my chatbot is running. Now if I give any message, let's say what is acne. See guys, it is giving me the response. Now see, my application is live right now. So it is already deployed. Now user can use my applications. Now what you can do, you can buy a domain, okay, your custom domain, and you can publish this application to the audience. Okay. Now for the second time, let's say you changed anything in the code. Let's say you added some more function. What you have to do, only just need to commit the changes. It will automatically get updated here. Fine. So no need to set up anything from scratch. It's just a one-time setup. Once setup is completed, just try to commit the changes. It will automatically running. Okay. Now you can ask me, if I close this terminal, will it work? Yes, definitely we can close it. Let's have a close this terminal. Now if I again go to the chatbot, if I refresh, see, still my bot is running. Okay. So that's how, guys, we can do the CI/CD deployment. Now let me show you how we can terminate all the instance, like whatever instance we created, if you don't want to keep it running, otherwise it will charge you, right? So what I can do, first of all, I will stop the EC2 machine I've created. So select the machine, click on the instance state and terminate. So terminate will delete it. Okay. So it will terminate and delete the instance. Then after that, I also need to delete my ECR. So let's go to the ECR. So first of all, delete the image inside that. Just write the delete command. Now try to select and delete. Okay, then what I have to do, I have to delete the then I will also delete my I'm user. Okay, the I'm user I created. User. Let's select and try to delete it. Medical chatbot I have to write here. So let me copy. And let me delete it. See, everything is deleted. Now nothing will charge you. Okay. So guys, that's how we can perform the deployment. And this is the code. You can use this code as it is. Okay. The code actually have shared. So yes, guys, this is all about, and I hope you liked it. So thanks for watching, guys. And what you need to do, guys, the next project I showed you now, that this one, source code analysis, you can deploy this project with the same process. Okay. Whatever project we have created so far, you can deploy with the same process. So guys, we'll be starting with another very important concept inside generative AI called LLMOps. So I think you already heard of this name, okay, called LLMOps. So the full form is large language model operation. So those who are from machine learning and deep learning background, I think you know there is another actually concept called MLOps. So with the help of MLOps, we can perform machine learning operations. That means, let's say if you want to build any kinds of end-to-end MLDL application, you can follow some certain step. Okay, there's some certain pipeline you can follow. That means you can follow some certain pipeline to implement that particular application. And here MLOps usually help you to implement that particular pipeline, right? So similar things actually we can also apply in the generative AI. So I think we saw inside generative AI, we can use different kinds of, let's say, tools and technology. Like we can use different kinds of framework. We can use commercial large language model. We can use open source large language model. Yes or no? So commercial wise, I already told you, we can use OpenAI platform, because OpenAI gives you the model with the help of API access. That means you can create an API with the help of that. You can access this model in the OpenAI platform. So for this, you don't need to download the model in your system. Okay. So download, you don't need to do. Let's say if you're using any low configuration system, still you can use that model. But whenever it comes to open source large language model, any kinds of foundation model, I think I showed you the entire Huggingface platform there. We are having so many open source large language model, right? Let's say if you want to use this kinds of foundation model, because apart from OpenAI, these are the model are also good. Now, this is also better. Some of the model you will see it is better than OpenAI model. Okay, now if I want to use these are the model efficiently, if I want to create a efficient application, even if I want to deploy this particular application on the cloud platform, how we can do it? Because we saw that if I'm using this kinds of model, like open source model, I have to first of all download the model in our system. And whenever I'm downloading, you should have good configuration machine, yes or no? That means you should have good GPU, good memory, good CPU. Then you will be able to execute this model. And let's say you want to fine tune these are the model. Definitely you need a very good configuration GPU. Otherwise, you won't be able to fine tune that. I think we already saw one fine tuning example of Llama 2 model. There I was fine tuning this model on top of our custom data, and I was using Google Colab. So there actually it was taking lots of time, let's say, to train only one epoch. Just try to consider. Got it? So that's why LLMOps comes into pictures. So LLMOps will gives you the flexibility to work with different kinds of foundation model. Okay. Like what kinds of foundation model? I think you saw like Llama is there, Mistral is there. Okay. Gemini is there. Different large language models are available. So different foundations model are available. I already showed you in the Huggingface platform. Okay. So if you want to use these kinds of foundation model, foundation large language model with all the flexibility, you have to use something called LLMOps. There are some LLMOps platform are available. This will give you all kinds of flexibility. You can work with this kinds of foundation model. Even it will give you all kinds of functionality. Okay, all kinds of functionality it will provide you. All you just need to use this platform to implement your LLM powered application. I'll teach you all the platform, whatever platform actually you are having, which is like famous in the market. I'll discuss all of them one by one. Okay, no need to worry. So first of all, let's try to see why LLMOps is required, because we saw that like what is LLMOps exactly. Now we'll try to see why LLMOps is required, why we need it exactly. For this, I'm going to open up my Blackboard and there I'm going to explain this concept. So guys, I think so far you have learned about Langchain. Okay, Langchain. Then you learn about LlamaIndex. Okay, then you also learn about open source large language model. Okay, open source LLM. Even I also taught you the OpenAI. Okay, OpenAI. And OpenAI provides actually commercial model because all the models are paid here. If you want to use them, you have to pay for that, right? And how it will charge you based on the token limit. And this will give you the API key. Okay, API key. With the help of API key, you can access this model. But apart from that, there are so many actually foundation model. I think I already discussed inside Huggingface. Okay, Huggingface platform like Llama was there. Okay, then Mistral was there. Then Falcon was there. Okay, then Gemini, Gemma. Okay, and so on. There are so many models. If you open the Huggingface platform, you'll see that there are so many models are available, and these are the foundation model. And this model is pretty good, guys. If you see this model is like very powerful model. It's very powerful model. Even I already showed you some of the demo. We created some of the application with the help of open source large language model. There, I think you saw the power of the model. Yes or no, right? But I think one issue you saw whenever I was using this open source large language model, the issue was this model size is very big. Let's say if I'm considering Llama 2, just try to consider about Llama 2. So now tell me, Llama 2 having actually how many variant? I think you know Llama 2 is having 3 variant, like 7 billion parameter model. Then it is also having 13 billion parameter variant model. It is also having 70 billion parameter model. Even recently there is another model you will see called Llama 3. Okay, Llama 3, and Llama 3 is very huge than your Llama 2. So you can open up the Huggingface hub and there you can search for Llama 3, you will see the model. So here I already told you, if I want to use this model, actually I have to use GPU based machine, GPU based system, yes or no. And if I'm not using GPU based machine, so what will happen? I won't be able to execute this at the model. But if you see, there are so many developers, there would be so many enthusiasts, they will prefer to use this at the open source large language model. But most of them will not have the GPU based machine. Okay, because it's obvious because if you see nowadays, actually whatever laptop, whatever let's say system we usually buy, people usually take this actually GPU, let's say 3060, okay, Ti. So I can consider RTX, okay, RTX 3060 Ti. If you have actually less budget, then you can buy this GPU. If you have more budget, you can also buy higher configuration GPU. But there are very less people, they will buy the higher configuration GPU. Let's say who have the huge amount of earning, they will buy it. Okay, but if you have actually less budget, because see, majority of the person will have the less budget whenever they buy any kinds of system. So they will have, let's say, this GPU 3060 Ti. Okay, so this GPU having actually, I think around 4 to 8 GB, I think VRAM. Okay, VRAM it is having. Okay, now just try to consider, let's say I'm loading this Llama 2 7 billion parameter, okay, this model in this GPU. So what would be the inference time? As of now, let's try to consider, let's say it will take 5 minutes. Okay, 5 minutes to give you the response. Now just try to consider, if your application is taking 5 minutes to execute only one prompt, will people use your application? Tell me. If let's say I'm using ChatGPT, and if I'm giving any prompt to the ChatGPT and ChatGPT is taking, let's say, 5 minutes to give me that response, so will I use the ChatGPT again? No, definitely I will not use, because nowadays you will see that people will have very less time. They want actually quick response from any kinds of application. So what you have to do, the system you are developing, this should be very fast. Okay, the inference time would be very fast here. Otherwise, people won't be using your application, right? Then let's say you are loading this 13 billion parameter model, okay, in the RTX 3060 Ti GPU. Let's say now it is taking 10 minutes to execute. Okay, 10 minutes to execute. And after that, let's say you are taking 70 billion parameter model in the RTX 3060 Ti, and you will see that sometimes it will give you memory, okay, memory out of space, okay, out of space error, okay, because this GPU doesn't have the capacity to load this 7 billion parameter model, because I told you it is having 4 GB and 8 GB VRAM. Okay, so that time actually we are not able to use this kinds of foundation model. But let's say somehow we are using this foundation model. Let's say we are using small variant of the model, let's say 70 billion or 13 billion. But what is happening? Inference time is very high here. Okay, it is like very slow here. So again, people won't be using my application. So this is another issue. Got it? Now let's say somehow you created one application. Let's say it is taking 5 minutes to execute. Now what you have to do? If you want to publish this application to the audience, you have to deploy this project, yes or no? Let's say you want to do the deployment. You want to do the deployment. Okay, deployment. Now, I think previously I showed you one deployment, right? We deployed one end-to-end medical chatbot project. There I was using actually AWS. Okay, AWS. So I was using, let's say, EC2 service from there. EC2. Then I was using ECR. Okay, Elastic Container Registry. Then I was also using something called Docker. Okay, so these are the services actually I was using there one by one. Now, see, there I was actually deploying the OpenAI based application. That means I was using OpenAI model. That's why I was able to deploy this project in the cloud platform with the help of these are the simple service only. But whenever you are using open source large language model, so that means this model you have downloaded in your local machine. And now what you have to do, you have to move this model to the production server. That means your cloud machine. And there, just try to consider if you are using this kinds of 8 GB, let's say instance, like T2 large instance, will it work? So I think you remember we used something called T2 dot large instance there. And it was having 8 GB memory only. Okay, 8 GB memory with CPU code. So it won't be working, right? If I'm loading this Llama 3 or Llama 2 in this machine, it won't be working. So for this, what I have to do, I have to purchase actually a GPU based machine there. So if you see the EC2 instance, you will see that there actually will also have GPU based machine. So there actually you can also purchase GPU based machine. Apart from that, AWS provides another service called AWS SageMaker. Those who are from actually MLOps background, they already know what is AWS SageMaker. So SageMaker is a complete actually platform. So here you can actually ingest, okay, train, evaluate, okay, evaluate and deploy any kinds of machine learning or deep learning project. Okay, and it also provides different virtual instance. That means virtual computer. Okay, virtual, let's say computer, it will also give you. So there actually you can take any kinds of instance and you can, let's say, host your model. It is also possible. So SageMaker provides actually lots of service. You can search over the Google. You'll see that it provides different services. Okay. Now, a few months back, actually, I was going through one actually research article. So there I found if I want to, let's say, deploy any kinds of open source large language model, let's say my custom created, let's say, server. Let's say I want to launch my own server, and there I want to host my model. For this, what I can use something called SageMaker. Okay, AWS SageMaker I can use because SageMaker will give you different kinds of instance. Okay, so there actually you can host your model. And if I want to use SageMaker and if I want to, let's say, deploy these kinds of open source large language model, because see, if I want to use this kinds of open source large language model, I have to use different library. Like I told you, we have to use Huggingface. Okay, we have to use Langchain. So different things we have to install. Even if I want to use Huggingface, I also need to install Accelerate, Bits and Bytes, because this model access the GPU, right? And to access the GPU, I also need these are the package. Okay, I already explained in my Huggingface session. So if I want to install these are the package, whenever, let's say I'm taking any EC2 machine, there you will see installation issue. So most of the time you will see lots of installation issue actually will get. But what they did actually, they created one service called DLC. Okay, DLC, that means deep learning container. So this service is already available in the AWS. Okay, you can use with the help of SageMaker. You can use this DLC, that means deep learning container. So inside deep learning container, you can install any kinds of deep learning package. Let's say you can install Huggingface, you can install, let's say, PyTorch, TensorFlow. So all the, let's say, library would be already pre-installed there. So you don't need to, let's say, manually put the effort to install these at the library. Okay, with the GPU configuration, everything would be already there. Okay, only just need to take the DLC, let's say, instance, and you have to connect with the SageMaker. That's the idea. Okay, so with the help of SageMaker, with the help of DLC, you can host this model. Let's say you are having one open source model. Now you can host this model in the DLC platform. Got it? And to get the, let's say, endpoint from the model, what you have to do, you have to use something called API gateway. Okay, API gateway. So this is another service from the AWS. With the API gateway, what you can do, you can create an API. Okay, API. Like we saw, like OpenAI API. Now we used to use one API. So here also you can create an API. With the help of API, other people can access your model. Let's say this is a user. So user can access your model with the help of API request. So this API will request this, let's say, model. That means, let's say you are using Llama model. Okay, and Llama model is present inside DLC. That means deep learning container. It is running on the SageMaker actual instance. Okay, from there actually you can get the response. Now let's say somehow you deployed this a model like that. Okay, the way actually I showed you with the help of SageMaker, DLC, API gateway. Okay, all the services. Let's say you deployed this model, and now let's say it is working fine. Now there one issue we'll get. The issue is cost. Okay, so it will actually charge you huge amount of money. Let me show you. So in that research article, I got one image actually. Let me show you the image. So I have already taken the screenshot. So this is the image, guys. I think this image is visible. See what they did actually. They have taken different Llama model. You can see they have taken different Llama model. Let's say Llama 2, 7B, 7B chat, 13B, 70B. Okay. And this is the model ID, and this is the max tokens. Like what would be the input length, okay, of this model? I think you know, Llama 2 takes actually 4096 token. Okay, and this is the default instance type actually they are suggesting. Let's say if I want to use Llama 2 7B model, so I have to take ml.g5.2x large machine. Okay, and this machine is available in the SageMaker platform. Now let me show you the SageMaker. So if you just search for SageMaker, okay, SageMaker pricing, just search for SageMaker pricing in Google. So you will get one website, machine learning service, Amazon SageMaker pricing, AWS. Just try to open it up. Now here, if you just go below, you will see SageMaker will give you all kinds of price list with respect to all kinds of, let's say, machine type. Let's say you want to use MLT3 medium. It is having actually 4 GB RAM, and here you will get 2 vCPU, and this is the price per hour. Like that, actually it is having actually different instance. Actually you can see it is also having large instance. So you can see it is also having large instance, X large instance. Okay, then 24x large also instance it is also having. Now see, the more good configuration instance you will be taking, that means your vCPU is increasing, as well as the, let's say, memory is also increasing. You'll see that price is also increasing. So this is the per hour price. Let's say per hour price, it will charge you $6 if you're taking ML M5D 24x large. Now see, if I show you the chart now, so this chart also they have also suggested. Let's say you are implementing one project with the help of Llama, let's say Llama 70. Okay, Llama to 70 billion parameter, and now see this is the configuration you have to take. This is the configuration you have to take. MLG5 48x large. Okay, configuration machine. But let's try to consider Llama to 13 billion. Okay, let's say you want to use this actually configuration model. Now let's find this configuration. MLG5 12x large. So here you can find out that configuration. You can see there are different series are available. This is the M5, C5. You can also find out the G5. So as of now, let's try to consider this machine. Let's say ML M5D 24x large. Okay, let's say I want to use this. Okay, this machine. I want to use this machine. This machine is having 96 actually CPU, and it is also having 384 GB memory. Now what is the per hour cost? Per hour cost is, you can see, $6. Okay, almost $6.5. You can consider $6 as of now. Now let's calculate the pricing. So what I'll do, I will open up my calculator. I'm going to actually calculate the price per day. Actually per day, how much actually it will charge me. Let's say the price, you can see it's $6. Okay, $6 times, I want to run 24 hours. This model, okay, this model I want to run, let's say 24 hours in my actually SageMaker, okay, platform. Because see, 24 hours your application should be keep on running. It's not like that you are running for 2 hours, again you are stopping. No, people won't be using your application. ChatGPT is running 24 hours, okay, 7 days. It is all, running every time. So you will see there is no downtime. So whenever you are creating your application, it should be always running in 24 hours, okay? So let's say I want to consider per day how much actually it will charge me. So 24, 6 times 24. So it will charge me actually $144. Only just one day, it will charge me $144. Now, if you're from India, if you're from Bangladesh, if you're from any other country, just try to convert the currency, okay, in your, let's say, money, and try to see how much money actually it is taking per day from you. Got it? Now, let's say I want to run this model. Let's say I want to run this model, let's say 7 days. So what I will do, I'll just multiply with 7. Multiply with 7. Now see, this is the 7-day cost I got, $1,008. So it is more than 1 lakh rupees. Okay, more than 1 lakh rupees actually it will take if you're running this model 7 days. Let's say I want to run this model 4 weeks. So this is the charge actually it will take. Now let's say I want to run this model 1 year. So I can multiply with 12. See, this is the 1 year cost actually you are getting. $48,000. Okay, 384. So now let's see, if you're running a small startup, if you're running a small company, so will you afford that much amount of money? Will you be able to pay this much amount of money? No, definitely you are not. So at the end, your cost is increasing. If you're using this kinds of open source large language model, if you're deploying on this kinds of, let's say, platform on the custom, let's say, hosted server, so you will have lots of cost at the end. So better to use the OpenAI model that time, yes or no? Because OpenAI model will charge you less, very less than, okay, very less than this amount of money. Got it? So that's why actually LLMOps comes into picture. So what big tech company actually did, they came up with actually different kinds of LLMOps platform. So I think you saw, not recently actually, this LLMOps platform came actually long back. So Google actually came up with one LLMOps platform called VertexAI. Okay, VertexAI. So previously, when you used to use MLOps, also we used to use something called VertexAI for the MLOps also. Because this VertexAI provides all kinds of functionality, all kinds of, let's say, pipeline for the machine learning operation as well. Okay, nowadays they also integrated generative AI, okay, in the VertexAI. Even AWS, that means Amazon Web Service, they also came up with another LLMOps platform called Bedrock. Okay, Bedrock. Okay, Bedrock. So Bedrock is also one LLMOps platform. And this is the new service actually they have launched in the AWS, actually, let's say, website. You will see that there will be one section called Bedrock. Okay, so Bedrock also provides all kinds of LLMOps services. Let's say you want to use any kinds of foundation model. You want to use Llama, Mistral, okay, any kinds of foundation model. So this model is already hosted. See, this model they have already hosted in their server. Let's say whatever Llama model, whatever Mistral model, whatever model you see, these are the model is already hosted in this LLMOps platform. Like that, Google has also hosted lots of foundation model in their server. It's not like that they're only hosting their model. Let's say Google is having their own model. They're having Gemini model. They're having Gemma model. Yes or no? Apart from these are the model, they also hosted some of the foundation model from any other organization. Let's say from Meta AI, from, let's say, Mistral. So what they did actually, they collaborated with these are the organization. Even they hosted their model in their platform as well. And they created one endpoint. They created one API. Okay, they created one API. Now, as a user, what I can do, I can use this API to interact with this model. That means, like, our OpenAI will send the request. Okay, will send the request to this kinds of LLMOps platform with the help of API. And here I will mention what kinds of model I want to use, and this will give me the response. That means I don't need to download these are the model in my system. Okay, so this is the main benefit to use this kinds of LLMOps platform. Okay, and it is having all kinds of flexibility. Let's say you want to connect the data. You can easily connect. Let's say you want to connect the vector database. You can easily connect. Okay, that means all kinds of storage, all kinds of flexibility this LLMOps platform will provide you. It's not like that manually you have to take from any third party, let's say, tool. It's not like that. Complete, like, let's say, pipeline it is already having. Even let's say you are thinking to fine tune this kinds of foundation model, you can also fine tune. You can also perform the fine tune operation. So fine tuning will happening in their server only, not your system. Only you just need to set the configuration of the model. Then you have to pass your data. Automatically, it will perform the fine tuning in their server. Yeah. it is sure they will charge you, but if you see this price would be very less than your this cost actually, whatever cost actually I showed you here. Nah? If you're, let's say, manually creating your server, if you're using manually different kinds of services, that time price would be high. But if you're using this kinds of LLMOps platform, your price would be very low, guys. Trust me, it would be very low. If you see the pricing, if you see the pricing, I'll tell you whenever we'll be exploring these are the LLMOps platform. There I'll also show you the pricing. You'll see the pricing, it should be very low. Alright. So that's why actually LLMOps is required. We need the LLMOps if I want to use these kinds of foundational model. It's not like that we only need to rely on the OpenAI model, because we saw that there are so many models which is more powerful than my OpenAI model. Even there is another cloud provider, I think you know, Azure. So Azure also having one LLMOps platform called Azure OpenAI. Okay, Azure OpenAI. So they have, what they did actually, they collaborated with OpenAI and they bring the OpenAI platform in the Azure platform only. Okay, on top of that, they created some more services and it is running on the Azure right now. So if you know about OpenAI now, OpenAI, so you'll be also work with the Azure. Okay, Azure, let's say OpenAI. So OpenAI wise, we already saw how we can use OpenAI with the help of OpenAI Peki, how we can access different kinds of foundation model. Okay. So yes, guys, this is the complete idea of our LLMOps and why LLMOps is required. Okay. So in the next video, we'll be learning about one amazing actually LLMOps platform called VertexAI from the Google side. So we'll see the entire platform, what kinds of service it provides. Even we'll also do lots of practical. We'll also do the hands-on. We'll be creating different, let's say, LLM powered application with the help of VertexAI. Even I will also show you the AWS Bedrock, how we can use the Bedrock, okay, to implement any kinds of end-to-end LLM powered application. Even we'll also learning how we can deploy these at the project as well. Fine. In this video, we'll be starting with our very first LLMOps platform called VertexAI. And I think I already told you VertexAI is the platform from the Google. So it is available in the Google Cloud. So Google has developed this platform. So here we'll be doing this complete generative AI on the Google Cloud. We'll be learning how we can use different kinds of foundation model. Even with that, how we can create different kinds of LLM powered application. So guys, here you can see this is the complete revolution at the Google inside artificial intelligence. I think you remember in 2017, they bring actually one architecture called transformer. So whenever this transformer architecture came in the market, after that actually so many revolution happened in the field of language model, in the field of large language model. That means whatever architecture you can see nowadays, all the architecture are using this transformer architecture in the backend. Even I already created one video, right? I already took one session on the transformer architecture, like what was the main component inside transformer architecture and why it is so powerful, right? So then after that, actually in 2018, actually they came up with another model called BART, B-E-R-T. So this is one of the actually language model they brought. Then they brought actually T5 model. Then slightly actually in 2020, actually they brought one large language model called Lambda. So Lambda was an amazing model in the field of large language model. Then 2021, they actually published AlphaFold model. Then 22 Palm model. And in 2023, they introduced something called BART model. Okay, B-A-R-D, BART. I think we used to use Google BART, right? Google BART, that means it is the ChatGPT kinds of interface, I think, remember. Nowadays, this BART has been, let's say, replaced with the Gemini. So we now actually we search for Gemini, but previously we used to search for BART, right? So this was the first application from the Google, actually they published. And you can see the model summary, like what are the tasks this model can perform. So as you can see, T5 can perform text-to-text generation. It's a transfer learning model. It is having actually 10 billion parameter and it's open source model. Then Google Lambda model. Then you can see the Lambda model trained to converse. Then AlphaFold predict structure for all known proteins. Then Palm, actually, this is the industry leading actually large language model. They introduced something called conversational AI, a service powered by Lambda. Okay. Then in 2024, I think you can see from the Google research, we are having Gemini. Then Imagen 2. Okay, this can actually generate image, okay, with respect to the text prompt. Then we're having also something called Llama. Okay, Llama is one of the large language model. Then there is another model called Sharp. This is the model, it can generate speech to text. So that's how actually revolution happened. That means it took actually lots of time to came up in this position. And Google introduced actually so many research, so many model, okay, so many technology. And nowadays actually we are using these kinds of technology, okay, in the field of generative AI. And guys, here you can see these are some actually first party foundation model like Palm for text. You can customize language task. Then Palm for actually chat. So here you can perform conversation. Okay. Then you can do the image gen. Okay. For the text to image. That means if you give any, let's say, prompt, it will generate the image. Okay. Then we also had something called embeddings model, that means embedding API. Let's say you want to generate any kinds of embedding for the text or image, you can use this kinds of embedding model. Okay. Then chart model, speech to text, then code generation model was also available. So this was the first party foundation model in the Google research. Okay. Then they introduced something called Model Garden. Okay. So what is Model Garden? So here you can access, customize, and experiment with different foundation models and its API. Okay. That means what Google did actually, they introduced one platform called VertexAI. So VertexAI was the platform in the Google, and it's been actually long. This platform is available in the Google Cloud, but only we used to perform MLOps operation with the help of VertexAI. But whenever actually this generative AI came, so they updated this VertexAI and they introduced something called Model Garden. That means inside VertexAI, you have one Model Garden. Inside Model Garden, you are having all kinds of Google model. Whatever model actually Google has published now, all the model you will get, all the foundation model you will get in the Model Garden. Apart from that, you will also get something called open source model. Like whatever open source model I think I showed you now, from the Huggingface, from different, let's say, organization like Llama, Mistral, Falcon, right? Different kinds of open source model I think I already introduced in the Huggingface. So what they did actually, they also hosted this kinds of open source model in the Model Garden. That means you can use all kinds of open source model from the Model Garden itself, okay, from the VertexAI. Then it is also having some partners model. So what is partners model exactly? So they collaborated with different kinds of organization. They collaborated with the different kinds of company. Let's say Cloud is a company. Then we are having Meta is a company. Okay, that's how we are having different kinds of company. So this company has also introduced so many large language model. Okay, so what they did actually, they collaborated with the company, collaborated with the organization, and all kinds of actually model they introduced in the Model Garden. So this is called actually partner models. Now let me show you the VertexAI platform right now, how it looks like. You can see, guys, this is the previous VertexAI platform. Okay, that means here we used to only perform the ML operation, that means machine learning operation. That means you can perform the experiment, train, and deploy, okay, for the data science workbench. Now what they introduce actually, on top of this platform, they introduce generative AI. You can see they introduce something called generative AI platform. That means here you can perform the prompt designing, fine tuning, generative AI studio, okay, foundation model, open source model, okay. Then you can also perform actually LLMOps, everything you can perform in this platform right now. That means instead of replacing the previous actually, let's say, VertexAI services, on top of that, they created one additional layer, and this is called actually LLMOps platform nowadays on the VertexAI. Okay, now I think it is clear. Now, as I already told you, they introduced so many actually partners model. Okay, I already told you they introduced so many partners model in the Model Garden. So these are the partners. Okay, these are the partners actually with Google. I think nowadays they also collaborated with so many organizations. If you open the Google Cloud VertexAI, will see different kinds of actually partner models are available. So here you can see AI21 Labs. These are another organizations that they collaborated with the Google. Then Anthropic, Cohere, then Contextual AI, okay, Midjourney, then OSMMO, then Resistant.ai, Meta, okay, Runway, and so on. So these are the actually partners model actually you'll be getting in the Model Garden. Now let me show you this GCP, okay, GCP VertexAI. So let's open up our account and let's open up the VertexAI there and try to see whether these are the things are available or not. So for these guys, what you can do, just search for GCP, okay, GCP console in your Google, and make sure you have one GCP account. Okay, if you don't have the GCP account, guys, so you won't be able to use the VertexAI. So make sure if you don't have the account, just try to create one account. Initially, it will give you $300 credit. Okay, so let me log in with my console. So guys, as you can see, this is my GCP console. So here, what you have to do, in the search button, just search for VertexAI. Okay, VertexAI. So you'll see this is the platform. This is the LLMOps platform you will get. See, this is the complete VertexAI. Now, left-hand side, you will see different kinds of services. So here, I already told you it is having Model Garden. So let me click on the Model Garden. So here, you will see all kinds of model. So guys, as you can see, whatever model I showed you, all kinds of model are available. Apart from that, they have also actually brought new model here. You can see. So foundation model, okay, then partners model. See, all kinds of models are available. Okay, as you can see, Meta model is available. That means Llama 2, Llama 3. Okay, then Palm model. You can also show all the model here. See here, I can click on the show all model. See, all kinds of model are available. See, Mistral also is there. Then Jamba model. Then you can see Cloudy. Okay. Apart from that, you will see different kinds of actually foundation model you will get. Okay. And these are the actually partner. Okay, partner company. Apart from that, you can also filter out. Let's say you need language model. So here you are having 63 language model. You can filter out all the language model. Let's say you need vision model. You are having 11 vision model. You can also filter out all the vision model. Okay. Now let's say you want to use this model. Just click here, and you will get all the guideline how to use this model and all. Okay. They have already given the source code, everything they have given. Okay. How to use the Python SDK for let's say using this model and all the, let's say, guideline they have already given. Okay, I'll tell you how we can use these are the model one by one. Okay, now let's say you want to also play this model in the model garden. Okay, it is also possible. Let me show you. So let's say this is my model garden. Let's say I want to let's say play with this model Gemini 1.5 Pro. So I'll just click here. Now you can see open in a Vertex AI Studio. So here you can open this model in the AI Studio. So they are also having one AI Studio. Let me show you. Even you can also open with the help of Collab notebook, and there also you can also play with this model. Now let's click on the I agree and continue. Now here you can pass any kinds of prompt. Let's say I will give hello, and I will send this prompt. And this is the response actually I'm getting. Okay, so that's how actually you can play with different kinds of model before using it, like how this model is working on all, what is the performance of the model, everything you can perform here. Okay, then you can also search by the model name. Let's say you need Gemini model, Llama model, anything you can search here. You will also get these are the model. Got it? And guys, these are the model is already hosted in the Google Cloud, so you don't need to manually download these are the model in your system. You can use these are the model with the help of API request. As I already told you, that's how. So that is why we call it as a LLMOps platform. Okay, so they give the API kinds of functionality with the help of API request. We can use these are the model in our let's say project implementation. And don't you worry, I'll tell you how we can access different kinds of model. We'll be also implementing some kinds of application. Now, apart from that, VertexAI also provides so many services. You can see it provides the pipeline services. This is the pipeline for the MLOps. Let's say you want to perform any end-to-end pipeline, data ingestion, data validation, model training, model evaluation, you can use the pipeline services. Apart from that, it also provides the notebook services. That means, let's say you want to, let's say use one large language model. You want to fine tune one large language model, you can use their Collab Enterprise. That means you can take the machine, okay, good configuration machine, good configuration Collab notebook in their Google Cloud service. Okay. Then you can also take the workbench as well. Then you can see different studio is there. You can perform different kinds of, let's say, task demo. Let's say you can perform chat demo, vision demo, translation, speech. Okay, you can play with these are the functionality. As of now, I'm not showing. Then you can also download different kinds of extension for the Generative AI from the extension market. Here you will also get something called feature store dataset. Okay, labeling task, then training, experiment. Okay, so some of the services you will see these are the MLOps services, not the Generative AI services. Apart from that, you will also get something called vector search here. This is another super important service from the Vertex AI. Let's say you don't want to use any other vector database. What you can do, you can use this Vertex AI vector search. This is another vector database. Okay, and this is hosted in the Google Cloud. That means in the Vertex AI. So going forward, I will also show you how we can use this vector search. Okay, vector search functionality from the Vertex AI itself. So yes, guys, these are the services actually Vertex AI provides. So unless and until you are not exploring all the functionality, okay, you won't be getting. So try to open this account, guys, and try to explore all kinds of functionality. Okay. And now there I told you we can perform different kinds of operation. Okay, different kinds of this operation. It will give you all kinds of functionality. Okay, and I showed you the model garden and all. So then I already told you we can also perform something called fine tuning. So it's not like that you can only use these are the foundation model for the inference. No, you can also perform the fine tuning operation. That means this Vertex AI will give you the functionality. You can also improve the model performance with the help of fine tuning. Okay, on top of your custom data. You can also perform something called human feedback to increase your model usefulness. Like I think previously you saw in the ChatGPT, it used to give one feedback box, right? Let's say how is your experience. So that you can give your experience rating. So that kinds of rating also you can pass if you're using this kinds of Vertex AI. Then here you can also generate customized images for your business. Then here you can also improve Google's predictive AI with your own custom data. Okay, everything is possible here. Now you can ask me what kinds of tasks actually I can perform here. You can perform all kinds of tasks. So you can perform language, image, video, okay, documents, speech, tabular. So here all kinds of tasks you can perform with the help of Vertex AI. Okay. And what Vertex AI actually provides, as I already told you, it will give you state-of-the-art foundation model. Even you will also get end-to-end governance. That means you can do the prompting, tuning. Okay, you can also perform MLOps operation on the Vertex AI. Even here you will get the data privacy. So whenever, let's say, you are uploading your custom data to the Vertex AI, it's not like that your data would be leaked. It would be secure. Okay, so this kinds of actually ensured you will get if you're using a Vertex AI platform. That means you will have the complete data security. So no need to worry about your data if you're having any custom data. All the data would be secured here. So now I think you got the difference between MLOps and LLMOps. So in the VertexAI, we have the MLOps like services already. On top of that, they created the LLMOps. Okay. So here we don't need to throw out your existing MLOps investment. Okay. So here what you need to do, you just need to understand the unique MLOps need for the generative AI. That means whatever additional, let's say, functionality they have given, just try to understand and try to use, let's say those are the service in the generative AI field. Okay. That means you can see in the VertexAI, you will see multitask model prompting, okay, then model garden, customization, managing new artifacts, evaluation monitoring, okay, connecting with the enterprise data. Let's say you want to connect with different kinds of data sources. It is also possible in the VertexAI. So now as a high level, you can see the complete MLOps on the VertexAI. This was actually our traditional VertexAI. That means here we can perform experiment, training and deploy and predict, okay, for the machine learning operation. And now in the VertexAI, you can also perform something called prompt predict. Okay, then you can also use something called foundation model. That means all kinds of generative AI based functionality you will get here. Then I already told you can also connect with different enterprise data. Let's say you want to connect any external sources, any API, any website, you can also connect, okay, with the help of VertexAI. So guys, all kinds of flexibility you will get here if you're using VertexAI LLMOps platform. So no need to worry about anything. So yes, guys, this is the complete introduction of our VertexAI, the complete generative AI on the GCP cloud. In the next video, we'll try to see how we can build different kinds of transformative LLM powered application, okay, with the help of this VertexAI platform. So far, we have discussed about LLMOps and this generative AI VertexAI. Now in this video, we'll be trying to use this VertexAI as a practical. That means, let's say if I want to use any kinds of foundation model with the help of Python code, so how we can do it. Okay, that means we'll be doing the entire hands-on in this video. So try to open up your Google Cloud, guys, everyone, and just try to open up your VertexAI. I already showed you how we can open up the VertexAI, right? Now, after opening the VertexAI, the first thing you have to do, you have to enable all the recommended APIs. So there you will see one option, enable all the recommended APIs. So make sure you have already enabled all the recommended APIs. So after enabling, in the notification bar, you will see all the API has been enabled. So these are the API you should enable. Otherwise, sometimes actually will get different error. So that's why make sure you enable all the API. Now here you can either open up your Google Colab to perform all the, let's say, operation I'll be doing here. Either you can also open up this Colab Enterprise or Workbench. Okay, so here I'm using this cloud platform, that means LLMOps platform. So in this video, I'll show you how we can use their services actually. Let's say if I want to use Colab Enterprise, how we can use Colab Enterprise. You can also launch this Workbench. So what is the difference between Workbench and Colab Enterprise? Let me show you. So in Workbench, actually, you can select the machine configuration. So here you can create a new Workbench. Just try to click on create. Now here you can select the machine configuration, like what should be the machine name, what is the reason. Then you can also select the instance type. Okay, that's how actually you can change the configuration. Okay, all the configurations you can change here. Okay, everything you can change here. That means if you want to create a custom machine as per your requirement, you can change here. And here you can see the pricing summary. That means per hour, it will charge you $0.18. You can see price is very less. It's not like a very huge amount of money they will be charging. It's like very less money. So you can also create your custom configuration. But here I'm not going to create the custom configuration. What I'll do, I'll use the Colab Enterprise. Okay, this one. So it will give me Google Colab kinds of interface. And there I can actually do my coding. So after clicking on Colab Enterprise, so here you will get one option, create a notebook. Okay, so just create a notebook. You can also select the region, but I will keep the default region, US Central 1. Okay, that's it. Now you can give the name. I can rename this notebook. Let's say I'll rename it as Vertex AI Demo. Okay, you can give any name. I've given this name. Now, if you want to increase the size of the notebook, if you want to increase the size of the cell, let's say if I write something, so the text is like very small here. So I can also increase the size. So for this, what I can do, I can click on the settings. You just go to the editor. And here you'll see this font size. Just try to make it as, I can take 28. Okay, 28, I think it is fine. Now, the next thing what you have to do, guys, you have to connect this notebook. So let's click on the connect button. See guys, once you will be connecting the notebook, it will give you this kinds of pop-up screen. That means you have to select an account, okay, like which account you want to use. So make sure whatever actually account you are using for the Google Cloud Console, that means for the VertexAI, that account you have to select here. So this is my Google Cloud account. I'll just try to select. Now it is also asking for password. So let me give my password and I'll click on next. So if you're doing for the first time, so it will give you this kinds of authentication. It's just a one-time authentication. Okay, that's it. So guys, as you can see, my runtime is connected. Now if I execute the cell, if you want to execute the cell, just press shift and enter. The same thing, the way actually you execute any collab notebook, you can execute as the same. Now see, I'm getting the okay output. Now you can also download this notebook. So there is a download button. You can also download the notebook. So first of all, let's do the coding. After that, you can also download this notebook. Even I will also share this notebook with you in the resources section. Fine. All right. Now see, here we'll be using actually Vertex AI. Okay, we'll be using Vertex AI services. That means we'll be using Model Garden. So from the Model Garden itself, what we'll do, we'll try to access different kinds of foundation model. Got it? And if I want to use Model Garden, that means the complete Vertex AI, I have to install one library. So you have to install Vertex AI SDK for Python, because we'll be using Python code, right? And if you're using Python code, you have to install this library. So here I want to install the upgraded version of the package, and this is the package name, Google Cloud AI Platform. Got it? If you want to use Vertex AI, you have to install this Python package. Now let me install. Okay, now after installing, it will tell you restart the runtime. Just click here. So it will automatically restart the runtime. After that, you just need to import Vertex AI. Okay, just to test whether everything is fine or not. Now see, if I import, it should work. See, it's working fine. There is no error. Fine. Now see, those who are running this code from the Collab notebook, you just need to do two configuration here. So let me show you. So the first configuration you have to do, this one. That means you have to authenticate with the Google Cloud first of all. So here, let me write the code. So first of all, you have to authenticate with the Google Cloud, okay, from the Collab notebook. And for this, you have to execute this line of code. So here, everything I'm running from the Vertex AI only. That means I'm using Collab Enterprise from the Vertex AI. I don't need to perform the authentication. But if you're running from the Google Collab, that time you have to do the authentication, guys. Okay. So let me show you one example. Let's say if I want to load any model from the Collab Enterprise, that means if I'm using Vertex AI services, I don't need to authenticate it. I can easily load it. Let me show you. So for this, let's import some of the library first. So here I'm importing some of the library. You can see generation config, generative model. Okay. I'll tell you why I'm importing them and what is the use of it. First of all, let me import all of them. Now let's say I want to load one model. Let's say I want to load this Gemini 1.0 Pro model. So you can see there is a model Gemini 1.0 Pro. Just click here. If I click here, you will see the model ID. You just need to copy the model ID from here. Now, if you just go below, they have already given the source code. Here, you can see this is the model ID. Just try to copy this ID and try to paste it here. Okay, that's it. Now, see, if I execute this code, it will automatically load the model. See, there is no error. But if you executing from the Collab notebook, you will see you will get one error. That means your notebook is not authenticated with the Google Cloud. Okay, so that's why you have to execute this line of code. It will, what it will do, it will authenticate first of all. It will ask for the email address. That means which email address you are using for the Google Cloud account. That email address you have to select first of all. Got it? Then the next actually configuration code you have to run. This one. Let me show you. This one. If you are using Collab Enterprise, guys, you don't need to execute. But if you are using Google Collab, you have to execute. Now see, this is the code you have to execute. So here you have to pass the project ID as well as your location. Okay, that means region. Now how you will get the project ID? So here you can see on top you have the project ID. Just try to click here. Now see, I'm inside my first project. So here is the project ID. Just try to copy the project ID and try to mention it here. Okay, in this box actually, you just need to paste it here. Then you have to give the region name. And what is your region name? You can see I'm inside US Central 1. So try to mention US Central 1 here. Okay. Then if you execute, it will automatically initialize with the Vertex AI. That means it will authenticate with the Vertex AI with your configuration. Now it will get to know, okay, now you are the correct user. So once it is authenticated, then you will be able to use all the services from the Vertex AI. That is all the foundation model, all the services you can use. Got it? So this two line actually you have to execute if you are using Google Collab. See, Collab only. And if you're using Collab Enterprise, no need to execute, guys. Okay, you can run as it is. I hope it is clear now. Okay, so now I think you saw how we can load the model. To load the model, you have to use one function called generative model. You can see I've already imported this generative model from the Vertex AI preview.generative AI models. Now import generative model. Inside that, you just need to give the model ID. Now, if you want to use any other model, simply just try to open. Let's say you want to use 1.5 Pro model. So just click here. Okay, so you can see Gemini 1.5 Pro model. Now just try to go below. And here is the model ID. So try to copy the model ID. So this is the model ID. Just try to copy and try to paste it here. So that's how, if you want to use any model from the model guardian, just try to copy the model ID and try to paste it inside this function. It will automatically load that model for you. So now let's test this model. So here I'm going to pass one prompt. So here I've already prepared one prompt. Let me show you. This is the prompt, guys, I have prepared. Okay, see. So here I'm using the model object and I'm calling one function called generate_content. Inside that I'm passing the prompt. Why is sky? So here is the prompt. Why is the sky blue? And stream is equal to true. Why I've given stream is equal to true? Because if I show you, if I let's say open the Gemini or ChatGPT, if you can open anything. Let's say if I give this same prompt here now. So if I let's say pass the same prompt, why is the sky blue? Any kinds of prompt if you give, it will give you stream kinds of output. See, it's not actually one shot output. It will give you stream output. So I think here you saw it will give you stream output. That means after one word, it is coming another word. Okay, that's how it is giving stream output, not in one shot. So that's how we also want to get the output from my response. Okay, that's why I've given this parameter stream is equal to true. That means it will give you stream output. Got it? Now see, if I execute, so here you will get one response object. See, this is the object. Okay, so it would be an object. See, this is a generator object. Now here I can apply any kinds of iterator, that means looping, and I can get the response. Now let me show you. So here you can apply looping. So here I'm applying looping for response in responses, and I just wanted to print the text. Okay, whatever text actually I'm having from the response, I want to print it. Now see, if I execute the for loop right now, you will see the response. See, this is the response actually I got, and this response is actually short response. That's why you didn't saw the streaming output. But if it is generating bigger output, you will see the streaming output would be visible. Got it? Now we can try with different prompt. Let's try with another prompt. So I'll give another prompt here. Let's say I'll give what are the latest developments in the automotive industry. Okay, now if I execute, so it should give me the response. Okay, see, this is the streaming response I'm getting, guys. I think you saw. Okay, this is called actually streaming response. See, the complete response I got. Great. Now see, here I pass the prompt directly. Okay, in the generate content function. But if you want to pass as a parameter, you can also do it. For this, I've created another example. So this is the example, guys. Just a minute. Just see that. So here I created a variable called prompt, and inside that I've written the prompt. Let's say this is my complete prompt. Create a numbered list of the 10 items. Each item in the list should be a trend in the tech industry. Each trend should be a less than 5 words. Okay, try. Now you can give any kinds of prompt. Now here what I'm doing, I'm calling the model object generate content. Inside that I'm giving the prompt. Okay, whatever prompt actually I've defined, stream is equal to true. Then again I'm performing the looping operation. Now see, if I execute, it should give me the output. Okay. Now you can also customize the prompt. Let's say here I can give translate in Hindi. See, I'm also getting the Hindi translation as well. Got it? So that's how you can also customize your prompt. It's up to you. Now, I think you remember whenever I was like going through the model garden. So I can also open this model in a Vertex AI Studio. I think I showed you. So let's open this model in the Vertex AI Studio. See, if you open the Vertex AI Studio, right hand side, you can see, you can also set some of the model parameter like temperature, output token. Okay. So these are the things you can also change. So how we can change with the help of Python code? Because as a developer, we have to use with the help of Python code, not from the UI interface. Got it? From the UI interface also, you can use the model, but as a developer, we have to use from the Python SDK. So here we can also set the model configuration. So let me show you. So for this, you have to use this function actually. So I think you remember the generation config. Okay. So let me show you. So I already prepared. So inside generation config, I'm passing all the parameter. Okay. Let me the temperature, top P, top K, candidate. Okay. Max output and so on. And I think you already know these are the parameter I already explained previously. What is temperature? What is top P, top K? Got it? Here temperature means here you are assigning the model creativity, like how much creativity you want from the model. If it is close to 1, that means it will take risk. It will be more creative. If it is close to 0, it won't be taking any kinds of risk. Okay, that's the idea. Now this generation config you have to pass as a parameter of generation config. Here you can see generation config is equal to generation config, and the same prompt I have given, stream is equal to true. Again, I'm looping through the response. Now if I show you, now I'll see that your output would be more creative. Okay. So previously, I think you remember we got actually very short output. Now see, this output is more creative right now because we given the configuration model parameter right now. Okay, I hope it is clear. Now let me show you another thing you can do. This is called actually test chat prompt. Now what is test chat prompts? Let me show you one example. Let's say here I ask one question by is the sky blue. Okay, now this prompt actually I have given, and my Gemini will try to remember this prompt. Now if I ask, give me the answer in bullet point. Okay, now see here I haven't mentioned I want this answer. I just give me the answer in bullet point. It will automatically remember my previous, let's say, context. Okay, that means I want to ask this particular response. Now see, it has given me in the bullet point. Okay, so this is called actually memory. That means it is trying to remember the chat history. So that thing you can also perform here. So let me show you. So for this, you have to use one more line here. This is the line, guys. Model.start chat. So this start chat will automatically remember all the conversation you are doing with your large language model. Now this is the prompt actually I have given. My name is Bappy. You are my personal assistant. My favorite movies are The Lord of Rings and Hobbit. Suggest another movie I might like. So this is the prompt I'm giving, and this is the stream is equal to true I'm giving. And now see, if you're using chat, that time you have to use chat.send message. Okay, chat.send message, because here you have initialized the model. I think you remember. Now see, if I execute the program. So guys, as you can see, I got the output. Okay, now what I will do, based on this answer, I will ask another question. So because it has remembered my previous context. Huh? So here now asking, are my favorite movies based on a book series? This is what actually I'm asking. Now see, if I ask this question, see, it will refer my previous actually context. Yeah, you can see both the Lord of Rings and the Hobbit trilogies are the based on the book series. Okay, by J.R.R. Tolkien. Okay, now I can show you the story. So if you want to see the story, just write chat.history. So it will show you the entire story. See, so first of all, you ask this prompt, your model has given this answer. Then again, you ask this question, your model has given this answer. Got it? I hope it is clear. Fine. So that's how actually we can use any kinds of language model. Now let's try to see any multi-model. That means we'll be also using some vision model. So I think here actually we are also having some vision model as well. So this is my model garden. Now just click on the vision model. You will see there are different kinds of vision model are available. So from here, I'm going to use one vision model. So Gemini 1. Pro vision model. So you can search this model here. Now, if you want to load this model, you can load like that. This is the model ID. So let me show you this model. I'll copy the name, and in the model garden. So here you can search this model. You will see Gemini 1.0 Pro vision model. Okay. Now see, this is the vision model. So with this model, actually, you can also work with the images and videos. Okay. Now this is the model ID you have to give. Now I've given the model ID. Now let's load the model. Fine. Now here I'll be working with images and videos, and to work with images, videos, I need some helper function. That means this helper function will help me to load the image, visualize the image. Okay. So here I have created some helper function. Let me show you. So these are the helper function I created. You can see different helper function I created. Display image. So it will display the image. If you want to get any image as a bytes from the URL, you can get with the help of this function. Load image from the URL, you can use this function. Get URL from the GCS, you can use this function. Print multi-model prompt. That means if you want to print any multi-model prompt, you can use this function. Okay, so that's how we can create some utility related function, and this function you will get over the internet. If you just simply search how to display image, give me a function, you will get this kinds of code. Okay, so I have initialized, these are the utility related function as of now. Okay, so here the first thing I'm going to show you how to generate actually caption from any image. Okay, so for this, let's see one example. This is the example, guys. So here I'm downloading one image. You can see this is the image URL. So guys, you can see this is the image. Okay, this image actually will be downloading. So here, let me show you. And how we are downloading the image, we're using gsutil command. Okay, so if you execute this command, it will download the image from the URL. Then I'm loading the image. Then I'm giving a prompt, describe this image. Okay, I'm passing the image as well as the prompt. Then I'm using the multi-model. That means the model we have loaded, I think, remember this Gemini 1.0 Pro vision model. Okay, you can also use any other vision model. So simply go to the model garden and try to choose any other vision model. You can use as it is. Okay, now let's get back. Now whatever actually, let's say output I'm getting, I'm just rendering. Okay, that's it. Now let me show you. So guys, as you can see, this is my results I got. So here I've given a prompt and this is the image. Now it has given me the caption. So the image shown a gray cat with black strips walking in the snow. The cat has yellow eyes and long tail. You can see yellow eyes and long tail. cat is walking towards the camera. Okay, that means this is a great caption my model has given me. Now let me show you another example. So I prepared another example. So guys, you can see I'm using another image. Now if I show you this example, see, this is my prompt. I have given describe the image. That means describe the scene. Now see, this is the response I got. Now this is the response to pontoon boats are anchored in the Charles River in Boston. In the background are two breeze and Boston skyline. So guys, as you can see, this is a correct caption my model has given me. Okay. Now if you want to use load image function, that means the function we created in the utility function to load this image URL, you can use this load image URL function as well. And with the help of that, we can also do the same thing. Okay, there are different techniques you can load the image. You can also use OpenCV to load the image. Okay, it's completely fine. Now see, I'm getting the same output. Now here we'll be learning another thing. Here we'll be combining multiple image and text prompt for the few shot prompting. That means here I'll be passing the few shot to my model, and my model will try to give me the response. So let me show you one example I prepared. So this is the example, guys. So here I'm using 3 images. So let me open all the images. So this is stored in the Google Cloud storage. Okay, you can see this is another image. So you can see this is one of the images, this is another image, and this is another image. So these 3 images actually I'm using here, and with the help of load image from URL, I'm loading both 3 images. Then first of all, I'm giving the prompt for 2 images. You can see these 2 images I'm giving the prompt. This one and this one. This one I'm not giving any kinds of prompt. Okay, you can see I've given city is equal to London, because you can see this is a London city and the landmark is a Big Ben. Okay, it's a Big Ben. So you can search on Google, Big Ben, I think. Yeah, see, this is the Big Ben. Okay, so that's why I'm giving some prompting. That means I'm giving the label. Okay, now prompt 2, the second image I'm giving, this is the Paris city. City is equal to Paris, and landmark, you can see it's Eiffel Tower. Okay, you can see it's Eiffel Tower. And the third image, I'm not giving any kinds of prompt. Now let's try to see my model is able to generate the actual, let's say, prompt for that particular image or not. So here you can see I'm passing my image 1, prompt 1, image 2, prompt 2, and I'm only giving the image 3 here, not the prompt. Now I'm using the multi-model and generate content. Now let's try to see whether it is able to identify that image or not. See, these 2 actually I have given, it's fine. Now see, third one, city, Rome, landmark, Colosseum. Okay, so let me copy and let me try to verify. See, correct. It's the correct one. Okay, so beautifully my model is able to generate the response. So this is called actually few shot prompting. Now also let's try to see some video example. So what I will do, I'll download one video. So this is the URL of the video. I'll download this video. Let me download and let me show you here. So I think you remember Google has launched one phone actually called Pixel. Okay, you can see this is the Pixel. This is the Pixel advertisement. You can see this is the Pixel advertisement. Okay, so this video actually I have downloaded from the URL. Now I will give this video to my multi-model and I will give some prompt. Let me show you. So I already prepared one prompt. This is the prompt. Answer the following questions using the video only. What is the profession of the main person? What are the main features of the phone highlighted? Which city was this recorded in? Provide the answer in a JSON format. Now see, if I give this video and if I pass it to my multi-model, it should give me the response. See guys, I got the response. Now you can see the person name is Sheikha Shimada. Profession is a photographer. Brand is Google. Phone brand is Google. Model is Pixel 8. And you can see the features: video boost, night sight, city Tokyo, country Japan. Amazing. Okay, amazing actually response I got. Now you can use any kinds of video. You can do the caption generation. Got it? So that's how guys you can export different kinds of model in the model garden. It's not like only Google model. You can also, let's say, use Meta model as well. Let's say you want to use Llama model. Just simply click on the Llama and try to open this notebook. So they have already given all the code example and everything. Okay, only just you need to execute and you have to see how we can access the Llama model and all. Got it? So just try to explore guys. This is up to you because all the model I can't show you. So I have just given the demo like how we can access different kinds of foundation model. Now you'll be exporting whatever model actually you need later on. Got it? Okay. And one thing guys, after implementing all the code, what you can do, you can download this notebook, and after that you can delete this instance. Okay, no need to keep on running, just try to delete the instance. Otherwise you can also stop the instance, but I will try to delete it. Okay, I'll just try to do the confirmation. So after some times, actually, you'll see that this notebook would be deleted. Okay, now see, this is deleted. So yes, this is the actually hands-on part of this Vertex AI. So in the next video, we'll try to see how we can do the setup, everything on our, let's say, local machine. That means how we can connect this Vertex AI with the help of local machine. That means we'll be coding everything in our VS Code. From the VS Code itself, we'll try to access the Vertex AI model. That means foundation model. Okay, so we'll try to access the model garden from the VS Code. So for this, whatever setup actually required, I'll tell you each and everything. To see how we can use this Vertex AI from our local machine. That means we'll be doing the setup, everything in our local. So previously I showed you how we can use Collab Enterprise. That means everything I was performing in the G Cloud. But in this video, I'll try to use my VS Code. And to access this Vertex AI, what are the configuration we have to perform? We'll be learning each and everything. Because see, going forward, whenever you will be implementing projects, right, end-to-end projects, so you have to implement through the VS Code, right? And if you want to implement through the VS Code, you have to know how to configure this Vertex AI in your local machine. Okay, so that's why it's super important to know how we can set up everything in our local machine itself. So for these guys, you need one tool actually. So the tool name is GCP CLI. Okay, GCP CLI install. Just search GCP CLI install on the Google. So after searching this GCP CLI install, if you just go below, you'll see this link actually. Install the G Cloud CLI. So just try to open it up. Now here you will get the installer. See, download the installer. So I'll click on the link. So it will automatically start downloading this CLI for me. See, it has downloaded. Okay. And if you're using any other operating system, let's say Linux, then Debian, Red Hat, CentOS, macOS. Okay. All the command is already written here. You can follow the command and you can install this G Cloud CLI in your system. Because see, with the help of this G Cloud CLI, we'll be doing the authentication with our account. Okay, that is the thing. Now I have already downloaded it. Now what you have to do, just double click and try to install. So the way actually you install any kinds of normal software, you have to follow the same step. Okay, there is nothing new. So for me, I already installed. See, after installing, just search for Google. So you'll see this Google Cloud SDK shell. Just try to open it up. So we'll see this kinds of window. Okay, if you are getting this kinds of window, that means you have installed successfully. Okay, now let me close it. Now what I will do, guys, I will open up my local folder, and here I'm going to open up my terminal. You can open up your any kinds of terminal, whether you're Anaconda terminal, Git bash terminal, anything. Now let's also open up my VS Code here. All right, so here the first thing what you have to do, guys, you have to create one virtual environment. After that, you have to install all the required packages. Okay, then after that we'll be writing our actually code, okay, with the help of Vertex AI. So to create the environment, you can execute this command. So conda create -n, let's say Vertex AI demo Python is equal to, let's say I'll take 3.10 -y. Now let's create the environment. Okay, it's done. Now let's clear. Before clearing, I have to activate the environment. So this is the command. Let's try to copy and try to execute it here. Now let's create a file called requirement.txt. So I'll just create this file, requirements.txt. Inside that, I will mention all the requirements I need. So these are the requirements, guys, I need. I think you remember. So I think you remember, to use the Vertex AI, we have to install this package, Google Cloud AI Platform. I think in the Collab Enterprise also we did the same thing. Then Streamlit I want to use because I want to create a simple user interface. There actually you can give a prompt and you can get the response, and python.env because I'm going to manage my GCP credential. Okay, that's why. Now here, let me create this file as well. So .env. Okay, inside .env, you need actually your project ID. Okay, then you need region. I'll tell you how to collect this project ID and region, but before that, let's do the configuration, okay, with our G Cloud. So first of all, let's me install all the requirements. So I'll just write pip install -r requirement.txt. All right, so installation is completed. Now let's do the configuration with our G Cloud. So for this, you have to execute this command called G Cloud init. Okay, just try to execute this command, guys. So if I execute this command, you will see that. See, if you're doing it for the first time, you will get this kinds of window. You must log in to continue. Would you like to log in? I'll give yes. So guys, now here you have to select the account. The account actually you are using for your G Cloud account. So this is my account. I'll select. Now you have to provide the password. So this is my password and I'll try to do the next operation. Okay, and then click on the continue and allow. Okay, now you can see I'm done with the authentication. Now if I come back, see, now actually I'm getting my project ID. You can see I'm getting my project ID. Got it? So let me show you. If I go to my dashboard, now if I click here, this is my project ID. Studios loader 4361. I think you can see that. Studio loader 4361 and 2. Okay, so this is my project ID. Yeah. Now, if you already have one existing project, you can select it. Either you can create a new project. So for me, I already have the projects. I'll just select the one. I'll select the one. That means my existing project. Now it is asking for, do you want to configure a default compute region and zone? I'll give yes. Now it is telling which region you actually want to take. So what I will do, I'll take this region actually. So Central US. So let's say I will take this one, US Central 1C. So I'll give 7 here. Okay, now I think it is done. Now let me clear my terminal. Okay, so everything is set. Now let's create one file here called main.py. Inside that, I'm going to write all of the code. Okay, that means we will be trying to access one. That means here we'll be trying to access one model from the model garden. But before that, you have to set this env. So you have to give the project ID. So here is the project ID, guys. I think I showed you how to get the project ID. This is the project ID. Just try to copy. And here, try to mention it. Then you have to give the region. So I think region I already showed you. So here you can check the region. Click on the collab enterprise. Left hand side, you can see US-Central 1. Just try to select it. US-Central 1. Okay. Now just try to verify it. US Central 1. Okay. So it's fine. Now let me save. Now let's create the main.py. So first of all, let's import all the necessary library. Yeah, so these are the library I need, guys. I think remember I was also importing them in my collab enterprise. So VertexAI, then Streamlit I need for the user interface. Then I'm also importing some of the necessary, let's say, function from the VertexAI preview generative models. Okay, so I need generative generation config and generative model, and .env I need because I want to load this env file. Now let's select my current environment. So this is my environment. Okay, now this arrow would be disappear. Now the first thing, I'll load my project ID as well as the region from my environment. Okay, for this code snippet you have to run. Got it? Then I'll be initializing. Then I'll be authenticating with my VertexAI. So this is the authentication code, guys. VertexAI.init. You have to give the project ID as well as the project location. That's it. Now let's load the model. So here I'm going to load one model from the model garden called Gemini 1.0 Pro. So let me show you. If I go to the model garden. So this is the model, guys, I'm trying to load. Just click here and you will see the model ID. So just try to copy the model ID and you can use it. So this is the model ID, guys, here. Just try to copy and mention it here. Okay, that's it. Then I've created a simple function. Let me show you. So this is the function I created. Inside that, what I'm doing, I'm just first of all creating my Streamlit title. First of all, I'm setting my page configuration like VertexAI demo. So it will give you one name. Then I'm setting the header. That means what will happen? It will give you one title. So here you can give any name. So here I've given, let's say, Gemini on VertexAI, or you can give VertexAI local demo, because everything we're doing in the local machine. Okay. Then user will give one question. So that's why I've taken a text input box, and this question actually I'm passing to my model. You can see. Okay, if there is a question, it will execute this model. Otherwise, it won't be executing. Okay. After that, actually, I'm going through the response and I'm printing in my console. Okay. That means in my Streamlit console. That's it. Now, if I want to execute, I have to call the function as well. So let's call the function. That's it. Now let's try to execute and try to see whether it's working or not. So I'll write Streamlit run app.py. Sorry, main.py. I think it's. Now let's give the allow permission. So this is the interface, guys. Now here you can ask anything. Let's say I'll give hello. Let's see. You can also see the terminal to get the log. Okay, you can see it is giving me one error. It is telling Google authentication default credential, your default credential are not found. To set the default configuration, you can visit this link. So let's open this link. And I think it will suggest me some command there. So let's copy this command. And now I'll execute from my terminal. I'll stop it. Now let's execute. I'll select my account. The account actually I'm using for my G-Cloud. So I'll give my password. Next. So if you're doing for the first time, so you might get this kinds of issue. So once this setup is done, you can use it as it is. Okay, now I think it is done. Now let's execute the application again. Now let's give hello. Okay guys, now see, I got the output. There is no issue. That means what you have to do, you have to set the credential as a default credential. So that's why we actually executed this command, gcloud auth application default login. Got it? Now see, I'm getting the output. Now here you can pass any kinds of prompt. So here I can give, let's say, tell me about Python. Okay, see, I'm getting the entire response. Okay, got it. So you can now ask any kinds of question. That means from our local machine itself, now we are able to access the model garden. That means by Vertex AI services. All right. Okay, great. So yes, guys, this is all about from this video. Now we'll be using this technique going forward whenever we'll be implementing any kinds of project. Okay. So in the next video, we'll try to see how we can implement a RAG-based application. Okay, with the help of actually Vertex AI platform. And we'll be using some Vertex AI services there. All right. So as of now, we saw how we can use model garden. That means how we can access different kinds of model. On top of that, how we can perform the inference. But let's say if you have some custom data, and with the help of that custom data, you want to create a knowledge base and you want to connect your large language model there. Okay, and you want to perform the query operation on top of it. So how we can perform it. And this is called actually RAG. I think I already explained, okay, in my previous video. So if you're not sure about the RAG, guys, first of all, check those video. Then you will be able to understand, okay, what I'm trying to implement here. So that means, let's say here I'll be using my custom data, and with that custom data, what I will do, I will create a knowledge base. Okay. And I'll just try to connect my large language model there. Then I'll be performing the query operation on top of my data. The data actually I have uploaded. This is the thing we'll be implementing. And here technology wise, actually we'll be using the Vertex AI, entire Vertex AI platform. That means here everything will be using Google Cloud services. Okay. We are not going to use any third-party services. That means to store our data, we'll be using Google Cloud Bucket. And to store our embedding, we'll be using vector store. Okay, vector store service from the Vertex AI. This is one of the vector database they have created. Okay, this is called actually vector store. So we'll be using all the Google Cloud service only, not any other service. Okay, in this video. So for these guys, you can see I prepared one notebook in the Collab Enterprise. So first of all, try to connect the notebook. After that, you can check with the help of OK command. And if it is giving the OK message, that means notebook is running. Then the first thing what you have to do, we have to install. These are the library. As I have told you, we'll be using some custom data. I'm going to use PDF document. That's why I'm installing this PyPDF2. Okay, this library. Then Google Cloud AI platform, because if I want to use the Vertex AI, I need to install this package. Then I already told you we'll be using custom data. That means custom document. And to store this custom document, I'll be using Google Cloud Bucket. I think you know Google Cloud also provides bucket service. Let me show you. So if you just open Google Cloud and search for bucket. So this is the bucket. So here you can create different bucket, and inside a bucket you can store the data. See, I already created one bucket called start content 2024. Inside that I'm having one documents. I'll tell you how to upload this document here. As of now, just try to consider we'll be using this bucket services to store my content. Okay, and no need to create manually, it will automatically create. I've already written the code for it. So these are the packages you have to install. For me, I already installed everything, so I'm not going to install again. Now see, you have to import. These are the library right now. So here I'm importing stories from google.cloud, because I told you we'll be using bucket, and to install bucket I need this actually function. Then I'm also importing text embedding model from the Vertex AI language model, because here we have to perform the embedding generation, and to generate the embedding I need some embedding model, and here I'm going to use Google embedding model. Okay, from the Vertex AI, from the model garden. That's why I have imported this text embedding model function. Then I also imported AI platform PyPDF, and these are the library I also imported here. And here I'm using UIID. Okay, why I'm using UIID? Let me tell you. See, there is a reason actually I'm using UIID. See, if you're using Vertex AI, this RAG would be slightly different. Okay, slightly different. That means, let's say whatever documents you will be publishing, let's say I will be publishing one statistics PDF I'm having. Let me show you the statistics PDF. So guys, as you can see, this is the statistics PDF actually I'm having. So this particular data actually I'll be using as my custom data. Now what will happen? First of all, I have to extract the documents from the PDF, yes or no. So after extracting, what I will get different documents. I think you know, I'll get different documents. That means doc1, okay, then doc2, and so on. Now what will happen? This document I have to convert to embeddings as well. That means it would be converted to embeddings. So let's say you will get some vector here. Let's say 0.29, 0.55, 0.88, and so on. Let's say this is the vector representation of this doc1 and doc2, and so on. Let's say I'll just create some dummy vector here. Now here what I want to do, with the help of this UI ID, I want to assign some unique ID. Let's say the document one it has extracted, I will assign one unique ID. Let's say this is the unique ID. Let's say 1210. Let's say this is the unique ID. Okay, it has assigned to the doc1. Then in the doc2 it will assign another unique ID. Let's say 1211. Okay. Now what will happen? This unique ID also would be assigned in the vector, because this vector is representing this documentation, yes or no. Okay, that's why this ID would be there, 1210. Then this ID would be also there because this vector is representing this document. So 1211. Now what will happen? Let's say whenever you will perform the similarity search operation, that time what happens actually, it will return the relevant answer, yes or no. I think you know, whenever you implement any kinds of RAG, whenever you perform similarity operation, it will give you some relevant answer. Okay, relevant answer you will get. Okay, and from where you will get the relevant answer? From the documents only you will get the relevant answer, the documents you are having. Okay, now let's say it will give you this relevant answer. Let's say doc1. Whenever it will give you doc1 relevant answer, that means it will return the vector, because your model will only return the numbers, not the text. Okay, and this particular number will map where? In this document. That means this document is representing this vector. That means whenever your model is generating this vector, that means it will map this documents, that means the text. Okay, how? With the help of this UI ID. Okay, with the help of this UI ID. So it will look for where this UI ID is present, that documents actually it will show you as a relevant answer. Okay, now I think it is clear why I'm using this UI ID to give to assign actually unique ID in front of my documents and in front of my vector embeddings. Okay, now I think it is clear. Now let me clear my board. Now the next thing what you have to do, guys, you have to initialize some of the variable. Now see, if you are doing this project from the Google Colab, first of all you have to authenticate with your G Cloud. And how to authenticate, I already shared you two code. I think you remember two configuration code I shared with you in my VertexAI demo session. So you can refer the notebook and you can first of all authenticate with your Google Cloud. Okay, until you are not doing the authentication, it won't be working. I'm running from my Colab enterprise, that's why I don't need to do the authentication. So if you're running from the Colab, Google Colab, so you have to activate this line actually, project. So you have to give the project ID here. How to collect the project ID? This is the project ID. Got it? So here I'm running from the Colab enterprise, so I don't need this variable. I'll just try to comment it out. So here what I need the location, and this is my location. Then PDF path. So where you have to upload the PDF. So in the files actually you have to upload the PDF. Let me show you. So here you can right click and upload and try to select the PDF. Whatever PDF you are having, just try to open it here. It will automatically upload here. See, for me, I have already uploaded, and these two files would be generated as of now. See, I already executed this project. Okay, that's why all the artifacts you can see. Okay, but for you it would be empty initially. So this two file would be created. How it will be created, I'll tell you. As of now, just try to consider we have uploaded the statistics.pdf file. Got it? Then you have to give the bucket name. So you can give any kinds of bucket name and make sure this bucket name should be unique. So this bucket would be created automatically in the bucket section. See, it is already created for me. Again, this would be created automatically. You don't need to create it manually. Then here you have to give embed file path. What is embed file path? Because see, I already told you, first of all, we have to extract the documents from my PDF. Then what we have to do, we have to generate the embedding as well with respect to the documents. And these documents and this embedding, I'm going to save in a JSON file. Okay, that's why I'm just creating some JSON file. You can see these two JSON file I'm creating. Okay, starts embedding .json and starts sentence.json. Inside sentence.json, it will store all the documents, that is the English text, and inside embedding, it will store all the your embedding. Okay, embedding of the sentence. That means whatever, let's say, documents you are having. That means whatever documents you have, okay, with respect to that, it will store the embeddings as well. Okay, with the unique ID. So that is the thing. Then you have to give the index name. Index name means, let's say here we'll be using vector search, na? And inside vector search, we just create an index. The way actually we used to create the Pinecone index, I think remember, we create an index here. So this is the index name. It will automatically create that index. Now here I've written a function. This function will extract the sentence from the PDF. So it will take the PDF path and it will give you the sentences. That means all the documents it will give you. Then I have written some of the helper function, guys. You can see generate text embedding. That means this function will generate the text embedding. It will take the sentence and it will generate a text embedding with the help of text embedding model. You can see I'm using text embedding gecko model. So this is the model, guys, text embedding gecko 001. So this model is available in the model garden in VertexAI. Got it? Then I have written another function, generate and save embedding. That means this function will actually add the unique ID in front of your sentence. That means documents, and in front of your embeddings. That means vector embeddings. Okay. That means it will generate this both file. Okay, and it will save as a JSON file. You can see here I'm doing it. I'm first of all actually creating my embedding. Okay, and I'm adding the unique ID. I'm also creating the sentence. I'm adding the unique ID. Then I'm saving in a JSON file. Okay, this is the thing actually we are doing. That means this function is responsible for creating these two files, and it will store your sentences, and it will store your documents as well as the embedding with the unique ID. Okay, that's it. Then there is another function I created called upload file. That means after let's say generating this file, I have to upload this start sentence.json in the bucket. And how I will push to the bucket, we will be using this function upload file. I can see if you go to the bucket section, so this file is already present. Okay, so if you want to push any kinds of file, you can use this function. That means we created some helper function. This helper function will help me to do certain operation. This is the thing. Now here another function I have written called create vector index. So this function will create the vector index in the vector source. Okay, in the vector source vector database, and each of the dimension would be 784. I think you remember previously we used sentence transformer actually embedding model, and we used to create I think 384 vector representation. I think you remember, right? But if you are using this text gecko model from the model garden, your vector dimension would be 780. 768. This is the dimension, and you can see with the help of AI platform actually library, we are creating the index. So this function will automatically create the index for you. Got it? Then after that, I'm calling these are the function. You can see first of all I'm calling generate and save the vector. I'm giving my PDF path, sentence file path, as well as the embedding file path. Then I'm also uploading this file to my bucket. That means if I execute this line, what will happen? It will create this two file. First of all, let me open it. So this is my sentence. That means this is my document, and you can see first of all it will show you the unique ID. Then it will show you the sentence. Okay, that means this is the document it has extracted from the PDF. With respect to that, it has also saved the embeddings as well. Let me show you. So this is the embedding, and here you'll see the unique ID. That means the same ID, and now this is the embedding representation. Okay, I hope now it is clear. Now, so once it is executed, then upload file will execute, and it will upload this sentence.json to my bucket. Now if I show you, see bucket would be created, and inside bucket actually you will see this start sentence.json would be present. Okay, because later on, whenever I'll perform the, let's say, similarity search operation, I need that file. I need to download that file. With that, I'll do the search operation. Okay, similarity search operation. That is the thing. Now, the next thing, what we'll be doing, we'll be creating the vector index. That means we'll be creating the index, and inside index actually will be storing all of my vector. Okay, so here you can see I'm giving the bucket name. That means from the bucket name, it will load this file. Okay, it will load this file. That means the sentence file. So sentence file it will load. Then it will also take the index name. And with the help of actually that embedding model, it will generate the embeddings of that documents. The documents actually we are having, and it will store to the vector database. That means inside my vector source. Now, if I execute this line, okay, if I execute this line, it will take some time. That means it will process all the data, and it will store to the vector embedding. After that, if you open it up, let me show you. So if you open it up, so you'll see that it will create an index. The name actually you have given start index. Okay. Now you can see both places you are getting this green tick icon. That means everything is executed successfully. If you are getting any red icon, it's not completed. Okay, that means there are some issue. Now if I click on the deployed index, you'll see one ID here. So we need this ID later on. So guys, you can see this is the ID. The last number you can see, this is the ID. So we need this ID later on. Okay, see this is the ID. This ID actually we need later on. So now let's get back to my collab. Now again, just import some of the necessary library. Then again, say these are the actually variable like your location, sentence file path, and index name. That means the same index name. Okay, same index name you have to give. Start index. Okay, that's it. Then just load the model, large language model here. So here I'm using Gemini Pro. You can also load any other model. Then just try to load the index. That means index endpoint you have to load. And to load the index endpoint, you just need to give this ID. And how you'll get the ID, guys, I already told you. So this is the ID. Just try to copy this ID and just try to paste it here. Now if you execute, it will load the index ID. Got it? That means this is going to be your knowledge base right now. And this is going to be your model. Now again, I have written some of the helper functions, generate text embedding. That means whatever user will give the prompt. Now let's say I have given one prompt. This prompt should be also converted to the embedding. Okay, then this function will help me to do that. Then I've written another function, generate context and load file. That means it will load that documents file and it will generate the context. Okay, that means if you are performing similarity search operation, it will give you some rank results, and how it will give the rank results with the help of these two function, it will give the rank results. Now here I've loaded the file. Then you can see. Then this is my query. Let's say what is correlation. First of all, I'm generating the query embedding with the help of that embedding model. And if you want to see the query embedding, see this is the vector representation, guys. This is the entire query embedding. Now let me comment it. Now this query embedding I will pass to my vector source. Okay, now you can see find neighbor. It will give me 10 rank results. Okay, 10 rank results actually it will give me. Then this response actually I'm giving to my model. Okay, this is the code snippet. My model will try to analyze this response, even the query I have given. Based on that, it will give me one response. Now if I execute, see, if I execute this last line of code, see here you will get the response. Correlation is a statistical measure that indicates see blah blah. I'm getting the output, and here you can also give the prompt based on the context delimited in the brackets, answer the query. Okay, that's how you can give any kinds of prompt, and that's how actually we can build retrieval augmented generation kinds of application. Okay, with the help of Vertex AI platform. And all these steps, guys, I have mentioned here. So if you are implementing any kinds of RAG based actually application, you can follow the same step. Okay, even you can also perform in your local machine. That means I told you how we can connect our local machine. That means how we can connect our VS Code. So with the help of VS Code also, you can create this kinds of RAG application, and you can create a user interface. Let's say you want to create a Flask interface, you want to create a Streamlit interface, you can also create. So this task actually I want to assign you. Just try to create one user interface. So you have to use the same logic, only you just need to integrate one user interface. That is the idea. Okay, I hope it is clear. Now see, once it is done, now if you want to terminate all the instance, what you can do. So first of all, just try to delete this. So first of all, just try to delete the bucket. To delete the bucket, just try to select the bucket, and there is a delete button you will see. Just try to click on delete, and delete confirmation you have to give. So it will delete the bucket. Then you also need to delete the index. So to delete the index, just go to the index, vector search. So first of all, you have to do the arn deploy. Then you can delete it right now, I think. Now there is a delete button. Just try to click on delete. So it would be deleted. Okay, so that's how you can remove all the instance you will be creating. Okay, so I think, guys, this is helpful. I showed you the entire like process how we can implement RAG. Okay. See, I think you already saw how we can set up everything in our local machine. That means if I want to connect with my VertexAI, so what are the setup actually I can perform. So setup wise, I already covered in my previous video, so you can check it out. So here actually I've already prepared everything, because see, most of the code are similar, whatever things we implemented previously. So make sure first of all you configured everything, your account, then your, let's say, configuration, everything you just prepared. After that, in the env file, just try to change this project ID and region. So let me copy my project ID. So just try to click here. So this is my project ID, guys. Just try to copy, and let's mention it here. Okay, and region, I'm inside US Central 1 only, and you don't need to change it. Now the next thing, you have to create an environment. How to create the environment, I already told you. Okay, I'm using the same environment, VertexAI demo. Now you have to install the requirement. So one more requirement I have added called Flask. So let me install the Flask, because in this project I'm going to use Flask. Okay, Flask framework to create the front-end application. So for this, just write this command, pip install -add requirement.txt. Now it should install the requirements. So guys, many people were asking me how to install actually GPU, NVIDIA GPU in our local system. For this, what I did actually, I created one video in my YouTube channel. Let me show you. So if you go to my YouTube channel, guys, this is my YouTube channel. You can also subscribe me here. Now, if I go to the video section, so here I already created one video. Here you can see the video, set up NVIDIA GPU. Okay, so here I showed you all these steps you can follow to set up your NVIDIA GPU for the deep learning task. Got it? So let's say if you're having good GPU and if you want to, let's say, execute open source large language model in your local machine instead of using Colab, you can refer this video that time. And make sure guys you subscribe to this channel, because here also I create lots of content related generative AI, MLOps, then end-to-end project implementation, okay, computer vision, everything. Now let's get back. So I think installation is completed. Yeah. Now see what I have done. I created one template file, and inside that this is my HTML code, because you already know if I want to use Flask, I need a HTML, okay, HTML code to create my front end part. And again, I used a Bootstrap website to prepare this front end. I'll tell you whenever I'll execute how it will look like. Now, this is my endpoint app.py, and here I've imported all the necessary library. And these code are common. I think you know we are doing the authentication with my VertexAI. Now, this is the route I created. This route is my default route. It will launch my index.html page, and this is my prediction route. That means whenever user will give any query, okay, user input, I'm getting the user input, and this input actually I'm passing to my model, and whatever response actually I'm getting, I'm showing in my Flask server. That's it. Now let me execute the application. So what I will do, I'll run this application in the port number 8080. Save it. Now I'll open up my terminal and let's execute Python app.py. Okay, so it is running. Now let's get back. Localhost. Now see, this is how your user interface will look like. Now you can give any comment. Now here you can give any query. So I'll ask what is Python. Now send a request. You can also see the log in the terminal. See, I got the response. So this is the complete response I got, guys. Got it? This is the complete response I got. Now if you want to ask another query, just try to refresh. Again, you can pass that query. Okay. Now that's how actually what you can do. The previous RAG application we implemented with the help of VertexAI, you can create your custom RAG. That means you can use your custom documents, like we did one project, like I think you remember, medical chatbot. So that's how you can use your custom documents, and you can create this kinds of application. And this is the front end you can use as it is. Got it? All the HTML code I will share with you. So yes guys, that's how we can also create LLM powered application with the help of VertexAI. So as I already told you, in the model garden, you are having so many foundation model. And if you want to fine tune, these are the model. So what are the steps you have to follow? In this video, I'll tell you each and everything. So I think remember previously, whenever we used to do the fine tuning operation, first of all, we had to download that model in our system. Then I was preparing the data. Then I was fine tuning, these are the model. But here, if you're using these kinds of LLMOps platform, you don't need to download these are the model in your system. So here, what you have to do, you have to use that model endpoint. That means you will be accessing this model through the API, right? That means, first of all, you have to authenticate with the VertexAI. I think I already told you how to authenticate with the VertexAI. After that, just give the model ID, which model you want to use. It will automatically hit that model. So here, the only thing you have to do, you have to prepare your data. After that, all the thing would be happening in their server only. Okay. Now, let me tell you the step actually you can follow to perform the fine tuning operation. So for this, what I will do, guys, I will use the Colab notebook. So I'll open up Colab notebook. You can also use Colab Enterprise. You can also do it from your local machine. It's completely fine. But as of now, we have explored like VS Code. We have also explored like Colab Enterprise. Now let's try to see how we can also use the Colab. Okay, like our Google Colab. So here, let me change my account. So let's say I'm going to use this account. Okay, this account actually I'm going to use. And make sure the account actually you are using for the G Cloud, the same account you have to use in the Google Colab as well. Okay, otherwise you might get some authentication issue. Now what I will do, guys, I'll just create a new notebook here. So let me create a new notebook. Now simply just connect this notebook. And in between, let me show you the fine tuning step you have to follow. So see, you can follow this blog actually. So this is from actually Google. So Google developer. So they have already given all these steps actually you have to follow to perform the fine tuning operation. So I already prepared all these steps you have to follow to perform the fine tuning. Only I will show you one thing from this blog actually, the data format. Okay, so here let me show you the preparation and loading the data. See, if you are fine tuning on the VertexAI, you have to prepare your data in the JSON-L format. Okay, see this is the JSON-L format data you can see. So here they have already given one example. Let me open up. So you can see this is the train JSON-L format data, and it is present inside this GitHub. So what you can do from this GitHub actually, see this is the data. You can download this data. Okay, in your system you can download this data. So I've already downloaded. Let me show you. So this is the data. I'll open it with the Notepad++. Now if you open the data, guys, you will see it's a JSON. Okay, JSON structure. That means you will have one key here called input text, and this is the input text, and this is the BBC data, guys. Okay, BBC news data. So in the input text actually they are having the entire news, and they are having another actually key here. Let me show you, or I can perform the Control F operation. Now here I will just write output underscore text. Now if I find it, now see guys, this is the output text. Okay, so inside output text actually what they are having the summary. Okay, summary of that news. So this is the data. Actually, that's how actually you have to also prepare your data. If you're having any custom data, what you can do, you can prepare your data with respect to that. That means what I'm trying to say, that means in the JSON file, actually, the first key will have the input. Okay, input underscore text. Okay, inside input text, what you will have? You will have the entire story. Okay, entire story. And you will have another actually key called output text. Sorry, output text. Okay, so inside output text, you will have the summary. Okay, summary of the entire story. So this is going to be your data format. Okay, that's how actually you can take as much as record you can. Got it? I hope now it is clear, the format. So whatever data actually we are having, try to convert in a JSONL format. And how to convert in a JSONL format? There are so many converters you will see inside Python. Simply you can execute those converters. It will automatically convert your data in a JSONL format. Got it? That is the idea. Now you can ask me, sir, where I will get these kinds of data? I think I already told you now. So you can use Huggingface Hub actually. So there actually will have like so many kinds of data set. So you can use any kinds of data from the Huggingface Hub. You can download it and you can convert to the JSONL format. And if you are using your custom data that time, you have to convert everything in a JSONL format. Okay, this is the idea. Okay, you can see the image also. They have already given the data format. So first of all, you have to take the input text. This is the entire BBC news you can see. And this is the output text. That means this is the summary of that story. Okay, this should be your data format. Now, apart from that, they have already given all the steps you can follow. So I've already prepared one notebook. Let me show you what are the things you have to do. Now, let me also add this link in the notebook so that you will have the reference later on. So this is the link I have added. Now here, the first thing you have to install some of the library. So here I'm going to install Google Cloud AI Platform because I want to access the VertexAI, then datasets, then Google Cloud Pipeline Components. Okay, these are the library I have to install one by one. Let me install. So after installing these are the library, you have to restart the kernel. And if you want to restart the kernel, you can use this code snippet actually. See, you can also do it from the UI. Just click on the runtime, restart the runtime. So there is a restart runtime option. Okay, restart the session. Otherwise, you can also execute this line of code. It will also restart your runtime. Okay, now what you have to do, you have to authenticate with your G-Cloud account. For this, you can execute this line of code. So here I'm using actually Google Authenticator. With the help of Google Authenticator, actually I will authenticate with my account. Got it? So now let me execute. So it will look for your account. So it will give you one pop-up screen. Let's give the allow permission. Select your account. Let's say I want to use this account because this is my Google account. Now I'll try to select it. Now you have to provide the password. So guys, as you can see, my authentication is completed. There is no error. That means you are successfully authenticated with your this one, your G-Cloud account. Fine. All right. Now the next thing, you have to select the project. So to select the project, you have to execute this line of code. So let me select the project. So I think you know how to select the project. Click here, copy the project ID, and just try to mention it here. And with this, actually, we'll be initializing our VertexAI. So let me initialize my VertexAI. Then let's say set some actually variable. That means my region and the project ID. Again, I'll give the same project ID. Now I have to set one configuration here. For this, you have to execute this line of code. Okay, you have to execute this command, gcloud config set project. This is the project ID. Okay, the project ID actually I'm having here. Now let me set. Fine. Now let's import some necessary library. So guys, you can see I'm importing some necessary library. Now you can ask me from where actually I got this code. If you go to that blog actually, so they are suggesting install and import. See, they're also importing. These are the library. Okay, so just try to read this blog. Actually, we'll see all the steps actually they have written. I'm following the same thing only. Now let me import all of the library. Okay, so I have imported all the library. Now the next thing, I will load my data. So let's upload my data. Either you can upload in the G-Cloud bucket. So from the bucket also you can download the data. If you're having, let's say, huge data, that time you can keep in the bucket. I think I told you. So it is already having one bucket service as well. So you can also open up the bucket. Inside that you can store any kinds of data, and you can also load it here. Okay, so if I show you the bucket, so this is the bucket, guys. So here my data size is not used, so what I will do, I'll directly upload here. So I'll just upload. This is the data. Now with the help of pandas, actually I'm going to load my data. So now we can copy the path and you can paste it here. Now let's execute. Okay, see, this is the data I have loaded. Now you can see this is the input text and this is the output text. Now if you want to see the shape of the data, you can also see this is the shape of the data. And now we can start the training, and it's like very easy. See, only you just need to execute this line of code. Your training would be started in their server only. Okay, not in my Google Colab actually. It will use their instance. Got it? Now see, here is my fine-tuned model name. So this model name actually I'm giving BBC fine-tuned model. You can give any name. So after fine-tuning, what would be your model name? Okay, that is what you have to give here. Then you can give the pre-trained model. That means which model you want to fine-tune. Here I want to fine-tune text based on 002 model. And if you go to the model garden, you will see this particular model. And if you want to use any other model, you can also give the model ID here. Got it? That's the thing. Now you have to pass the data, that is by DF. The DF actually I got. And you have to set the number of epoch. Training epoch you want to, let's say, train. So here I mentioned 100 epoch. Okay, I want to train as of now. And you have to give the tuning job location. Okay, so I have given Europe West 4. You can keep the default size. If you go to the blog, you will see that they are also using this particular location. Now see, if I execute the program, it will give me one URL. And if I click on the URL, I can see the pipeline. That means completely. That means I can see the complete pipeline. My training process is running. And it will take, guys, like 1 to 2 hours to complete the training. But I can't wait 1 to 2 hours. What I will do, I'll stop the execution. So guys, I stopped the execution because it will take time. See, I'm telling you after actually executing this line of code, what you have to do. So you can see one URL. Just try to open up the URL. So this is the URL, guys, and try to make sure you have selected your account. Okay, that GCP account. Then you can see this pipeline. Okay, this pipeline would be running, and this is the jobs. So here you will see all the, let's say, logs. So in the pipeline section, you will see all the logs. That means whether your training is running or not. Okay, and how much time actually it will take to complete. So everything, all the log actually you can see here. Got it? So once this execution is completed, you will see it will automatically stop. After that, your model would be ready. Okay, and then you can use this model. And if you want to delete this pipeline, so what you have to do, guys? So there is a delete button. Just try to click on the delete and try to delete the pipeline. Okay, it will automatically delete the instance. Okay, and guys, one thing, after completing the training, if you open up your bucket, you will see 2 buckets would be automatically created. Okay, and inside this bucket actually it will save all the model checkpoints. Okay, let's say whatever training it is doing, all the artifacts would be saved inside this bucket itself. Okay, you can see. But once you complete the execution, see, it will already save the tuned model. Okay, inside that you can see the text based on model. Got it? So that's how actually it will save all the artifacts in the bucket. And from this bucket itself, we have to deploy our model as an endpoint. Okay, and this model would be available in your model garden. So if you click on the model garden, so there you will see one option. So here is the option, my view my endpoint and model. If you click here, you will see that model would be present here. Okay, I hope it is clear. Now let me show you the next step you have to perform. So previously I already did this actually fine tuning. So let me show you what you have to do after that. See, after that actually what you can do, you can use your trained model. That means the model actually you have trained, and you can do the inference operation. So here I'm giving this prompt actually summarize this text to generate a title. So this is the entire actually prompt I'm giving, and this is the output actually I'm getting. Got it? Now you have to deploy your model as an endpoint. For this you have to execute this line of code. Okay, so this will deploy your model as an endpoint, okay, to the GCP server. That means this model would be available in your model garden right now. So if I go to the model garden, so here you will see one option, view my endpoint and model. Just click here. In this section actually will see your model would be published. Okay, from here actually it will load the model. But what I did actually, I deleted the model because again I'm using cloud platform. I don't want to keep anything. Okay, otherwise it will charge me. So that's why I already deleted. Okay, then after that I was loading that model and I was again performing the prediction. You can see this is the result actually I'm getting from my model. Then I was also loading the base model, that means the actual model, and I given the same actually prompt, and I was just checking the actually output. Okay, whether this output and this output actually good or not. That means which model is giving the better output. And here you can see both model giving the good response. Okay, it's not a bad, although I only trained 100 epoch, but you can see this response is pretty good. Got it? So that's how actually you can perform the fine tuning operation. After that, you can deploy your model as an endpoint to the G Cloud. Okay. Now I think it is clear. Now you can pick up any other model and you can perform the same fine tuning operation. All right, so these resources would be shared, guys, in your resources section. From there, you can download this notebook and you can perform the fine-tuning operation. So, guys, as of now, we have seen the Vertex AI demo, the complete, let's say, Vertex AI demo we have seen. We have implemented different kinds of application with the help of Vertex AI. So now it's time to explore another LLMOps platform called AWS Bedrock. So this service is available in the AWS cloud. So make sure you have the AWS account. So if you don't have the account, just try to create one account. Initially, it will give you $300 free credit, but you have to add your card there. Got it? So after login with your console, so you will get this kinds of window, okay, in the AWS. So this is my console. So now here, what you have to do, you have to search for Bedrock. So let me search. So see, Amazon Bedrock. And this is the service, actually the easiest way to build and scale generative AI application with the foundation model. So let me open up the Bedrock. Now I'll just click on get started. See, if you're opening for the first time this Bedrock, what you have to do, you have to request for the model access. So there is a button you will see, request model access. Just try to click here and see, for me, I already requested the model. Okay, for me, I already requested the model and I got the access. You can see some of the model, actually they didn't given me the access. For this, what I have to do, I have to again, let's say, resubmit the access request. Then I think I might get. But for you, what you will do, you will select all the model and try to send the request. Okay, send the request. You will see that in 5 to 10 minutes, actually, they will provide the access. Got it? And make sure you check your region, actually, in which region actually you are sending the request. Okay, because that in that region, actually, your model would be available. So I'm currently inside AP South 1, that means Asia Pacific, Mumbai. Okay. So now if I go to any other region, let me show you. So if I, let's say, go to North Virginia, so there you will be able to see I don't have any access of any model. Now see, it will show you this kinds of window, enable all model. Okay, now if I click here, now just select all the model and try to click on the next. Okay, now you have to submit the request. Okay, you have to submit the request. So let's submit the request. Sometimes actually they will ask for some information. So you also need to, let's say, submit some information. Let's say your name, email address. Okay, then you can send the request. After sending the request, in 5 to 10 minutes, you will see that they will give you the model access. So guys, you can see after sending the request, actually I got the access. You can see granted access. And some of the model you can see it is still in progress. So I think it will take some time to give me the access. Okay, so that's how actually you can apply for the access. So once you got the access, that means congratulations. Now you can start with the Bedrock services. That means now you got all the, let's say, access of the foundation model. Now let me get back to my that region, actually Mumbai region. Now see, this is your Bedrock interface. If I click on the overview, now you are having different foundation model here. And what is foundation model? I already told you these are large language model. And different companies also has collaborated with the AWS. Even they have also published their model. Like you can see, Amazon is having their own model. Apart from that, Cloudy has like updated their model. Then Cohere, Llama, Mistral. Okay, so you can see all the provider. Okay, all the provider, they have collaborated with the AWS and they hosted their model on the AWS. That means AWS Bedrock. Okay, now what you can do, you can access this the model through API. Got it? So you don't need to download these are the model in your system. That is the main advantage here. Now you can also play with the playground. Let's say if I click on the chat, so here is the chat, guys. So you can select the model. Let's say I want to select this model. Let's say I'll select this Llama 3 8 billion instruct model. Now if I send any request, let's say hello. Let's say this is my prompt. Now see, it is giving me the answer. So that's how actually it is having different kinds of playground, text playground, chat playground, image playground, because it is also having multi-model as well. So you can see here different model. Let's say you want to use this Amazon model. So just try to click here. See all kinds of Amazon model you will be able to see. It is having Titan text G1 Lite, Titan text G1 Express. Okay, Titan image generator, then Titan multi-model embeddings. Now if you want to use, let's say, this model, what you can do, you need to just copy the model ID. So this is the model ID, and with the help of model ID you can use it. Similar wise for the meta also, let's say you want to access Llama. Okay, Llama model you can see. So for this you have to use this model ID. Okay, even from here also you can directly open in the playground and you can also play with these are the model. Even if you go to the example section, they have given different example. Even you can also copy these are the code and you can execute in your system. Now let's click on the base model. You can see different kinds of base model it is also having. Even if you want to train your custom model, it is also possible. Just go to the custom model you can also perform the fine-tuning operation. So from the UI itself, you can do the fine-tuning operation. Even let's say after fine-tuning, you can also keep your model here, okay, in the custom model section, so that you can load this model as an API. Okay, every functionality actually this Bedrock will give you, so you can use them. So yes, this is the overview of our Amazon Bedrock. That means it's a platform. It's a LLMOps platform. Here we are having different kinds of foundation model. Even all the functionality it is also provides. With the help of these are the functionality you can create any kinds of GenAI based application. So in the next video, what we'll do, guys, we'll just try to do the hands-on on this AWS Bedrock. That means we'll be accessing these are the foundation model through the Python. Okay, Python code. This video will be learning how we can, let's say, access this kinds of foundation model with our Python code. That means we'll be setting everything in our local machine. I will be writing everything from our VS Code. Okay, so what I will do, guys, I'll open up my local folder, and here I've already created one empty folder. Let me open up my VS Code. Okay, so I'm also going to open up my terminal here, and make sure you create one environment. So for me, I already created one environment. So let me activate. So conda activate LLM app. I think you remember this environment we created previously. So I'm using the same environment here, and you can see the Python version I'm using. It's 3.10. So you can use 3.9, 3.8. It's up to you. Okay, here the first thing you have to set up the requirements. So let me create a file called requirements.txt. Inside that, let me mention all the requirements actually I need. So I need the Langchain. Then I also need Streamlit, because I'm going to create a small, let's say, user interface here. And I need two more library, Boto3 and Python.env. Python.env, I think you know why we need it, because we're going to create one .env file. Okay, .env file. So inside that, you have to mention the your secret credential. That means we'll be generating access key, AWS access key, and AWS secret access key. With the help of that, we'll be authenticating with our AWS account. Got it? So we'll be keeping these are the key inside this .env file, and to load it, I need this Python.env. And what is Boto3? With the help of Boto3 Python package, will be making the connection with our AWS. Okay, so this library will give you the functionality you can connect with your AWS. Now let me set up everything in my environment. So I'll open it up and just write pip install requirement.txt. Okay, for me it is already installed. For you, it will take some time. Now the next thing what I have to do, guys, I have to create a IAM user. So let's go to my AWS. I'll go to the home page, and here you will see, or you can also search IAM. Okay, identity access management, because I have to create a user, and there actually I will only give the permission related my Bedrock. Now click on the user. Now just create a user here. I'll give, let's say, Bedrock test attach policy. Now search for Bedrock. I want to give the Bedrock Amazon Bedrock full access. Now click on the next and create the user. Then after that, I will click on Bedrock test and go to the security credential. And here you will get one option, create access key. Just try to click here. Select command line interface. I understand, and click on the next. Now create the access key. Now, so guys, this is your access key, and this is your secret access key. Now you can also download as a CSV file. Let me download. Now I have to configure it. So for this, you have to install one tool actually. So just search for AWS CLI. Okay, AWS CLI. This is the first website you can open. So for all the operating system, they have mentioned, okay, how we can install it. For Linux, Mac OS, okay, see, Linux, you have to execute some of the command. These are the command you have to execute. For Mac OS also, you have to execute some of the command. And for Windows, you are having one MSI file. So you can directly download this MSI file, and you can install, okay, as a software. That means the way you usually install any software. Now next, install, you have to do the same thing. After doing it, let me cancel it because I already have. After doing it, just try to open up your terminal, okay, and execute this command, AWS configure. AWS configure. Now see, if I execute, it should give you this kinds of window. If you're getting this kinds of window, that means your installation is fine. Now what I have to do, guys, I have to set these are the access key. Now just try to copy the access key. Open the terminal, and it is asking for the access key. Just try to paste. Just right click, it will paste, and press enter. Then you have to give the secret access key. Just try to copy. This is my secret access key, and I'll paste it here. And don't share guys this key with anyone, otherwise they will be also accessing your account. I will delete it after the recording. And now it is asking for the region. Now you can see which region you are in. I'm inside Mumbai, that means AP South 1, so I have to give the region. So you just check which region you are working on. Based on that you can decide. So AP South 1. Now default output format, just keep it empty, press enter. That's it. See, my credential has been set. So this was the first method. And the second method, what you can do, you can I think you remember we created this .env file. So here inside .env file also you can mention. So let me show you. So inside that you can mention AWS access key ID, secret key ID, and region name. So let me replace all of the secret key again. This is my access key ID. And this is my secret access key. And AP South 1, it's fine. Now let me save. Now here I'm going to create a file. I'll name it as main.py. Inside that I'm going to do the coding. So here first of all let's import some libraries. So these are the library I need. Let me select my environment. LLM app I'm using. Now here you can see guys, I'm importing Bedrock from Langchain. Langchain.llms Bedrock. I'm importing Bedrock. Then LLM chain, then prompt template, Boto3, and Streamlit. Okay. Then I need another package, this one actually, .env, because I want to load these at the credential. And how to load guys, I think you remember. So you have to use this code snippet. So load env, and you also need operating system. With the help of operating system, we'll be loading these are the key, okay, from the environment variable. Now here it will store everything. Now, if I want to initialize Bedrock client, so I have to use Boto3. So this is the syntax. If you go to the documentation, you will see that they're using this syntax. Bedrock client, you have to make a Bedrock client. The Boto3 client, you have to mention the service name. I want to use Bedrock. Okay, Bedrock services. That's why I've given Bedrock runtime. You have to give the region, AWS access key ID, and secret key ID. So with the help of that, it will authenticate with your account. Okay, I hope it is clear. Now, the next thing, you have to give the model ID, like which model you want to access. So I'll give the model ID is equal to, let's say I want to use one foundation model. Let's say I want to use this Mistral model. I'll click on Mistral. Now you can see Mistral having different variants, 7B, 8X, 7B, then Mistral large. Now let's say I want to use 7B instruct. So what I will do, I'll copy this model ID. So that's how, just try to open any kinds of model and copy the model ID. And here you just need to mention it. That's it. Okay, so it will automatically load this model. Now let's create our LLM wrapper. So inside Bedrock, you have to give the model ID. Okay, and here you have to give the Bedrock client. Okay, client is equal to Bedrock. Fine. And this is the temperature parameter. That means the creativity parameter. I think you already know. Now here I'm going to create a function. So this function will take the input from the user, like in which language they want to, let's say, get the output, and what is the input prompt. Okay, so this function will take this input, you can see language as well as the user text. Then it is create. Then inside that I'm creating a prompt template. I think you know what is prompt template, right? So this is the input variable, language and user text, and I'm creating a prompt template. You are a chatbot and you are in this language and this user text. Now based on that you have to give me the response. Now here I'm creating a LLM chain and I'm passing my LLM as well as the prompt. And finally, I'm passing my language as well as the user input to my Bedrock chain. That means the chain I actually have created. Okay, because inside that I'm having my large language model as well as the prompt. And whatever response I'm getting, I'm just returning. That's it. Now let me create a Streamlit title. Streamlit, let's say user interface, Bedrock chatbot demo. Now user will also able to give the language. So let's say here I'll take a language input from the user. Whether he want to get English response, Spanish response, or Hindi response, you can. So here you can also pass any other language. It will also work, because I think you know these kinds of large language model can also support multi-language. Then this is my final logic. So if language is there, so they will give the input. That means what kinds of question they want to ask. Then once they have, let's say, given the prompt, this particular prompt I'm checking first of all this they have given the prompt or not. If they have given, I'm passing it to my chatbot. You can see this function. So it will take the language as well as the user input. Language and user input, and whatever response actually I'm getting, I'm writing in my Streamlit application. Now let me execute and let me show you. I'll save it. Now simply I'll just open up my terminal And this is the command streamlit run main.py. So this is the interface, guys. Now you can select the language. Let's say I want to select the English. Now here I can ask any query. Let's say, what is Python? Now you just need to press you just need to press Ctrl and Enter. So guys, as you can see, if you give any kinds of prompt, now here is the response. So here I've given what is Python, and here is the response I got. Now I can ask any kinds of query. Let's say I will ask, give me a Python code to add two numbers. See, here I got the Python code to add the two numbers. Okay, so that's how you can pass any kinds of prompt and you can get the response. It's amazing, guys. And here we're using Mistral model. Okay, Mistral model we are using. Okay, and it is present inside Bedrock platform. That's why this inference time is very low. You will see that I'm getting very fast response. But whenever I was using Mistral model, I think you remember in Huggingface, okay, Huggingface Hub. So there I had to download this model in my system, and the execution time was like very slow there. Yes or no, right? So that's why we have to use this kinds of LLMOps platform if I'm implementing any kinds of project, efficient project, okay, in the industry. So yes, guys, now you can explore different kinds of model, different kinds of like foundation model. You can also explore query model, meta model, anything you can explore. Only just need to keep the model ID and everything you can access. Got it? So yes, guys, I hope it is clear now how we can use this Bedrock platform. And if you want to get this kinds of content more, so please try to support our channel. So please try to subscribe to the channel, try to share this kinds of content with your friends and family so that they can also get to know, okay, this kinds of session is going on. So please try to support the channel, guys. Try to like the video, try to subscribe to the channel. You can subscribe to the Code Commander channel. Even you can also subscribe to my channel, DSwithBappy. Okay, both channel actually I'm operating. You will see that in both channel I'm creating lots of content related data science, machine learning, generative AI, MLOps, okay, end-to-end project implementation, okay, everything I'm creating the content. If you don't know what is AWS Bedrock, AWS Bedrock is a platform from Amazon Web Service. We can use this particular AWS Bedrock to create scalable generative AI application with the help of large language model. So if you want to use this particular platform, Amazon Bedrock, so you should have one AWS account. So for me, I already have the account. So if you don't have any account, so please try to create one AWS account. Then you will be able to access this particular platform. Now, if you can't see this particular service here, so what you can do, you can search here called Bedrock. Okay, if you just search for Bedrock, so you will get this particular service called Amazon Bedrock. Now let's try to click here. So it will launch this particular platform for you. See guys, so this is the Amazon Bedrock platform, and this is the easiest way to build and scale generative AI application with the help of foundation model. So it is having lots of foundation model. I'll tell you what are the models actually it is having. So it has one beautiful documentation. You can go through this particular documentation, like what it can perform and all. So you can perform text generation. You can also create chatbots. You can also perform the search operation, text summarization, image generation, and personalization. Okay, so this many tasks actually you can perform here. And these are the actually foundation model. So it is having, let's say, lots of model. It is having Jurassic 2 model, Cloudy model, Command, Stable Diffusion, and Amazon Titan. And you have another model called Llama 2. Okay, Llama 2 is a model actually from Meta AI. So this is one of the like very popular and powerful model. Okay, you can use. So in this particular project, actually, I'm going to use this particular Llama 2 model. Okay, and I will also use any other model to show you like how we can access this particular Bedrock model. Okay, from the Bedrock platform. Now what you have to do, you have to click on this particular get started button. So if you just click on the get started button, okay, so initially it will tell you just try to request for the model. Okay, request to access all the model, because if you're using for the first time, you have to send a request like to access all the model. Okay, so I already made the request and I already got the permission, and I can access all the model, okay, from this particular platform. Now guys, as you can see, so in the overview section, so these are the models are available. Now let's say if you want to use this particular model, Jurassic 2 model, just click on this particular model. Now if you see, Jurassic model is having different variant. Okay, so it is having Jurassic 2 Ultra, and it is having another model called Jurassic 2 Mid. Okay, you can either use this Mid model, either you can use this Ultra model. Okay, so similar wise, if you are using, let's say, Amazon, okay, so it is having different model. So it is having, let's say, Amazon this Titan embedding G1 text model. So this is the embedding model. Then it is having Titan text G1 model, light model. Then Titan text G1 express model. Okay, that's how it is having different model. Even it is also having Titan image generation model. Okay, that's how actually, let's say if I click on Meta, okay, that means Llama 2. So it is having different variant of the model Llama 2. So it is having Llama 2 chat 13 billion model.
it is having Llama 2 chat 70 billion model. Even it is also having Llama 2 13 billion model and 70 billion model. Okay, so these are the pre-trained model and these are the chat model. Let's say if you want to perform question answering and chat operation, you have to use these are the model. And let's say if you want to only generate, let's say a text, and if you want to, let's say, do the sentence completion, at that time you can go with this particular model. Okay, so that's how actually it is having different model. Okay, based on the base model actually you can see here. So again, I will go to the overview. Now you can see I already showed you the foundation model. Now it can perform different tasks. I already showed you. Let's say you want to do any example, so you just go to the example section. Now here you can select what kinds of tasks actually you want to perform. So here you can see different tasks. Even it is also having the playground. Let's say I will open this particular playground. Okay, so playground, I want to perform let's chat operation. So now here what I have to do, first of all I have to select the model I want to use. So let's say I will be using this particular model called Jurassic to mid model. So I'll select this particular model and apply. Okay, after that I will get this kinds of interface. Now here you can give any kinds of prompt. Let's say if I give hello, so here let's say if I send hello, okay, to this particular model, so it will give me the response. See, it is also responding like hello, how are you, how I can help you today. That's how actually you can also change the temperature parameter, topic parameter. Okay, so these are the parameter you can change. So what is the temperature parameter? Temperature parameter is a creativity actually parameter. So let's say if this temperature parameter is like, let's say, close to 0, that means you are telling your model to be stick. Okay, it won't be taking any risk. And if you are setting this parameter to close to 1, that means you are like telling your model just take any risk, okay, and try to give a creative output. So that's actually you can change these other parameters. So by default you can, so by default just keep this default parameter only. Now you can give any kinds of prompt here. Okay, it will respond with respect to that only. Now guys, this is for the playground. Okay, but whenever I will be creating the application, I'm not going to use this particular model like that. So I have to use this particular model, okay, with the help of this Python programming language. So with the help of Python client, actually we'll be accessing this particular model. But how to access this particular model, because this model is already available in the AWS. Okay, so how to authenticate with this particular account? So for this, first of all, you have to create one IAM user. Okay, so first of all, let me create one IAM user and let me like add this particular secret key and access key. Then I'll tell you how we can access this particular uh, foundation model, okay, from the AWS Bedrock. So guys, as I already told you, to authenticate with this particular AWS, and if you want to access this particular Bedrock services and all, so you have to first of all create one IAM user and you have to collect that particular access key and secret access key. Okay, then you have to configure that. So for this, you have to search for this particular service called IAM. Okay, that means Identity Access Management. Now here I'll go to the first option, IAM. Now left hand side, you can see there is a user option. Okay, let's click on the user. Now here I'll be creating one user, create user. Just give the name. So here is, let's say I'm doing a Bedrock project. So I'll just give it as Bedrock user. Okay, then I'll just click on next. Then I will be adding the policies directly. So here you need to select this particular option. Now here you have to search for the Bedrock service, okay? Because I want to only give the Bedrock access, okay? Not the entire service access, okay, from my AWS account. Now here if you see Amazon Bedrock full access, okay? So I'll select the first option, then click on next. Then once it is done, I will just create the user. Now my user has created. Now I'll go to the user. I'll go to the security credential. And here you will see something called create access key, okay? Let's click on the create access key. Now I'll select on the command line interface. Then I understand the above recommendation, then click on the next. Then once it is done, I will create the access key. Okay, now see guys, this is my access key and this is the secret access key. And don't share this particular credential with anyone else, otherwise they will also able to access your account. Okay, I'm sharing because I'm going to delete this particular user after the recording. Okay, that's why I'm showing. Now what I have to do, I have to download this thing as a CSV file. So click on this particular button. Okay, it will download as a CSV file. Okay, see, I've already downloaded. Now if you want to authenticate, okay, if you want to authenticate with your actually code. So what you have to do, first of all, you have to install one tool, okay, called AWS CLI, okay, AWS CLI download. Just search on Google AWS CLI download. So this is the website actually you will get, and you have to install this particular tool. Now you have different operating system. Let's say if you're using Windows, so you will get one MSI file. Okay, as you can see, this is a MSI file. So try to download this particular MSI file and try to install it the way actually you do install any regular software. Okay. Then if you're using any Mac OS or let's say Linux operating system, you can follow these are the command to install this particular AWS CLI. So here I'm using Windows machine. So I already downloaded this particular MSI file. Okay, let me show you. So this is the MSI file. So inside Windows, so this is the MSI file. If I click here, so it will start download. See guys, it will start download. Okay, now I'll cancel it. Okay, after downloading, you have just need to double click and you have to install as a regular software. Okay, then once it is done, then I will open up my terminal. So first of all, let me open up my local folder. Okay, so this is my local folder. So here I'm going to open up my terminal. Okay, but before that, let me create one folder here. So inside that, I'm going to do my project. So here I'm going to name this particular folder as uh, uh, Generative AI application. Okay, uh, Generative AI project. Okay, Bedrock. Let's say this is the name. Now inside that, I will open up my terminal. Okay, so let's open up my terminal. Yeah. So now here, what you have to do, first of all, you have to test this particular AWS CLI, whether it has downloaded successfully or not. So for this, you just need to execute this particular command called AWS, okay, configure. So if you execute this particular command, so it will give you this kinds of interface. See, it will give you this kinds of interface. And if it is not giving this kinds of interface, if it is throwing any kinds of error, that means you are not able to install successfully. Okay, you have to install it successfully. So for me, I already installed successfully. That's why I'm getting this particular option. Now here you have to provide that particular credential. Okay, that AWS secret key ID you have downloaded. Now let's go back to the CSV file I have downloaded. So this is the CSV file. Let me open it up. So guys, I already opened up this particular file with the help of my Notepad++. Now, as you can see, this is the access key ID. Now you have to copy before the comma because this is the comma separated. This is a CSV file. So I'll copy this particular credential and I'm going to open up my terminal and I'm going to paste it here. Okay, so just right click and paste it. Okay, so it hasn't copy yet, I think. So I'll copy again. I'll open up the terminal and let me remove. Now I'm going to paste. Okay, now see, if you right click, it will paste. Now if you hit enter, it will automatically save. Okay, now you have to also set for the AWS secret access key. Okay, so this is the secret access key. So copy before the comma and again open up the terminal and paste it here. Okay, then it is telling select the region. Okay, so make sure you are checking the region currently, which region you are in. So for this, just go to the home. Okay, AWS home. So here you actually will see that particular region. Okay, see, now currently I'm inside North Virginia. That means US East 1. Okay, but if you're in any other region, you have to select this particular name. Let's say you are inside Asia Pacific. That means Mumbai. You have to write AP South 1 that time. But I'm inside US East 1. Okay, that means North Virginia. So I'm going to write US East 1 here. So I'll be opening the terminal. And here you just need to write in the same way US East 1. Okay, now I'll press enter. Now you have to keep it as default. Press enter. Now see, all the credentials has been set. Now I can easily authenticate with my Bedrock. Okay, Bedrock platform with the help of this particular terminal. Okay, now what I have to do, so let me open up my folder, the project folder I have created. Now inside that I'm going to open up my VS Code. Okay, so let's open the VS Code. So here let me write down all the steps so that you can refer later on also. In the readme file I'll add everything. So here let me close it. Now first of all I'll create a file called readme. Okay, readme.md. So here, first of all, let me give the project name. So this is end-to-end, okay, end-to-end generative AI project, okay, using AWS Bedrock, okay. So this is the title of my project. Now inside that, I'm going to write the step, okay, you have to perform to set up this particular project. So first of all, you have to create one virtual environment. So I already written, so let me just give it here. So these are the steps I have to perform. Okay, if I want to execute this particular project. So first of all, I have to create one. Okay, I have to create one virtual environment. So let's give the name. So this is, let's say, Bedrock project. Okay, so Bedrock. Okay, Bedrock project. Bedrock project. Now you have to activate this particular Bedrock environment. Okay, you have created, and make sure you are using Python 3.8. You can also use more than Python 3.8. It's completely fine. Then you have to install the requirements because I'm going to write some requirements. Okay, for this particular project, you also need to install them. Then I already told you have to download this particular AWS CLI. Okay, and this is the link I have already given. Then you have to set up it. Okay, after setuping, you have to configure that and add all the credential. Okay, so these are the steps actually you have to perform. Then what I will do, I'll quickly create some of the folders and file here. So first of all, I'm going to create a folder called research. Okay, research. Inside research, I'm going to create one file called trials. Okay. I can write bedrock trials. Okay, bedrock underscore trials dot file. Then outside I'll be creating another file called main.py. Okay. Then I'm going to create a requirements file, requirements, okay, dot txt. Yeah. So as of now, I need these are the folders and file. If you want to add like git ignore and license file, you can add it. If you want to commit this particular code in the GitHub, but I'm not going to commit. Okay. So that's why I only need these are the files and folder. Now, first of all, let's add all the requirements actually I need for this particular project. So first of all, let me show you what are the tools and technology I'm going to use. So for this, I'm going to open up my Blackboard. So here, I'm going to use some of the tools. Okay. So the first thing I'm going to use Langchain. Okay. I think you already know what is Langchain. Langchain is a generative AI framework. Okay. So we can use this particular Langchain to create generative AI application. Okay. So it is having different functionality. So it will help you to create that particular application. Okay. So then second, I need something called PyPDF. Okay. PyPDF. Why I need PyPDF? Because I'm going to upload my PDF data. Okay. And from there, actually, I'm going to do the retriever operation. Okay. That means query operation. I'll tell you like what kinds of application we're building. Okay. So we'll be building something called RAG application. So there actually we'll be creating one knowledge base. Okay. With the help of custom data actually I'm giving. So that's why my data source would be PDF data. You can also use docs data or txt data. It's completely fine, but I'm going to use PDF data here. So I'm going to like also show you the architecture. Okay, architecture of this particular project, like how everything will work. But before that, let me write down the tools and technology I'm going to use in this particular project. Then I'm going to use something called Streamlit. Okay, Streamlit. So Streamlit I'm going to use to create the user app. Okay, because I'm going to create a user app. So that actually user will get some interface to use your application. So for this, I'm going to use Streamlit. You can also use Flask, okay, First API or any other, let's say, web framework. It's completely fine. But Streamlit would be easy for me to, like you can say, implement because there I'm not going to write any HTML and CSS code. Okay. Then after that, fourth, I'm going to use VectorDB. So VectorDB wise, I'm going to use Fies. Okay. So Fies. So Fies is a VectorDB. So this is for Facebook. Okay. Facebook team has developed this particular VectorDB called Fies. And this is the local VectorDB. Okay. You can also integrate Pinecone, then Web8, ChromaDB. Okay. It's up to you. But I'm going to use Fies. So in future, maybe we'll be creating some other projects. So there actually we can use any other VectorDB. Okay. So these are the tools and technology I'm going to use for this particular projects. And definitely the final tool and platform I'm going to use something called Bedrock. Okay. Bedrock from the AWS. Okay. So Bedrock I'm going to use. And LLM wise, I'm going to use something called Llama 2. As I already told you, I'm going to use Llama 2. Okay. From Meta AI. So this is the LLM I'm going to use. So yes, so this is the tools and technology I'm going to use. Now let me quickly, install these are the tools and technology. So what I will do, I'll open up my code and here, let me write down everything one by one. So first of all, I need something called Langchain. Okay. Langchain. Then I need something called PyPDF. PyPDF. Then I need something called Streamlit. Okay. Then I need something called Fies CPU. Fies CPU. Okay. So let me save it. Now, first of all, I need to create an environment. So I'll copy this particular command and I'm going to open up my terminal. And let me create this particular environment first of all. So guys, as you can see, my environment is created. Now I have to activate. So this is the command on the activate. So now let's activate also. Now see, I'm inside this Bedrock project. Okay, that means this particular environment. Now I have to install the requirements. So for this, I'm going to execute this particular command. See, now it is installing everything. So it will take some time. Okay, so let's wait. I'll come back once it is done. So guys, as you can see, installation is completed. Now what I have to do, yeah. So now I can start the coding part. So yeah, so make sure, yeah. So now what I will do, I'll go inside this particular research folder, and first of all, I will test this particular Bedrock. Okay, like how we can connect this particular Bedrock and how we can access the model and all. Because I already showed you it is having some foundation model, and if you want to access it, so for this, first of all, you need to do some authentication. So that authentication we have already completed. So let's go inside this particular Amazon Bedrock. Yeah. So now see, these are the models are available. Okay. And I think you already know this Llama 2, then Mistral. So these are the model is also open source model. Okay. So this model is also available in the Hugging Face. Okay. Hugging Face is also having, these are the model. Let's say I want to access Meta Llama model. Okay. So this is the model actually I can see. So all the model actually you have 7B, then 70B, 13B, all the model actually you are having. But if you want to load this particular model, okay, you have to download this particular model from the Hugging Face itself. Okay. For this, you need GPU machine. Okay. You need a GPU machine, and you should have a good memory there. Okay, otherwise you can't actually load this particular model. Even if you have already used this particular model, okay, so you'll see like inference time would be also high because it's a huge model again. Okay, because everything you are running on your local machine. Okay, and then you are executing this at the model. But whenever I'm talking about this particular Amazon Bedrock, so this model actually is already hosted here. Okay, as an API, so you can connect this model through API. Okay, API request. So first of all, you just need to make a client. Okay, with the help of this particular client, you can send a request. That means you can send a prompt and you can get a response, okay, from this particular model. And this execution time would be very fast. Okay, so for this, if you want to, let's say, create a production grade application, and if you want, let's say, faster inference, okay, at that time you can go with this particular Amazon Bedrock service. Okay, but let's say you have a good instance. Okay, you have a good instance, you have lots of money, you can buy good instance, good GPU configuration machine and all. And if you are not worrying about the faster inference, at that time you can go with these are the model. Okay, you can like manually download this particular model and you can use it. But here we'll be using the client, okay, to access this particular model. And every request actually will be sending, okay, will have some of the cost. Okay, now if you want to check the cost also, so you can check it out. Let's say if I want to use Llama model, so Llama is having their like cost, okay, cost per request. So here you can see the view pricing option. So per token actually it will charge you. Okay, so see, so if you are using this model, Jurassic to mid model, so let's see the Llama model. I think Llama model is also there. Yeah, Meta Llama. So this is the price per 1,000 tokens. Okay, see, per 1,000 tokens, this is the price actually it will charge. It's like very less. Okay, lesser than your OpenAI, I think. Okay, so there is no like more charge, so you don't need to worry about. So if you want to create a production grade application, so you can go with this particular Amazon Bedrock service. Okay, you can visit that particular pricing page and you can try to understand. Now what I have to do, guys, first of all, let's try to access one particular model, okay, from this particular Amazon Bedrock. So let's say I want to access this particular model called this Jurassic model. Okay, so Jurassic model I want to access. Let's say I want to access this particular model, Jurassic mid model. So if I want to access this particular model, I have to hit the API request. Okay, so here I have to send the API request, but I'm going to send the API request throughout the Python. Okay, so guys, now let's see how we can use this particular Amazon Bedrock. That means the different actually foundation model. Okay, so first of all, we'll be doing this particular experiment, and if we are able to access this at the model, okay. So next, actually, I'm going to show you how we can create this particular end-to-end RAG application with the help of this particular Amazon Bedrock. So I'll go to my code editor, and first of all, here I'm going to import this Bedrock from the Langchain, because it is already available in the Langchain. Okay, Langchain framework. So we have already installed this particular Langchain. So make sure you have selected the correct environment. So let me refresh. So this is the environment I'm using. Yeah. So Langchain dot you have to import LLMs. Then inside that you have something called this particular service called Bedrock. Now I'm going to import this particular Bedrock class. Okay, so Bedrock. Then I also need something called LLM chain, because here whenever you will be creating that particular QA object, okay, so you need this particular LLM chain. So let's create this particular LLM chain. So from Langchain dot chains. So if you already know about Langchain, I think you already know what is the things actually I'm importing, because these are the requirement actually I'm expecting you are already familiar with this particular Langchain framework. Okay, so chains, I'm going to import something called LLM chain. Then I'm going to import something called prompt template. So here I'm going to write from Langchain dot prompts. Okay, I'm going to import something called prompt template. Then I'm going to import another library called Boto3. Okay, so if you don't know what is Boto3, Boto3 is a library, Python library actually we can use to connect with our AWS account. Okay, but here we haven't installed this particular package, so let me install also. So here I can write Boto3. Now let me open up my terminal. Now again, I'm going to install this particular requirements. So installation is completed. Now let's create the client quickly. So with the help of this particular client, actually, I'll be accessing the Bedrock. So we have imported both of the. Then I also need to import Streamlit, okay, because I'm going to create one basics UI for my user. Okay, so that's why it's needed. So let's import it. So import Streamlit as ST. Yeah. Okay, it should be import. Okay, not from. Yeah, now I think everything is fine. Now, first of all, I'll be defining the Bedrock client. Okay, so let's define the Bedrock client. Bedrock client. So for this, I'm going to use this particular Boto3. So Boto3, okay, dot client, and here you have to mention the service actually want to use. So service underscore name. So I want to use this particular Bedrock service. Okay, so you have to write Bedrock underscore runtime. Okay, Bedrock underscore runtime. Then you also need to define the region, like which region actually you want to use in the AWS you are having. I already told you how to check the region. So we are inside this particular US East 1. Okay, so let me also write down this particular region. So I'm inside this US hyphen East hyphen 1. Okay, so this is the region. So yeah, guys, this is my client. So I'll store this particular client in a variable. So let's name it as Bedrock. Okay, Bedrock client. Then I need to write the model ID. Okay, which model actually you want to access from the Bedrock. Okay, so you have to define the model ID. Now, how you will get this particular model ID? So again, go back to this particular Bedrock, and I already told you it is having different foundation model. Let's say I want to use this particular Jurassic 2 model. Okay, I'll click here. Now it is having different like variant Jurassic Ultra and Jurassic Mid. Let's say I want to use this particular Jurassic Mid. I'll click here. Now, if you just go below, this is the model ID. Okay, now let's copy this particular model ID. I'll copy and I'll open up my code, and here I'm going to paste it. Okay, so this is the model ID. Now here what I have to do, I have to create a LLM wrapper. So let's create a LLM wrapper. LLM is equal to Bedrock, and inside that, first of all, you have to define the model ID. Okay, model ID. So model ID means the model ID actually we have defined. Okay, this particular model I want to access. Then after that, I have to also define the client. Okay, so client is equal to this Bedrock client we have created. Okay, with the help of this Bedrock client, it will authenticate. And how it will get this particular credential, I think you remember we already set those credential, okay, in the terminal by running that particular AWS configure command. Okay, so it will take the access key and secret access key from there, and it will take by this particular library called Boto3. Okay, Boto3 automatically will take take this particular credential, okay, from the environment. Then what I have to do, I have to define the model keyword. Okay, so let's define the model keyword also. So model arguments. So inside that, I'm going to mention one arguments called temperature parameter. Okay, because this is the parameter we usually tweak a lot actually whenever we are using LLM and all. Okay, so here is the temperature parameter, but it should be defined as a string, right? Then here you have to provide the value of this particular temperature parameter. So let's take 0.9. That means I'm taking close to 1. I'm telling my model just take any risk and try to give a creative output. Okay, whenever you are generating any kinds of let's say output and all. So you can set this particular parameter based on your requirement. So I set 0.9. Now what I will do, I'll create a function here called my chatbot underscore chatbot. Okay, my chatbot. So inside that, actually I'm going to write the final logic. Okay, so it will take the language. I also want to give the language. Okay, language. Let's say choice. Let's say you want to generate this particular response in English language, or let's say Spanish language, or let's say Hindi language. Okay, you can give any kinds of language. So you can give this particular parameter as language. Then it will also take the user. Okay, user text. Like whatever text user is giving, it will also take that particular input. Then what I have to do, I have to create a prompt template here. So prompt template. I have already imported this particular prompt template. Now inside prompt template, first of all, I need to specify the input variable. Okay, so input variables. Okay, so here input variables, I'm having the language. Okay, language and this user text. Okay, these two actually, I have this input variable. Okay, here. Now what I have to specify, I think I should also close this particular quotation. Yeah. Then I also need to specify my actual template. Okay, so the template is equal to, so here you can give any kinds of, let's say, prompt. So I'll give this kinds of prompt actually. So you are a chatbot, you are in this particular language, and this is the user text. Okay, so this is the prompt I have given to my LLM. Okay, that's how you can define this particular prompt template. Now let's store this particular prompt template in a variable. I'll just name it as prompt. Okay, prompt. Now what I will do, I'll just create a LLM chain. So LLM chain is equal to, I'll define this particular LLM object. Okay, LLM is equal to the LLM wrapper we have created, LLM. Then I also need to give this particular prompt. So prompt is equal to, okay, prompt is equal to prompt we have created. Okay, then I'll store this particular things in a variable. I'll just name it as Bedrock. Okay, Bedrock underscore chain. Now user will ask the query and they will get the response. So for this, I'm going to utilize this particular Bedrock chain I have created. So Bedrock chain. So it will take first of all the language. Okay, input as a language, because first of all user will give one language, so it will take that particular language. So language should be language. Okay, then it will also take the user input, user text. So user text should be user text. I think everything is fine. Let's test. Okay, it should be text. Okay, not a test. So that's why this error is coming. User text, and now I think everything is fine. Now the response actually I'll be getting. So it will return me the response. Okay, so I'll return this particular response. So return this response. Yeah. Now this function is ready. Now I can inference on top of the model actually. I'm using here. Now what I will do, I'll create a basics Streamlit. You can say UI. So for this, first of all, I'll give one title, so st.title. So here you can give any name of the application. So here I can write Bedrock. Okay, Bedrock demo or Bedrock test. Okay, Bedrock test. I can just write. Then first of all, I'll be taking one. You can say select box here, because user will you can say choose the language. So for this, you can use this particular code snippet. So see here I'm creating one like select box, and user will select the language. So here you can add as many as language you can. So I have only added 3 languages: English, Spanish, and Hindi. Okay, you can also add Bengali. Then you can also add, let's say, like Russian. Okay, anything you can add here. It's up to you. Now what I will do, I'll just write one logic. If user is given any kinds of language, so what you have to do, first of all, you have to take the input from the user. So I'll take this input and I will store in this particular variable user text. Okay, user text is equal to, so here I'm going to create a select text area. Okay, because I'm going to just create a box. Inside that particular box, user will give the input. Okay, so for this you can use st.sidebar. Okay, then you can take something called text area. Okay, text area. Yeah, then inside that you can define the label. That means the quotient actually you want to render here. So I'll give a message, what is your, okay, what is your question. Okay, and you can also define like how many, let's say, character user will able to put. Okay, so here you can just define max character is equal to, I will just specify 100. Okay, so 100 character user will put here. Then once it is done, so I also need to check this user text. That means if user has given any kinds of input text, that means the prompt, okay, to the LLM. So what I have to do, first of all, I have to give it to my model. So I'll call this particular function my chatbot. Inside that, first of all, I'll give my language. Okay, the language user has selected. Then I will also provide something called user text. Okay, whatever question actually user is asking, then it will give me the response. Okay, so it will give me the response. Yeah. Then after that, I will write this particular response in the Streamlit. Okay, Streamlit application says t.write, and here I'm going to write this particular response. So I'm going to only extract the text, okay, from the response. So it should be text. Yeah. So I think it should work. Now let's test whether it is working or not. So I'm going to open up my terminal. So let me create this particular terminal, and I'm going to execute this particular file, this bedrock trials.py. So for this, you have to execute this particular command. Okay, so let me also add this particular command. So if you want to execute the file, so you can write streamlit. Okay, streamlit run. This is inside resource. Okay, slash. The name of this file is bedrock trials. Okay, .py is the name. Now let's copy the command. I'll open up my terminal and let me execute. Okay, so it is giving one error. It is telling research. Okay, so research spelling is not correct. Let me check. So research. Okay, now I think it's fine. Now let me copy and execute. Okay, now my application is running. Now if I go to my browser, now if I open up my browser, okay, so it will open up one new tab. So this is the tab it has opened. But again, I can see there is an error. So what is the error? So unknown service error. So unknown service bedrock underscore runtime. Okay, so let me check this particular code snippet. So here, okay, so it should be bedrock hyphen runtime. Okay, not a underscore runtime. Now I think it should work. I'll go back and rerun this particular application. Okay, now see, this is my interface. Now you can select any kinds of language. So let's select the English language. Now ask any kinds of query. So I'll ask what is, okay, what is let's say what is C++? Okay, what is C++? So now let's see whether it is able to give me answer or not. Now if you want to execute, you need to press Control and enter. So here it is giving me the response. C++ is a general programming language. That means yeah, so it's a correct response. Now you can ask any kinds of query. So you can ask like what is Python, okay, and Control enter. See, it is also giving the response. Now see guys, although I am using this particular model, okay, this large language model, and I'm also using this open source model, okay, Jurassic is also open source model, but the response time is like very fast here because this model is already hosted, okay, over the Bedrock, and we can access this particular model with the help of this particular client. Okay, the client actually you have created. Okay, this particular client we have created. Okay, so that is why actually whenever you want to create any kinds of production grade application and you want to, let's say, get a quick response, at that time you can go with these other services. But whenever, let's say, you are loading these other model on your machine, at that time your inference time would be very higher. Okay, like it will take lots of time to execute that particular code. So that's why actually you can use this particular Bedrock, and this is like very scalable. Okay, like it is like very efficient solution whenever you are trying to create any kinds of generative AI application. Now see guys, I already showed you how we can access different models. Now let's say you want to also access meta model. Okay, so what you can do, you can come to the meta and you can take this particular model ID. Now let's say you want to access this particular model, this 70 billion parameter model. So you need to give this particular ID. Okay, so here you just only need to change. So let me show you. If I open up the code, so here you only need to change it, okay, inside the model ID, and everything will remain same. But here only we're doing the inferencing, okay, on top of the model. But now what I'm going to do, I'm going to create one end-to-end RAG application. Okay, so end-to-end RAG, like you can say, project will be implementing. So what is RAG? So let me give you one idea. So first of all, I'm going to create a architecture, okay, of this particular project I'm going to develop. So here, first of all, what I'm going to do, as I already told you, I'm going to use PDF documents. Okay, let's say I'm having some PDF documents. Okay, PDF docs. Okay, so it can be multiple PDF also, it can be one PDF also, it's up to you. Now what I have to do, first of all, I have to extract the text. Okay, I have to extract, okay, extract data, okay, from this particular PDF. After extracting, what I have to do, I have to create a chunks. I have to create a chunks. Why I have to create a chunks? Because all the model is having their input length. Okay, if I show you, let's say I'm using this Meta Llama 2. Okay, going forward, I'll be using this Meta Llama 2. So Meta Llama 2 is having actually input size. Okay, this token input size. Let me show you. So if I go to the official Meta Llama 2 website, so let's go to the website. So here you can see, guys. So it is having different models: 7 billion, 13 billion, and 70 billion. And if you see here, the context length is 4096 token. Okay, Now what will happen? So whenever you are using any kinds of PDF documents, so if you extract all the data, that means all the documents, okay, from the PDF, you will see sometimes it would be more than 4096 token. Okay, it would be more than 4096 token. At the time, if you give this particular input to the model, okay, to the model, your model will throw input error. So to prevent this kinds of issue, what I have to do, I have to create a chunks. Okay, chunks means I have to create a different chunks. Okay, let's say this is your entire text. Okay, let's say this is your entire text. Okay, this is your entire text. So what he will do, he'll just take a chunks. Okay, chunks of the text. So this is one chunks. This is another chunks. Okay, this is another chunks. Okay, that's how he will be giving to the model. Okay, as input. So different chunks actually you are giving. Instead of taking all the text together, you are giving different chunks. So that time you have to also define the chunk size. Okay, and there is another parameter we can also define called chunks overlap. Okay, so this is the idea of this chunking. Now once this chunks is created, now what I have to do, I have to download one embedding model. Okay, I have to download one embedding model. So in this case, I'm going to use this Titan embedding model. I already showed you. Okay, so embedding model, Titan embedding model. With the help of this particular embedding model, I'll convert this particular data to vector embedding. Okay, so vector embedding. Vector embedding. That means numerical representation. Vector embedding. Then what I have to do, I have to store this particular vector embedding in a knowledge base. That means in a vector DB. So here I'm going to use something called FIAS. Okay, FIAS is a vector DB. It's a vector DB. Vector DB. Okay. So this is nothing but this is my knowledge base. Knowledge base. Okay. Now what will happen? User will ask some query. So let's say this is the user. So user will ask some query. So let's say this is the query user has asked. So what I have to do, I have to pass this particular query to my knowledge base. Okay. So it will do something called semantic search. Okay, semantic search, semantic index search. I think you already know what is semantic search inside vector DB. Then it will also return some of the rank results. Okay, it will return some rank results. Rank results. Okay, so it will return this particular rank results based on the k parameter. Let's say if k is equal to 3, so it will return only 3 relevant answer. Okay, with respect to the query you have asked. Now what I have to do, I have to connect the LLM. So I'll be collecting the LLM. So in this case, I'm using something called Llama 2. Okay, Llama 2. So I'll feed this particular rank results to the LLM. Okay, then I'll also give the query to the LLM. So LLM will try to understand the query. It will also try to understand the results. That means the answer. Then it will process this particular query answer and it will give you the actual response. Okay, actual response. So response. Okay. So let's say you have asked something related Python. So first of all, it will check in the knowledge base whether I'm having answer related Python or not. If it is having, so it will take most relevant 3 output, okay, from this particular knowledge base. Then it will process, okay, based on the query. Then it will give you the correct response. That means what is Python exactly? Okay, this is the idea. And this is called, okay, this is called RAG application. Okay, RAG pipeline. This is called RAG pipeline. Okay, this is called RAG pipeline. That means retrieval augmented generation. So instead of fine tuning the model, what I'm doing, I'm just adding some additional knowledge, okay, additional information information, okay, additional information to the model. Okay, so this is my additional information. So I'm just processing this information, I'm creating the embeddings, okay, and I'm storing in a knowledge base, and I'm connecting, okay, I'm connecting the LLM to the knowledge base, and whatever is user is asking this kinds of query, okay, I'm just like getting the response and I'm showing to the user. Okay, so this is called RAG pipeline. And what is fine tuning? Fine tuning means whenever you will be like say training that particular model, that means you will be changing the weight parameter. That is called actually fine tuning. And fine tuning is like very hard task and it's like very costly task. Okay, so that's why you don't need to perform this fine tuning every time. Okay, first of all, you will be applying this particular RAG concept, and if RAG is working fine, then you will be going with the RAG concept. And if RAG concept is failing somewhere, that time actually you have to perform the fine tuning. So in future actually we'll be also learning how we can perform the fine tuning, okay, on top of the custom data. That thing we'll be also learning. So yes guys, this is the entire architecture of our, like you can say, application. Now I need to code this particular example. So for this I'm going to again open up my code editor. Now here I'm going to open this particular main.py file. So guys, I think you already got the idea how things are working and how we can make the connection with this particular Bedrock and all. So let me just quickly write all the code. So first of all, I need to import some of the library here. So let's import all the library. So these are the libraries are required. Okay, so I'm importing Boto 3 because of that particular, you can say Bedrock. I want to access with the Bedrock. Streamlit I need because I'll be creating the web application. Then I'm also importing something called Bedrock embedding, okay, because I already told you I'm going to use one embedding model, okay, from the Bedrock. So Bedrock having also embedding model. So if I show you, let's say Amazon is also having one model called Amazon Titan, okay. So let me show you. Yeah, Titan embedding G1 text, okay, this is the model. So this embedding model actually I'm going to use, okay, that's why I'm importing this particular embedding from the you can say Langchain, okay, and this is the Bedrock embedding. Then I also need this LLM, that means Bedrock. Then PyPDF directory loader, because I'm going to keep some PDF, okay, in the directory. So let me create a directory here. I'm going to name it as data, okay, and I can name it as PDF data, okay, PDF data. Inside that I'm going to keep my PDF. So with the help of this particular package, I'm going to load this particular PDF. Then recursive character text splitter. So I already told you something called chunkings. So if you want to perform the chunkings, you have to use this particular method called character text splitter, okay, recursive character text splitter. Then I also need something called VectorDB. So VectorDB wise, I'm going to use Fires, and it is already available inside Langchain. Then prompt template and retrieval keyway, because I'm going to perform. Then I'm importing this particular retrieval keyway, okay, this particular method, because as I already told you, I'm going to create this RAG application, and on top of the knowledge base, actually, I'll be performing the query operation, okay. So that's why actually this is needed. Now the first thing what you have to do, you have to define one prompt template, okay. So this is the default prompt template I just prepared, okay. So here I've just written, so a human will ask some query, okay, based on that you have to return the response, okay, by taking the context, okay. Context means the knowledge base. So this is the prompt template I have created. Now what I have to do, you have to connect the client, okay. So I think you know how to collect the client. So this is the code for the client. So Boto3 client, and you have to provide the service name and the region name. Then what you have to do, you have to get the embedding model. So to get the embedding model, what you can do, you can use this particular Bedrock embedding, okay, Bedrock embedding to load the embedding model. So here is the code, okay. So that's how you can load this particular embedding model. As you can see, Bedrock embedding. Here you have to give the model ID. So Amazon Titan embed text v1. So this is the model actually I'm using. So Amazon Titan embed text v1, okay. So this is the model ID I'm using. Let me show you. Yeah, so this is the model ID. After that, you have to also assign the client, okay, the client actually you have created. Then first of all, what I have to do, I have to load this particular PDF documents, okay. So I don't have any PDF, so let me upload some of the PDFs here. So I'm going to open up the folder, and here I'm going to keep this particular PDF, okay. So this is one research paper actually, as you can see. So let me show you. This is one research paper, and the name of the research paper is Development of Multiple Combined Regression Method for Rainfall Measurement, okay. So this is the research paper actually I have given here. So you can give any kinds of research paper, any kinds of PDF here, any kinds of PDF documents. It's up to you, okay. So I already have this in my system. That's why I'm giving this particular PDF. Now let's see how we can extract these are the PDF text. Now what I will do, I have already created one function. So let me show you. So inside main.py, here I can mention this particular function called get documents, okay. So first of all, I will load this particular PDF, okay, as you can see. So here I need to give the path of the PDF, copy the name. Yeah, so this is the folder. Inside that, actually whatever PDF actually you are having, it will load everything. Then after that, I'm performing this recursive text splitter. That means I'm performing this chunking operation, okay. So as you can see, so this is the chunkings actually I'm doing. After extracting the documents, I'm performing this chunking operation. That means it will create the chunks, different chunks, and this is the chunk size. That means it will take 1000 character, okay, in one chunks. Let me show you. So let's say whenever it will create this particular chunks, it will consider thousands character, okay, thousands tokens in a one chunks, okay. So that's why you have to give this particular chunk size. And chunk overlap means how much overlap actually you want from the previous, okay, from the previous like you can say chunks you have created, okay. So this is called chunks overlap. Now once this is done, then you have to apply this particular split document. That means it will perform the chunking. Then after that, I'm just returning the documents. Then I also need to load the vector, okay. So to load the vector, you can execute this particular function. Let me show you. You can load this particular function called get vector store. Now it will take the documents actually you have extracted. Now here I'm using this files, okay, files vector db, as you can see, files, and I'm initializing the files. I'm giving this particular documentation, the documentation I have extracted, and I'm also giving the vector embedding, okay, the vector embedding I have initialized, okay, Bedrock embedding. Then what it will do, it will automatically take those are the documents, and it will convert to vector representation, okay, and it will save inside my local system with the help of this particular name, okay, files index. Now once it is done, I also need the LLM object, okay. So I have created another function called get LLM. So here I'm initializing this particular you can say LLM. Now if you see, I'm using Meta Llama 2, okay. So now if I show you my Bedrock, now if I go to the overview and I'm using this Llama 2, and I'm using this particular model, Chat 7 billion model. Okay, now this is the model ID. Okay, just copy, and here you can paste it. Okay, here you can mention now client, and here you can give the model arguments. Okay, now here I have given max gen length. Okay, that means how much actually like let's say tokens you want to get as a output, okay, from the LLM. So here I've given 512. Okay, that is 512 token it will give me as a output. And after that I'm just returning the LLM. Then what I have to do, I have to create the prompt template. So I think you remember we already defined the you can say prompt here. So prompt template. Now here I'm just defining the template. Okay, inside the template I'm just defining these are the thing. Now input variable should be context and question, because here I have mentioned, okay, question and context. Now once it is done, I have to create the response function, because here it will take the input and it will give you the response. Okay, so this is the simple response function. So it will take the LLM, that means large language model, and vector store, that means your files and query. Now first of all it will create this particular retrieval QA object. Okay, inside that it will take the LLM. Then chain type is stub, because I'm going to create a simple chain. That's why, because in LangChain there are so many chain type you can explore over the documentation. Now retriever object means your knowledge base. Okay, here I'm using the files, as you can see, vector store files and as retriever, and I'm performing similarity search. Okay, and this is the this rank result parameter, that means k is equal to 3. It will return only 3, okay, relevant answer. Then I'm just returning, okay, this particular source document as well. Then you also need to give the prompt template you have created here. Then you need to ask the query. Okay, the query actually user will give, and whatever answer actually will get, I'm just returning this particular answer. Okay, then here I just need to create a simple user application. So first of all I'm going to create a new main method. Let me show you. So this is the main method. So here first of all I've given one title, that's a RAG demo, and here I've given the name of the project, end-to-end RAG application. Okay, then here I'm just giving one input. Okay, input text. Okay, text input from the user. So user will ask any kinds of query from the PDF itself. Now first of all what I have to do, okay, let's say if you want to ask any question on top of the knowledge base, first of all you have to build a knowledge base. That means you have to execute this particular function called get vector store. Okay, but before that you have to execute this particular function called get documents. That means it will extract the documents. After that it will store as a embedding. Okay, so I have to execute these two functions. So for this I'm going to create one button here. Okay, so let me show you. So here I'm going to create one button, as you can see. So here I'm created one slide bar, and here I've given update or create a vector store. Now if someone is clicking on this particular button, store vector, first of all it will run this particular document, that means this particular function, and it will extract the documentation, and whatever documentation actually I'm getting, okay, sorry, whatever documentation actually I'm getting from here, I'll be passing inside this particular function called get vector store. Okay, as you can see, get vector store, this documentation I'm passing. Then once it is done, I'm just sending the success message. Then if my knowledge base is created, that means vector store is created, now I'll be performing the question answer on top of it. Okay, so again I'm going to create another function. I think it should be inside this particular if statement. Yeah, so again I've created another function called send. Okay, send button. So whatever user will give the query, here, okay, first of all what I have to do, I have to load my knowledge base. Okay, as you can see I'm loading the knowledge base, files.load actually I'm doing, and this is the index name. Then I also need to give the embedding object. Then you also need to give this particular parameter called allow dangerous deserialization is equal to 2. Okay, if you are using this file, so this is the parameter you have to pass, because I saw from the documentation they are also using this particular parameter. Then I need to load my LLM. Okay, that means I already created one function to load the LLM. So as you can see, get LLM object. Okay, then after that here is the final function I'm calling. So get LLM response, and it will take this LLM vector store and query. So LLM vector store and query, the query actually user is asking, and I'm just writing the response. Okay, whatever response actually I'm getting, I'm writing on top of the Streamlit. Okay, now let's see whether it's working or not. So to execute this particular file, you need to run this command. So let me also mention this command. So it should be Streamlit run main.py. Okay, because I'm going to run this particular main file. Now let me copy the command, and I'm going to open up my terminal. So this is the terminal. Now I'm going to stop the previous execution. Let me clear, and let me execute this particular file. Now again this is running. So if I go back and I will close the previous one, and this is the new one, it has loaded. Okay, I'm not getting anything because let me check my code. Main.py. Okay, so this main actually I'm not calling. Okay, so I need to also define this particular main function in this particular if statement. Okay, if underscore name underscore main, then I'm going to access these are the code. Okay, now I think it should work. I'll go back and rerun this particular code. So guys, now as you can see, I got my interface. Now, first of all, I need to store the vector. Okay, because I need to extract the documents. I need to store the knowledge base. So let's click on this particular store vector. So once it is done, you will see the success message. So guys, as you can see, the execution is done. Now, if I show you my code, left hand side, you can see it has created this particular index. Okay, that means here actually it has stored all of my vector, but it is in a pickle format. Okay, because you can't visualize these are the vector. Again, it's a local vector DB. Okay, if you want to see that particular vector, you can use Pinecone. Okay, Pinecone or Webit. There actually you can visualize these are the vector, like how it is look like and all. Now what I will do, I'll ask some of the queries. So let's ask query with respect to the PDF actually I'm having. So let me open the PDF. So let's say I'll be asking related this particular rainfall measurements. Okay, so rainfall measurements. I'll copy this particular term and here I can ask. So tell me about rainfall measurements. Now if I just, I think I need to click on the send button. Okay, now I think it should work. Now guys, let me ask another query. So I'll ask, tell me about methodology. Tell me about methodology of the paper. Now guys, here is the response I got. So guys, here is the response I got. The paper compares the performance of the various regression models for the rainfall prediction, and the methodology involves the comparing of the performance of different regression model statistical metrics such as R2 score, MAE, MSC, and RMSC. Okay, if you read this particular paper, you will see the same thing actually. They are also explaining about this particular paper and all. That means it is working fine. Okay, now not only this particular paper, you can place any kinds of actually PDF here in this particular folder. Okay, any kinds of PDF, any kinds of PDF books, and you can again click on this particular button. So let me show you. So this is my application. You can again click on this particular button. That means store vector. It will again store those new vector. That means new text, and it will create a new knowledge base. And on top of that, you can perform the question answer. Okay. So this is like awesome application actually you can create with the help of this particular AWS Bedrock. Okay. Not only this model, you can also use Mistral AI. Okay. You can also use this particular stability AI. Okay. You can try these are the model at least. Okay. After this particular, you can say video, you can try with different model, and you can create different application on top of it. So yeah, guys, this is all about from this particular video. I hope you got the entire understanding how we can create a different actually application, how we can create a, you can say, end-to-end RAG application with the help of this particular AWS Bedrock. So here you can explore this particular playground as well as the model actually, different foundation model you can export, and you can create different application. Okay. So yes, guys, this is all about from this particular video, and this is like awesome actually platform they have developed. If you see the inference execution time, actually it's like very fast, although I'm using like bigger model. Let's say I used metal model, this particular 70 billion parameter model, and my execution time was like very fast there. Okay, but if you're loading this particular model on your system, you will see you will get lots of difficulty there. Okay. So yes, guys, this is all about from this particular video. I hope you like this particular video. So thank you so much guys for watching this video, and I'll see you next time.